Hi, welcome to the Corbettmaths Ultimate GCSE Higher Revision video. In this video we're going to go through the topics on the GCSE Higher Maths course, and the aim is to make sure you're familiar with those topics. Now, if you've got your GCSE Maths exams coming up, your GCSE Higher Maths exams coming up, this video is going to be absolutely perfect for you. Also, it's useful for anyone who wants to brush up on their math skills. Now, this video is quite large. I spent 2 or 3 minutes going through every single topic. So rather than watching it in one go, I highly recommend you watch it in chunks and you make notes as you go through and watch the video. But also, there's an accompanying booklet, and that booklet has a question on every single topic as we go through. So that booklet can be useful to do as you're watching the video. Alternatively, you can keep it to the end of the video and then do that booklet. Now, in terms of this video, we're going to go through the topics on the GCSE Higher Revision checklist. So this is the Corbettmaths GCSE Higher Revision checklist. And if you go to the website, there's a checklist for Edexcel, AQA and OCR. So those checklists are bespoke for each of the exam boards. And they look something like this. Now, they're pretty much identical, with only a couple of subtle differences. And as we go through this video, I'll point out those subtle differences as we go through that particular topic. But there's not many of them. An example being a topic such as capture, recapture, where one exam board covers it and the other two don't. But the differences are very subtle, and I'll talk about that as we go through. So we're going to go through the topics in red to begin with. So the topics in red are the number or the ratio and proportion topics, such as standard form, limits of accuracy, proportion, reverse percentages, compound interest, topics such as those. Then we're going to go through the topics in green, which are the geometry or the shape, space and measures topics, such as trigonometry, Pythagoras, your circle theorems, vectors, topics such as those. Then we're going to go through in blue the algebra topics such as simultaneous equations, quadratics, types of graphs, and so on. And then finally, we're going to go through the topics in orange, which are the statistics or the probability topics. Now, this revision checklist is going to be really useful for you. So I've put a link to it in the description below. You may want to print it, pin it up on your wall, bring it with you on the bus. It's very important that you have that with this checklist. And this checklist has a video tutorial on every single topic. So if you want a more detailed explanation, rather than the 2 or 3 minute explanation I'm going to do in every topic in this video, if you wanted a 5 or 10 minute explanation on the topic, there's the more detailed video tutorials on each one of these video numbers, and you can go to corbettmaths.com and watch those. Now, as I've mentioned, I've made a booklet to accompany this video, and it's called the Ultimate GCSE Higher Revision Question Booklet. Catchy title, I know. And there's a link to it in the description below, and this booklet is going to be really useful as you watch this video. As I've said, there's a question on every single topic as we go through. There's a QR code which brings you to this video. Also, there's a QR code which brings you to the answers as well on the front of the booklet. So that booklet is going to be really useful. Now, as we go through this video, sometimes I use some of the information from the Corbettmaths revision cards, and these are going to be really useful for you if you're studying for your GCSE Higher exams. So I'd highly recommend those, and there's a link to them in the description below. So they're the Corbettmaths revision cards. Also, whenever you're revising for your GCSE Higher exams, I'd highly recommend a little and often approach. So the Corbettmaths 5-a-day booklets are going to be really useful for that. And we've got 3 versions that will be particularly useful for you if you're studying for your higher exams. And they will be the yellow Foundation Plus booklets, the green Higher booklets, and the blue Higher Plus booklets. And there's 5 GCSE questions for every single day of the year in each of those books. And there's answers at the back of those books as well. Okay, so our first topic is adding fractions, and that's video 133 in Corbettmaths. So whenever I go through this video, for every single topic we go through, in the top right hand corner there's the video number from corbettmaths.com. So if you want a more detailed explanation rather than the 2 or 3 minute explanation I'm doing in this video, if you want the longer 5, 10, 15 minute explanation, if you go to corbettmaths.com and go to this video number, then that will be the video tutorial that you can watch. Okay, let's get started. So to add fractions, it's very important that the fractions have the same denominator, a common denominator. So for instance, if we were asked to work out 2/5 plus a quarter, as you can see, the denominators, the numbers on the bottom of the fraction, aren't the same. We've got a 5 and a 4. So what we're going to do is we're going to find the lowest common multiple of 5 and 4. Well, that's going to be 20, because 5, 10, 15, 20, 4, 8, 12, 16, 20. The lowest common multiple of both of them is 20. And what we're going to do is we're going to find 2 equivalent fractions. Now remember, to find an equivalent fraction, we consider what do you multiply 5 by to get to 20? Well, that's 4. So you multiply the numerator by 4 as well. So 4 times 2 is equal to 8. So 2/5 is the same as 8/20. Next, our quarter, we want to have 20 on the denominator. So to get from 4 to 20, you multiply by 5. So you need to multiply the 1 by 5 as well. So that's going to be 5. So 1/4 is 5/20. And finally, we've got 8/20 plus 5/20. When we're adding fractions with the same denominator, we just add the numerators. So if we had 8/20 plus 5/20, that's going to be 13/20. And that's it. So 2/5 plus 1/4 is 13/20. Okay, let's have a look at our next question. So our next question is to work out 2 7/9 plus 1 and 2/3. So here we've got some mixed numbers, and a mixed number is where you've got a whole number and a fraction. So for instance, 4.5. And we're going to be dealing with these mixed numbers. And whenever we're dealing with mixed numbers, whenever we're adding or subtracting or multiplying and dividing fractions, it can be very useful to turn them into top-heavy fractions. So if I just take the whole number, which is 2, and times it by the denominator, so 2 times 9 is 18, and add on the 7 is 25. So that gives me the 25/9. Next, I take the whole number, which is 1, and I do 1 times 3 is 3, and add on the numerator, which is 2, so 3 plus 2 is equal to 5, so it would be 5/3. So here we've written our mixed numbers as top-heavy fractions. So we want to have the same denominators. So we've got ninths and we've got thirds. So the lowest common multiple of 9 and 3 would just be 9. We could multiply both the numerator and the denominator of this fraction by 3, and that would give us 9 on the denominator. So let's do that. So we've got 25/9, and then we're going to add. If we multiply both of these by 3, we get, well, 5 times 3 is 15, and 3 times 3 is equal to 9. So we've got 25/9 plus 15/9, and that's fantastic because they've both got the same denominator. So if we just add the numerators, 25 plus 15 is 40, so our answer would be 40/9. I would change this top-heavy fraction or answer into a mixed number as well. Remember, the line in a fraction means divided by, so how many 9s go into 40? Well, 4 9s is equal to 36, so it's going to be 4, and 36, well, we have 40, so our remainder would be 4. So our answer would be 4 and 4/9, and that's it. Our next topic is multiplying fractions. So multiplying fractions is really easy. You just need to multiply the numerators and multiply the denominators, and that's it. So if you had 2/5 times 1/4, if you multiply the numerators, 2 times 1, that's 2. And if you multiply the denominators, 5 times 4, that's 20. Now the answer here is 2/20. I'm going to cancel this down. I'm going to simplify it. We can divide both of these by 2. So our final answer would be 1/10. Okay, next we've got 1 and 1/7 multiplied by 2/3. Again, this is a mixed number, so let's make this a top-heavy fraction. 1 times 7 is 7, plus the 1 is 8, so 1 and 1/7 would be 8/7, and then multiplied by 2/3. So let's multiply the numerators, so 8 times 2 is 16, and 7 times 3 is 21. So our answer would be 16/21. 16 and 21 have no common factors apart from 1, and that's not going to help us. So if you want more practice on multiplying fractions, if you watch video 142 on Corbettmaths, you can watch the video tutorial on it, you can do some practice questions, do the textbook exercises, but also remember you've got that practice question booklet, so you can do these questions down that booklet and just make sure you're happy with this topic. Okay, let's have a look at our next topic. Our next topic is dividing fractions, which is video 134 in Corbettmaths. So to divide fractions, what we do is we multiply by the reciprocal of the number we're dividing by. And that sounds really complicated, but what it means is if you've got 7/15 divided by 3/4, instead of doing 7/15 divided by 3/4, what we can do is we can do 7/15 multiply by, and then we can find the reciprocal of 3/4. And the reciprocal is a fancy word for flipping it over. So instead of writing 3/4, we could write 4/3. Okay, so we've got 7/15 multiplied by 4/3. Now we've got multiply, so we can just multiply the numerators and multiply the denominators. So 7 times 4 is equal to 28, and 15 times 3 is equal to 45. So answer is 28/45. And apart from 1, they've got no other common factors. So that's it. Okay, our next question. Our next question is to work out 2.5 divided by 1 3/5. So we've got mixed numbers here, so let's turn them into top-heavy fractions. So 2, well, we've got 2 times 2 is 4, plus 1 is 5, so it's going to be 5/2. And we're dividing by, well, if we look, we've got 1 3/5, so 1 times 5 is 5, plus 3 is 8, so it's going to be 8/5. Now remember, we want to multiply by the reciprocal of the number we're dividing by, so we're going to write 5/2 multiplied by 5/8. Next, we're going to multiply, so we've got 5 times 5 is 25, and 2 times 8 is 16. So our answer would be 25/16. Now, because the question is given in mixed numbers, I'm going to write this top-heavy fraction as a mixed number. So the line means divide by, so we've got 25 divided by 16. So there's 1/16 in 25, and the remainder is 9, so we've got 1 and 9/16, and that's it. Okay, let's have a look at our next topic. So our next topic is reciprocals, and that's video 145 in Corbettmaths. So reciprocals, we talked about that whenever we were dividing by fractions, we multiply by the reciprocal. So to find the reciprocal of a number, we flip it over. Or another way to look at it is a number multiplied by its reciprocal will always give you 1. So if we've got 5, 5 is the same as 5 wholes, 5 for 1. If we flip that over, we would get 1/5. So the reciprocal of 5 is 1/5. And if we think about it, 5 times 1/5 is equal to 1. So a number times its reciprocal is always equal to 1. So the reciprocal of 5 is 1/5. Okay, next one, find the reciprocal of a third. Well, if we find the reciprocal of a third, we flip it over, which is 3 over 1, which is just 3. So the reciprocal of 1/3 is 3. And if you just check it, a third times 3 is equal to 1. Okay, our next one. The next one says find the reciprocal of 7/10. Well, flipping it over would be 10 over 7. Alternatively, we could write this as a mixed number. So how many 7s go into 10? 1, remainder 3, 7s. So the reciprocal of 7/10 is 1 and 3/7, or 10 over 7. Okay, next we've been asked to find the reciprocal of 0.75. Well, 0.75 is equal to 3/4. So when we find its reciprocal, we flip it over, so that's going to be 4/3. So the reciprocal of 0.75 is 4/3. Or alternatively, we could write it as a mixed number, so it'd be 1, because 1, 3 goes into 4, remainder 1, so 1 and 1/3. And then finally, we've been asked to find the reciprocal of 2 1/4. Now, whenever we're finding the reciprocal of a mixed number, I like to write it as a top-heavy fraction to begin with. So 2 1/4, well, 2 times 4 is equal to 8, plus 1 is 9. So it's going to be 9/4. And then if we find the reciprocal, that would be flipping it over 4/9, and that's it. So the reciprocal of 2 1/4 is 4/9. So we've now got multiplying decimals and dividing decimals. So multiplying decimals. Now, to multiply decimals, we can do this in two ways. We can either just ignore the decimal point and do 2,854 and multiply that by 8. And then looking at our question, we've got 1, 2, 3, 4 digits after the decimal point. So you put the decimal point in the answer, so there's 4 digits after it. Alternatively, you could multiply this number by 1,000 to get 2,854, and you can multiply this number by 10 to get 8, and then with your final answer you divide it by 1,000 and divide it by 10, and then that would give you your answer as well. Okay, so let's do 2,854 multiplied by 8 and see what we get. So 8 times 4 is equal to 32, so put the 2 down, carry the 3. 8 times 5 is 40, plus 3 is 43, so put the 3 down, carry the 4. 8 times 8, 64, plus 4, 68, so put the 8 down, carry the 6. And 8 times 2 is equal to 16, plus 6 is 22. So we've got 22,832. And to get our final answer, we can either consider the decimal places in the question. So it was 1, 2, 3, 4 digits after the decimal points in the question. So it's going to be 4 after it in the answer. So the answer will be 2.2832, like so. Alternatively, you can take this 22,832 divided by 1,000, because you need to multiply this number by 1,000 to get a whole number. So dividing this by 1,000 would be 22.832, and then dividing it by another 10 would be 2.2832, and that's it. Okay, and our next question is dividing by decimal. So we've got 1.2 divided by 0.04. Now remember that if you have something like 6 divided by 3, that's equal to 2. And if you multiply both those numbers, the number you're dividing and the number you're dividing by, both by 10, you get 60 divided by 30. And whenever you divide that, you get 2. And if you had 600 divided by 300, you get 2, and so on. So as long as you multiply both the number you're dividing and the number you're dividing by either 10 or 100 or 1,000 or whatever, you'll always get the same answer. So if we had 1.2 divided by 0.04, I want to turn this 0.04 into a whole number. So I want to multiply it by 10 and by 10 again to get 4. So I want to multiply it by 100. So I'm going to multiply both these numbers by 100. So 1.2 times 100 is 120, and 0.04 times by 100 is equal to 4. So we're going to do 120 divided by 4, and that's equal to 30. So the answer would be 30. Okay, let's have a look at our next topic. So our next topic is fractions, decimals, and percentages. And that's videos 121 to 129 in corporate maths. So it's going to be very important that you're able to convert between fractions, decimals, and percentages. So let's have a look at these questions. That'll help us remember how to do that. So let's change 17/20ths to a decimal. And let's do that by dividing the numerator by the denominator. So to change from a fraction to a decimal, we divide the numerator by the denominator. Now we know it's going to be a decimal number, so let's put a decimal point and some zeros. And well, that'll help us. And just a decimal point there. So how many 20s go into 1? That'll be 0, remainder 1. How many 20s go into 17? 0, remainder 17. How many 20s go into 170? Well, 8 20s would be 160, so it's going to be 8, remainder 10. And how many 20s go into 100? That would be 5. So the answer is 0.85, so 0.85. So 17/20ths is 0.85. Now let's change this decimal to a percentage. So to change from a decimal to a percentage, we just times by 100. So 0.85 multiplied by 100 would be 85, or 85%. And that's it. Okay, now we've got a decimal number. We have got 0.85 0.315, and we need to change that to a fraction, and we need to change that to a percentage. So let's change it to a percentage to begin with, because that's quite straightforward. So timesing this by 100 would be 31.5, and then we'll put percent, 31.5%. And then the change from our decimal to our fraction, I just consider what we've got. We've got 0.315, so we've got our units or our ones, we've then got our tenths, we then got our hundredths, and then we've got our thousandths. So we've got 315 thousandths. So that's 315 thousandths. And that's it as a fraction. And then we could just cancel this down by dividing both of these by 5, would give us 63 over 200. So 0.315 would be 63 200ths. And that's it. Okay, our next one, we've got 194%. So let's write that as a fraction to begin with. So it's percent, so that means out of 100, so that's 194 out of 100. And then we can just cancel this down by halving them both, and that would give us, that's equal to 97 over 50. So 194% as a fraction would be 97 50ths. We could write this as a mixed number, so we could say how many 50s go into 97? 1, remainder 47 over 50. So we could write 97 50ths or 1 and 47 50ths. Okay, let's write our percentage as a decimal. So divide by 100 would be 1.94. So 194% would be 1.94. And finally, we're going to convert 2/11ths to a decimal and as a percentage. So 2/11ths, I've chosen this one on purpose because this isn't a terminating decimal. These are terminating decimals, decimals that stop. A recurring decimal is one that goes on forever. Think of your third, which is 0.333333, and so on. So 2/11ths. So to change this to a decimal, we're going to divide. So let's do 2 divided by 11 and see what we get. So let's put a decimal point and some zeros, and the same with our numerator, put our decimal point above. How many 11s go into 2? 0, remainder 2. How many 11s go into 20? 1, remainder 9. How many 11s go into 90? That's going to be 8, which is 88, remainder 2. How many 11s go into 20? 1, remainder 9. You can see a pattern here forming. How many 11s go into 90? 8, remainder 2. How many 11s go into 20? 1, remainder 9. And so on. How many 11s go into 90? 8, remainder 2, and so on. So you can see we're getting 0.18181818 and so on. So we could write that down, 0.181818 and so on, and put some dots to say that it just carries on like so. Or alternative, if it's a recurring decimal, we could put dots above it. So we could write 0. And then because it goes 181818, we do 18 and a dot above the 1 and a dot above the 8. And that just says that the 1 and the 8 repeat. So it's 0.18181818 and so on. And that's it. Okay, and as a percentage, we want to write this as a percentage. Now we had 0.181818 and so on. So we're going to times this by 100, so that'll be 18.1818 and so on percent. And that's it. So it's going to be very important that you're able to convert between your fractions, your decimals, and your percentages. Okay, our next topic. Okay, so our next topic is recurring decimals and converting recurring decimals to fractions. So let's look and see how we would do that. And that's video 96 in Corbettmaths. So we're going to use algebra to write this recurring decimal as a fraction. So here's our recurring decimal, 0.0262626 and so on. It could be written as 0.026 with a little dot above the 2 and a little dot above the 6. That would also be the same thing. And we're going to look at how to write this as a fraction. So first of all, what we're going to do is we're going to let this be called x. So we're going to write x equals 0.0262626 and so on. Okay, so that's x. That's our recurring decimal we were given in the question. Now what we're going to do is we're going to look at our number, our 0.026262626 and so on, and look at the bit that's recurring forever. So that is our 26. It goes 262626 and so on. So we want to find a number where we have the decimal point and then we've just got that recurring bit, 26262626 and so on. Now if we multiplied this number by 10, what that would do is move all our digits one column to the left. So 10x, if we wrote down 10x, that would be equal to, if we multiply this by 10, we would get 0. And then that would be 262626 and so on. And that's going to be really useful for us. Now what we're going to do is we want to get another number when we get 26262626. So if we go back to our original number, if we multiplied this by, well, if we multiplied it by 10, that's 10x. If we multiply it by 100, we would have 2.626262. Well, that's not what we want. We want 26262626. So let's try multiplying x by 1,000. So let's write 1000x. So if we multiply this by 1,000, we would get, well, moving all the digits 3 places to the left would give us 26.262626 and so on. So we've multiplied that by 1,000. So what we've done is we've taken our x and we've multiplied it by 10 to get 0.26262626 and so on. And we've also gone back to our x and we've multiplied it by 1,000 to get 26.26262626 and so on. Now what's really fantastic here is if we subtract these from each other, our 26.26262626, and we take away 0.26262626, the parts after the decimal point will cancel out. So let's write that down and see what we get. So let's write down our 10x and then equals 0.262626 and so on. And when we take these away from each other, we get, well, on our left-hand side, we've got 1000x take away 10x. Well, 1000x take away 10x will be 990x, so 990x. And on our right-hand side, well, we had 26.262626, and we take away 0.262626. And if you have a look, take away 6 is 0, 2 take away 2 is 0, 6 take away 6 is 0, 2 take away 2 is 0, 6 take away 6 is 0, 2 take away 2 is 0. So we would just have, so all those numbers after the decimal point would just cancel out. So we'd just be left with 26 take away 0. And 26 take away 0 is 26. So whenever you take 26.262626 and you take 0.2626 away from that, you'll just be left with 26. So we've got 990x equals 26. Now remember, we let the number we started with in the question be x. So what we want to do is we want to solve this equation and find out what x is. So if we divide both sides of this equation by 990, we'll find x. So divide by 990 and divide by 990. And that gives us, on the left-hand side, x. And on the right-hand side, we would have 26 over 990. And that's it. So we have written our 0.0262626 as a fraction as 26 over 990, and that's it. Now we could sometimes in the question be asked to cancel it down. So if we were asked to cancel this down, well, we can see first of all that both of these numbers are even, so we can divide both of them by 2. So that would give us, well, 26 divided by 2 is 13. And if we divided 990 by 2, we get 495. And then finally, 13 and 495 don't have any common factors apart from 1, so that means that that's it. We've simplified it as far as we can. And that's it. So that's how you write a recurring decimal as a fraction. So let's have a look and see how we would round numbers to two significant figures. So let's have a look at our first one. So we've got 394. So we want two significant figures. So for this number, that would mean we would want 2 digits and then followed by zeros. So our options would either be 390 or 400 because they are 2 digits, so 39 and then followed by zeros, or 400, that's 40 followed by zeros. And we would want to round it to two significant figures, so let's choose the closest one. So it's either 390 or 400, so it's going to be 390 because this is closer to 390 than it is to 400. So the answer would be 390. Or an alternative way to look at it is if we had 394 and we wanted to round this to two significant figures, well, we want to have two numbers then followed by zeros. So we look at the third significant figure, which is a 4, and that means that we round down, so it'd be 390, not 400. Okay, our next one is 1273. We want to round that to two significant figures, so we either want to have 1200 or 1300, where we've got 2 digits then followed by zeros. Now, as you can see, 1273 would be closer to 1300 than it is to 1200, so the answer would be 1300. Or again, we could look at the third significant figure. We've got the first 2, and then the third significant figure is a 7, so we round up, so our answer would be 1300. Okay, our next one is 7,961, and we want to round that to two significant figures. So that means we want to have 2 digits followed by zeros. So we could either have 7,900 or 8,000 because 80 and then followed by zeros. So because this is 7,961, it's closer to 8,000 than it is to 7,900. So that means our answer would be 8,000. Or again, another way to look at it is if we want to round this to two significant figures, we look at the third significant figure, which would be a 6, and that means we round up, so it'd be 8,000. Okay, let's have a look at our next one. Our next one is 0.618, so we want to round this to two significant figures. Now remember, with decimal numbers, we ignore the 0 point and the zeros in the front, so we're just going to look at our 618, and we want to round this to two significant figures. That means we either want 0.61 or 0.62, and because it's 0.618, we're going to round up, so it's going to be 0.62. Okay, and our last number is 20.501. We want to round this to two significant figures, so we want 2 digits, then followed by zeros, or if it's just a 2-digit number, we just want a 2-digit number. So we've got 20.501, so our choice is either going to be 20 or 21. And because it's 20.501, we're going to round up, so our answer would be 21. Or again, another way to look at it is, because we have 20.501, we look at our significant figures. Well, our first significant figure is a 2, our second significant figure is a 0, and then we look at our third significant figure, which is a 5. That means we round up, so our answer would be 21. Okay, let's have a look at our next topic. So the next topic we're going to look at is use of a calculator, and that's video 352 in Corbettmaths. Now it's very important you know where all the buttons are on your calculator that you need to know. So for instance, making sure you know where your squared is, your cubed, your power button, your square root, your cube root, your sine, your cos, your tan, and so on. Making sure you're able to convert between fractions and decimals and so on. Now there's different calculators you could have. You could have this type of calculator that your display would look something like this. You might have a calculator where the buttons are in slightly different places, but all the calculators will have the key buttons that you need to know. All your scientific calculators, you need to have your sine, your cos, your tan, your fraction buttons, and making sure that you're able to use them. Also, you may have a calculator that looks like this. So let's just have a look at one of these. I'm just going to use this calculator display for the minute. And this is our question. It says, work out 5 cubes, subtract the square root of 2, all divided by tan 32. So if I want to type something like this into my calculator, the first thing I would do is, because it's got a fraction, I would press the fraction button. So here, my fraction button is there, and I'd press that button, and then my display would look something like this. Next, I would type in 5 cubes subtract the square root of 2 by pressing 5, and then the cubed button. Now obviously in your calculator it might be in different places, so for me I'd press 5, and then I'd press shift and then the squared button, and then that would give me the cube symbol, and then take away, and then I would press the square root of 2. And make sure you're familiar with your calculator and you know where those buttons are for your calculator. Then, because that's the numerator, I would then press the down button, and then I would press the tan, so tan 32. And it would look something like this. Now, with my calculator, whenever I type in tan 32, it opens the brackets, but it doesn't close the brackets. So I then make sure that I close my brackets, so it would look like this. And then I would press equals. And whenever I press equals, I get the answer 197.77866013. Now, if that came up as a fraction I wanted as decimal, I would then press this button, SD, standard decimal button, and that would then write it as if it was a fraction, which convert it into a decimal for me, and that would be quite useful. Now, if we've got this calculator, what I would do is I would press the fraction button, and then I would type in my 5, and then I would press my power button, and then type in 3, and then use my arrows to then go across and then type the square root of 2. Press down to go to the denominator, press tan 32, and make sure I close brackets, and then press equals, and again my answer would be 197.77866013. Now if I had a different question and my answer came up as a fraction and I wanted to write it as a decimal, for this calculator, press format, and then I would press down and then press decimal, and then it would write it as a decimal for me. So instead of having the SD, the standard decimal button, it has this format button on this type of calculator, and that's it. Okay, let's have a look at our next topic. So our next topic is estimation. And sometimes in estimation questions, we're given questions like this, where we've been asked to work out an estimate for 40.18 multiplied by 6.87, all divided by 0.512. Now, whenever we're doing a question like this with estimation, it can be useful to round our numbers to one significant figure. So let's round our numbers to one significant figure. So let's start off with our first number, 40.18. So we're going to round that to one significant figure. But that means one digit followed by zeros. So that means that we're either going to have a choice of 40 or 50. Because it's 40.18, I'm going to choose 40. It's much closer to 40 than it is to 50. Our next number, well, we've got multiply by, and then we've got 6.87. So our choices will be 6 or 7. Now 6.87 will be closer to 7 than it is to 6, so we're going to choose 7. And then finally we've got divided by, and then we've got 0.512. We want to round this to one significant figure, so our choices will be 0.5 or 0.6. This number is closer to 0.5 because it's 0.51 than it is to 0.6, so we're going to write then 0.5. Now, whenever I round my numbers to one significant figure, obviously whenever I carry on, the answer is not going to be the exact answer. So instead of writing an equal sign here, I do this curly equal sign. It looks like this, and that means it's approximately equal to. So whenever you round your numbers, whenever you do an estimation question, you round your numbers, rather than putting an equal sign after you've rounded them, it can be useful to put this approximately equal to symbol. It just shows your teacher, your examiner, or even just remind yourself that you've rounded the numbers. So now what we're going to do is we're going to work this out. So we're going to work out 40 multiplied by 7. Well, 4 times 7 is 28, so 40 times 7 would be equal to 280. And then we've still got divided by 0.5. So we now just need to work out 280 divided by 0.5, and that will give us our approximate answer to this question, our estimate. And what you would do is you would just times both these numbers by 10, do 2,800 divided by 5. How many 5s are there in 2? 0, remainder 2. How many 5s are there in 28? Well, that'll be 5, remainder 3. How many 5s are there in 30? That's going to be 6. And how many 5s are there in 0? 0. So the answer is 560. So our estimate for the answer to this question would be 560. Now, it's not going to be exactly 560, unless we're very, very lucky. But that's our estimate. That's the approximate answer. Okay, so let's have a look at our next topic. So our next topic is Best Buys, which is video 210 on Corbettmaths. So here we've got a question, a Best Buys question that says packets of biscuits are sold in two sizes. You've got a regular box of biscuits, which has 10 biscuits for 95p, or you've got a large box of biscuits. And we've got a large box of biscuits, which is 15 biscuits, and it costs £1.50. And the question asks, which packet of biscuits is better value for money? Now, there's two ways which I typically answer questions like this. So using the first approach, we could divide the total cost, the 95p, by the 10 biscuits to find the cost per biscuit. So I could do 95p divided by 10, and that would tell me how much it costs per biscuit in the regular box. So 95 divided by 10 is 9.5p. So it's 9.5p per biscuit here, per biscuit. And in the large box, it's £1.50, which is 150 pence, and that's for 15 biscuits. So you can divide a 150 for 150 pence by 15 biscuits, and that would tell us that's equal to 10p per biscuit. So 9.5p per biscuit is cheaper than 10p per biscuit, so that means that the regular box is better value for money. So that's one approach, to divide the total amount by how much you get. Another approach is to buy the same amount of biscuits by either buying just the regular boxes or the large boxes. So with the regular box, I could buy 10 biscuits, I could buy 20 biscuits, I could buy 30 biscuits by buying just regular packets. Or with the large box, I could buy 15 biscuits, or if I bought 2 packs, that would be 15 plus 15, which is 30 biscuits. So I could buy 3 regular boxes, and that would be 30 biscuits. So that would be 3 boxes at 95p each, so 3 times 95p, which is equal to 285p, or £2.85. Or alternatively, if I was looking at just the large boxes to buy 30 biscuits, well, 30 biscuits would be 2 boxes of those, so that would be 2 lots of £1.50, and 2 lots of £1.50 is £3. So if I wanted to buy 30 biscuits, I could use the regular boxes, which are 95p each, and that would cost me £2.85. Alternatively, I could use the large boxes to buy the 30 biscuits, and that would cost me £3. So as you can see, it's better value for money to buy the regular boxes. So the regular is better value. Okay, let's have a look at our next topic, which is exchange rates or currency. And that's video 214A in Corbettmaths. And we're told Nicola went to Italy and she changed £800 into euros. And the exchange rate was £1 is €1.40. So in other words, for every pound, the bank give her €1.40. And the question says to change £800 into euros. So to change from pounds into euros, or pounds into whatever currency you're converting into, if you go what £1 is, you just need to multiply how many pounds there are, the 800, by the number in the exchange rate. So here we've got £1 is €1.40. So if we do 800 multiplied by 1.4 or 1.40, well, we don't really need the 0 there. So if we do 800 multiplied by 1.4, we'll see how many years she gets, because for every pound she gets €1.40. So 800 multiplied by 1.4 equals 1,120 euros, and that's it. Now while she's there, Nicola's seen a watch that she likes and it costs 105 euros, and she wants to know how much that is in pounds. Well, if she wants to convert back from euros into pounds, we need to divide the 105 by the number in the exchange rate, the 1.4. So if we do 105 divided by 1.4, that would tell us how many pounds it would be. So if we do 105 divided by 1.4, that is 75. So the watch costs £75, and that's it. So our next topic is to look at conversion graphs. And here we've got a conversion graph, and conversion graphs can be used to maybe compare distances, like in this graph here where we've got miles and kilometers. Conversion graphs could be used to convert money. Perhaps you've got different currencies and you want to convert between one and the other, and a conversion graph can be quite useful for that. So here we've got a conversion graph, and horizontally we've got miles going 0, 1, 2, 3, all the way up to 10 miles. And vertically we've got kilometers going 0, 1, 2, 3, and so on. And let's convert 4 miles into kilometers using our conversion graph. So it's important to be able to know how to use a conversion graph. So we get a ruler and a pencil, and we want to convert 4 miles. So we'll go to 4 miles on the horizontal axis here, 4, and we'll get our ruler and a pencil, and we'll go up to the line, and it's just there, and then we go across from the line and do this with a ruler and a pencil on the test paper, like so. So as you can see, we've got to the second box above the 6. So let's find out what each one of those boxes is worth. So from 0 to 1, there's 1, 2, 3, 4, 5 boxes. That must mean we're going up in 0.2s. There's 0.2, 0.4, 0.6, 0.8, 1. So that would be 6.2, 6.4. So 4 miles would be 6.4 kilometers using this conversion graph. Now we've been asked to change 8 kilometers into miles. So again, getting a ruler and a pencil. So getting your pencil and ruler and going from 8 kilometers across to the line and then down from the line, we get to exactly 5 miles. So using this graph, 8 kilometers would be equal to 5 miles. And that's it. Now, if you were asked to maybe change something like 80 kilometers into miles, I would go from 8 across and get 5, and then say, well, if 8 kilometers is 5 miles, 80 kilometers would be 50 miles, and so on. So you can use conversion graphs to convert what's on the scales, but you can also use that information to work out other conversions as well that go beyond the scales. The topic is index notation, and that is video 172 on Corbettmaths. So if I had 5 times 5 times 5, that is 5 cubed, and if you remember your cube numbers, which is multiplying a number by itself and by itself again, you may want to write it in index notation, which means write it as a number with a power. So we could write that as 5 cubed, because there's 3 5s multiplied together. Here we've got 2 times 2 times 2 times 2 times 2 times 2. So writing that in index form, because there's 1, 2, 3, 4, 5, 6 2s, we would write 2 to the power of 6. And if we had y times y times y times y, because it's 4 y's multiplied together, we would say y to the power of 4. It's very important to be able to write these in index form, particularly for a topic called product of primes, and I'll talk about that in a moment. So if, for instance, you wanted to work out 2 to the power of 6, we would just do 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32, times 2, which is 64. So 2 to the power of 6 would be 64. You can use a calculator to help you. So here's a calculator. So what I would do is I'd press the 2 button, so I'd press 2. And then there's the power button, and on my calculator it's an X with a little white square just above it, like so. So I'd press that button, and on your calculator display above the 2 would be a little rectangle or little box appears. And then press 6, and then press equals, and then you will get the answer. So 2 to the power of 6 is 64. And that's just a quick way of working it out on your calculator rather than writing 2 times 2 times 2 times 2 times 2 times 2. So that's index notation. Okay, let's have a look at our next topic. So our next topic is laws of indices. And there's 3 very important laws of indices that I would recommend you know, and this is video 174 on Corbettmaths. So our first law, well, if you're multiplying things with the same base, so for instance, if you had m cubed multiplied by m to the power of 4, well, that would be m times m times m cubed, multiplied by m times m times m times m, and altogether there'd be 7 of them, so that'd be m to the power of 7. And a quick way to work that out is, because we've got m to the power of 3, and we're multiplying by m to the power of 4, you can add these powers. You can do 3 plus 4 is equal to 7. And this is the Corbettmaths revision card on laws of indices, so if you've got the revision card, this revision card will be very useful for you. Okay, next one, if we're dividing, if you had m to the power of 8, so if you had m times 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 m, and you divided that by m squared, that's m times m, 2 of the m's would cancel out with 2 of the m's, so you'd be left with m times m times m times m times m times m, and that'd be m to the power of 6, which is m to the power of 6. And a quick way to work that out is, if you're dividing and you've got the same bases, you can take away the powers. You can do 8 take away 2, and that's m to the power of 6. And finally, we've got a power of a power, so if you've got a power and then another power, you multiply the powers together. And let's have a look and see why that works. So if you had m cubed squared, remember squared means multiplied by itself, so we're doing m cubed multiplied by itself, so that's m times m times m, multiplied by itself, so that's m times m times m, and if you multiply all those together, you'd get m to the power of 6. And a quick way of doing it is to multiply the power. So if you've got a power to a power, you can multiply the two powers. 3 times 2 is equal to 6. So let's have a look at some examples. So if I had 3 to the power of 4 multiplied by 3 squared, I'd add the powers together because it's multiplied, and that would be to the power of 6. If I had 3 to the power of 10 divided by 3 squared, I would subtract the powers, so 10 take away 2 is equal to 8. And finally, if I had 4 squared cubed, I would multiply the powers because it's a power of a power. You've got a power and then another power. So you'd multiply the powers together. 2 times 3 is equal to 6, so it would be 4 to the power of 6. And that's it. Okay, let's have a look at our next topic. So our next topic is negative indices, and it's a number topic because it's in red, and it's video 175 on Corbettmaths. And let's consider this pattern where we've got 5 to the power of 3, 5 to the power of 2, 5 to the power of 1, 5 to the power of 0, 5 to the power of negative 1, and 5 to the power of negative 2. So 5 cubed, well, 5 times 5 times 5 is 125. 5 squared, well, that's 25. 5 times 5 is 25. 5 to the power of 1, well, that's just a 5, so the answer would be 5. Okay, next we've got 5 to the power of 0. Well, 5 to the power of 0 is 1. Okay, and next one is 5 to the power of negative 1. Well, if we look at our numbers here, we've got 125, 25, 5, and 1. Now, there's a pattern here. To go down in this pattern, we're dividing by 5. We're dividing by 5. We're dividing by 5. We're dividing by 5. And then if we want to find out our next one, we would just divide by 5 again. So if we do 1 divided by 5, well, that'd be 0.2, or we could just write it as a fraction, which is 1 over 5. If we want to get our next answer, we could divide by 5 again. Okay, so we do 1 over 5, or 5th divided by 5, so that'd be 1 over 25. Now what's actually quite useful to spot here is, because we've got 5 to the negative 2, that's the same as putting 1 over and 5 squared. And 5 squared is 25. So that's our rule. If we have x to the power of negative n, that's the same as 1 over x to the n. So you can just put 1 over and then just use the positive power. So here, if we were asked to work out 2 to the power of negative 3, we could just put 1 over and then just write 2 cubed. Changing our negative 3 to just 3. And then 2 cubed is 8, so the answer would be just 1 over 8, or 1/8. So 2 to the power of negative 3 is 1 over 8. Next, 10 to the power of negative 2, well, we would put 1 over and then just write 10 squared. And 10 squared is 100, so the answer would be 1 over 100. So if we had 10 to the power of negative 2, our answer would be 1 over 100. And that's it. So if we want to work out a negative power, you just put 1 over and then just use the positive power on the denominator. Okay, now let's have a look at fractional indices, and that's video 173 in Corbettmaths. So if we have something like x and we've got a power of 1 over n, so perhaps it was x to the power of a half, or x to the power of a third, or x to the power of a quarter, or something like that, that is equal to the nth root of x. So for instance, if you had x to the power of a half, that would be the square root of x. If you had x to the power of a third, that would be the third root, or the cube root of x. If you had x to the power of a quarter, it would be the fourth root of x, and so on. So whatever the denominator is on the fraction, that's what root you take off the base number, this x. And that's how you deal with fractions where you've got a 1 on the numerator. If there's another number on the numerator, such as x to the power of m over n, so what you do is, whatever's on the denominator of the power, you take that root, so you're going to take the nth root of x, and then whatever's on the numerator, you then work out that power. So whenever you've got a fractional indice, what you do is, whatever's on the denominator, you take that root, and whatever's on the numerator, you then do that power. And the rule looks really complicated, but it's much more easier whenever we look at numbers. So let's have a look at the revision card and let's get started. So if we had something such as 25 to the power of a half, to the power of a half means square root. We don't need to worry about the 1, so we can just square root it. So 25 to the power of a half, we just square root the 25, which is 5. If we had a power of a third, such as 8 to the power of a third, well, again, because there's a 1 on the numerator, we just need to look at the denominator. Because it's a 3, we're going to take the cube root, and the cube root of 8 is 2. So 8 to the power of a third is just 2, because you take the cube root. Okay, now let's have a look at some with numbers on the numerator. So if we had something like 27 to the power of 2/3, well, we're going to look at the denominator to begin with, and it's a 3. So we're going to work out the cube root of 27, and the cube root of 27 is 3. And then you're going to look at the numerator, and it's a 2, so you're going to square that answer. So 3 squared is 9. So 27 to the power of 2/3 would be 9. And finally, if we had something such as 16 to the power of 3/4, again, you look at the denominator, and it's a 4, so we're going to take the fourth root of 16. Well, 2 times 2 times 2 times 2 is 16, so that's going to be 2. And then you're going to look at the numerator, which is a 3, and you're going to do 2 cubed, which is 8. So whatever's on the denominator, you take that root, and then whatever's on the numerator, you then do that power. Okay, let's have a look at some examples. So first question says, work out 16 to the power of a quarter. So here we've got 16, and we've got a power that is a fraction, so this is a fractional indice. And what's good about it is it does have a 1 on the numerator, so we just need to work out whatever root's on the denominator. So it's going to be the fourth root. So we need to work out the fourth root of 16. So that's the fourth root of 16. Now 16 is equal to 2 times 2 times 2 times 2. And as you can see, whenever you got 4 2's and you multiply them all together, we get 16. So that means that the fourth root of 16 would be 2. So that means that 16 to the power of a quarter is equal to 2. Okay, this time we've got 4 to the power of 5/2. So again, we've got a power that's a fraction, and this time we do have something on the numerator other than 1, so we are going to need to work out that power. But first of all, we're going to look at the denominator, and it's a 2. So we're going to work out the square root of 4. So you're going to do the square root of 4, and the square root of 4 is equal to 2. Now you take that answer, that 2, and we're going to do 2 to the power of 5. So 2 to the power of 5. And then whenever you do that, you get 2 times 2 times 2 times, we can have 2 times 2 times 2 times 2 times 2. And well, 2 times 2 times 2 times 2 we know is equal to 16. And times by 2 again, that's going to be 32. And that's it. So 4 to the power of 5/2 is equal to 32. Okay, next one is 125 to the power of 2/3. So we're going to look at the denominator, and it's a 3. So we're going to work out the cube root of 125. So let's work out the cube root of 125 to begin with. And the cube root of 125 is 5. Now we're going to look at the numerator, and that's a 2. So we're going to do 5 squared. And 5 squared is equal to 25. So 125 to the power of 2/3 is equal to 25 by taking the cube root and then squaring it. Okay, now we've got our negative fractional indice. So we're putting together our negative indices and our fractional indices. So we've got 49 to the power of minus a half. So first of all, because it's a negative power, we're going to write 1 over and then 49 to the positive power. So that's just going to be to the power of a half. So 49 to the negative a half, I would write that as 1 over 49 to the power of a half. Now, to the power of a half means square root, so we're going to square root 49, and the square root of 49 is 7. So the answer would be 1 over 7. So if you had 49 to the power of negative a half, it would be equal to 1 over 7. And finally, if we had 64 to the power of negative 2/3, again, I would write it as 1 over 64 to the power of 2/3, getting rid of that negative power and writing it as 1 over 64 to the power of 2/3. Then we're going to take the cube root of 64 and then square it. So the cube root of 64, the cube root of 64 is equal to 4, because 4 times 4 times 4 is equal to 64. And then we're going to square it, so we're going to take our 4 and we're going to square that, and that's equal to 16. So 64 to the power of 2/3 is equal to 16. So we had 1 over that, so it's going to be 1 over 16, and that's it. So the answer is 1 over 16. Okay, so we've looked at fractional indices and we've looked at negative indices. Let's have a look and see what happens whenever we work out the fractional or negative indice of a fraction. So if we had 4/25 to the power of a half, remember to the power of a half means to square root. So we're going to square root this fraction. Now whenever we square root this fraction, we can square root the numerator and square root the denominator, and that will give us our answer. So if we work out the square root of 4, that's 2. And if we work out the square root of 25, that's 5. So 4/25 to the power of a half would be 2/5. And we could just check it. 2/5 times 2/5 would be 4/25, and that's it. So if you have a fraction to the power of a half, you can just square root the numerator and the denominator. If you get a fraction to the power of a third, you can cube root the numerator and cube root the denominator. And if, for instance, you had a fraction to a power of maybe 2/3, you could cube root the denominator and the numerator and then square your answers, and then that would give you your answer. And that's it. Okay, now let's have a look and see what happens when we have a fraction to a negative power. So whenever we have a number to a negative power, we normally do 1 over. And we're doing 1 over because we're working out the reciprocal. So if we've got a fraction with a negative power, to get rid of the negative sign in the power, what we can do is we can do the reciprocal of the fraction. So if we had 2/3 to the power of negative 3, to get rid of the negative, we can take the reciprocal of 2/3, which should be 3/2. So we then have 3/2, and then instead of being negative 3, it'd be to the power of 3. And now we've got 3/2 cubed. Well, we can just cube the numerator and cube the denominator. So 3 cubed is 27, and 2 cubed is equal to 8. And that's it. So if we had 2/3 to the power of negative 3, we would get rid of the negative sign by doing the reciprocal of 2/3 to get 3/2. And then we'd have the power of 3, so we'd just cube the numerator and the denominator. And 3 cubed is 27, and 2 cubed is 8. Now here, as you can see, our answer is a top-heavy fraction. So what we can do is we can see how many 8s go into 27. So that would be 3, because 3 8s is 24. Remainder 3, and then the denominator will still be 8. So we've got 3 and 3 8s. Okay, let's have a look at our last question. So this time we've got a fraction to a negative fractional indice. So we've got 8/27 to the power of negative 2/3. So first of all, what I'm going to do is, because it's a negative power, I'm going to take the reciprocal of the fraction. So the reciprocal of 8/27 would be 27/8 by flipping it over. So that gets rid of the negative power. So we'd have 27/8 to the power of 2/3. So that gets rid of the negative power, taking the reciprocal. Now we need to work out what 27/8 to the power of 2/3 would be. So let's say the cube root of both of these. So the cube root of the numerator would be 3, and the cube root of the denominator would be 2. So we're going to have 3/2. And we've done the cube root, so we now just need to square it. So we've got 3 squared is equal to 9, and 2 squared is equal to 4. So the answer would be 9/4 or 2 1/4. And that's it. Okay, let's have a look at our next topic. Our next topic is called LCM, or lowest common multiple, and that's video 218 and 219 on Corbettmaths. To find the lowest common multiple of two numbers, you consider their multiples. So if we had 6, the multiples of 6 would be 6, 12, 18, 24, 30, 36, and so on. The multiples of 15 would be 15, 30, 45, and so on. And the lowest common multiple, or the LCM, is the first number in both of those lists. And as you can see, 30 is the lowest common multiple. It's the first number in both the multiples of 6 and the multiples of 15. So 30 is the lowest common multiple, and that's it. So let's have a look at the highest common factor. So let's consider 16. So 16 is equal to 1 times 16, 2 times 8, and 4 times 4. So the factors of 16 are 1, 2, 4, 8, and 16. And if we consider 20, well, 20 is equal to 1 times 20, 2 times 10, and 4 times 5. So the factors of 20 are 1, 2, 4, 5, 10, and 20. And let's look at our common factors. Our common factors are 1, 2, and 4. So they are our common factors. And the highest common factor, well, that's going to be 4. So the highest common factor of 16 and 20 is 4. And this topic is particularly useful if you want to cancel fractions and factorize and things like that. Okay, our next topic. Okay, let's have a look at our next topic. So our next topic is product of primes, and that's video 223 on Corbettmaths. So every single whole number that is greater than 1 is either prime or can be written as a product of primes. And the word product means to multiply. So it either means that every single number that's greater than 1 is either a prime number or is equal to prime numbers multiplied together. So our first question, our example says, write 60 as a product of primes. So it's very important that you know your prime numbers, and your prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, and so on. And it's very important you know those prime numbers. So we're going to write 60 as a product of primes, and we're going to give our answer in index form. So let's start off with 60, and I like to do this using a prime factor tree. You can use another approach by using sort of an upside down bus shelter. Whatever approach you prefer is totally fine, but I like to use a prime factor tree like so. So 60, I think of two numbers that multiply together to give me 60. So I'm going to go for 2 times 30. So 2 times 30 is equal to 60. Now we look and see if either of these numbers are prime, and 2 is prime, so I'm going to circle it, but 30 is not prime. So what I'm going to do is I'm going to think of two numbers that times together to give me 30. So 3 times 10. Now 3 is prime, so I circle it, whereas 10's not. So I'm now going to think of two numbers that multiply together to give me 10, and that's going to be 2 times 5. Never choose 1 in the number itself because you don't get any further. So 10 would be 2 times 5, so 2 times 5, and let's circle them. And that's it, we're finished. So 60 is equal to 2 times 3 times 2 times 5. So let's write that out. 60 is equal to, and let's just do it in order. So instead of doing 2 times 3 times 2 times 5, I'm going to do 2 times 2 times 3 times 5. So 2 times 2 times 3 times 5. And let's just check it works. 2 times 2 is equal to 4, times 3 is equal to 12, times 5 is equal to 60. And as you can see, we've written 60 as a product of primes. But the question says to write it in index form. Now, as you've just seen earlier on with index notation, if you get something such as 2 times 2, that's 2 squared. So we can write 60 is equal to 2 squared multiplied by 3 multiplied by 5. So we have written 60 as a product of primes in index form. And that's it. And it's very important to be able to do that. And video 223 will go through that. And also, if you go to corbettmaths.com and you go to videos and worksheets and you scroll down to 223, as well as having the video tutorial, there will be some practice questions and textbook exercises on this topic. So if you do want extra practice, feel free to do those. But also remember there's the revision booklet, which you can print. It's the links in the description below. And if you have that, there's some questions on this now. Okay, let's have a look at our next topic. So our next topic is applying product of primes, and that's video 223A in Corbettmaths. So let's start off by looking at this question. So a number m has been written as a product of primes as 2 multiplied by 3 squared. So this is m, 2 multiplied by 3 squared, and the first part A is to say what number is m. So let's work this out. Now remember, we've got our order of operations. That is, we do any brackets? No. Orders, now that's another name for powers, so that's squared. So we're going to work out the squared first of all. So we're going to do 3 squared. So 3 squared is 9. And then we're going to multiply by the 2. 2 times 9 is equal to 18. So that means that m is equal to 18. And part B says, write the number 10m as a product of primes. So 10m, well, if we know that m is equal to 18, 10m would be equal to 10 times m. So that would be 180. So you could take 180 and do that prime factor tree and find out what 180 is as a product of primes. Now what's really useful here is we know that 10 is equal to 2 times 5. So two prime numbers, 2 and 5, multiplied together would give me 10. 2 times 5. Now we know that m is equal to 2 times 3 squared. So m is equal to 2 times 3 squared. So if we multiply this 10 by m, which is 2 times 3 squared, that would be our answer. But we want to write this obviously in index form. And as you can see, we've got 2 times 5 times 2 times 3 squared. I would look at the 2's first of all. You've got 2 times 2, which is 2 squared. We've then got our 3 squared, so multiply by 3 squared, and then multiply by 5. So 2 squared times 3 squared times 5 would be 10m. And we can check that, because remember we knew that 10 times m was 180. Let's check this as 180. 2 squared is 4, 3 squared is 9, 4 times 9 is 36, and multiplied by 5 would be 180. So that means that 10m as a product of primes would be 2 squared times 3 squared times 5. Okay, and next part. Now we can also use product of primes to find square numbers and cube numbers. So for instance, if we knew that 280 was 2 cubed multiplied by 5 multiplied by 7, and we were asked what the lowest whole number that 280 would need to be multiplied by to give a square number, what we can do is we can consider what a square number is. So a square number is a number multiplied by itself, and that would give you a square number. So if we take what we've been given here, so 280 is 2 cubed, that's 2 times 2 times 2 times 5 times 7, just writing it out in full. If we share these prime numbers out as evenly as possible, and then find out what extra ones we need, then we can find out what number you can multiply 280 by to get a square number. So let's share these numbers out as evenly as we can. So we've got 2, 2, 2, that's 3 2's. So we're going to have to give one circle 2 2's and one circle 1 2. We've got a 5. Well, unfortunately, that's just going to have to go in one of the circles as well. We can't, we don't have 2 5's. And we've got a 7. So again, that's going to have to go in one of the circles. Now we want the same thing in both of these circles. So let's put some extra prime numbers in this circle. So we had 2 2's. So we're going to need another 2. We're going to need a 5. And we're going to need a 7. If we multiply 280 by 2, 5 and 7, that should give us a square number. So let's see what 2 times 5 times 7 is. So 2 times 5 times 7 is equal to, well, 2 times 5 is 10, times 7 is 70. So if we multiply 280 by 70, we should get a square number. So 280 multiplied by 70 is equal to 19,600. And if we work out the square root of that, we get that's equal to 140. So it is a square number. So if you want to find a square number, what you need to do is share out the prime numbers that you've been given as evenly as possible, and then add in the extra ones you need. And there is a bit of a shortcut. If we take all the numbers in the circles here, are 2 times 2 times 5 times 7 times 2 times 2 times 5 times 7, that would be 2 times 2 times 2 times 2, which is 2 to the power of 4, times by, and we've got 5 times 5, that's 5 squared, and we've got 7 times 7, that's 7 squared. If you notice, all the powers are even. So if you want a square number, all you'd need to do is to make all the powers even. So if I was doing this question, I would first of all just look and see, well, it's 2 cubed, well, I'm going to need an extra 2. I've got 5, well, that's 5 to the power of 1, so I need an extra 5. And I've got 7 to the power of 1, so I need an extra 7. So if I multiply this by 2 and by 5 and by 7, I will get a square number. And likewise, if I wanted to find a cube number, all the powers would have to be multiples of 3. So for instance, if I had 2 to the power of 9 multiplied by 5 to the power of 3, that would be a cube number because this power is a multiple of 3 and this power is a multiple of 3. We use the product of primes to work out the LCM, that's the lowest common multiple, or the HCF, the highest common factor. So let's have a look at our first question. So let's write some numbers as product of primes, and then we'll use that information to find the lowest common multiple and the highest common factor. So our first part says, write 92 as a product of primes. So I'm going to do my prime factor tree. So 92, that's 2 times 46. Let's circle the 2. And 46, that's 2 times 23. And they're both primes, so let's circle them. So 92 as a product of primes would be 2 times 23. And in index form, that would be 2 squared times 23. Now our next question is to write 48 as a product of primes. So I'm actually going to use my calculator to write 48 as a product of primes. So on my calculator, I've got this yellow fact there. So what I do is I press 48, then press equals, and 48 comes up in my calculator display. Then I press shift, and then where it says fact there, and on the display it will show me 2 to the power of 4 multiplied by 3. So 48 equals 2 to the power of 4 times 3, or 2 times 2 times 2 times 2 times 3. So we've got 92 as a product of primes, and we've got 48 as a product of primes. Let's now use that information to work out the lowest common multiple and the highest common factor of those numbers. So here we've got our question. It says write down the highest common factor of 48 and 92 and write down the lowest common multiple of 48 and 92. So let's write down what they were as product of primes again. So 48 was equal to 2 to the power of 4 multiplied by 3, or if we wrote it out in full, it would be 2 times 2 times 2 times 2 times 3. And 92 was equal to 2 squared multiplied by 23, or in full 2 times 2 times 23. Now let's put those numbers in our Venn diagram. So here we've got a Venn diagram, and we've got one circle for 48 and we've got one circle for 92, and we're going to put their prime factors into this Venn diagram. So first of all, let's see if they share anything. So as you can see, 48 is 2 times 2 times 2 times 2 times 3, and 98 is 2 times 2 times 23. So they've both got 2 2's. 92 has got 2 2's, and 48 has got 2 2's. So we're going to put 2 2's in the middle. Now, as you can see here, 48 had 2 more 2's, so let's put those 2 2's in the 48 side. 48 also had a 3, but 92 doesn't, so let's put the 3 there as well. And finally, 92 has a 23, so we'll put that into the 92 side. So as you can see in both circles, we've got 48, and we've got 2 times 2 times 2 times 2 times 3, and that's 48. And for the 92 circle, we've got 2 times 2 times 23. So you put what they share in the middle, and then you put the extras onto each side. So the first question says, work out the highest common factor of 48 and 92. So to find the highest common factor, we multiply the prime numbers in the middle. So we're going to do 2 times 2. So the highest common factor will equal 2 times 2, and 2 times 2 is equal to 4. So the highest common factor is 4. Okay? Our next question says to work out the lowest common multiple of 48 and 92. So to find the lowest common multiple, we multiply all the numbers in the Venn diagram. So we're going to do 2 times 2 times 3 times 2 times 2 times 23, or in order, the lowest common multiple equals 2 times 2 times 2 times 2, because there's 4 2's, times 3 times 23. And when we do that, we get that's equal to 1104. So we've worked out the highest common factor and the lowest common multiple of 48 and 92 really quickly and easily by using this Venn diagram. So what you do is you write each number as a product of primes, you put the numbers into the Venn diagram and make sure whichever ones they share go in the middle and put the extras on each side, and that's it. And to find the highest common factor, you multiply the prime numbers in the middle, and to find the lowest common multiple, you multiply all the numbers in the Venn diagram. Okay, let's have a look at our next topic. So our next topic is called standard form. And a number is in standard form if it's in this format, where we've got a number between 1 and 10. So it's a number bigger than or equal to 1, but less than 10. So for instance, 1 or 4.22 or 9.9 multiplied by 10 to a certain power. So maybe 10 cubed or 10 to the power of 8 or even 10 to the power of negative 3. And I'm actually going to do this part of the video twice. I'm going to actually use two different techniques here, because some teachers will use a technique where they add zeros or move decimal points, and some teachers will move the digits and say the decimal points have to stay fixed. My job is to help you and make sure that I cover the way that you are familiar with, and I don't want to confuse you by using just one technique and then you think, oh, hold on, my teacher talks about it in a slightly different way. So to begin with, I'm going to talk about adding zeros and moving decimal places, and then I'm going to do the questions again by moving the digits rather than the decimal points. So first of all, if we had 7,000 and we wanted to write it in standard form, well, a number between 1 and 10 to choose, well, I'm thinking 7 would be a good choice, and then we're going to multiply it by 10 to a certain power. Now, whenever we have a whole number and we multiply by 10, we add a 0 on. So 7 times 10 is 70 by adding a 0 on. If here we want to add 3 zeros on, so what we actually want to do is multiply 7 by 1,000, and that would be 10 cubed, because 10 times 10 times 10 is 1,000. Now notice that if you have a whole number and you want to add 1, 2, 3 zeros on, the power would just be 3. So the answer would be 7 multiplied by 10 cubed. If we had a number such as 80,000, which is 8 followed by 4 zeros, we could have 8 multiplied by it, and because this is a whole number, we could say it's 10 to the power of 4, because it's 1, 2, 3, 4 zeros. Okay, let's have a look at our next one. So our next one is to write 2,500,000 in standard form. So we're going to choose a number between 1 and 10. Now we've got 2, 5, so we're going to choose 2.5 here, because that's a sensible number to choose between 1 and 10. Now what we're going to do is we're going to figure out if we have 2.5, how many times we need to move the decimal point to get it at the end of the number. So we want to move the decimal point from here to here. So we would move it 1, 2, 3, 4, 5, 6 times. So that means we need to multiply 2.5 by 10 to the power of 6, because that would move the decimal place 1, 2, 3, 4, 5, 6 places to the right. Okay, next let's look at some small numbers. So here we've got 0.00004. So that would be 4 would be our number we would choose between 1 and 10. We need to multiply by 10 to the power of. Now we've got a small number here which is less than 1, so this is going to have a negative power, and we need to figure out how many times we move the decimal point to get from 4 to be this number. So if we had 4, the decimal point would be here, and we would move it 1, 2, 3, 4, 5, 6, 7 times. So answer would be 4 times 10 to the power of negative 7. Or a student once actually told me a bit of a shortcut. They said, well, so there's 1, 2, 3, 4, 5, 6, 7 zeros in front, so you can just write 4 times 10 to the negative 7. And I thought that was quite a neat way to do it, is just count the number of zeros. Okay, and finally, we've got 0.018, and if we want to write that in standard form, well, it's going to be 1.8, because that's the number we would choose between 1 and 10, multiplied by 10. And now we've got 1.8, so the decimal point's here, and we want to move the decimal point 1 twice to the left, so the power would be negative 2. Alternatively, you might have spotted the pattern that my student mentioned to me, and because it's a small number, a 0-point number, and it's got 2 zeros, it'll be to the power of -2. Okay, now let's have a look at these questions using the other approach, so let's get rid of that. Okay, let's have a look at our first question. So our first question is to write 7,000 in standard form. So we want a number between 1 and 10, and a sensible number to choose here would be 7, and we're then going to have multiplied by 10 and to a certain power. Now if we have 7, 7's in the units of the ones column, and we want to move it 1, 2, 3 columns to the left. So we want to move this 7 3 columns to the left. So we would multiply by 10, 100 and 1,000. So actually 1,000 is 10 cubed. So if we want to move it 3 columns to the left, we have a power of 3. So the answer would be 7 multiplied by 10 cubed. Next, we've got 2,500,000. So we've got to choose a number between 1 and 10. So a sensible choice here would be 2.5 and then times 10 and to a certain power. So let's put 2.5 in. So the 2 would be in the ones column or the units column there. We'd have our decimal point and we'd have our 5. And we want to move the digits 1, 2, 3, 4, 5, 6 columns to the left. So we would have to the power of 6. So 2.5 times 10 to the power of 6 would be 2,500,000. Okay, let's have a look at some small numbers. So we've got 0.0000004. So that would be, well, we need a number between 1 and 10. So we're going to have 4 times 10. Now, because this is a small number, we're going to have a negative power because 10 to the -1 is 0.1. So we'll be multiplied by 0.1. 10 to the power of -2 would be 0.01 and so on. So we want a negative power, a very small number. And if we put our 4 in our units or our ones column there, we want to move the 4 1, 2, 3, 4, 5, 6, 7 columns to the right. So because we want to move it 7 columns to the right, the power would be -7. So the answer would be 4 multiplied by 10 to the power of -7. And finally, 0.018, well, a sensible number to choose between 1 and 10 would be 1.8. And we want to multiply it by 10 to the power of negative something because we want it to be smaller. And we've put our 1.8 in our columns. Our 1 is in our units column or our ones column, and we want to move it to our hundredths column. So we want to move the 1, 2 columns to the right. So we want to times it by 1.8 times 10 to the power of -2. Okay, next. Now let's look at how we would write numbers that are almost in standard form in standard form. So if we have a look at this number, 562.8 times 10 to the power of 5, this number is almost in standard form. And what I mean by that is we need a number between 1 and 10, and this number at the front isn't between 1 and 10. So we need to make it between 1 and 10. So if I had the number 562.8, I would divide that by 100, because if I divide that by 100, I would get 5.628, and that's between 1 and 10. But if I divide one number by 100, so for instance, if I had 700 multiplied by 2, the answer is equal to 1,400. If I divide this number by 100 and get 7, I would need to multiply this number by 100 to get 200 to still keep the same answer. So if I've divided this by 100, I need to multiply this by 100 to make sure our answer stays the same. So it's going to be 5.628 multiplied by 10. So if I multiply this by 100, I'd multiply by 10, so that'll be 10 to the power of 6, and I multiply by 10 again, so that'll be 10 to the power of 7. So the answer would be 5.628 times 10 to the power of 7, and that's it. Okay, let's have a look at another one. Okay, this time we've got 0.0024 times 10 to the power of 9. Now this isn't a standard form because this number needs to be between 1 and 10. So we're going to have to write 2.4 here because that would then make sure that we would have a number between 1 and 10 at the front. And then we would do multiply by 10 to the power of something. So we'll multiply this by, well, we've moved the 2, 1, 2, 3 places to the left. So we'll multiply this by 1,000. So if we multiply this by 1,000, we need to divide this by 1,000. So dividing it by 10 would be 10 to the power of 8. Dividing it by 10 again would be 10 to the power of 7. And dividing it by 10 again would be 10 to the power of 6. Or another way to look at it is if we were dividing it by 1,000, remember that's 10 cubed. And then if we take away the powers, we get 10 to the power of 6. And that's it. So just make sure that if you have a number that's almost in standard form, if you make the number at the front 10 times larger, you need to make the times by 10 bit 10 times smaller to make sure that the answer stays the same. Okay, next. Okay, let's look at how to do our arithmetic with numbers in standard form. So how to do adding numbers in standard form, multiplying numbers in standard form, dividing numbers in standard form, and so on. Now, with adding numbers in standard form, there's no set rule. So if I had 5.3 times 10 to the power of 7, plus 7.96 times 10 to the power of 8. The way I would do this question would be to write them out in full. So I'm going to write our 5.3 times 10 to the power of 7 in full. So that would be 5, 3, and then 1, 2, 3, 4, 5, 6 zeros. And then we've got 7.96 times 10 to the power of 8 will be plus 796. So that'd be 796, and then we would then have another 6 zeros, 1, 2, 3, 4, 5, 6, and then we need to add these numbers together. And whenever we're adding them together, I'm just going to use the column method. So let's line them up. So we've got 7, 9, 6, and then 1, 2, 3, 4, 5, 6 zeros, 5, 3, and then 6 zeros. So 1, 2, 3, 4, 5, 6, and then 3, 5. Okay, and then we're going to add them. So let's just add them and see what we get. So it would be 0 plus 0 is 0, 0, 0, 0, 0, 0. We've then got 6 plus 3 is 9. 9 plus 5 is equal to 14. So put the 4 down, carry the 1. And 7 plus 1 is equal to 8. So the answer would be 849 million. Or we might want to write it in standard form again. So it would be 8.49 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8. So it would be to the power of 8. And that's it. Okay, let's have a look at our next question. So the next question is multiplying numbers in standard form, and I like this because we can now put together our laws of indices. If we have 9 times 10 to the power of 4 multiplied by 2 times 10 to the power of 5, so what we can do is we can multiply the numbers at the front. We can do 9 times 2 is equal to 18, and then we can multiply the 10 to the powers. So we could do 10 to the power of 4 multiplied by 10 to the power of 5. And whenever we're multiplying things with the same base, they're both 10 to the power of something, we add the powers. So we would do 10 to the power of 4 plus 5 to the power of 9. So that's not our answer, because that's 18 times 10 to the power of 9. Remember, if for our answer to be in standard form, we want it to be between 1 and 10. So we're going to do 1.8 times 10. Now we've made 18 10 times smaller, so we need to make this 10 times larger. So 10 to the power of 9 times by 10 would be 10 to the power of 10. So the answer would be 1.8 times 10 to the power of 10. Now, as well as being able to do this in a non-calculator paper, it's also important to be able to do it in a calculator paper. So let's have a look and see how we would type this in our calculator. So on our calculator, we've got our standard form button here, down at the center there at the bottom. We've got our multiply by 10 to the power of x there. Now, whenever I'm doing a question like this, I tend to like to use brackets. So I would write it like this. So I would open up my brackets to begin with. I would press my 9, because that's the number between 1 and 10 we're going to use. And then I would press the standard form button there. And then you would get, it would come up with 9 times 10, and then you'd press 4, and that would be how you type in 9 times 10 to the power of 4. It looks something like this, and then close brackets. So you open up your brackets, you press 9, the standard form button, and then press 4 to show that the power is 4, and then close brackets. Then press times, and then for this 2 times 10 to the power of 5, you're going to do 2, the standard form button, and then 5. And then close brackets and press equals. And you should get this as your answer. It'd be a good idea to practice that now. Get your calculator and try typing this in. And the answer in your display should look something like this, where we had 1.8 times 10 to the power of 10, and that was our answer. And that's it. Okay, let's have a look at our next question. So this time we've got a division question, and we've got 4.5 multiplied by 10 to the power of 7 divided by, or over, 9 times 10 to the power of negative 5. So we've got a large number divided by a very small number. And whenever we divide by a very small number, it's going to get even bigger. So let's have a look at this question and see what we do. So we've got 4.5 times 10 to the power of 7. And we're dividing that by 9 times 10 to the power of negative 5. So we're going to do 4.5 divided by 9. Let's actually do that quickly. Now I know the answer is 0.5, but I'm just going to show you how. 4 divided by 9 is 0, remainder 4. And 45 divided by 9 would be equal to 5. So that would be equal to 0.5. So 4.5 divided by 9 is 0.5. Then we've got our multiply by 10 part. So we've got 10 to the power of 7 divided by 10 to the power of negative 5. And remember, whenever we're dividing, we take away the power. So we've got 7 minus 5. And 7 minus 5 would add on the 5 would be multiplied by 10 to the power of 12. Because 7 minus 5 would be 12. So we would get 0.5 multiplied by 10 to the power of 12. Now this isn't in standard form because this needs to be between 1 and 10, so we're going to multiply that by 10 to get 5, but we need to divide this by 10, so 10 to the power of 12, take away one of those 10s would be 10 to the power of 11. So that would be 5 multiplied by 10 to the power of 11. Okay, let's have a look at our next question. So this time we've got a situation that involves standard form. And the question says, an asteroid travels at 25 kilometers per second. And we're asked, how far does it travel in 1 hour? Give your answer in meters and in standard form. And because we've been asked to give our answer in meters, let's change this 25 kilometers into meters. So that would be 25,000 meters, because there's 1,000 meters in a kilometer. So it's traveling at 25,000 meters per second. And we're asked to find out how far it travels in 1 hour. So let's work out how many seconds are in 1 hour. So there's 60 seconds in a minute, and then there's 60 minutes in an hour. So if we do 60 times 60, that's equal to 3,600. So there's 3,600 seconds in 1 hour. And we've been asked to work out how far does it travel. So remember, we've got speed, distance and time. So distance is equal to speed times time. So if we multiply the speed by the time, because it travels 25 kilometers every second and it travels for 3,600 seconds, if we multiply those two together, we should get our answer. So we've got 25,000 multiplied by 3,600. And we get that's equal to 9 followed by 7 zeros, or 90 million, so 90 million meters. Now the question says to give our answer in standard form. So this is a very large number, so we want to give this in standard form. So a number between 1 and 10, well, let's choose 9 multiplied by 10 to the power of 1, 2, 3, 4, 5, 6, 7. So the answer would be 9 multiplied by 10 to the power of 7 meters. Okay, so our next topic is expressing as a percentage. So whenever I'm expressing something as a percentage, I tend to express it as a fraction first of all, and then I change it into a percentage. So the question says, in a box there's 20 counters. 9 of the counters are blue. What percentage of the counters are blue? So I'm going to express that as a fraction to begin with. I know that 9 of the counters are blue, so I know there's 20 counters in the box and 9 of them are blue. So that means that 9/20ths are blue. Now, if I'm doing this on a non-calculator paper, I want to get this to a percentage, which means that I want to write this as a fraction with 100 on the denominator. To get from 20 to 100, we multiply by 5. So 20 times 5 is 100. I then look at my numerator, which is 9, and I times that by 5 as well. And 9 times 5 is 45. So that means that if I know that 9/20ths of the counters are blue, that would be the same as 45 out of 100 being blue, which is 45%. So that's how I would do it without a calculator. But if I was doing this on a calculator, what I would tend to do is I would write it as a fraction to begin with, which is 9/20, like so. And then I want to change that into a percentage, so I would just do 9 divided by 20 on my calculator, and 9 divided by 20 on my calculator is equal to 0.45. So I would just do the division, 9 divided by 20, and that gives it as a decimal, 0.45. And then I times by 100, so I times by 100, and that would give me 45%. Okay, our next topic is percentage of amounts, and this is a very important topic, and quite often we'll be asked to do it either with or without a calculator. I'm going to do it without a calculator to begin with, and then I'm going to show you how to do it on a calculator. So this is videos 234 and 235 in Corbettmaths. Now, whenever I'm working out percentage of amounts without a calculator, I tend to remember these 4 building blocks. You've got 50%. To find 50% of something, you divide by 2. To find 25% of something, you divide by 4, or you half it and half it again, and that will give you 25%. So that's divided by 4, half and again. Then we've got to find 10%, you divide by 10, and to find 1%, you divide by 100. And with these 4 building blocks, we should be able to work out these questions quite nicely. So our first question says, work out 25% of 60. So to find 25% of something, you divide by 4. So we're going to take our 60 and we're going to divide it by 4. So 60 halved is 30 and halved again is 15. So the answer would be 15 centimeters. Okay, our next question. Our next question says find 60% of 800. So what I'm going to do is I'm going to find 50%, I'm going to find 10%, and then I'm going to add them together. So if we take our 800 and we take 800 and we divide it by 2, we will find 50%. So 800 divided by 2 is equal to 400. So that's equal to 400, so that's 50%. Now we want to find our 10%. So to find 10%, we divide by 10. So we take our 800 and we divide it by 10. And 800 divided by 10 is 80, and that's 10%. Now we want to find what 60% is, so we would add these two together. So if we add our 50% and 10%, we will find 60%. Now 400 plus 80 is 480. So 60% of 800 is equal to 480. Okay, and our last question. Our last question says find 5% of 90. Now to find 5%, I tend to want to find 10% and then half it. So let's find 10% of 90 to begin with. So to find 10%, we divide by 10. So we're going to do 90 divided by 10. And 90 divided by 10 is 9, so that's 10%. So we find 10% is equal to 9, but we want 5%, which is half of 10%. So if we do 9 divided by 2, that's equal to 4.5. So the answer would be 4.5. So whenever we find a percentage of amounts with a calculator, there's two common approaches. One of them is to find 1% and then multiply by the percent you want. So for instance, if we were asked to find 19% of 240, what I would do is I would divide 240 by 100 to find 1%. So I would do 240 divided by 100 to get 1%. And because it's a calculator, you can type in 240 divided by 100 and you get 2.4, so 2.4. And then if we wanted to find 19% of 240, I would just take our 1%, which is 2.4, and I would multiply by the percent we want, which is 19. So then you do 2.4 multiplied by 19, and you'll find an answer of 45.6, and that's it. So 19% of 240 is 45.6. So to find the percentage of an amount on a calculator, I tend to divide by 100 to find 1% and then multiply by the percent you want. And there is another approach, and that's by changing the percentage that you want to find of the number into a decimal. So changing 19% to a decimal, that's 0.19. This is called a multiplier, and you multiply the 0.19 by the 240, and that would give you 45.6 as well. So if you want to find a percentage of an amount on a calculator, you can divide by 100 to find 1% and times by the percent you want. Or you could change the percentage of the amount you want to find, so 19% into a decimal, and then you can multiply that decimal, that multiplier, by the number you're finding the percentage of. So you could do 0.19 times by 240. Okay, let's have a look now at finding a percentage of an amount where the percentage is greater than 100%. So we're going to find 180% of £300. Now, there's lots of different ways to do this, but I'm going to show you one way to begin with, and then I'll talk about a few other approaches you could use at the end. So we're going to find 180% of £300. So what I'm going to do is I'm going to find 80% of £300 and then add it on to 100% of £300. So let's find 80% of £300 to begin with. So let's find 80%. So to find 80%, what I'm going to do is I'm going to find 10% and then times it by 8, and that would give me 80%. So let's find 10% of £300. So 10% of £300, if I divide £300 by 10, I will get 10%, which is equal to £30. So £30 is 10% of £300. Now we want 80%, so I'm going to times that by 8 to get 80%. So I'm going to find 80% of £300. So 80% of £300, if I times that by 8, well, 8 times 3 is 24, so 8 times 30 would be £240. So we've now found 80% of £300, which is £240. Now to find 180%, I just need to add that on to 100%. So 100% of £300 would obviously just be £300. So if I take our £300, or 100%, and I add the 80%, which is £240, that will tell me 180% of £300. So 300 plus 240 would be equal to £540. So 180% of £300 would be £540. So that's one way to do it. There's other approaches that we could use. We could take our £300 and we could divide it by 100 to get 1%, which would be £3, and then we could just times by 180, and that would tell us 180%, which is equal to £540. Okay, and that's it. Okay, so our next topic is percentage change, and this is video 233 in Corbettmaths. So percentage change is calculated by change divided by original times 100. Sometimes in a question you might be asked to find the percentage increase, percentage decrease, percentage profit or percentage loss, and they'll all be calculated the same way by using this formula. So here's a typical question. It says the height of a plant increases from 30 centimeters to 46 centimeters. Work out the percentage increase. So the formula is change. So as you can see, the change is 16 centimeters, so change is 16, divided by the original, which would be 30, and then times by 100. So if we do 16 divided by 30 times 100, we get that's equal to 53.333 and so on percent. So the percentage increase would be 53.333 so on percent. Or we could round this. Sometimes in the question you're asked to give your answer to 1 or 2 decimal places. So let's round this to 2 decimal places. So the answer would be 53.33%. And that's it. So percentage change is change divided by original times 100. Okay, our next topic. Okay, let's have a look at our next topic. So our next topic is simple interest. So simple interest is where interest is added on to money in a bank account, and simple interest is where the same amount is given every single year. So the question says £600 is invested for 3 years at 5% per year simple interest. Work out the total interest. So in this question we're told that it's 5%. So let's work out 5% of 600. So let's take our 600 and divide it by 100. So that'll tell us 1%, which is 6. And then take our 6 and multiply it by the percent we want, which is 5. 6 times 5 is equal to 30. So every single year, because it's simple interest, every single year £30 of interest is earned. So in the first year, £30 added on, in the second year, £30 added on, and so on. And we've been asked to work out the total amount of interest. So the money's been invested for 3 years. So that means that 3 lots of 30 has been earned in interest. So 30 multiplied by 3 is equal to 90. So the question asks us to work out the total interest earned. So that would be £90. And that's it. If we were asked how much money would be in the bank account at the end of the 3 years, that 90 would be added on to the 600, so that would be £690. But the question just asks us for the total interest, so that would be £90. Right, so our next topic is compound interest, and that's video 236 on corporate maths. So compound interest is where the interest is added at the end of every single year. So our question says, James invested £8,000 in the bank for 2 years, and it earns compound interest at a rate of 5% per year. Calculate the total amount of money that James has in the bank at the end of 2 years. Now, there's 2 different ways to do this question, and I'm going to show you both approaches now. The first approach is to just treat it like a percentages question. So we're going to increase it by 5% to see how much James has at the end of the first year, and then to work out another 5% of that and add that on to see what he has at the end of 2 years. So at the beginning he has £8,000, and let's work out 5% of that. So let's divide that by 100 and times by 5. So when we divide by 100, we get that's equal to 80. And if we do 80 multiplied by 5, because it's 5%, that gives us £400. So 5% of £8,000 is £400. Now if we add that on, that's how much money James has at the end of the first year. So at the end of the first year, James would have 8,000 plus 400, that's £8,400. Now, to see how much money James has at the end of the second year, we now need to work out 5% of this and add it on to find out what he has at the end of the second year. So if we take our £8,400, because that's how much he has, divide that by 100, we get that's equal to £84. And then if we take our £84 and we times that by 5, we get 5%. So 84 multiplied by 5 is equal to £420. So in his second year, James earns more interest. He earns £420. And if we add that on to the 8,400, we'll see how much money James has in the bank account at the end of 2 years. So 8,400 plus 420 is equal to £8,820. So at the end of 2 years, James has £8,820 in the bank. So that's one approach, and that's quite a useful approach for a small number of years, maybe 2 years. But as we go into 3 years, 4 years, 5 years, it can get quite time consuming to do it that way. So there is a quicker way to do that. And to do that, I'm going to show you another topic called multipliers and then come back to compound interest. So we're going to look at multipliers, which is video 239 in corporate maths. Now, increasing by a percentage and decreasing by a percentage. Now, we can use a thing called a multiplier to do that really quickly and easily. So if we were asked to increase 500 by 8%, we can use a multiplier. Now, if we start off with 100% and we increase by 8%, we'll have 108%. And 108% is the same as 1.08 as a decimal number. So that would be our multiplier. So if we increase by 8%, we'll have 108%, and that's 1.08. So if we take our number, 500, and we multiply by 1.08, that will tell us our answer straight away. It will increase 500 by 8%. So that would be, if we do 500 multiplied by 1.08, that gives us 540. So if we increase 500 by 8%, the answer would be 540. So we can use this multiplier really quickly and easily to do it. So next one, if we wanted to increase 3,500 by 13%, well, the multiplier, well, if we had 100% and we increase by 13%, that's 113%. So our multiplier is 1.13. That's an increase of 13%. So if we take our 3,500 and multiply by 1.13, we get our answer. So 3,500 multiplied by 1.13 is equal to 3,955. So these multipliers are really great for increasing by percentage really quickly and easily, and that'll be useful for compound interest. Likewise, we can decrease using a multiplier. If we decrease something by 2%, we're left with 98% because we would have started with 100%, and decreasing by 2% leaves us with 98%. So as a multiplier, 98% is the same as 0.98, converting the percentage to a decimal. So we can just multiply 3,000 by 0.98, and that would tell us our answer right away. So 3,000 multiplied by 0.98 is equal to 2,940. So you can use a multiplier to decrease by a percentage as well. So if we wanted to decrease 8,000 by 24%, we would take our 8,000 and we would multiply by, well, we would have started off with 100%. We're decreasing by 24%, so 100 take away 24, 76. So our multiplier would be 0.76. And if we multiply those, we'll get our answer straight away. So 8,000 multiplied by 0.76 is equal to 6,080. And that's it. So this topic of multipliers will be really useful whenever we're looking at compound interest, because if we go back to our question, we had James invested £8,000 in the bank account for 2 years. It earned compound interest of 5% per year. So 5% increase would be 1.05 as a multiplier, because it's gone from 100% to 105%. So we can use this multiplier really quickly and easily to work out our answer. So if we want to work out how much money James had in the bank account after 1 year, we could take the 8,000 and multiply by 1.05. If we wanted to work out how much money he had at the end of 2 years, we could then times by another 1.05, and that would tell us how much money he has in the bank after 2 years. Or a really quick and easy way to do it is to do 8,000 multiplied by, because we're multiplying by 1.05 and multiplying by 1.05, we could write 1.05 squared using that index notation. So we could do 8,000 multiplied by 1.05 squared, and let's see what we get. So 8,000 multiplied by 1.05 squared equals 8,820. And that's the same answer as before. So this is really quick and easy way of doing compound interest questions, and it's got a formula. It's the initial, so the amount of money or whatever started with, multiplied by the multiplier to the power of time. So this formula will help us work out compound interest questions really easily. So our initial is the amount of money that was invested to begin with, the 8,000. Our multiplier, because it's a 5% increase, we used 1.05, so that's the multiplier. And because it was 2 years, so we used squared. If it was 3 years, we'd use cubed. If it was 4 years, we'd use to the power of 4, and so on. And that's it. Okay, let's have a look at our next topic. So our next topic is growth and decay. And here's a typical question. It says the population of an island at the beginning of 2018 was 50,000. And each year the population increased by 2%. Work out the population of the island at the beginning of 2023. Give your answers to the nearest 100. Now in a question like this, we can use the compound interest formula. We can use the initial times multiplier to the power of time. And that'll be really useful in a situation like this, because we're increasing by 2% each year. So first of all, our initial. The population initially was 50,000, so we're going to use 50,000. And then we're going to multiply that by the multiplier. Well, it's a 2% increase, so that will be as a multiplier 1.02, because you're increasing by 2%. You're going from 100% to 102%. So as a multiplier, that would be 1.02. And to the power of time. Well, between 2018 and 2023, that's 5 years, and it's increasing at 2% per year. So we've got 5 years, so it's going to be to the power of 5. So that's it. So we're going to work out 50,000 multiplied by 1.2 to the power of 5. And when we do that, we get an answer of 55,204.04 and so on. Now in the question said give our answer to the nearest 100. So to the nearest 100, our answer would be 55,200. And that's it. And this compound interest formula can be really useful whenever you're dealing with situations that involve growth, so whenever things are getting bigger, such as this, an increase of 2% each year, or decay, so that might be whenever things are getting smaller, so whenever your multiplier will be a 0 point something number, and that's it. So here we've got a finance question. And you'll see lots of videos on Corbettmaths under finance. So if you go to video 400, there's 400A, B, C, and so on. And there's lots of different finance topics there that will be useful. So here's a typical question. It says the value of a car decreases by 5% each year. And so if you bought a car 2 years ago for £10,000, work out the value now. So we can use the same formula, initial multiplied by the multiplier to the power of time. So initially the car cost £10,000. And then the multiplier, well, it's decreasing by 5% each year. So if we had 100% and we took away 5%, we'd be left with 95%. So that's 0.95. And we're wanting to find the value of the car after 2 years. So that's going to be to the power of 2. So we do 10,000 multiplied by 0.95 squared. And that gives us £9,025. So the value of the car after 2 years would be £9,025. And that's it. So our next topic is reverse percentages, and that's video 240 in Corbettmaths. And remember, you can watch that video tutorial, video 240 in Corbettmaths, and I will go through reverse percentages in a lot of detail. Also, beside that video 240 in Corbettmaths, you'll find the practice questions, which are really great because they will have a lot of curveball questions in there, which are really fantastic to do. I'll have the textbook exercises, and I'll have the answers as well. So video 240, and also remember there's reverse percentages questions in that bumper pack of questions, which is in the description below. So here's a typical reverse percentages question. And it says Rebecca is given a 35% pay rise. She is now paid $13.77 per hour. What was Rebecca's pay before the pay rise? So to do this, what we need to do is consider the fact that we have increased her pay by 35%. So that means she now has 135% because she had 100% before pay rise, and then she's given a 35% increase. So she's now got 135%. And 135% is equal to £13.77. Now to find what her pay was before, we want to find 100%. So let's find 1% and then find 100%. So if we know what 135% is, we can divide by 135. We can divide by 135 and we can divide by 135. And when we do that, we get 1%, and 1% is equal to 0.102 pounds. And then we want to find what 100% is, so we'll multiply by 100. So let's multiply by 100, and let's multiply by 100. And when we do that, we'll get, well, 1% times by 100 is 100%, her pay before the pay rise. And whenever we multiply 0.102 pounds by 100, we get that's equal to £10.20. So Rebecca's pay before the pay rise was £10.20. Now there is another way to do this. I went for a topic called multipliers, and to increase by 35% we use a multiplier of, we multiply by 1.35. So if you want to go backwards and find what number was increased by 35%, we could divide by the multiplier. So if you do 1377 divided by 1.35, you'll also find £10.20, and that's it. Okay, our next topic. Okay, let's have a look at our next topic. So our next topic is simplifying ratios, and that's video 269 on Corbettmaths. And we're told the ratio of oranges to apples in a box is 4 to 6. And whenever you got those two little dots, you read it as the word 2. So 4 to 6. And what that means is for every 4 oranges, there's 6 apples. So as you can see here, for every 4 oranges, there's 6 apples. And sometimes we can cancel ratios down, because here we've got simplified 4 to 6. Well, both of those numbers are divisible by 2. So we divide both of them by 2. So 4 divided by 2 is 2. And 6 divided by 2 is 3. So if we had the ratio 4 to 6, we could simplify it to 2 to 3, and that would be an equivalent ratio. And that's it, and we've simplified these as far as we can go. Okay, let's have a look at some more ratios and simplify those. And our next one is simplify 35 to 10. So both of these numbers are divisible by 5, so let's divide both of them by 5. So 35 divided by 5, that's 7. And 10 divided by 5 is 2. So the answer would be, if we were asked to simplify 35 to 10, our answer would be 7 to 2. Okay, let's have a look at our next question. So our next question says simplify 28 to 40. Now both of these numbers are divisible by 4, so we can divide 28 by 4 and we can divide 40 by 4. So 28 divided by 4 is 7 and 40 divided by 4 is 10. So 28 to 40 would be the same as 7 to 10. So if you're asked to simplify 28 to 40, the answer would be 7 to 10. And we can't simplify this any further because the only whole number you can divide these by is 1, and that wouldn't actually help. Okay, let's have a look at our next topic. So our next topic is ratio, and writing ratios in the form of 1 to n or n to 1. And that means 1 to a certain number or a certain number to 1. And in certain situations it can be very useful to do that. So here we've got a question that says the ratio of adults to children on a school trip is 5 to 24. So that means that for every 5 adults there's 24 children. So there could be 5 adults and 24 children, or it could be 10 adults and 48 children. It could be 15 adults and 72 children. It could even be 50 adults and 240 children, and so on. And we've been asked to write this ratio in the form of 1 to n. So instead of being 5 to 24, we want it in the form 1 to a number. So we want the left-hand number in the ratio to be 1. So to go from 5 to 1, we're going to have to divide by 5. So 5 divided by 5 is 1. So if we divide the left-hand side of the ratio by 5, we're going to have to divide the right-hand side of the ratio by 5. So we're going to have to do 24 divided by 5 as well. So divided by 5. And 24 divided by 5 is equal to 4.8. So if we were asked to write the ratio of adults to children in the form 1 to n, the answer would be 1 to 4.8. And that means that for every 1 adult, there's 4.8 children. Now obviously there can't be 1 adult and 4.8 children, but what it does is it lets us know that for every 1 adult there's just under 5 children, or perhaps there's even a rule. It might be that for a school trip there needs to be a ratio of 1 to 4.5, so for every 1 teacher there's 4.5 children, and with there being 1 to 4.8 in this trip, that they're actually going past that rule. So writing a ratio in the form of 1 to a certain number or a certain number to 1 can be very useful. And if in this question, instead of being asked to write the ratio in the form of 1 to n, we were asked to write it in the form n to 1, what we would want to do is make the number on the right hand side of the ratio 1. So we'd divide both of these numbers by 24, and that would give us 0 point something to 1. Okay, let's have a look at our next topic. Okay, let's have a look now at forming ratios. So we're told there's red and purple counters in the bag, and there's 5 times as many purple counters as red counters in the bag. Write down the ratio of red counters to purple counters in the bag. So we don't know the exact number of counters in the bag, but we do know there's 5 times as many purple counters as red counters. So for instance, there could be 5 purple counters and 1 red counter. There could be 10 purple counters and 2 red counters. There could even be 50 purple counters and 10 red counters. So we don't know the exact numbers, but we do know there's 5 times as many purple counters as red counters in the bag. And we've been asked to write down the ratio of red counters to purple counters in the bag. So for instance, if there was 1 red counter, there would be 5 purple counters. So that means the ratio of red counters to purple counters in the bag would be 1 to 5. For every 1 red counter, there's 5 purple counters. And that's it. Now we could have chosen other numbers here. We could have said, for instance, there were 2 red and 10 purple, and then we could simplify the ratio, and when we divide both of these numbers by 2, we would get 1 to 5. So the ratio of red counters to purple counters in the bag is 1 to 5. So our next topic is ratios and fractions, and that's video 269A in Corbettmaths. And our question says, a box contains white beads and grey beads, and the ratio of white beads to the grey beads is 2 to 3. So we don't actually know how many white beads and grey beads there are, but what we do know is that for every 2 white beads, there will always be 3 grey beads, like so. And we're asked what fraction of the beads are grey. Well, if we have a look at this diagram, this little sketch, this will help us. So if we work out what fraction of this is grey, that will be the answer to how many fractions of the beads in the box are grey. So we've got altogether 5 beads here, 1, 2, 3, 4, 5. So we'll put 5 on the denominator. And for the numerator, what fraction are grey? Well, there's 3 that are grey. So that means that 3/5 of these 5 beads are grey. So that means that 3/5 of the beads will be grey. And that's it. So whenever you're asked to write a ratio as a fraction, a diagram, a little sketch like this can be very useful, and our answer here would be 3/5. And instead of being asked what fraction of the beads are grey, we could have been asked what percentage of the beads are grey. So we would then write it as a fraction, as we've just done, 3/5, and then we'd just change the 3/5 to a percentage. So then that would be 60%, because 3/5 is 60%. If we're asked the question what percentage of the beads were white, well, altogether there was 5 beads and 2 of them are white, so we would write that as a fraction, 2 out of 5, 2/5 of the beads are white, and then let's change that to a percentage. That would be, well, 2/5 is 40%, because 1/5 is 20%, so 2/5 is 40%, so the answer would be 40%. So if you're asked to change a ratio to a percentage, I would often change it to a fraction to begin with, and then change that fraction into a percentage. Now, whenever we're dealing with ratio questions, we may encounter questions that look like this. Omar says there's 91 beads in the box. Explain why he must be incorrect. So it's very useful to consider what the ratio means. So we've got the ratio of white beads to grey beads in the box is 2 to 3. So that means that in the box there could be, we could have white beads and grey beads, white and grey. There could be 2, because the ratio is 2 to 3, there could be 2 white and 3 grey, and altogether the total number of beads would be 5 there. Now there may not be 5 beads in the box, there may be more, so there could be another 2 white and another 3 grey. So another 2 white would be 4, another 3 grey would be 6, so that would be 10 beads altogether. Now there may not be 10, so there may be more beads. There may be, if we add another 2 white and another 3 grey, that would be 6 and 9, and 6 plus 9 is equal to 15. And as you notice, the total number of beads is a multiple of 5, because if we add the 2 and 3 together, every time we're adding another 5 beads. So Omar says there's 91 beads in the box. Well, there can't be 91 beads in the box, because if then the ratio of 2 to 3, that means it must be a multiple of 5. There must be a multiple of 5 number of beads in the box, and 91 isn't a multiple of 5. Okay, let's have a look at our next topic. So our next topic is sharing in a ratio, and that's video 270 on Corbettmaths. So here's part of the Corbettmaths revision card, and we've got Jack and Chloe share £75 in the ratio 2 to 3. How much money do they each receive? Now, it's very important to be able to share a number in a ratio, and to share a number in a ratio, the first step is to add together the parts in the ratio, because Jack gets 2 parts and Chloe gets 3 parts, so altogether 2 plus 3 would be 5, so there's 5 parts in total. Now what we're going to do is we're going to take the grand total of what they're sharing, so in this case it's £75, and we're going to do 75 divided by whatever you get whenever you add the ratio together. So we're going to divide it by 5, because 2 plus 3 is 5, so we know there's 5 parts in total. So if we divide 75 by 5, we'll see how much money is in one part. So 75 divided by 5 is 15, so that means there's £15 in one part. Now we know that Jack gets 2 parts and Chloe gets 3 parts, so that means that Jack gets 2 lots of 15 and Chloe gets 3 lots of 15. So for Jack, we're going to do 15 multiplied by his number in the ratio, which is 2, so 15 times 2 is £30. And for Chloe, she gets 3 parts, so we'll do the £15 multiplied by 3, her number in the ratio. So for Chloe, we'll do 15 multiplied by 3, and that's equal to 45. And what's great is if we add £30 and £45, we get the £75 that we started with. So if you're asked to share something in a ratio, the steps would be, first of all, add the parts together in the ratio, then divide the grand total by the total number of parts, and then times each of the numbers by how much is in one part, and that's it. Okay, let's have a look at our next topic, which is whenever we're dealing with ratio questions, whenever we're given one quantity, and that's video 271 on Corbettmaths. So here we've got the ratio of lemon sweets to strawberry sweets in a tub is 5:3. So in this tub, for every 5 lemon sweets, there's 3 strawberry sweets. And we're told there's 120 lemon sweets in the tub. So rather than the last time when we're told how many sweets there are altogether, what we're told is how many lemon sweets there are. And we're asked how many strawberry sweets will there be in the tub. So in a question like this, whenever you're given one quantity, we know there's 120 lemon sweets. Now we're told the ratio of lemon to strawberry is 5:3. So the lemon number in the ratio is 5. So if we divide 120 by 5, we'll find out how many sweets there are in one part. So 120 divided by 5 is equal to 24. So that means there's 24 in one part. And we find that by dividing how many lemon sweets there were by the lemon number in the ratio, the 5. Now we're asked how many strawberry sweets there were in the tub. Now strawberry is 3 parts, so what we'll do is we'll multiply 24 by 3. So we'll do 24 multiplied by 3, and that's equal to 72. So whenever you're given one quantity, so in this case we were told there was 120 lemon sweets, what you do is you divide that by the lemon part in the ratio, which was the 5, and whenever you do 120 divided by 5, that tells you how many sweets are in one part. And then you can times it by the other number in the ratio to see how many strawberry sweets there were in this case. And that's it. And if you were asked how many sweets there were in total, you could add together the 120 and the 72, and that'll tell you how many sweets there were altogether. So that's it. Okay, so we're now going to look at what happens whenever we're given two ratios, and this is video 271A in Corbettmaths. So here we're told that a farmer keeps sheep, cows and chickens on a farm, and the ratio of sheep to cows, so sheep to cows on the farm is 4:3, so that means that for every 4 sheep there's 3 cows, and the ratio of cows to chickens is 10:7, so that means that for every 10 cows there's 7 chickens. And we've been asked to find the ratio of sheep to cows to chickens. So whenever I'm given a question like this, I like to do a little table. So I like to write down what we've been given. So we've got sheep, cows and chickens. Now it could have been in the question, it may not have told us what we're looking at. It could have just been the ratio of A to B and B to C, and then the headings in my table would be A, B and C. But in this case we were told what we're looking at, sheep, cows and chickens. So the ratio of sheep to cows is 4:3. So sheep to cows is 4:3. So I'm going to write that ratio down, 4:3. And then we're told the ratio of cows to chickens is 10:7. So cows to chickens, and I'm just going to write that beneath, is 10:7. So if we have a look, we've got the ratio of sheep to cows is 4:3, and the ratio of cows to chickens is 10:7. So we've been asked to write this as one ratio of sheep to cows to chickens. So the key thing is going to be the cows, because if we have a look, the cows are in both ratios. For every 4 sheep, there's 3 cows, and for every 10 cows, there's 7 chickens. So if we can find a common multiple of 3 and 10, that will help us combine these as one single ratio. Now I'm going to find the lowest common multiple of 3 and 10. Well, the lowest common multiple of 3 and 10 would be 30, because if you write down the multiples of 3, 3, 6, 9, 12, and so on, and if you write down the multiples of 10, 10, 20, 30, 30 would be the first number in both of those lists. So I'm going to write 30 beneath the 3 and the 10, because that's the lowest common multiple of 3 and 10. Now what I'm going to do is I'm going to have a look at this top ratio, and I want it, instead of being 4:3, I want it to be something to 30. So to get from 3 to 30, we multiply by 10. So if we multiply the 4 by 10 as well, then we will know what number this is in the ratio. So if we times by 10 and times by 10, that would give us 4 times 10 is equal to 40. So 4 to 3 is the same as the ratio 40 to 30. Now if we have a look at our next ratio, the cows to chickens ratio, which was 10:7, well, instead of having 10:7, we want to write 30 to something. So if we multiply 10 by 3, we get 30. So if we multiply 7 by 3, we'll find this number in the ratio. So 7 times 3 is equal to 21. So we've got that the ratio of cows to chickens would be 30 to 21, and that's an equivalent ratio as 10:7. So now we've got one ratio. We've got the ratio of sheep to cows to chickens is 40 to 30 to 21. Okay, now let's have a look at writing ratios as equations and equations as ratios, and that's video 271D on Corbettmaths. So we've been given the ratio x to y is equal to 1 to 4, and we've been asked to write this as an equation linking x and y. So here we've got the ratio, and we know that the ratio of x to y is 1 to 4, and that means that y is 4 times larger than x, because for every 1 of x there's 4 of y. So it could be that x is equal to 1 and y is equal to 4. It could be that x is equal to 2 and y is equal to 8. It could be x is equal to 10 and y is equal to 40, and so on. But what we know is the value for y is 4 times larger than the value for x. So let's write that as an equation. y is equal to 4x, because 4 times the smaller number x, 4 times x, is equal to y, because y is 4 times larger. And that's it. And we can show this just looking at this diagram. Here we've got y, and we know the ratio of x to y is 1 to 4. So in other words, if we've got y is 4 times larger than x. If we multiply x by 4, we would get y is equal to 4x. And that's it. Okay, let's have a look at our next question. So next question says, given the ratio of x to y is equal to 2 to 3, write an equation linking x and y. So here we've got x and y are two numbers, and when we simplify the ratio we get 2 to 3. Now it could be that x is equal to 2 and y is equal to 3. It could be that x is equal to 4 and y is equal to 6. It could be that x is equal to 20 and y is equal to 30. But what we know is that when we simplify that ratio we get 2 to 3, and that means for every 2 of x there's 3 of y. So y is going to be bigger than x, and I've represented it here as a diagram where I've got that my x is equal to 2 centimeters and my y is equal to 3 centimeters. So that's a little diagram here where x is equal to 2 centimeters and y is equal to 3 centimeters. So it represents this ratio. Now if we were to double y and we were to treble x, they would be the same as each other. If we have a look here, if we had 2 y's and we had 3 x's, they would be the same length. And that's it. So that means we've got an equation that 2y is equal to 3x. So that's our equation linking x and y. Now that is an equation linking x and y, but if I had something like this, I would tend to make y the subject or x the subject. But if I was making y the subject, I would divide both sides by 2. So divide by 2 and divide by 2. And my left hand side of the equation would just become y, because 2y divided by 2 is just y. And if we had 3x divided by 2, we could write 3x over 2, like so. So y equals 3x over 2. I would tend to write it like this, as 3 over 2x. So y equals 3 over 2x. Okay, let's have a look at our next question. So we're going to write an equation as a ratio. So if we've got the equation y equals 2x, and we've been asked to write down the equation of x to y, let's have a look at the equation to begin with. We know that y is equal to 2 times x. That means that y is 2 times larger than x. For instance, if x was equal to 10, y would be equal to 20. So let's write that as a ratio. So for instance, if x was equal to 10, then y would be equal to 20. And then you can just divide those by 10 and you get 1 to 2. We could have just written 1 to 2 to begin with. For instance, we know that y is twice as big as x. So if we just say x is equal to 1, y is equal to 2, and that's it. So our ratio of x to y would be 1 to 2. And that's video 271D on Corbettmaths. Okay, let's have a look at our next topic. So our next topic is direct proportion, and that's video 254 on Corbettmaths. And here's part of the Corbettmaths revision card, and we're told that C is directly proportional to the square of D. So let's write that statement down. So we've got C is directly proportional, so we'll use the proportion symbol. Some of my students call it fishy, but the proportion symbol to the square of D. So that means D squared, because it says the square of D. So if we read this, it says C is proportional to D squared. C is directly proportional to D squared. Sometimes the question might say it varies directly, and that means the same as directly proportional. And then we've got some information, and this information is going to be really useful. We're told when C is equal to 200, D is equal to 2. So let's write this out again, and let's get rid of this proportion symbol. So let's write down C and then equals, and then we'll put in a K, and that K is the constant of proportionality. So it's a certain value we're going to find, multiplied by D squared. So we've got C equals K times D squared. We've got rid of the proportion sign and we've put in the K, which stands for the constant of proportionality. Now what we're going to do is we're going to substitute in our values. We've got C is equal to 200. So we've got 200 equals K multiplied by, and we've got D squared. Now D is equal to 2, so it's going to be 2 squared. Now let's work this out. So we've got 2 squared is equal to 4. So we've got 200 equals K multiplied by 4. And if we divide both sides by 4, we get 50 is equal to K. So K is equal to 50. And let's put that back into our formula. So we've got C equals, instead of K times D squared, we're going to have C is equal to 50 times D squared, or 50 D squared. And that's our formula. And what I'm going to do is I'm going to put a box around it. It's very important, and that's what we would use for the rest of this question. So that's how you approach directly proportional questions. And I'm not finished yet, but that's how you approach them. So you write down the statement you're given with the proportion symbol. You then get rid of that proportion symbol and put in a K for the constant of proportionality, a certain number we've got to work out. In this case, it was 50. Then there'll be some information that you can put into your formula that has the K to work out what the value of K is. And then once you find it, then you've got your formula, which is really useful. Okay, so the next part of the question says, find C whenever D is equal to 5. So D is equal to 5. So C is equal to 50 multiplied by D squared. But D is equal to 5. So we're going to have C is equal to 50 multiplied by, and instead of D squared, it's going to be 5 squared. Now remember our order of operations, we have to do squaring before we do any multiplication. So we're going to do 5 squared is 25. So C is equal to 50 multiplied by 25, and then finally 50 multiplied by 25 is 1250, and that's it. And if you look at the Corbettmaths revision card, there'll be a step-by-step guide on how to do that, and these revision cards will be really useful for you. If you do have a set of the higher revision cards, it's really useful, and there's a link to it in the description below. One other thing that's useful with direct proportion is to know what the graphs look like, and here are some situations on what their graphs look like. If you have y is directly proportional to x, that means as x increases, so does y, and the graph looks something like this. This is a nice straight line going up like that. Okay, next one is y is proportional to x squared, and the graph of that will look something like this. It's half of the quadratic graph, so it starts at the origin 0, 0 and curves upwards like that. And finally, if we had y is proportional to the square root of x, it'll look like the square root of x graph, so it would start at 0, 0 and then go upwards like that. And that's just some of the proportionality graphs which might be useful for you. Okay, let's have a look at our next topic, and our next topic is inverse proportion, and that's video 255 in Corbettmaths. We're now going to look at inverse proportion, and what that means is as one value gets bigger, the other value gets smaller. So here's our example. We've got t is inversely proportional to the cube of L. So let's write that down. We've got t is inversely proportional, so we write t is proportional, and because it's inversely, we put 1 over, and then we put whatever it says next on the denominator. So it says t is inversely proportional to the cube of L, so we do L cubed. So here we've got t is proportional to 1 over L cubed. So if it says inversely proportional, you do the proportional sign and you put 1 over. And then we're given some important information. We're told whenever L is equal to 0.2, t is equal to 5. And we've been asked to find the formula connecting t and L. So whenever we had direct proportion, we wanted to get rid of this proportional sign and we put in k. So what we're going to do is we're going to write t, and then what we'll do is we'll get rid of this, so we'll put in equals, and whenever it's inversely proportional, we're going to put our k in the numerator. Okay, so we'll have k over L cubed. The reason is we've multiplied this by k, and whenever you multiply this by k, the k will be on the numerator. Now we're told some information. We're told whenever L is equal to 0.2, so whenever L is equal to 0.2, t is equal to 5. So let's substitute those in. So we've got 5 instead of t equals k, which is what we want to find out, over L cubed. So that's going to be 0.2 cubed. Let's work out what 0.2 cubed is. So 0.2 cubed is 0.008. Now we want to get k on its own, so we don't want this to divide by 0.008. So what we're going to do is multiply both sides by 0.008. So we'll multiply both sides by 0.008, multiply by 0.008. And when we do that, we get, on the left hand side, 5 times 0.008 would be 0.04. On the right hand side, we had k divided by 0.008. We times by 0.008 to get rid of that, so we're just left with k. So k is equal to 0.004. So the question says, write down a formula connecting t and L. So if we go back up to here, we're told that t is equal to k over L cubed. Now we know that k is equal to 0.04, so that means we're going to have 0.04 over L cubed. And that's our formula that connects t and L. T is equal to 0.04 divided by L cubed. Next, we're asked to work out the value of t whenever L is equal to 0.5. So that means that t is equal to 0.04 divided by 0.5 cubed. And when we work that out, we get t is equal to 0.32. So we substituted our value for L, our 0.5, into our formula, and we find that t would be equal to 0.32. Okay, next we're asked to find the value for L whenever t is equal to 2. So let's write down our formula again. We've got t is equal to 0.04 divided by L cubed. And we're told that t is equal to 2, so we're going to have 2 equals 0.04 divided by L cubed. So let's solve this. Let's multiply both sides by L cubed, so we would get 2L cubed is equal to 0.04. Next, we want to get the L on its own, so let's get rid of the 2, so let's divide both sides by 2, so we'll get L cubed equals 0.02. And then finally, we want to get the L on its own, so we want to get rid of this cubed, so let's cube root both sides. So L is going to be equal to the cube root of 0.02, which is equal to 0.27144 and so on. Or let's just round that to 2 decimal places, so that's going to be 0.2722 decimal places, and that's it. So whenever you're doing inverse proportion questions, you want to make sure that whenever you put the proportional symbol in, because it's inverse, it's going to be 1 over, and then whatever comes next in this statement. And then whenever you get rid of the proportion symbol and put in the equal sign, then you put the k in the numerator, and then you can just solve the questions quite nicely. Another thing I want to show you then is the proportionality graphs. So we've already looked at y is proportional to x, so this graph, and we've looked at y is proportional to x squared, so this graph starting at the origin and curving upwards like the x squared graph. And we've also looked at y is proportional to the square root of x, so it would start at the origin and then curve like this. Or whenever we've got something such as y is inversely proportional to x, the graph will look something like this, where it starts up quite high. Remember, as one value gets bigger, the other value gets smaller, and it'll curve downwards like so. Now, sometimes whenever we're dealing with proportion, we have questions that involve time. And this is proportion, dealing with time, and this is video 256A in Corbettmaths. So here we've got our question. It says, it takes 20 hours for 3 pumps to fill a swimming pool. How long would it take if 4 pumps were used? So in a question like this, we're told that it takes 20 hours for 3 pumps to fill a swimming pool. So what I'm going to do is I'm going to consider how long it would take for 1 pump to fill a swimming pool. Well, if there's 3 pumps, 1 pump would take 3 times longer. So if there's 20 hours, if we multiply that by 3, that would tell us how long it would take 1 pump to fill the swimming pool. So 20 multiplied by 3 would be equal to 60. So if there was 1 pump, it would take 60 hours. If there was 2 pumps, it would take half of that time, it would take 30 hours. If there was 3 pumps, you would divide it by 3 to get 20 hours, and so on. And the question says, how long would it take if there was 4 pumps used? So if there's 4 pumps being used, well, if it takes 1 pump 60 hours, 4 pumps would take 4 times less time, we would divide it by 4. So we're going to take 60 and divide it by 4. And 60 divided by 4 is equal to 15 hours. So if there was 4 pumps used, instead of taking 20 hours for 3 pumps, it would take for 4 pumps 15 hours. And that's it. Okay, and that's video 256A in Corbettmaths. Okay, so we looked at rounding. Now we're going to look at finding what the highest number could have been or the lowest number could have been. So here we've got the population of Wales, and that's 12,000 to the nearest 1,000. And we've been asked to find what was the lowest possible population of Wales and what's the highest possible population of Wales. So we're told the population of Wales is 12,000 to the nearest 1,000, and we've been asked to find the lowest possible population of Wales. So let's consider the numbers below 12,000 that would round up to be 12,000 to the nearest 1,000. So the population of Wales could have been 11,999, and that number would obviously round up to be 12,000 to the nearest 1,000. It could have been even lower, it could have been 11,900. If we rounded that to the nearest 1,000, it would be 12,000. It could be even lower, it could have been 11,600. If we rounded that to the nearest 1,000, our answer would be 12,000. It could even be as low as 11,500. That number would round to 12,000 to the nearest 1,000. But it couldn't be 11,499 because that would round down to 11,000. So the lowest possible population of Wales would be 11,500. 11,500 because that's the lowest possible number that would round up to be 12,000 to the nearest 1,000. Okay, next question. What's the highest possible population of Wales? So let's consider the numbers above 12,000 that would round down to be 12,000 to the nearest 1,000. So the population of Wales could have been 12,001. Obviously, if we rounded that to the nearest 1,000, it would be 12,000. It could be something even higher. It could be 12,200. If we round that to the nearest 1,000, it'd be 12,000, not 13,000. It could be something even higher. 12,400 would round down to be 12,000, but it wouldn't round up to be 13,000. So it could be 12,400. And it could be anything as high as 12,499, because 12,499 would round down to be 12,000 and not up to 13,000. It couldn't be 12,500 because 12,500, if we rounded that to the nearest 1,000, because it's a 5 in the hundreds column, we would round it up to be 13,000. So it couldn't be 12,500. So the answer would be 12,499. So the answer would be 12,499. So the lowest possible population of Wales would be 11,500, and the highest possible population of Wales could have been 12,499. Now in this question we've looked at what we call discrete data, and that's data that can only take certain values. With it being population, we didn't need to consider decimal numbers. Later on in this video we'll look at what we call continuous data, and that's data that can take any value on a given scale, and we'll look at that whenever we look at a topic called error intervals. Okay, let's have a look at our next topic. Okay, so let's have a look at our next topic. So our next topic is error intervals, and that's video 377 on Corbettmaths. So we've looked at rounding, and we've looked at finding the lowest number or the highest possible number whenever we've looked at data such as the population of Wales. Now let's have a look at what happens whenever we round numbers that can take any value at all. And we often do that whenever we're looking at error intervals. So here we've got the mass of a letter is 80 grams to the nearest 10 grams. So because it's the mass of the letter, it can take any value. It can be whole numbers or it can even be decimals. And we've been told to write down an error interval for the mass of the letter y. So the mass of the letter has been rounded to the nearest 10 grams. So that means that the mass of the letter may not be 80 grams. It could have been 80 grams. It could have been 79 grams. It could have been 76 grams. It could be anything as low as 75 grams because that's the lowest possible value that it could be, because 75 grams would round up to 80. But anything below 75 grams, it would be 74 point something, and that would round down to be 70 grams to the nearest 10 grams. So 75 grams would be the lowest possible mass of the letter. Now let's consider the masses above 80 grams because, as I said, the letter could be 80 grams, but it could be something that's even higher than 80 grams as long as it rounds to 80 to the nearest 10. So it could have been 81 grams, it could have been 82 grams, it could have been 84 grams. It couldn't be 85 grams because 85 grams would round up to be 90 grams, but it could be 84.7 grams, it could be 84.9 grams, it could be 84.99 grams, and so on. It could be anything that is up to, but not including 85 grams. So let's write this as an error interval. So let's start off with the mass of the letter, which is y, so y, and we know that it's bigger than or equal to 75 grams, so it could be 75 grams or a number's bigger than that, so we're going to write bigger than or equal to 75 grams, but it can go up to, but not include 85 grams, so we then write is less than 85 grams. So this reads that y, the mass of the letter, is bigger than or equal to 75 grams, but less than 85 grams, and that's our error interval. It shows all the possible values for the mass of the letter, y. Okay, let's have a look at another question. Okay, let's have a look at our next example. So Nigel rounds a number x to one decimal place. So there's a certain number x and he's rounded to one decimal place and his answer is 7.3. Write down an error interval for x. So the number could have been less than 7.3. It could have been 7.29. That would round to 7.3 to one decimal place. It could have been 7.26. It could be anything as low as 7.25 because 7.25, when we round that to one decimal place, because it's a 5 and above in the second decimal place, when we round that to one decimal place, it'll be 7.3. But it couldn't be anything lower than that. So Nigel's number could be as low as 7.25. But it could have been a number bigger than 7.3. It could have been 7.3. It could have been 7.31. It could be 7.34. But it couldn't be 7.35 because then that would round up to be 7.4. So Nigel's number could be anything up to, but not including 7.35 because it could be 7.348 and so on, right up to, but not including 7.35. So let's write that down. X, his number, could be bigger than or equal to 7.25, but it can be up to, but not including 7.35. And that's it. So that's the error interval for x. Okay, so let's have a look at our next question. So next question says, Chloe truncates a number w to one decimal place. So Chloe's got a number, she truncates it. So she's not rounding it, she's truncating it. And what that means is if you get a decimal number and you just chop it off. So for instance, if we had pi, which is 3.14159 and so on. And if I rounded this to three decimal places, it would be 3.14. And then because the fourth decimal place is a 5, I would round up, so it would be 3.142. So that's rounding. If I was to truncate this to three decimal places, what that would mean is I just chop off, or I just ignore anything after the third decimal place. So if I truncated this to three decimal places, it would be 3.141. So in this case, Chloe has truncated a number w to one decimal place and her answer is 1.4. So she's got 1.4. So Chloe's number, it could have been 1.4. It could have been 1.41. If we truncated that to one decimal place, that would be 1.4. It could have been 1.47259. If we truncated that to one decimal place, it would be 1.4. Chloe's number could have been 1.498972. And if we truncated that to one decimal place, it would be 1.4. But it couldn't be 1.5, so it'd be anything up to, but not including 1.5. So let's write down the error interval for Chloe's number w. So w, it could have been 1.4, so it could be bigger than or equal to 1.4, but then it can go up to 1.5, but not be 1.5, so less than 1.5. So that would be the error interval for w, and that's it. So here's a typical question. It says the length of a field is 120 meters to the nearest 10 meters, and the width of the field is 70 meters to the nearest meter. And we've been asked to work out the lower bound for the area of the field. So it's a rectangular field. Perhaps I should have said that in my question. It's a rectangular field, and to find its area, we're going to multiply the length and the width together. And we want to find the lower bound, so we want to find the lowest possible area of the field. So let's start off by looking at the length of the field. We know it's 120 meters to the nearest 10 meters. So its lower bound, the lowest possible value that it could be, would be 115 meters. That's the lower bound. And the upper bound for the length of the field, well, the upper bound would be 125 meters. In terms of the width of the field, well, this has been rounded to the nearest meter, so the lower bound for the width of the field would be 69.5 meters, and the upper bound for the width of the field would be 70.5 meters. So they are the bounds, and we've been asked to work out the lower bound for the area of the field. So the lower bound would be the smallest possible area. So we would do 115 multiplied by 69.5. So we're going to do 115 meters multiplied by 69.5, and that will give us the lower bound for the area of the field. So we'll do 115 multiplied by 69.5, and that equals 7,992.5 meters squared. So that's the lower bound for the area of the field. If we were asked for the upper bound of the area of the field, we would do 125 meters multiplied by 70.5, and that would give you the upper bound for the area of the field. So we've got the lengths of time taken by 4 people to complete a puzzle are listed below, and it says each time is given to 1 decimal place. So the 4 people have taken seconds to 1 decimal place, 8.4 seconds to 1 decimal place, 35.5 seconds to 1 decimal place, and 19.8 seconds to 1 decimal place. And we've been asked to work out the greatest possible range. So remember, the range is equal to the largest subtract the smallest. So the largest subtract the smallest. So here our largest value would be this one, 35.5, and our smallest value would be 8.4. But each of these times have been rounded to 1 decimal place. Okay, so let's find the upper bound and lower bound for these values. So the upper bound, so this number's been rounded, this 8.4 has been rounded to 1 decimal place. So the upper bound would be 8.45 seconds, because it could go up to 8.45 seconds, but not including. And the lower bound would be, well, it could go down as far as 8.35 seconds, because that's the lowest possible value that would round up to 8.4 seconds. Likewise, for 35.5, the upper bound would be 35.55 seconds, and the lower bound would be equal to 35.45 seconds. So we've found the upper bound and lower bound for each of those values, and we've chose those ones because we're looking at the range, which is the largest subtract the smallest. So we're going to want to use the upper bound for the largest value, and we're going to want to use the lower bound for the smallest value, because when we take them away we'll get the biggest possible answer. So we're going to do 35.55 seconds, and we're going to take away 8.35 seconds, and whenever you do that you get 27.2 seconds. If they wanted the smallest possible range, you'd want them to be as close together as possible. So you use the lower bound for the largest value and the upper bound for the lower value, so that they're closer together, and they'll give you the smallest possible range. Okay, next question says Natalie runs 100 meters to the nearest 10 meters. So it's 100 meters to the nearest 10 meters. That means it could be the lower bound would be 95 meters, and the upper bound would be equal to 105 meters. They are the upper and lower bounds for how far she's ran. And it takes her 14 seconds to the nearest second. So the lower bound would be, so she could do it in 13.5 seconds, or the upper bound, the greatest possible amount of time it would take, would be 14.5 seconds. They're the lower bound and upper bound for 14 seconds to the nearest second. So the question says to work out the greatest possible speed. So we're working out speed. So the speed is found by the distance divided by the time. Now, but we've been asked to find her greatest possible speed. So to do that, what you want to do is you want to run the largest distance in the smallest possible time, because the largest distance in the smallest possible time will give you the greatest speed. So the greatest possible distance would be 105 meters. That's the greatest possible distance she could run. And the smallest amount of time would be 13.5 seconds, because if she ran a large distance in a smaller amount of time, that means she's running even faster. 105, the upper bound, divided by the lower bound, that's going to give you the greatest possible speed. So 105 divided by 13.5 would be equal to 7.778 meters per second to 3 decimal places. That would be her greatest possible speed. If you wanted to find her slowest possible speed, you should do the smallest distance in the greatest amount of time, and that would mean she's traveling slower, and so on. Okay, let's have a look at our next topic, and our next topic is Surds, and this is video 305 to 308 on Corbettmaths. And whenever we're dealing with Surds, there's laws of Surds. So if you're multiplying 2 Surds together, such as the square root of 3 multiplied by the square root of 5, you can just multiply those to get the square root of 15. So the square root of 3 multiplied by the square root of 5 is the square root of 15. So if you've got 2 surds, you can multiply them together. And that also works even if you've got numbers in front of them. For instance, if you had 3 root 2 multiplied by 2 root 5, you can multiply the numbers at the front. So 3 times 2 is 6. And then you can multiply the surds. root 2 times root 5 is root 10, so the answer would be 6 root 10. So you can multiply surds together. If they're surds without numbers in the front, so if it's just root 3 times root 5, you can multiply them to get root 15. Or if you're multiplying surds with numbers in front of them, such as 3 root 2 multiplied by 2 root 5, you can multiply the numbers in front first of all to get 6, and then you can multiply root 2 by root 5 to get root 10. Okay, next. If you've got root a times root a, the answer is just a. So for instance, if you had root 7 times root 7, well, root 7 times root 7, looking at the row above, would be root 49, because 7 times 7 is 49. And remember, the square root of 49 is just 7, so the answer would be 7. So if you had root 7 multiplied by root 7, the answer would just be 7. Root 2 times root 2 would be 2, root 10 times root 10 would be 10, and the reason is root a times root a is equal to a. And also, we can divide surds as well. So for instance, if we had root 6 divided by root 2, we just do 6 divided by 2, which is 3. So the answer would be the square root of 3. And also that works with numbers in front as well. So for instance, if we had 12 root 14 divided by 3 root 2, we can divide the numbers in front to begin with. A bit like algebra, we can do 12 divided by 3, which is 4, so 4. And then we could do the square root of 14 divided by the square root of 2, which would be the square root of 7, so it would be 4 root 7. And that would be it. So these are the laws of surds, and they're very important. So you can multiply surds together, you can divide surds, and also if you've got something such as root a times root a, it's just a. Okay, let's have a look at our next topic. Okay, we've looked at our rules, now let's look at how we can simplify some surds. So if we had something such as the square root of 200, if you type that into your calculator and press the square root of 200 and press equals, you'll find it comes up as 10 root 2. So it doesn't come up as the square root of 200, it comes up as 10 root 2. Whereas if you press the square root of 10 and press equals, it would just come up as the square root of 10. And that's because some surds can be simplified and some surds can't be simplified. So here we've got a surd that can be simplified, the square root of 200. So what you do is you consider what's the biggest square number that you can divide 200 by. Now the biggest square number that I can divide 200 by is 100, because 200 divided by 100 is 2. I can divide 200 by 100. So I'm going to write down the square root of 100, that biggest square number, multiplied by the square root of 2. Now what's fantastic is if you've got a square number, you can work out the square root of it, and the square root of 100 is 10. So we've got 10 times the square root of 2. And in surds, a bit like algebra, we tend not to write the multiplication sign. So instead of writing 10 times root 2, we just write 10 root 2. And that means 10 lots of root 2. And that's it. So if we want to simplify a surd, you look for the biggest square number you can divide it by, and then you split it up into two surds timesing together. So the square root of 100 times the square root of 2. You square root the square number, and then you just put them together. Let's have a look at another one. Okay, let's have a look at our next one. So we're going to simplify the square root of 75. So what we're going to do is look for the biggest square number we can divide 75 by. So let's write down our square numbers: 1, 4, 9, 16, 25, 36, 49, 64, 81, and so on. Now I'm not going to go any further because we've gone past 75. And we're looking for the biggest number, the biggest square number we can divide 75 by. Well, 1, well, that's not going to actually help us because we'd end up with the square root of 1 times the square root of 75. So that's not actually going to simplify it. 4, well, 4 is not a factor of 75. 9 is not a factor of 75. 16 is not a factor of 75. 25 is, because 75 divided by 25 is 3. 36, 49, 64, and 81 are not factors. So 25 would be the biggest square number that is a factor of 75. So let's write that down. The square root of 25 multiplied by the square root of 3, because those two will multiply together to give us 75. Now we can square root of 25. The square root of 25 is 5, so it'll be 5 times the square root of 3. And then again, we tend not to write that multiply sign, so the answer would be 5 root 3. And if you got your calculator and typed in the square root of 75 and press equals, you should get 5 root 3. Okay, let's have a look at our next topic, and that's adding surds. So whenever we want to add surds or take surds away from each other, we want to simplify them, and then hopefully we can add or take them away. So let's have a look at our first example. We've got the square root of 18 plus the square root of 8. So let's start off with the square root of 18. So the square root of 18 would be equal to, well, let's consider the biggest square number that's a factor of 18, and that would be 9. So we'd have root 9 multiplied by root 2. And the square root of 9 is 3, so that'd be 3 times root 2, or 3 root 2. So instead of root 18, we're going to write 3 root 2, because that would simplify to 3 root 2. And root 8, well, the biggest square number that's a factor of 8 is 4, so we're going to write root 4 multiplied by root 2. And square rooting the 4 would give us 2 root 2. So root 8 would be 2 root 2. So we've got, instead of root 18 plus root 8, we would have 3 root 2, or 3 lots of root 2, plus 2 lots of root 2. And that's great because we're now dealing with just root 2's. And if you had 3 root 2's and you added 2 root 2's, altogether that would be 5 lots of root 2. So the answer would be 5 root 2. And that's it. Okay, this time we've got root 75 plus 9 root 12. So let's start off with our root 75. That would be root 25. That's the biggest square number that you can divide 75 by, multiplied by root 3. And the square root of 25 is 5, so that'd be 5 root 3. So root 75 is 5 root 3. And then in terms of our 9 root 12, let's deal with our root 12 to begin with. So root 12 would be, well, the biggest square number we can divide 12 by would be 4. So it'll be root 4 multiplied by root 3. And the square root of 4 is 2, so that'll be 2 root 3. And here we didn't just have our root 12, we had 9 root 12. So that means 9 lots of root 12. So we're going to multiply this by 9. So we're going to multiply the number 2 by 9, so that'll be 18 root 3. So we've got 5 lots of root 3 plus 18 lots of root 3. So altogether that would be 23 lots of root 3. So root 75 plus 9 root 12 would be 23 root 3. So sometimes with surds we're asked to expand and simplify brackets that involve surds. So here we've got 3 minus root 2 close bracket squared. And whenever we've got a bracket squared, it means to multiply it by itself. So let's write the bracket out beside itself. So 3 minus root 2 close brackets, 3 minus root 2 close brackets. And we're going to multiply this by itself. So we're going to do 3 times 3, which is 9. So that's equal to 9. Then we're going to do 3 times minus root 2. So it's going to be minus. And when we're multiplying a whole number by surd, we can just put them together. So 3 times root 2 would be 3 root 2. Or in this case, it's going to be minus 3 root 2. Then we've got minus root 2 times 3. Again, putting them together would be minus 3 root 2. And finally, we've got minus root 2 times minus root 2. Well, negative times a negative is a positive, so plus. And then you've got root 2 times root 2. Now that could be root 4, but remember the square root of 4 is 2, so the answer just there would be 2. So now we need to simplify. So let's look at our whole numbers. We've got 9, and then we've got plus 2. Well, 9 plus 2 is 11, so we're just going to write 11. Now looking at our surds, we've got minus 3 root 2, take away another 3 root 2. Well, altogether that'd be minus 6 lots of root 2, so that'll be minus 6 root 2, and that's it. Okay, let's have a look at our next topic. Okay, so let's have a look at our next topic. So our next topic is rationalizing denominators. Now in maths, we tend not to like to have irrational numbers on the denominators of fractions. So for instance, something like 10 over root 2, we tend not to like to have that because we've got an irrational number, root 2, on the denominator. So whenever we've got a fraction such as 10 over root 2, we are sometimes asked to rationalize the denominator. And what that means is get rid of that root 2 on the denominator. Now whenever we're dealing with fractions, we can multiply both the numerator and the denominator by the same thing and we get an equivalent fraction. So for instance, if we had 10 over root 2, we can multiply these both by 4 or by 9 and you would get an equivalent fraction. But what would be really great is that whenever we choose our number, that whenever we multiply both the numerator and the denominator by it, that we can turn this denominator into a rational number. Now remember, if you've got something like root 2, you can do root 2 times root 2, and that would give you 2, because root 2 times root 2 is equal to root 4, which is 2. So if we multiply both the numerator and the denominator of this fraction by root 2, what we will do is we will get rid of this root 2 on the denominator. So whenever we do that, we get 10 times root 2 is equal to 10 root 2. And then on the denominator, we would have root 2 times root 2, which is root 4, and the square root of 4 is 2. So that we would get 10 lots of root 2, 10 root 2 divided by 2. And that's fantastic because we have rationalized the denominator. We've changed our irrational number, our root 2, into a rational number. Now, something like this, we can actually simplify it a little bit further. If you had 10 root 2 and you divided it by 2, you would get 5 root 2. And that's it. Okay, so if you had something like 4 over root 3 and you were asked to rationalize the denominator, what you do is you multiply both the numerator and the denominator by the surd on the denominator, this root 3. So multiply by root 3 and multiply by root 3, and let's see what we get. 4 times root 3 is 4 root 3, and on the denominator, root 3 times root 3 is root 9, which is 3, and that's it. So we would have 4 root 3 over 3, and again this is great because we have rationalized the denominator. We have changed our root 3, our irrational number, into a rational number. So if you're asked to rationalize the denominator where you've just got a surd on the denominator, you can just multiply both the numerator and denominator by that surd. Let's have a look at another one. Okay, our next fraction is 5 over 4 root 3. Now on this one, it's a little bit different because it's not just root 3 on the denominator, we've got 4 root 3. Now we've got a choice here. We could multiply both the numerator and the denominator by 4 root 3 if you wanted to. I personally just multiply it by the surd part. I'm just going to multiply both the numerator and the denominator by root 3, and let's see what we get. So multiply by root 3 and multiply by root 3. 5 times root 3 is just 5 root 3. And on the denominator, we had 4 root 3 and we multiplied it by root 3. Well, if we had 4 root 3 and multiplied it by root 3, that would give us 4 times the square root of 9. And the square root of 9 is 3, so we would have 4 times 3, and 4 times 3 is equal to 12. So if you had 4 root 3 and you multiplied it by root 3, you would get 4 times 3, which is 12. And that's it, so we have rationalised the denominator. And we can't cancel this down because 5 12s can't be cancelled down, and that's it. Okay, we're now going to look at how to rationalise the denominator for something like this, where we've got 3 over root 2 plus 1. And because we've got this root 2 plus 1 on the denominator, it's where the exam boards will subtly differ from each other. AQA only expects you to know how to rationalise the denominators whenever you've got a surd like root 2 or root 7 on the denominator, or even 4 root 7 or 2 root 2, but not where you've got this root 2 plus 1. But if you're studying for OCR or Edexcel, you're expected to know how to rationalise the denominators like this. So if you're studying for OCR or Edexcel, you're going to need to know how to do this. If you are studying for AQA, feel free to skip on to the next topic. Alternatively, you could watch it anyway because it's going to be very useful for you if you're going to go on to do A-level maths anyway. Okay, let's get started. So if, for instance, you were given a question such as this, rationalise the denominator of 3 over root 2 plus 1. Now, if you're given something like this, okay, and you want to rationalise the denominator, what we've got to do is multiply both the top and the bottom by what we call the conjugate of the denominator. And what that means is, because we've got root 2 plus 1, if we want to rationalise the denominator, we need to multiply both the numerator and the denominator by root 2 minus 1. Root 2 minus 1. And if we multiply both the numerator and denominator of this fraction by the conjugate of root 2 plus 1, what that means is change the plus sign to a minus sign. And if we multiply both the numerator and denominator by that, we will rationalise the denominator. Let's have a look and see what we get. So with the numerator, we would just get, well, 3 times root 2 minus 1 would be 3 bracket root 2 minus 1. And then on the denominator, we would have root 2 plus 1 bracket root 2 minus 1, close brackets. So let's expand our brackets. The numerator, expanding that, would give us 3 root 2 minus 3, multiplying both of these by 3. And in terms of the denominator, let's expand these brackets and see what we get. So if we had root 2 plus 1, bracket root 2 minus 1, if we expand these brackets, we'll get root 2 times root 2 is 2. Root 2 times minus 1 would be minus root 2. 1 times root 2 would be plus root 2. And then finally, 1 times minus 1 would be minus 1. And when we simplify that, we get 2 minus 1 is 1. Then we've got minus root 2 plus root 2, well, that's 0. So the answer would just be 1. So on our denominator, we would have 1, and that is rationalised. 1's rational. And then finally, because we can divide both of these by 1, our answer would just be 3 root 2 minus 3, and that's it. So if you do get a fraction where you've got a surd and then a number, or a number then a surd, then what you do is you multiply both the numerator and the denominator by the conjugate. And what that means is the same expression, but if it has a plus sign, put a minus sign, or if this had a minus sign, put a plus sign. So our next topic is the product rule for counting, and that's video 383 in Corbettmaths. So the product rule for counting is a really useful technique to work out how many possible ways there are of doing things. So for instance, if there's n ways of doing a first task and n ways of doing a second task, if we multiply those two together, we find out the total possible numbers of ways of doing those two tasks. So if for instance we went into a restaurant and there was 8 different starters and there was 10 different main courses, and we wanted to find out how many possible ways there are of choosing a starter and a main course, so 1 starter and 1 main course, and we wanted to list down all the possible options. If we do 8 times 10, and that gives us 80, that would tell us the answer to how many possible ways we can pick a starter and a main course. There would be 80 possible ways we can choose 1 starter and 1 main course. For instance, we could have the first starter with each of the 10 possible main courses. We could have the second starter with the 10 different main courses, the third starter with the 10 possible main courses, and so on up until the 8th starter and the 10 possible main courses. And that would mean there would be 80 possible combinations of a starter and a main course. So this product rule for counting is a really useful technique to work out how many possible ways you can do things. So let's have a look at an example. And this is the Corbettmaths revision card. And we've got Grace picks a 4-digit number. So she's got a padlock and she's going to choose a 4-digit code for it. The first digit is a prime number. The third digit is greater than 7, and we've been asked how many possible different 4-digit numbers can she choose. So let's look at each of the digits. So the first digit is a prime number, so that could be 2, 3, 5, 7, but it can't be 11 because that's got 2 digits, so she's got 4 possible options for the first digit. She can choose a 2, a 3, a 5 or a 7. So that means she's got 4 possible options for the first digit. The third digit is greater than 7, so that could be an 8 or a 9. We can't have 10 because that's got 2 digits, so the possible digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 8 and 9 are the only two that are greater than 7, and because it's greater than, we're not going to include 7 itself. So there's 2 possible digits we can choose for the third digit. In terms of the second digit and the fourth digit, we've not been given any rules for those. That means they can be any of the 10 digits. It could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10 different choices for digit 2, and there's 10 different choices for digit 4. So what that means is, if we want to find out how many possible 4-digit codes you can choose, we could multiply these numbers together. We could do 4 times 10 times 2 times 10. And 4 times 10 is 40, times 2 is 80, times 10 is 800. So that means there's 800 different possible numbers you could choose. We could try and list them all if you wanted to, but with there being 800, I'd rather use this technique. So this is video 383 in Corbettmaths. If you want to try some practice questions on it, there's practice questions beside those as well. And also remember, in the description below, there's a link to that bumper booklet that accompanies this video. And so if you want to do a practice question on this, you can click that link and try that practice question. Okay, so let's have a look at our next topic, and that's angles and polygons. And a polygon is just a straight-sided shape. So we've got our triangles, our quadrilaterals, pentagons, hexagons, heptagons, octagons, and so on. And this is the Corbettmaths revision card on angles and polygons. So it tells you the angles in a triangle add up to 180 degrees, the angles in a quadrilateral add up to 360 degrees, the angles in a pentagon add up to 540 degrees, and it's very useful to know that, or alternatively know that if a quadrilateral adds up to 360, you can just add on another 180. If we add on another 180, that's 720, so the angles in a hexagon add up to 720 degrees, the angles in a heptagon add up to 900 degrees, the angles in an octagon add up to 1080 degrees, and so on. And this is very useful. This is the Corbettmaths revision card, and if you want to get a set of those, they're in the description below. And so here we've got a polygon, and it's got 1, 2, 3, 4, 5 angles. So, and it's also got 1, 2, 3, 4, 5 sides. So that means it's a pentagon, and the angles in a pentagon add up to 540 degrees. So if we want to find the size of this missing angle x, we can add together the angles we're given, the 80, the 140, the 95, and the 130, and we can take that away from 540 to see what's left for x. So let's do that. So 140 plus 80 plus 95 plus 130 is equal to, and I'll just do that on my calculator, 445 degrees. And if we take that away from 540, we can see what x is. So 540 take away 445 equals 95 degrees. So that means that x is 95 degrees, and that's it. If you were given a hexagon, they would give you 5 angles, and you would add those up and take it away from 720 to find the size of the 6th one, and so on. Now, there's a formula that's really, really useful, and that if you want to find out the sum of the interior angles, or what the angles in the shape add up to, you could use this formula, which is n take away 2, so the number of sides take away 2, multiplied by 180. So for instance, if I wanted to know what the angles added up to in an octagon, I could take the number of sides, which is 8, take away 2, that gives me 6, and then multiply by 180, and that gives me an answer of 1080. Likewise, if we knew what the angles in a shape added up to and we needed to find out how many sides there were, we could work backwards, so we could divide by 180 and then add 2. And that's it. So this formula is really useful. Okay, let's have a look at a question based on that. So here we've got a question, and it says find the sum of the interior angles of a 12-sided polygon. So a 12-sided polygon, that's a dodecagon, I believe, and we need to find the sum of the interior angles. We need to find out what the angles in that 12-sided shape will add up to. And the formula is to do n take away 2 times 180. So if we take our 12 sides and do 12 take away 2, that's equal to 10, and then do 10 multiplied by 180, that's equal to 1800. So in a 12-sided polygon, the angles would add up to 1800 degrees. Okay, our next example. So our next question says the sum of the interior angles of a polygon is 4500 degrees. So it's got a few more sides than a 12-sided one. And the question says how many sides does it have? So to find this answer, this 4500 degrees, we've taken the number of sides, we've subtracted 2, and then we've multiplied by 180 degrees. So if we want to work backwards, we're going to take our 4500, divide it by 180, and then that will give us 25. But remember, we've taken away 2, so because we're going backwards, we're going to add 2, so we're going to do 25 plus 2 is equal to 27. So the angles in a 27-sided polygon will add up to 4500 degrees, and that's it. Okay, and that's it. Now this formula is really useful. It's really useful for both regular polygons. So regular polygons are where all the sides are the same length and the angles are the same size. And it's also useful for irregular polygons where the angles aren't all the same size. So for instance, if we knew that it was irregular, we could add up the angles that were given and then take it away and then find out the size of the missing one. But if it's a regular polygon, what we can do is, so for instance, with this 27-sided polygon, if we divided 4500 by 27, and we could find the size of each one of those angles. Now there's some other rules with polygons, and they are the exterior angles. So if you've got the interior angle and you carry on that straight line, the angle between the polygon and that straight line is what we call the exterior angle. And I've marked them all on this diagram in red. So all of these red angles are exterior angles. So the sum of all those exterior angles, all of these red angles, will be 360 degrees. So for no matter what polygon you've got, if you add up all the exterior angles, it will always add up to 360 degrees. And then also the interior angle and the exterior angle, because they make a straight line, they will add up to 180 degrees. So there are two very useful rules as well. The sum of the exterior angles, all those outside angles there, all those red angles will add up to 360 degrees. And the interior angle and the exterior angle will add up to 180. So let's do some questions based on that now. So here we've got a typical question. It says, work out the size of each exterior angle for a 20-sided regular polygon. So this is a regular polygon, so that means that all the interior angles are the same size, and also all of the exterior angles are the same size. And it's got 20 sides, and we know that all the exterior angles will always add up together to give you 360 degrees. So if we divide 360 by 20, we will find the size of each exterior angle. So if we do 360 divided by 20, that's 18. So that means that each of the exterior angles will be 18 degrees. So we'll have 20 exterior angles and they'll all be 18 degrees each. This time we're asked to work out the size of each interior angle of a 20-sided regular polygon. Now we've got two different ways to do this. We could use our first formula where we take away 2, so that's 18, times that by 180, and that would tell you what the angles add up to in a 20-sided polygon, and then divide that answer by 20 to find the size of each one of those angles. So that's one approach. Alternatively, if we know that all the exterior angles are 18 degrees each, if we take that at 18 degrees away from 180, we will find the size of the interior angle, because remember, the interior angle and the exterior angle will always add up together to give us a straight line, 180 degrees. So if we do 180, take away 18, that's equal to 162 degrees. And that's it. Our next topic is angles and parallel lines. Now, whenever you've got two parallel lines and a line that crosses them, a straight line that crosses them, you'll find that many of the angles are the same. Because as you can see, you've got lots of vertically opposite angles. Like for instance here, this obtuse angle is vertically opposite to this one, so they're the same. This acute one's equal to that one. Now, as it is a straight line that crosses the two parallel lines, then the angles below will be exactly the same. You'll also have a 75, 75, and so on. Now we've got some special names to use whenever we're talking about these angles being the same as each other. So if you've got two parallel lines and a line that crosses it, and you've got this Z shape, these are called alternate angles because they're alternate to each other. So this 75 is the same as this 75 because they're alternate angles. And it's very important to know that word, alternate angles. Try not to use Z angles, use the term alternate angles. So this angle is the same as this angle because they're alternate to each other. Here, these angles, these green angles, are 130 degrees, these obtuse angles, and they're the same as each other, so they're called corresponding, because you've got, if you look at it, you've got the angles at the top and the angles at the bottom. They're both in the bottom right corner, here and here, so they're corresponding to each other. The bottom right angle and the bottom right angle are the same, because they're corresponding. Some people call it an F angle, because you've got this F shape, and the angles at the below the F are the same, but try to learn the word corresponding. So as well as our alternate and corresponding angles, we've also got co-interior and vertically opposite angles. So if we've got two parallel lines, this angle and this angle will add to 180 degrees. And that's really useful because if we know one of them, we can then work out the other one by taking it away from 180. So this angle and this angle will add up to be 180 degrees. So they are co-interior angles. And also this angle and this angle will add together to be 180 degrees. So they're co-interior angles as well. That's really useful because if you know one of them, you can then find the other one. Also, we've then got vertically opposite angles. So remember, if you've got two straight lines across each other, the opposite angles will be equal to each other. So if this angle is 135 degrees, the angle opposite it will be 135 degrees. Also, if this angle is 45 degrees, the angle opposite it is equal to 45 degrees. So opposite angles, where you've got two lines that cross each other, the opposite angles are equal to each other. And again, that's really useful for co-interior angles. So if we could look at this diagram here, we know that if this angle is 60 degrees, this angle will be 60 degrees because they're opposite each other. And if this angle is 120 degrees, this angle is 120 degrees because they're vertically opposite each other. And that's it. So here we've got a question just to practice we remember which one's which. So we've got our two parallel lines, RS and TU, and you've got that straight line that crosses them. And we've been asked to find which angle is corresponding to A. So we've got A here, and A is the top left angle in this little section here. So if we look at the angles below at the other line, the angle in the top left there is E. So A and E are corresponding to each other, E. B would be corresponding to F, D would be corresponding to H, and C would be corresponding to C. Our next question says, which angle is alternate to C? Now when we see alternate, we're thinking of that Z angle, and you can see here we've got that C here. And if you look at my pen here, you've got this sort of Z shape here, where you've got the C in there and the F there. They are alternate to each other, so C is alternate to F. So C is alternate to F. D would be alternate to E, and they would be the alternate angles. C is alternate to F, and D is alternate to E. And that's it. Bearings. And here's a typical bearings question. And bearings is video 26 on Corbettmaths. So if you do want that full video talking through bearings, if you watch that video 26 on Corbettmaths, it'll go through bearings in a bit more detail. But as I said, the aim of this video is to spend about 3 or 4 minutes in each topic to make sure you're familiar with the topics. So here we've got two towns. We've got Antrim and we've got Belfast. And the question says, write down the 3-figure bearing of Belfast from Antrim. So bearings are a direction of travel and they're measured clockwise from north. So in this question, we've been asked to write down the 3-figure bearing of Belfast from Antrim. So if I was asked to do that, the first thing I would do is get a ruler and pencil and join up the two towns. So I would join up Antrim and Belfast like so. Then next I would draw a north line at Antrim. So I just get a ruler and pencil and I would draw a north line going upwards from Antrim like so, because that's where we're measuring the bearing from. It's the bearing of Belfast from Antrim. So there's our north line. And I'm just going to put a little n beside it just to show that it's north. Next, we want to mark in the angle that we want to measure. Now, bearings are measured clockwise from north. So the bearing will be this clockwise angle going around from the north line to the line joining Antrim and Belfast. And we're going to get our protractor. So we're going to get our protractor and we're just going to rotate it. So we've got our protractor and we're just going to put it on top of Antrim. So we've got the cross of it on top of Antrim. And we've got the 0 going along the north line and we've got 0 on the top. Now the bearing is measured clockwise from north, so we just need to measure this angle. So we've got 0 at the top, so we're looking at these outside angles and we're going to start from 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and then we've got 101, 2, 3, 4, 5. So that is 105 degrees. So if I move my protractor, a 105 degree angle, and the question said write down the 3-figure bearing of Belfast from Antrim, so the answer would be 105 degrees. Okay, let's have a look at another one. So we've got two made up towns here. We've got Castletown and Milton, and we've been asked to write down the 3-figure bearing of Castletown from Milton. So again, our first step is to join up the two towns. So get your ruler and pencil and join up Milton and Castleton, like so. So we've joined up our two towns. Next, we want to just make sure we know where we're measuring the bearing from. So we want to measure the bearing of Castletown from Milton. So we're in Milton. So let's draw our north line at Milton, and we'll just put a little n at the top to show that it's north. Next, let's get our protractor, and we want to rotate it so that we've got the 0 at the top. So we've rotated our protractor, and now let's just double check with the angle we want to measure. So we want to measure the angle going clockwise from north. So marking in the angle, it's clockwise from north. So that's the angle we want to measure. And we're going to get our protractor, and we're going to put the 0 on the north line and the cross on Milton. So let's now measure our angle. So we're starting at 0, so it's 10, 20, 30, 40. And as you can see, we haven't reached 45, so we've actually got 44 degrees. So that angle is 44 degrees. So let's just move our protractor and mark in that it's 44 degrees. So 44 degrees. And we've been asked to write down the 3-figure bearing of Castletown from Milton. But remember, the bearing has to have 3 figures, so it's going to be 0, 4, 4 degrees. We're just going to put a 0 in front of that, so 0, 4, 4 degrees. And that's it. So the bearing of Castletown from Milton is 0, 4, 4 degrees. That's it. Okay, our next question. Okay, this time we've been asked to write down the 3-figure bearing of Portrush from Larne. So this time we're going to join up the towns as before. So we've joined them up. Now we're going to make sure we know which way north is. So north is going upwards, and we want to just check where we're starting from. So it's writing down the 3-figure bearing of Portrush from Larne. So we're in Larne, and we're going to do our north line at Larne. So there's our north line, and let's just mark it with a little n. Now we've got a mark on the angle we want to measure. So remember, bearings are measured clockwise from north. So we want to go clockwise from north all the way around to the line joining Portrush and Larne. So we need to measure this angle here. It's a reflex angle, so it's going to be bigger than 180 degrees, but less than 360. So we want to measure that angle. Now there's 3 different ways we can measure this angle. The first way is my favorite way. It's actually getting a 360 degree protractor. So this protractor only goes up to 180 degrees. So if you've got a 360 degree protractor, they're actually really, really fantastic because you can put the 0 on the north line and you can just go around and read off even reflex angles like this one. If you're measuring this one, what you could do is, one approach is you could actually turn it the other way. So we can measure this small angle here. So we could actually get our protractor and measure the angle anti-clockwise. So it's starting at 0 on the inside, 0, 10, 20, 30. And we're in the middle here between 30 and 40, so that's 35 degrees. So one approach is actually to measure this angle, which is 35 degrees. And because we know the angles in a full turn add up to 360, we could take the 35 away from 360 and do 360 subtract 35, which is equal to 325 degrees. So that means that this angle is 325 degrees, and then that would be our bearing because it's the angle measured clockwise from north all the way around to the line joining the town. So our answer would be 325 degrees. So that's one approach. Another approach is to measure that reflex angle, and what we could do is, so answer is 325, we can just go back to the beginning. And we want to measure this reflex angle, so what we could actually do is draw a line straight down, like so. And we know that a straight line, the angles add up to 180 degrees, so we do know this is 180 degrees on the right hand side, so we're just drawing the line straight down, our south line, which would be 180 degrees there. And then we could just get our protractor, and we could turn it around, so that we've got 0 at the bottom this time. And we want to go from 0 around to where the line is. And as you can see, if we start at 0, which is at the bottom here, we've got 0, 10, 20, 30, all the way around to in between 140 and 150, and it's in exactly the middle. So that means that's at 145 degrees. So if we wanted to measure this clockwise angle, this reflex angle, we know that we've got 180 degrees and another 145 degrees. And if we add those two together, we also get 325 degrees. So that's it. So the bearing measured clockwise from north, from Larne to Portrush, would be 325 degrees. Okay, let's have a look at our next topic, and that's actually bearings as well. It's working out back bearings. So in other words, here's an example. If we know the bearing off Nottingham from Dublin as 098 degrees, what's the bearing off Dublin from Nottingham? So going the other way around. So there's two different ways you can actually approach this. The first way is actually just do a little sketch. So the bearing off Nottingham from Dublin. So let's do a little X for Dublin. So let's just label that Dublin. And then we've got Nottingham, and it's on a bearing of 098 degrees. So let's put our north line in. And 098 degrees or 98 degrees, if we started at the top and we went around 98 degrees, it would be go past east and just a little bit beyond it. So it means that it wouldn't be here, it would just be a little bit further. So let's put a little cross there and say that's Nottingham. So we've got Dublin and we've got Nottingham. Let's join them up with a straight line. Now let's mark in the angle. So we know that angle is 98 degrees because the bearing is 098. So that's 98 degrees there. Now let's also draw another north line at Nottingham. So we're drawing our north line with the little n at Nottingham, and we want to measure the bearing off Dublin from Nottingham. So we want to measure the angle going clockwise from the north line at Nottingham, going around to the line joining Dublin and Nottingham, like so. So we want to find the size of that angle. Now here we've got two north lines and they are parallel lines. And remember with parallel lines, the two interior angles are called co-interior. These two angles add up to 180 degrees. And actually if we go back to our revision cards here, we've got co-interior angles, two angles inside of parallel lines add up to 180 degrees. So if this angle was 60, that angle is 120. So that's quite important. So if we go back to our bearings, we've got, this is 98 degrees. So this angle and this angle here will add up together to give us 180 degrees. So if we do 180, subtract 98, we get that's equal to 82 degrees. That means this angle here is 82 degrees. Next, we want to find the size of this reflex angle. Now we know the angles in a full turn add up to 360 degrees. So if we take 82 away from 360, we can find the size of this angle. So we can do 360 take away 82, and that's equal to 278 degrees. And that's it. So that means that this angle would be 278 degrees, and that would be the bearing off Dublin from Nottingham. And that's it. Or another way to do it is to actually notice a bit of a pattern. So if you're doing a back bearings question and the bearing that you're given in the question is less than 180 degrees, to get the bearing going the other way, you could just add on 180 degrees and that would give you your answer. And if the bearing you're given in the question was more than 180 degrees, if you take away 180 degrees, you can get your answer. And that's a bit of a shortcut. Now, the way I do that is I visualize it. If I was traveling from Dublin to Nottingham, and then I wanted to go the other way, I would rotate through 180 degrees to go the other way. If you want to watch that in more detail, you can watch video 27A in Corbettmaths, and there's questions there on it as well. Okay, let's have a look at our next topic. And our next topic is constructions, and they are video 78, 72, and 79 on Corbettmaths. And if you want to watch me do these constructions where I'm filming myself actually doing the constructions, those videos will actually show that. But here what I'm going to do is show you step by step on how I would do the constructions. So first of all, our first question says construct the perpendicular bisector of AB. So first of all, what is a perpendicular bisector? So perpendicular means 90 degrees and bisector means to cut in half. So if we were asked to construct the perpendicular bisector of AB, it would be a straight line that cuts AB in half going through the middle at 90 degrees. So it'd be cutting this line AB in half at 90 degrees. And to do that, by using a pair of compasses and a pencil, what you would do is, first of all, you would get your pair of compasses and you would put the point of the compass on A, and you put the pencil on the compass and you would set it over halfway of the line. So I've just chosen this point. It's definitely over halfway off the line, and I've drawn this semicircle starting at A, and I've drawn the semicircle around. So keeping the point here and making sure I draw a nice semicircle going around. Now, lifting up your compass and your pencil and making sure it doesn't change size, put the point of the compass on B, and then what we're going to do is we're going to do the same thing. So we're going to do another arc. We're going to put a point of the compass on B, and we're going to do another arc, and making sure it's the same size as the arc we've done at A. And then finally, what we're going to do is get a ruler and pencil and draw a nice straight line through those. And this line will be our perpendicular bisector. So that line will cross our line AB at 90 degrees. So it's perpendicular. And it's a bisector because it cuts the line AB exactly in half. So if that line AB was 10 centimeters, you would have 5 centimeters to the left here, and you'd have 5 centimeters to the right. So that's it. Okay, next we're going to construct the angle bisector. So here's an angle ABC, and we're going to cut this angle in half by using a compass, a pencil, and a ruler. So the first thing we're going to do is we're going to put our point of our compass on B. So we're going to put the point of our compass here, and we're going to do an arc on the line AB here, and an arc on the line BC here. And it's important that you keep the compass the same size for both of those arcs. So you put the point here and you just move it so you've got an arc there on the line AB and an arc here on the line BC. Okay, so next we're going to lift up our compass and we're going to put the point of the compass here. So we're going to put the point of the compass where the arc and the line AB meet, and we're now going to do an arc in this direction. So we're going to get our compass and we're going to do an arc in this direction, and it'll look something like this. So that's where the point of the compass is, and we do this arc looking like that. Now we're going to lift it up, and we're now going to put the point of the compass here, and we're going to do another arc in that direction, and it would look something like this. And then finally, what we're going to do is get a ruler and a pencil, and we're going to join up the center of the angle ABC to where those two arcs meet. And that will be our angle bisector. That line will cut this angle exactly in half. So if this was a 60-degree angle, you would now have 30 degrees above it and 30 degrees below. So that line is called the angle bisector. And that's a very important construction. So we've constructed the perpendicular bisector, and we've now constructed the angle bisector. Okay, our next construction is to construct a line perpendicular to AB. So it's going to be a line that's at right angles to AB, and that passes through the point C. So it's going to be a line that passes through C and is at right angles to AB. And we're going to do that again with our compass, our pencil, and our ruler. So first of all, what we're going to do is get our compass, and we're going to put the point of the compass on C, and we're going to set it so that it's longer than the distance between C and the line. So it's a bit further than that. So it's not just going to reach the line, it's going to be a bit further, but it also needs to make sure that it reaches the line on two different places. So if I set it too large, so if I set it over here, it would cross somewhere over here, but it wouldn't actually meet the line. So I've set it about here, so it's a bit longer than the distance to the line. And we're going to do two arcs, one here to the left and one arc to the right. And again, it's very important that you keep your compass the same size the whole way through. Next, what we're going to do is, keeping the compass the same size, we're going to now lift it up and we're going to put it on the point here. Okay, so putting the compass here, what we're doing is an arc below the line, and it's going to be below C, so it's going to be an arc in this direction. And then we're going to lift it up and we're going to repeat it here. So we're going to put our point of our compass here, and we're going to do another arc below. And if you get your ruler and pencil and join up from C to where those two arcs meet at the bottom here, that line will be perpendicular to the line AB, and it will obviously pass through C. And that's it. So we've constructed the perpendicular to the line AB that passes through the point C. We're now going to construct a perpendicular to the line AB that passes through the point C, which is on the line. So in other words, we're going to make a perpendicular line using our ruler, our compass, and our pencil, and it's going to be a perpendicular line to AB, so it's going to be at right angles, and it's going to pass through the point C. So our first step is to put the point of the compass on C, and we're going to set the compass so that it's getting close to the distance between C and B. So I'm going to put it about this distance here, and we're going to do an arc on this side, and we're going to keep it the same size and do an arc on the other side. So it would look something like this. So we've put the point of the compass there, and we've done an arc on this side and on that side, and it's the same distance. Okay, so now what we're going to do is we're actually going to look at this line going from here to here, and we're now going to construct the perpendicular bisector of that, so using the same steps as before. So our first step is to put the point of the compass here and set the pencil so it's past C, and then we're going to do an arc above C and below C, and keeping the compass the same size, we're then going to swap over and we're going to put the point of the compass here, and again keeping it the same size, we're going to do an arc above and below. And then finally, if we join up these 2 points there and there, that line will pass through C at 90 degrees. So that is a line that is perpendicular to AB and passing through C. And that's it. Our last construction that we're going to look at is constructing an equilateral triangle. And remember, an equilateral triangle, all the sides have the same length. So this is quite a nice one, that if you put your point of your compass here and you put your pencil of your compass on the end of the line, that'll be 5 centimeters. And then if you do an arc above, it would look something like that. So all of these points are 5 centimeters away from here. Now keeping the compass the same size and putting the point of the compass on this side and putting the pencil here, now doing the same thing. And then we'd end up with something that looks like this. And this point here would be 5 centimeters away from this end of the line, and would also be 5 centimeters away from this end of the line. So if we get a ruler and pencil and join them up like so, so there and there, that will be an equilateral triangle. So it'll be a triangle where the sides are 5 centimeters, so that's 5 centimeters, that's 5 centimeters, and that's 5 centimeters. And also the angles will be 60 degrees, so that'll be 60 degrees, that'll be 60 degrees, that'll be 60 degrees, and that's it. Okay, so they were our constructions. If you do want to watch full videos on them and me showing you how to do each one of them really clearly using a compass, a ruler and a pencil, watch the videos above there. Okay, let's have a look at our next topic. So our next topic is loci, and that's video 75, 76 and 77 on Corbettmaths. And our question says to draw the locus of all the possible points that are 2 centimeters away from the line below. So in other words, we've been given a rule and we've got to draw on all the possible positions the points can be that follow that rule. So we want to draw all the points that are 2 centimeters away from this line. So the points above the line would be quite straightforward. You could be 2 centimeters just above the end. You could be 2 centimeters above there. You could be 2 centimeters above here. And you could be anywhere that's 2 centimeters above the line, like so. Alternatively, it could be 2 centimeters below the line, so it could be 2 centimeters there, 2 centimeters there, and you get your ruler and pencil, you make sure all the points are 2 centimeters below the line. So it looks something like this, where you've got all the possible points above the line and all the possible points below the line. And then what you do is get your ruler and join and go through the points. They're all 2 centimeters above and below. Now obviously if you were using a ruler and pencil, they would all be in a nice straight line, so this point here wouldn't be there, it would be actually up there. Okay, and so these points above here and below here are all 2 centimeters away from the line. But what about the end of the line? So if we're at the end of the line here, we could have 2 centimeters to the right, so that would be there. And then we could be 2 centimeters here, or 2 centimeters here, or 2 centimeters here. And as you can see, we're forming this semicircle where they're all 2 centimeters away from the end of the line. So it looks something like this. And with a compass and a pencil, you'd put the point of your compass here and your pencil here, and you draw a nice semicircle going around like so, and that would join up perfectly. Excuse my freehand one, but that's just a little sketch there. And likewise, if we're at the end of this line here, we could have 2 centimeters here, and if we measure the points that are all 2 centimeters away from the end of the line, again it would be another semicircle. And all of these points would be 2 centimeters away from this end of the line. So what we would do is again get the point of our compass and put it there, and then put the pencil 2 centimeters away, and then draw a nice semicircle going around through those points. So that's it. Okay, let's have a look at our next question. So this time we've got a diagram and we've got the points A and B, and we've got a scale that 1 centimeter is 1 mile, and we've got land and we've got sea. And the question says a boat is within 8 miles of A, so it's within 8 miles of A, and it's within 5 miles of B. Shade the possible positions of the boat. And one thing I should have said in this question is the boat's at sea. So it's not on land, it's at sea. So we know that it's within 8 miles of A. And we know that 1 centimeter is 1 mile. So what I would do is I would measure 8 centimeters and I would set my compass so that it is 8 centimeters. So I put the point of the compass on A, and I would put the point, my pencil, so it's 8 centimeters away. So I put my pencil where the sea and the land meet, and I would draw a circle. And this circle has got a radius of 8 centimeters, and it would look something like this. It's a freehand sketch, sorry. It's got a radius of 8 centimeters, and it's a circle that looks something like that. Okay, next, we're now told that the boat is within 5 miles of B. So within 5 miles of B, and that's 5 centimeters. We'd get our compass, we'd measure it, so the distance between the point and the pencil is 5 centimeters, and we'd put the point here, and it would be over here somewhere. So we'd put the pencil where the sea and the land meet, and we'd draw another circle. And this circle's a bit smaller, it's only got a radius of 5 centimeters this time, and it would look something like that. And again, sorry, excuse my diagram. So this circle has got a radius of 5 centimeters, and this circle has a radius of 8 centimeters. And we were told that the boat's within 8 miles of A, so in other words, it's in here somewhere, but it's also within this circle as well. So that means the possible positions of the boat would be in this region here. And that's it. If you want more practice on loci, videos 75, 76 and 77 will go through more examples. Also, there's some fantastic practice questions that you can do on Corbettmaths. So if you go to Corbettmaths and go down to worksheets and click on it and go down to those video numbers, beside that you'll see practice questions and they'll be ideal to practice as well. The next topic is views and elevations. So views and elevations are whenever you're looking at 3D shapes, looking at it from different perspectives and considering how the shape will look if you look at it from those angles or those perspectives. So here we've got a shape. It's a load of multi-link cubes stuck together, and I'm going to look at it from different angles. We've been asked to draw what the front elevation would look like. So if I was standing here, if I was small and I was looking at it from here and this was the front of this shape, I would just see these four blocks, this one, this one, this one and this one. So I would see this shape here, and I could get my pencil and ruler and draw these really tidily, excuse this, and that's what I would see. I would see a rectangle that was 1, 2, 3, 4 blocks across, but that's what I would see. I would see that rectangle. So again, that's the front again. Now I'm going to draw the side elevation. Now there's two different side elevations here. I could draw it from the left hand side or I could draw it from the right hand side, and I'm actually going to draw both. So let's start off with the left hand side. So if I was here at the side and I was looking at it that way, I would again see a rectangle and it would be 1, 2, 3, 4 blocks across. So it would be 4 blocks across like so. And I would draw it like that. Alternatively, I could draw it from the other side, so I could be standing over here and I could be looking at it from this side here, and again I would see 1, 2, 3, 4 blocks. Now they're not all level with each other, but that's what I would see. I would see the block on the left, the block in the middle, the next one back and the back one there. So I would see again 4 blocks. Some people like to put in the lines as well in between, the one on the left hand side, that one being further forward, and then I might see that one a bit further back and that one a bit further back and that one a bit further back. But again, it would just be a rectangle 4 blocks across. Okay, and finally, we've been asked to draw the plan view. The plan view is from above. It's the bird's eye view as such. So we're going to pretend that we're above the shape and we're looking down on it. So if we were looking down at it from above, we would see our 4 blocks at the bottom. So our 4 blocks would be going along the bottom like so, 1, 2, 3, 4. And I'm looking straight down. So then on the left hand side, it would go up. So it would go like 1, 2, 3, 4, like so, if I'm looking down from the top. Then it would go across and down, across and down, across and down, and across and down. So it would look something like this from above the shape. So, and that would be the plan view, the view from above. So whenever you're drawing shapes from different perspectives, you've got the front elevation, which is the view from the front. You've got your side elevations, which are the views from the sides, and you've got your plan view, which is the view from above. Okay, let's have a look at our next topic. So our next topic is speed, distance and time, and that's video 299 on Corbettmaths. So if we consider a speed such as 30 miles per hour, we would know that in 1 hour we would travel 30 miles because it's 30 miles per hour. In 2 hours we would travel 60 miles, in 10 hours we would travel 300 miles and so on. Now if we divide the distance we travel by the time, we will always get that speed. 30 divided by 1 is 30, 60 divided by 2 is 30, 300 divided by 10 is equal to 30. So that means that our speed is equal to distance divided by time. Also, if we multiply the speed by the time, so 30 times 1, we get 30, 30 times 10, we get 300. If we multiply the speed and the time together, we'll get the distance traveled. And finally, if we divided the distance by the speed, we get time. So it's very important to be able to know these. So speed is equal to distance divided by time, distance is equal to speed times time, and time is equal to distance divided by speed. So let's have a look at our first question. So our first question says, a car drives 171 miles in 4 hours and 45 minutes. Calculate the average speed in miles per hour of the car. So speed is equal to distance divided by time. If we divide the distance, the 171, by the time, we'll find the speed of the car. So speed is equal to distance divided by time. The distance the car travels is 171 miles. So that's going to be 171. And we're going to divide that by the time. Now the time is 4 hours 45 minutes. Now whenever we're dealing with speed, distance, time, we've got to be careful. We're finding the speed of this car miles per hour. So we want to get this as hours. Now if we think of 45 minutes is 3/4 of an hour. So we're going to divide by 4.75 because 45 minutes is 3/4 of an hour. So it's going to be 4.75. And if we do 171 divided by 4.75, let's see what we get. 171 divided by 4.75 is equal to 36. So the average speed of the car is 36 miles per hour, and that's it. So speed is equal to distance divided by time. And just be careful that if you have hours and minutes, that you write that as just hours. So for instance, in this case, it was 4.75. If it was 15 minutes, that'll be 1/4 of an hour, so it'll be 4.25. If it's 4 hours and 30 minutes, that'll be 4.5 because 30 minutes is half an hour. If you're not sure what the minutes is, if you divide the minutes by 60, because it's 60 minutes in an hour, that will give you the decimal part. So if we done 45 divided by 60, that's 0.75. 4.75, so we know it'll be 4.75. Okay, let's have a look at our next question. Okay, our next question says, Josie drives 200 miles at an average speed of 60 miles per hour. How long does the journey take? So we're trying to find how long it takes, that's time, and time is equal to the distance divided by the speed. If we divide the distance by the speed, we'll see how long the journey takes. So the distance is 200 miles, and the speed is equal to 60 miles per hour, so divided by 60. So if we do 200 divided by 60, that will tell us how long the journey takes. Now this could be a calculator question or a non-calculator question. I'm going to do this question as if it was a non-calculator question. So I'm going to do 200 divided by 60 and see what we get. So how many 60s go into 2? 0 remainder 2. How many 60s go into 20? 0 remainder 20. How many 60s go into 200? That's going to be 3, which is 180, so 3. And then that's going to leave us with 180, the remainder will be 20. How many 60s go into 200? 3, remainder 20. How many 60s go into 200? 3, remainder 20, and so on. So we have got 3.33333, and it goes on forever. So 3.3 reoccurring. So 3.3 reoccurring hours. So her journey takes 3.3 reoccurring hours. Now, in some questions, we might want to change this into hours and minutes. So let's do that. So it's going to take 3 hours. 3 hours. Now we've got 0.33333 and so on. 0.3 reoccurring is equal to a third. So that's going to be a third of an hour. And an hour has 60 minutes, and a third of 60 is equal to 20 minutes. So the journey will take 3 hours, 20 minutes. And that's it. This time we're told an aircraft flies at an average speed of 350 kilometers an hour for 2 hours and 24 minutes. How far does the aircraft fly? So if we want to find distance, distance is equal to speed times time. So if we multiply the speed by the time, we'll find how far the aircraft travels. So the speed, well, the speed is equal to 350. And the time, we're going to multiply by the time now. It's 2 hours and 24 minutes. So I want to multiply by 2 point something. And I'm going to need to change my 24 minutes into a decimal number. So it's 24 minutes, so it's going to be 24. And if we divide that by 60, we'll get that as a decimal. 24 divided by 60 is equal to 2/5 or 0.4. So it's going to be 2.4 hours. So if we do 350 multiplied by 2.4, that would tell us how far the aircraft travels. So 350 multiplied by 2.4 is equal to 840. And make sure we put the right units on, kilometers. So the aircraft flies 840 kilometers, and that's it. Let's have a look at our next topic. So our next topic is called distance time graphs, and that's video 171 on Corbettmaths. So here we've got a distance time graph, and we've got the distance from home. So it starts at 0, so that means they're at home, and it goes up in 2, so it goes 2 kilometers, 4, 6, 8, 10, and so on. And horizontally, we've got the time, so it starts at 8 a.m, and we've got 9 a.m, 10 a.m, and so on. And we're given some information. We're told Rosie jogged to her friend's house, so Rosie starts at home, and she jogs to her friend's house. And after having a short rest, Rosie then jogged home, arriving at 10:30. And we were told to complete the distance time graph. So let's find out where 10:30 would be. So if we look at 8 a.m. and 9 a.m, let's find out where 10:30 would be. So 10:30 is 1, 2, 3, 4 blocks going from 8 a.m. to 9 a.m. And after 2 of them would be 8:30. So if we look at 10 a.m, we've got 1, 2 blocks, so that would be 10:30 there. So that is 10:30. And we've been asked to complete the distance time graph. Well, she jogs home, so we now need to draw a line, a straight line going from here down to 10:30. And it would look something like this. Okay, part B. So part B says, how long did Rosie rest for? So as you can see, she rested for 1 block. And when I say block, that's a collection of 5 of the little small squares. 1, 2, 3, 4, 5. It's where the line is slightly thicker. So she rests for 1 block. So as we spotted earlier, we knew that 2 of them was 10:30. So this should be 15:15. Let's check. So we've got 8 o'clock, 8 a.m, 8:15, 8:30, 8:45, 9 o'clock. So each one of the smaller blocks, or those collection of 5 squares, is 15 minutes. So Rosie rested for 15 minutes. Okay, and part C says, when did Rosie jog at the fastest speed? So in other words, did she jog to her friend's house at a faster speed than whenever she jogged home? If it's steeper on a distance time graph, it means it's a faster speed. And as you can see, the line going to her friend's house is slightly steeper than the line coming back. This is a steeper line than this one. So the jog to her friend's house is faster than the jog home because the line is steeper. And I've just written that down, going to her friend's house because the line is steeper. Okay, let's have a look at our next topic. So our next compound measures topic is density, and that's video 384 on Corbettmaths. So here's part of the Corbettmaths revision card, and density is equal to mass divided by volume. So if you want to find the density of something, you do its mass divided by its volume. But we can rearrange this. We can multiply both sides of this formula by volume. So if you multiply both sides of this formula by volume, you'll get density times volume is equal to the mass. So if you want to find the mass of something, you can multiply its density by the volume. And finally, if you divide both sides of this formula by density, you get mass divided by density is equal to volume. So if you want to find the volume of a material, you can divide its mass by its density, and that'll give you its volume. So let's have a look at some questions now. So first of all, we've been given a piece of metal has a volume of 50 centimeters cubed and a mass of 900 grams. Calculate the density of the metal. So we want to find the density of the metal. So the density is equal to mass divided by volume. So if we want to find density, we do mass divided by volume. So the mass of the metal is 900 grams. So we're going to do 900 divided by the volume of the metal, which is 50. And if we do 900 divided by 50, we'll find the density of the metal. So 900 divided by 50 is equal to 18. So it's going to be 18. Now we're dividing mass, which is grams, by the volume, which is centimeters cubed. So the units for density will be 18 grams per centimeter cubed. So that means the density of this metal is 18 grams per centimeter cubed. Okay, let's have a look at our next example. Okay, let's have a look at our next question. So our next question says a glass paperweight has got a mass of 420 grams and the density of the glass used is 2.5 grams per centimeter cubed. Find the volume of the paperweight. So the volume is equal to mass divided by density. So what we want to do is we want to find the volume of the paperweight. So we want to do its mass divided by its density. So the volume is equal to the mass, which is equal to 420, divided by the density, which is 2.5. And when we do 420 divided by 2.5, we will find the volume of this paperweight. So 420 divided by 2.5 is equal to 168, and our units will be centimeters cubed. And that's it. Okay, and let's have a look at one more example. So this time we've been told Kylie has a solid glass cube. So she's got a solid glass cube. The length for each side of the cube is 3 centimeters. So the cube's got a side length of 3 centimeters. The density of the glass used is 2.5 grams per centimeter cubed. And it says find the mass of the cube. So mass is equal to density multiplied by volume. So we want to find the mass of this cube. So we know its density. Its density is equal to 2.5. And we want to multiply that by the volume. So to find the mass, we're going to do 2.5, the density, multiplied by the volume. But in this question, it's not obvious what the volume of the cube is. We're told the side length of the cube is 3 centimeters, but we don't know its volume. But we know enough information to work it out. The volume of a cube is the length multiplied by the width multiplied by the height. And because it's a cube, all of the side lengths are the same, so it's going to be 3 multiplied by 3 multiplied by 3. And 3 times 3 is 9 times 3 is 27. So the volume of the cube is 27 centimeters cubed. So to find the mass of the cube, we're going to do the mass is equal to the density multiplied by the volume. So we're going to do the density 2.5 multiplied by 27. So 2.5 multiplied by 27 equals 67.5 grams. And that's it. So the mass of this cube will be 67.5 grams. Okay, let's have a look at our next topic. So our next topic is pressure, and that's video 385 in Corbettmaths. So pressure is equal to force divided by area. So this is part of the Corbettmaths revision card, and pressure is equal to force divided by area. So if we divide the force by the area, we'll find the pressure. And if we rearrange this, if we multiply both sides of this formula by area, we would get the pressure times area equals force. So that means that the force is equal to the pressure times the area. And if we divided both sides of this equation by the pressure, we'd find that force divided by pressure is equal to area. So it's very important to remember that pressure is equal to force divided by area. So here we've got our question, and it says a box exerts a force of 4,000 newtons on a table. So a box has been placed on a table, and it exerts a force of 4,000 newtons on that table. And the area of the base of the box is 250 centimeters squared. Work out the pressure on the table in newtons per centimeter squared. So we want to find the pressure on the table. So pressure is equal to force divided by area. Pressure is equal to force divided by area. So if we divide the force, which is 4,000 newtons, by the area, which is 250 centimeters squared, that would tell us the pressure. So 4,000 divided by 250 is equal to 16. And that's measured in newtons, because we had 4,000 newtons, and we're dividing by 250 centimeters squared, so it's going to be newtons per centimeter squared. And that's it. So the pressure on the table is 16 newtons per centimeter squared. And that's it. So if you want any extra practice on pressure, if you go to that ultimate GCSE practice booklet, there's a question out on pressure for you. Okay, let's have a look at our next topic. So our next topic is population density, and that's video 384A in Corbettmaths. So population density is calculated by taking the population and dividing it by the area. So here we've got a question that says the population of a county is 980,000 and the area of the county is 3,200 square kilometres. Work out the population density of the county. So to work out the population density is equal to the population, which is 980,000, and we'll divide that by the area of the county, which is 3,200 square kilometres, and that gives us an answer of 306.25 people per square kilometre. And that's it. So the population density of the county is 306.25 people per square kilometre. Okay, let's have a look at another question. So this time we're told the area of the county is 5,000 square kilometres and the population density of that county is 315 people per square kilometre. Work out the population of the county. Now there's two different ways we can consider this. The first approach is by looking at the area of the county, which is 5,000 square kilometres, and the population density is 315 people per square kilometre. So if we take the 5,000 and multiply that by 315, that will tell us the population of the county. And that's equal to 1,575,000, and that's it. So if we take the area and multiply that by the population density, we'll find the population of the county. Another way to do it is to actually look at the formula. Population density is equal to population divided by area. If we want to find the population, well, we don't want this divided by area, so we'd multiply both sides by the area. So we'd multiply the left hand side by area and the right hand side by area, and that would give us the population density times the area is equal to the population. So we get the population density multiplied by the area is equal to the population. So we would do the population density, which is 315, multiplied by the area, which is equal to 5,000, and that would give us the population, which is 1,575,000, and that's it. So this has been population density. Okay, let's have a look at our next topic. So our next topic is parts of the circle. So here we've got some parts of the circle that you need to know off by heart. We've got the radius, and the radius is the distance from the center to the edge of the circle. We've got the diameter, that's the distance across the middle of the circle, so through the center. You've got the circumference, that's the distance around the outside of the circle, and you've got the chord. The chord's a line that joins one part of the circle to another part of the circle. Now let's look at some more parts of the circle. So we've got the arc, which is part of the circumference. We've got a tangent, which is a straight line that touches the circle once and carries on. We've got a sector, which is part of the circle, this green region here, or I like to think about it in terms of a slice of pizza. And then we've got a segment. And so a segment is if you've got that chord that goes from one part of the circle to the other part of the circle, and the segment is one of those regions, such as this. Okay, so it's very important to know these parts of the circles as well. And if you've got the Corbettmaths revision card on that, that's very useful. The next topic we're going to look at is finding the circumference of the circle. So the circumference is a fancy name for the perimeter of the circle. It's the distance around the outside of the circle. And the circumference of a circle is found by working out pi times diameter. So if you multiply pi by the diameter, the distance across the circle going through the center, that will tell you the circumference of a circle. So it's very important to know where pi is on your calculator. And if you look down here on my calculator, I've got a yellow pi there. So because it's in yellow, that means I need to press the shift button first of all, and then press the button here just beneath the pi symbol, and that then will bring up pi on the calculator. So in this question, we've been asked to find the circumference of a circle that has got a diameter the whole way across of 14 centimeters. So the circumference of the circle is pi times diameter. So it's going to be pi times the distance across the circle, which is 14. So that's going to be pi times 14. So we on our calculator, we press shift and then the pi button, this one here, it'll bring up pi. Then you'll do times 14. And then press equals, and it will tell us the circumference of a circle. Now sometimes it will come up like this, 14 pi, depending on the mode of your calculator. So you'd press the SD button there, and then it will tell you the circumference of a circle. And here we've got the circumference of the circle will be equal to 43.98229 and so on centimeters. I'm going to round this to two decimal places, so I'm going to write 43.98 centimeters. So the circumference of the circle will be 43.98 centimeters. And always remember your units. The circumference is a perimeter, it's the distance around the outside of the circle. So if the diameter is 14 centimeters, the circumference will be measured in centimeters also. Okay, and also we might be given a circle like this where we've got the radius is 5 centimeters. So remember the circumference is pi times diameter. So the diameter is the whole way across the circle. So if the radius is 5, that means the diameter of this circle would be 10. So we would do circumference is pi times diameter. So we'd do pi times 10, and then you would just work out what that is. Okay, our next topic is the perimeter of a semicircle. So here we've got a semicircle. You can see it's got a radius, the distance from the center of the circle, if it was a full circle, to the edge is 3 centimeters. So the whole way across would be 6 centimeters. And we've got this arc at the top. And we want to find this distance from here around to here. And that will be half of a full circle because it's a semicircle. So if I treat this as a full circle to begin with, and I do pi times diameter, I get the circumference of the whole circle. And then if we half it, and you'll get just this distance here, just the length of this arc at the top. So we can then do 6 plus whatever that is. So we're going to need to use the circumference formula. So that circumference is equal to pi times diameter. So we're going to do pi on our calculator times by the diameter of the circle. And the diameter is 6 here, the whole way across. So we're going to do pi times 6. That's equal to 18.8495592 and so on. And it's important not to round this because we're going to be doing more calculations with this. So you may just want to keep it on your calculator display so then we can do the next stage. So whenever you do pi times 6 and press equals, keep that on your calculator display. So that's the circumference of the whole circle. Now we're dealing with a semicircle, which is half of a circle. So if we take that 18.849 and so on, I'm just going to do some dots so that I don't have to write the whole thing down. And if I divide that by 2, so on my calculator, I've already got that on my calculator. If I press divided by 2, so it comes up with answer ANS divided by 2 on my display, and press equals, I get, it says 3 pi to begin with, and then I press the SD button, and that gives me 9.424777961 and so on. So that 9.424 so on centimeters would be the distance from here all the way around the semicircle to here. So that distance from here around to here would be 9.42477 and so on centimeters. Now we want to find the perimeter of this semicircle, so that's going to be the length of all the sides. So we've got the base and this arc, so we're going to do 9.42477 and so on, and just keep it on your calculator display, plus, and we've got the base. Now the base of the shape is 6 centimeters. We've got our 3 and another 3, so plus 6 gives us 15.42477 and so on. Now I'm going to round this to 2 decimal places. So whenever I round this to 2 decimal places, that would give me 15.42 centimeters. Now it's perimeter and we're dealing in centimeters, so our units were centimeters, and that's why I use centimeters, and that's it. So next topic is arc length. And the formula to find the arc length, so the length from here round to here, is given by veta, the angle, over 360 multiplied by pi multiplied by the diameter. And this is video 58 in Corbettmaths, and this is part of the Corbettmaths revision card. And our question asks us to find the perimeter of this sector. So here we've got a sector. It's got a radius of 8, so the distance from the center to the edge of the circle is 8 centimeters, and we want to find its perimeter. So we're going to do 8 plus 8 plus whatever this arc length is. So the arc length is veta, so the angle is 14 degrees, divided by 360. Multiplied by pi, and now we're going to multiply by the diameter of the whole circle. So if we did have a whole circle here, the diameter would be 16 the whole way across, so multiply by 16, and that gives us 1.9547 and so on centimeters. So we've been asked to find the perimeter of this sector, so we're going to do 8 plus 8 plus 1.9547 and so on, and we're going to get our answer. So I've already got this on my calculator display, so I'm just going to press plus 8, and that gives me 17.9547 and so on centimeters. Or if I round it to 2 decimal places, the answer would be 17.95 centimeters to 2 decimal places. And that's it. Okay, let's have a look at our next topic. So the next topic is the area of a trapezium, and this is part of the Corbettmaths revision card. I've actually cut it into little pieces. So you've got the area for a trapezium is given by the formula a half bracket a plus b. So a and b are the 2 parallel sides of the trapezium. So we're going to add those 2 together, divide that answer by 2, and then times it by the height, and that will give you the area of a trapezium. So here's a trapezium. So the area would be equal to a half a plus b. They're the 2 parallel lines, so that's 7 plus 11. And then we'll get that answer and we'll multiply it by the distance between the parallel lines, which is 5. So when we do that, we get a half, and then 7 plus 11 is equal to 18, so a half of 18 multiplied by 5. A half of 18 is 9, so we've got 9 times 5. That's equal to 45 centimeters squared. And that's it. So to find the area of a trapezium, you add together the 2 parallel sides, you divide by 2, and then you times by the height, the distance between the 2 parallel lines, and that's it. And if you want more practice on that, that's video 48 in Corbettmaths. Okay, our next topic is to find the area of compound shapes. So that's whenever shapes have been put together. Now those shapes could be rectangles, triangles, semicircles, quarter circles, sixth circles, parallelograms, trapeziums. It could be loads of different shapes, and they've just been put together, and you need to find the area of them. So if you have a look here, we've got this shape. It looks like an arrow, but if we divide it into 2, we can see that there's 2 parallelograms. So we've got 2 parallelograms, and each of them has a length of 35 centimeters for the base, and the height of them, with the distance between the 2 parallel lines, as you can see, the whole thing is 52. When you divide that by 2, we get 26. That means the height of this parallelogram is 26 centimeters, and the height of this parallelogram is 26 centimeters. So all we need to do is work out the area of this parallelogram and the area of this parallelogram, and then add them together. The area of a parallelogram is the base times the height, so that's 35 multiplied by 26. And when we do that, we get 910 centimeters squared. Now these two parallelograms are identical or congruent, so that means that they both have the same area, so it's going to be 910 plus 910, and that's equal to 1820 centimeters squared. Our next topic is the area of a circle, and if you want to revise this topic in Corbettmaths and watch the full video, it's video 59. So the area of a circle is given by the formula pi r squared. And remember our order of operations, you square, you do any orders before you do any multiplications. So what it means is we're going to square the radius and multiply it by pi. So here we've got a circle and we want to find the area of this circle, and it's got a radius of 6 centimeters. The distance from the center to the edge is 6 centimeters. So the area is equal to pi r squared. So it's going to be area is equal to pi times the radius 6 squared. So what we could do is on our calculator, we're just going to type this in, pi times 6 squared. The great thing is your calculator will know the order of operations whenever you type in pi times 6 squared, and it'll work it out for you. Alternatively, you could do 6 squared, which is 36, and then do pi times 36, and you get the same answer. But I'm just going to type this in. I'm going to type in pi, so shift, and then the pi button here, and then that'll bring up pi, and then times by, so multiply by 6, and then squared, pressing the square button, and then I'm going to press equals. My answer would be 113.0973355. So the area of the circle would be 113.0973355. Or I'm going to round this to one decimal place, so 113.1 centimeters, and it's squared because it's area. That's it. Now if we were given the circle like this, where we knew the diameter being 20 centimeters, well, it was pi r squared, so it's pi times the radius squared. So if you know the diameter, you might need to half it. So in this case, the radius would be 10. So I would do pi times 10 squared. Okay, so let's have a look at finding the area of a semicircle. So that's video number 47 on Corbettmaths. So here we've got a semicircle, and using a similar approach to finding the perimeter of a semicircle, we're going to consider the whole circle. So here's a whole circle. Yep, there we go. So there's a full circle, and you can see the radius of the whole circle is 3 centimeters. So what we're going to do is we're going to find the area of the whole circle and then divide it by 2. So we're going to do pi times 3 squared, because that will give us the area of the whole circle. And when we do that, we get 28.27433, so on. And then what we're going to do is we're going to divide the area of the whole circle by 2. So we'll take our 28.27433, so on, and we'll divide that by 2, and we find that that's equal to 14.137166, so on, or 14.1 to one decimal place. Okay, let's have a look at our next topic. So the next topic is the area of a sector, which is video 48 in Corbettmaths. And just remember, you do have those practice questions in the link below, so if you do want to practice any of these questions as we're going through, there's questions there for you to try. Okay, so for the area of a sector, here's part of the Corbettmaths revision card. So we get the area of the sector is veta over 360, so the fraction of the circle, times by pi, times by the radius squared. So here we've got a sector, and again it's got an angle which isn't necessarily a nice angle. We've got an angle of 109 degrees, so we're going to have 109 over 360 times by pi multiplied by the radius of the circle. So if we had a whole circle here, the radius would be 0.7 centimeters, so 0.7 squared. And when we do that, we get that's equal to 0.46609 and so on centimeters squared. I'm going to round this to 3 decimal places, so I'm going to write 0.466 centimeters squared to 3 decimal places. And that's it. Okay, so let's have a look at our next topic. So our next topic is the volume of a prism. So to find the volume of a prism, we find the cross-sectional area. So whenever you've got a prism, it's got that constant cross-section, so it's got that shape that's the same the whole way through it. So for instance, this triangular prism has a triangle as the cross-section, and it's the same the whole way through it. So you get the area of that shape, and you multiply it by how long it is. So to find the volume of this triangular prism, we're going to find the area of the triangle at the front, and then just multiply it by 4. So to do that, let's work out the area of the triangle. So the area of a triangle is half the base times the height. So the area of this triangle would be half the base, so half times 7 multiplied by the height, 5. So whenever we do that, we get 7 times 5 is 35, and multiplied by half, or dividing it by 2, would give us 17.5 meters squared. So the area of this triangle at the front is 17.5 meters squared. Now we just need to multiply by how long the shape is, and the shape is 4 meters long. So if we do 17.5 multiplied by 4, that gives us the volume of this triangular prism. So multiplied by 4 equals 70 meters, and the units would be cubed because it's the volume, so 70 meters cubed. So to find the volume of a prism, you get the area of the cross section and then multiply by how long it is, or alternatively, it's standing upright, you multiply by how tall it is. Our next topic is the volume of a cylinder, and as you can see, this cylinder is standing upright, so we're going to find the area of the circle and then multiply by how tall it is. So the area of a circle, area equals pi r squared, so that's equal to pi times the radius. So this is the radius, 8, so pi times 8 squared. And when we do pi times 8 squared, we get that's equal to 201.0619298 and so on centimeters squared. So that's the area of the top. Now we're going to multiply that by how tall it is. Don't round this answer because we're multiplying it by 30. So if you round it, that multiplied by 30 can mean that you're somewhere out from the actual answer. So we're going to take our 201.0619 and so on. If you've got a new calculator display, just leave it there and press multiply by 30. And whenever you do that, you get times by 30, 6,031.857 and so on. And to one decimal place, that would be 6,031.9. And our units would be centimeters cubed. And that's it. Okay, so the next topic is looking at giving our answers in terms of pi. Now, I've previously looked at topics such as circumference and area of a circle, volume of a cylinder, and so on. And in all of those questions so far, we've been given our answers as decimals. Now, I've actually hinted in previous videos that we could actually give our answer in terms of pi. And that's working exactly. So rather than giving a decimal, we're given an exact answer in terms of pi. So let's have a look at a typical question. So we've got a cylinder has got a diameter of 8 centimeters. So we've got a cylinder. So if by magic, we've got a cylinder and it's got a diameter of 8 centimeters. So that means that the width of it is 8 centimeters. So the whole way across the circle at the top or the bottom is 8 centimeters. And the height of the cylinder is 15 centimeters. So the height is 15 centimeters. So we've now got our sketch. Now what we need to do is work out the volume of the cylinder in terms of pi. And what that means is rather than giving our answer as a decimal number, we're going to give it as perhaps something like 100 pi or 75 pi. And that means we've got an exact answer. So rather than actually having to work it out and then rounding it, we can actually just give it in terms of pi. So the volume of a cylinder, so we would find the area of the cross section, so in this case the circle, and then multiply by how tall the shape is. So let's get the area of the circle. So the circle has got a diameter of 8, so the radius of the circle is 4 centimeters, and the area of a circle is pi r squared, so pi times 4 squared. Now 4 squared is 16, so that means that we would have pi times 16, and then if we just put them together, like in algebra where we'd maybe write 16y or 16x, we're just going to write that's equal to 16 pi. We're just going to put the number in front of pi. So it means the area of this circle is 16 pi centimeters squared. So that's the area of this circle. And rather than rounding that as a decimal number and then multiplying it by 15 and so on, what we're just going to do is use that 16 pi. So to find the volume of a cylinder, we've found the area of the circle. Now we need to times it by how tall or how long the shape is. So the height of the cylinder is 15 centimeters. So to get the volume, we're going to do 16 pi, the area of the circle, times by how tall the shape is, which is 15. So what we're going to do is we're going to do 16 times 15 and then get our answer and just put pi after it. So 16 times 15 is equal to 240 and then pi. So the answer would be 240 pi centimeters cubed. And that's it. So we've left our answer in terms of pi, and our answer would be 240 pi centimeters cubed. So we're not actually having to work out what 240 times pi is and then write that as a decimal number. We can actually just give it in terms of pi, and this is particularly useful on non-calculator papers. Our next topic now is to find the volume of a cone. The volume of a cone is 1/3 pi r squared h. That means we're going to find 1/3 of pi times the radius squared multiplied by the height of the cone. So in this cone, we've got a radius of 20 and we've got a height of 21. So we're going to do 1/3 multiplied by pi, multiplied by the radius, which is 20 squared, and then multiplied by 21, the height of the cone. And when we do that, we get an answer of 2,800 pi, which would be 8,796.46 centimeters cubed to 2 decimal places. And that's video 359 in Corbettmaths. So the volume of a cone is 1/3 pi r squared h. Here's a pyramid, and if you've been given a pyramid and you're asked to find the volume of it, again the volume is equal to 1/3 the area of the base times the height. So it's going to be the volume is equal to 1/3 times the area of the base. Well, that's going to be 9 times 6. So 9 times 6 is equal to 54. So times 54 times its perpendicular height. So that's going to be from the base straight up to the top, which is 7 centimeters. And whenever we work that out, we get that's equal to 126 centimeters cubed. Our next topic is the volume of a sphere. So the volume of a sphere is 4/3 pi r cubed, and this is part of the Corbettmaths revision card here, and on Corbettmaths video 361. And here we've got a sphere, and it's got a radius of 14 centimeters. So to find its volume, we will do 4/3 multiplied by pi multiplied by the radius, which is 14 cubed. So I'm going to press the fraction button on my calculator, type in 4/3. I'm then going to press multiply by, and then pi times by 14, and then the cubed button, 11,494.04 centimeters cubed to 2 decimal places. And that's it. Okay, next, we've been asked to find the volume of a frustum. A frustum sounds complicated, but it's just a cone or a pyramid with the top chopped off. So here we've got, this is video 360A in Corbettmaths, and it says shown as a frustum of a cone, so as you can see the top's chopped off, that had a perpendicular height of 20 centimeters. So it did go up to a top point, just say there, and down again, and it did have a height of 20 centimeters in total. Now the height of this part is 10, so it would have had another 10 centimeters to have a total height of 20 centimeters. And we've been asked to find the volume of the frustum, so that's the bit that's left, this part here. So to do that, what we're going to do is we're going to work out the volume of the cone to begin with, so the whole big cone. We'll then work out the volume of the cone that's been chopped off, and then take them away and see what's left. So let's do the volume of the big cone. So the volume is equal to 1/3 times pi times the radius. So for the big cone, the radius is 8, so 8 squared, times its height, and we've been told its height was 20 centimeters. Okay, whenever we work that out, we can either get 1,280 over 3 pi. Alternatively, you can write it as a decimal number as 1,340.412866 and so on centimeters cubed. That's the volume of the whole big cone to begin with. Now the top was chopped off, and that is a smaller cone. It's similar to the large cone. You'll learn about similarity later, which means enlargement, but so we'll just work out the volume of this. So working out the volume of this smaller cone, it's got a volume of 1/3 times pi times the radius 4 squared times its height 10, and whenever we work that out we get, and that's equal to 160 over 3 pi, or alternatively 167.5516082 centimeters cubed. And then finally, to work out the volume of the frustum, well, we're going to take that away. So we're going to do 1,340.412866, take away the 167.5516082, and when we subtract them we get 1,172.86 centimeters cubed, and I've rounded that to 2 decimal places. So if you ask to find the volume of a frustum, you just work out the volume of whatever shape there was to begin with, whether it's a big cone or a big pyramid. You work out the volume of what's been chopped off, and then you take them away, and that'll tell you the volume of what's left. This time we've been asked to find the surface area, and here's a cuboid, and we've been asked to find the surface area of a cuboid, and the surface area is the area of all the faces of that particular shape. So this is a cuboid, so it'll have 6 faces. You've got the top, which is green. You've then got the bottom, which would be the same size, it would have the same area. You've then got the rectangle on the right hand side here in blue, and that would be the same as the rectangle on the left hand side. And you've got the rectangle at the front, the face of the front, this red one, and that would be the same as the back. So what we've got is we've got 6 rectangles we need to find the area of, and we need to add them all up. Now the great thing is that you've got pairs of them that are the same, the top and the bottom, the right and the left and the front and the back are the same. So if we work out the area of each of these ones, so what we can do is then we consider 2 of them and then add them all up. Let's call the front 1, the right hand side 2, and the top 3. Let's consider the front to begin with. So for face 1, we've got the width of the rectangle is 8, multiplied by the height of the rectangle, which would be 5, because here we've got a height of 5, so that means that the height here of this rectangle is 5, so we've got 8 times 5, and 8 times 5 is equal to 40 centimeters squared. So the area of the front is 40, that means the area of the back would also be 40 as well, so I'm just going to write it there as well. And then 2, we've got the right hand side here. If we look at this rectangle, it's got a length of 7 and a height of 5, so we're going to do 7 multiplied by 5, and 7 times 5 is 35, so that's 35 centimeters squared. So that means the area of this rectangle on the right hand side is 35, and that would be the same as the rectangle on the left hand side, so there's another 35 centimeters squared. And then the top, which is face 3, we've got 3. that has a width of 8 and a length of 7, because you've got 8 here, so that's going to be 8 there, and the 7 here will be there, so we've got 8 times 7, and 8 times 7 is 56 centimeters squared, and the top will be the same as the bottom, so we've got another 56 centimeters squared. So to find the total surface area of this cuboid, we're going to do 40 plus 40 plus 35 plus 35 plus 56 plus 56, and that would tell us the total surface area of this cuboid. And when we do that, we get a total surface area of 262 centimeters squared. So the surface area is the area of all the faces of that 3D shape. Okay, let's have a look at our next topic. So our next topic is the surface area of a cylinder, and that's video 315 in Corbettmaths. Now here we've got a cylinder, and we've been asked to find the surface area of this cylinder. Now this cylinder has 3 faces. It's got a circle on the top, a circle on the bottom, and it's got this curved face going around the outside. Now the area of the circles will be straightforward. We'll do pi r squared for the top, and then we'll do pi r squared for the bottom, and they'll also be the same area, so you could just do pi r squared for the top and multiply it by 2 or add it to itself. Now for this curved face going around the outside, if we were to straighten that out, that would be a rectangle, and the height of the rectangle would be 6 meters, and the length of the rectangle, that would be the circumference of the circle. So we're going to get the circumference of the circle and multiply it by 6, the height of the cylinder, and that would give us the area of the curved face. And then we'll add together the 2 circles and the curved face. So let's do that now. So let's start off by getting the area of the circle. So that would be pi times 5 squared, and that will give us the area of the circle, which is 78.53981, and so on. Then we've got the circle at the bottom, and that'll have the same area. So we'll have a circle beneath, and that'll have the same area. And then finally, we need to find the area of this curved face going around the outside of the cylinder. And to find that, we're going to find the circumference of the circle. So we'll do pi times diameter. So we'll do pi times 10, because the diameter of the circle will be 10. So pi times 10 will be 31.4159, and so on. And then we'll take the circumference of the circle and multiply it by the height of the cylinder, and that will tell us the area of the curved face. So we're going to do 31.4159, and so on. And I've got that in my calculator display, so I'll just press times 6, and that will give me 188.4955, and so on. So I'm going to add together now the area of the circle on the top, the 78.53981, and so on. I'll add another circle, so 78.53981, and so on. And I'll also add the area of this face, the curved face, which was 188.4955, and so on. And when I do that, I get that's equal to 345.575 to 3 decimal places, and then the units, because it's surface area and it's meters, will be meters squared, and that's it. Okay, let's have a look at our next topic. So the next topic is the surface area of a cone. So here we've got a cone, and to find the surface area of a cone, we have to get the area of the 2 faces, and that's the area of the circle at the bottom, which will be pi r squared, so that's straightforward. And then we need to find the curved surface area, so the area of the top of the cone, and that's given by the formula. Curved surface area is pi rl, where pi is obviously pi, r is the radius of the base of the cone, so that will be 6, and then l is what we call the slant height, so this diagonal length here of 11 centimeters. So let's find the surface area of this cone. So for this cone, we would do pi r squared, so pi times 6 squared for the base, and when we do pi times 6 squared, we get that's equal to 113.0973355, and so on. And then, so that's the area of the base. Now we need to find the curved surface area. So it's going to be pi times the radius, 6, times the slant height, which is 11. And when we do that, we get that's equal to 66 pi, or 207.345151, and so on. And when we add those together, we'll find the surface area of this cone, which would be 320.44 centimeters squared to 2 decimal places, and that's it. Okay, our next topic. Our next topic is the surface area of a sphere, so the surface area is 4 pi r squared. So here we've got a sphere, and we're going to find its surface area. So we're going to do 4 multiplied by pi multiplied by the radius, which is 5 squared. So we're now just going to work this out in our calculator. So we're going to do 4 multiplied by pi multiplied by 5 squared. And that gives us 100 pi, which is equal to 314.16 centimeters squared to 2 decimal places. And that's it. So our next topic is convert metric units for area and volume. So let's start off with converting metric units for area. So here we've got a rectangle, and it measures 3 meters by 2 meters. So it's 3 meters long and 2 meters wide. And here's the exact same rectangle. And instead of writing 3 meters, I've written 300 centimeters because there's 100 centimeters in a meter. So 3 meters would be 300 centimeters. And instead of writing 2 meters, I've written 200 centimeters because obviously 2 times 100 would be 200 centimeters. Now let's find the areas of these rectangles. Because they're identical, the areas will be the same. So to find the area for this rectangle, we multiply the length and the width together. So we're going to do 3 times 2. And 3 times 2 is equal to 6 meters squared. So the area for this rectangle is 6 meters squared. Now if we look at this rectangle is 300 centimeters long and 200 centimeters wide. So to find this area, we're going to multiply these together. So 300 times 200, well 3 times 2 is 6, and then add 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. And then that's measured in centimeters squared. So we've got the same rectangle, and its area would be 6 meters squared or 60,000 centimeters squared. So that means that 6 meters squared is equal to 60,000 centimeters squared. Or if we divide both of these by 6, we get 1 meter squared is equal to 10,000 centimeters squared. So in 1 square meter, there'd be 10,000 square centimeters. And that makes sense because if you had a square which was 1 meter by 1 meter, that would be 100 centimeters by 100 centimeters. So that'd be 100 rows of 100, which would be 10,000 little smaller centimeter squares in there. And that's it. So if we want to convert between meters squared and centimeters squared, we can multiply by 10,000. Or I like to multiply by 100 and multiply by 100 again because it's squared, so I know to multiply by 100 twice. And that's it. Okay, let's have a look at our next one, converting metric units for volume. So here we've got 2 cubes. One of them's got a side length of 2 meters and one's got a side length of 200 centimeters. So these cubes are identical. So if we know the side length is 2 meters, we can write 2 meters for the length, 2 meters for the width, and 2 meters for the height. So to get the volume of this cube, we're going to do the length times the width times the height. So we're going to do 2 times 2 times 2, which is equal to 8 meters cubed. So the volume of this cube is 8 meters cubed. So this cube's identical, so it will have a length of 200 centimeters, a width of 200 centimeters, and a height of 200 centimeters. So if we do 200 multiplied by 200 multiplied by 200, that will give us the volume of this cube. And the volume of this cube is equal to 2 times 2 times 2 is equal to 8, and then we're going to add on 6 zeros. 1, 2, 3, 4, 5, 6. So 8 million centimeters cubed. So 8 meters cubed would be equal to 8 million centimeters cubed. And if we divide both of these by 8, we get 1 meter cubed is equal to 1 million centimeters cubed. And that's it. So that's going to be really useful for converting between meters cubed and centimeters cubed. So you can multiply by a million to convert between meters cubed and centimeters cubed. And likewise, to convert back from centimeters cubed to meters cubed, you can divide by a million. I like to multiply by 100 and by 100 and by 100 again, and divide by 100, 100 and 100 again if I want to convert between them. And that will give me the same answer. So we're now going to look at imperial units. So that's videos 347 and 348 in Corbettmaths. So we have our metric units, which are centimeters, meters, grams, kilograms, milliliters, liters, and so on, the modern units. We've then got our imperial or older fashioned units. Hope we're not causing any offense to anyone there, but you've got your older fashioned, your imperial units, such as pounds, ounces, inches, feet, miles, and so on. And we're going to need to be able to convert between them. And here's a typical question where we're told the length of a table is 35 inches. So we've been given it in inches, which is going to be in imperial, and we're told that 1 inch is 2.54 centimeters. So every inch is 2.54 centimeters. And the question says, how long is the table in centimeters? So we want to convert this 35 inches into centimeters, and we're told that every single inch is 2.54 centimeters. So in other words, we've got 35 lots of 2.54 centimeters. So if we do 35 multiplied by 2.54, that will tell us then how many centimeters long the table is. So we'll do 35 multiplied by 2.54. And when we do that, we get that's equal to 88.9 centimeters. And that's it. And this is a calculator question, so you can just type in 35 multiplied by 2.54 and then just make sure we're putting centimeters on the end. Okay, so our next topic is Pythagoras, and here's part of the Corbettmaths revision card on Pythagoras' theorem, which is a squared plus b squared equals c squared, where a and b are the two shorter sides, and c is the length of the longest side, with the hypotenuse of the right angle triangle. So here's a right angle triangle, and we've been asked to find x, the length of the hypotenuse, the longest side. So I label the sides first of all. So I label the shorter side A, the next shortest B, and the longest side C. Now in terms of A and B, it doesn't actually matter which way around you label those as long as A and B are the two shorter sides. And we're going to substitute those values into Pythagoras' theorem. So Pythagoras' theorem is A squared plus B squared equals C squared. So if we substitute these values in, well, instead of A squared, we're going to write 5 squared. Instead of B squared, we're going to write 12 squared. And instead of C squared, we're going to write X squared. So we know that 5 squared plus 12 squared equals X squared. So now we're going to work out 5 squared and 12 squared. So 5 times 5 is 25. And remember, this is a calculator paper, so you can just write 5 squared plus 12 squared and press equals on your calculator. Plus, and 12 squared is 144, and that equals X squared. Now 25 plus 144 is 169. So that gives us 169 equals X squared. So we've got 169 equals X squared. Now obviously X is the length of the side here, so we can square root both sides. So that gives us square root of 169 equals X, and the square root of 169 is 13. So 13 equals X. That means that X equals 13 centimeters, and that's it. So that means that X equals 13 centimeters. Okay, let's have a look at a right angle triangle where we're trying to find the length of one of the shorter sides. So here's a right angle triangle, and again, Pythagoras' theorem is A squared plus B squared equals C squared. So let's label our sides. Now we don't actually know which one's the shortest here, so I'm just going to label this side, the XA. I'm going to label the 5 centimeters B, and obviously the longest side will be the hypotenuse, the side opposite the right angle, so that will be C. So we write down Pythagoras' theorem, that's A squared plus B squared equals C squared. And so A squared, well, that's going to be X squared plus, and instead of B squared, that will be 5 squared, and that equals C squared, which is 8 squared. So X squared, that's X squared plus, I'm working out 5 squared, well, 5 times 5 is 25, so that's 25, equals 8 squared, which is 64. Now here we've got X squared plus 25 equals 64. So we want to get the X squared on its own, so let's take away 25 from both sides. So that gives us X squared equals, and 64 take away 25 equals 39. So we've got X squared, and to find X we're going to square root 39. So we'll work out the square root of 39, and that equals 6.244997998 and so on centimeters. So let's round this to 2 decimal places. So that means that X equals 6.24 centimeters. And that's it. So Pythagoras' theorem is really useful for right angle triangles to find the length of missing sides, if you know 2 of them. And Pythagoras' theorem is also useful in situations where you've got shapes that are made up of right angle triangles. So for instance, if there was a rectangle and it's cut across diagonally, you may need to use Pythagoras' theorem to work out the lengths of the sides there and so on. Okay, let's have a look at our next topic. So with Pythagoras, we were dealing with right angle triangles, and we're using the lengths of 2 sides to find the length of the third side. With trigonometry, we're going to be dealing with right angle triangles again, but this time we're going to be involving angles. We're either going to be using 2 sides to work out the size of one of the angles, alternatively we'll be using an angle and one of the sides to work out the length of another side. And it's very important whenever you're dealing with trigonometry to know the trigonometric ratios or the trig ratios, and they are sine is equal to opposite divided by hypotenuse, the cos is equal to the adjacent divided by hypotenuse, and the tan is equal to the opposite divided by adjacent. And some students remember saying such as so, ka, toa, or I like to remember 2 old angels skipped over heaven carrying a harp. So it's very important you remember these trig ratios whenever you're answering a trigonometry question. So let's have a look at one now. So here we've been given a right angle triangle and we've been asked to find the sides of this angle x. And it's a right angle triangle, and we know that because it's been marked on, and we've been given the length of the hypotenuse is 10 centimeters, and we've been given the length of this side is 8 centimeters, and we've been asked to find the sides of this angle. So the first thing I do on a trigonometry question is to write down the trig ratios, and they are 2 old angels skipped over heaven carrying a harp. So 2 old angels skipped over heaven carrying a harp, or so ka toa. And they are that tan is equal to the opposite divided by adjacent, sine is equal to the opposite divided by hypotenuse, and that the cos is equal to the adjacent divided by hypotenuse. Now let's have a look at our triangle and figure out which trig ratio we're going to use in this question. And I do that by labeling the sides as the opposite, hypotenuse, and adjacent. So let's start off with the opposite. So the opposite is the side opposite the angle we're using or trying to find in the question. So we're trying to find this angle, so the side opposite that is this one. So this is the opposite. Then let's label the hypotenuse. So that is the longest side of a right angle triangle, and it's the side opposite the right angle. So this is the hypotenuse, and that means the side that we've got left is the adjacent, and it's adjacent to the angle we're trying to find, but it's not the hypotenuse, so that's the adjacent. So that is our opposite, hypotenuse, and adjacent. So we've labeled the three sides of the right angle triangle. So now we've labeled the triangle as the opposite, hypotenuse, and adjacent. Now we need to figure out which trig ratio we're going to use in the question. So here we've been given the hypotenuse is 10 centimeters. We've been given the adjacent is 8 centimeters. So we're going to use those two. And the opposite, we've not been given, and we're not trying to find out, so we're just going to cross it off. We're not going to be using any trig ratio that's involving the opposite. So we're not going to be using the tan, and we're not going to be using the sine. We're going to be using the cos in this question. The cos x is equal to the adjacent divided by the hypotenuse. That's the trig ratio we're going to use in this question. So let's substitute in the values for the adjacent and the hypotenuse into our trig ratio. So we've got the cos x is equal to the adjacent, which is 8, so 8, divided by the hypotenuse, which is 10. So we've got the cos of the angle, x, is equal to 8 tenths. So we know that the cos of the angle is equal to 8 over 10, or 0.8. But this angle obviously isn't 0.8 degrees. This angle is much bigger. So what we want to do is we want to find out what x is. So we want to get rid of this cos. So we're going to do the inverse cos, so the opposite of cos, to both sides of the equation. So whenever we do the inverse cos to both sides, on the left-hand side we'll just be given x, the angle we're trying to find. And then we want to do the inverse cos of 8 tenths. Now on your calculator, just above the cos in yellow, you've got a cos with a little -1. That's the inverse cos. So we would then press shift and then the cos button, and it would come up as cos with the little -1. And then you just type in 8 over 10, or 0.8, and then close brackets and press equals, and that will give you the size of the angle. And we find that x is equal to 36.86989 and so on degrees. And let's just round that to 2 decimal places. That'll be that x is equal to 36.87 degrees. And that's it. So in this question, we're asked to find the sides of this angle x. So my steps were, first of all, I wrote down the trig ratios. Then what I done was I looked at my right angle triangle and I labeled the side. So I labeled the side opposite the angle as the opposite, the hypotenuse as the hypotenuse h, and the adjacent as a. Then we knew we weren't dealing with the opposite in this question, so we crossed off any of the trig ratios involving the opposite. So we knew it was a cos question. We knew that the cos of x, the cos of this angle, is equal to the adjacent divided by the hypotenuse. So we found that cos x was equal to 8 tenths. This angle obviously isn't 8 tenths, so we need to do the inverse cos of that. So we press shift cos and then type in 8 tenths and press equals, and we get the size of this angle, which is 36.87 degrees. Okay, let's have a look at our next question. So this time we're going to find the lengths of one of the sides. So we've got this right angle triangle, and we know that the hypotenuse of this right angle triangle is 4 kilometers, and the size of this angle is 60 degrees. And we've been asked to find the size of x. So again, let's write down our trig ratio. So we've got 2 old angels skipped over heaven carrying a harp. So here we've got our right angle triangle. Let's label the sides. So we have got the opposite. So in the question we've been given the 60 degrees. So the side opposite it is x. So that's our opposite. Then we've got our hypotenuse, which is the side opposite the right angle. So our 4 kilometers is the hypotenuse. And the side left is the adjacent. So this side is our adjacent. Next, we cross off any side that has not been given or looked for in the question. So in this question, we're looking to find the opposite. We've been given the hypotenuse and we don't need the adjacent, or we're given the adjacent, so we can cross it off. So we then look at our trig ratios and we cross off any trig ratio that involves the adjacent. So we're not using tan and we're not using the cos. So in this question, it's a sine question, that sine x is equal to the opposite over hypotenuse. So let's substitute in our values. So we've got the sine of our angle, so that's going to be sine 60. So sine 60 is equal to the opposite, which is equal to x in this question, divided by the hypotenuse, which is 4. So we've got sine 60 is equal to x divided by 4. So we want to find out what x is. So we don't want this to divide by 4 in this right hand side of this equation. So let's multiply both sides of the equation by 4. So we've got sine 60 times 4, so that's going to be sine 60 times 4, and that's going to be equal to, and on our right hand side of the equation we had x divided by 4. We times by 4 to get rid of the divide by 4, so we're just going to be left with x. So we've got that x is equal to sine 60 times 4. So let's work that out. So on our calculator, press sine 60. Now make sure you close brackets, so close brackets. Multiplied by 4 is equal to 3.4641 and so on kilometers, and that's equal to x. So x is equal to 3.464 kilometers to 3 decimal places. And that's it. So x is equal to 3.464 kilometers to 3 decimal places. Okay, let's have a look at our next topic. So our next topic is exact trig values. And it can be useful to remember some of your exact trig values. So in other words, if you were to work out the sine of 0 degrees, that's equal to 0. The sine of 30 degrees, that's equal to a half. That's one I remember off by heart. The sine of 30 degrees is equal to a half. The sine of 45 degrees, that's equal to root 2, the square root of 2 divided by 2. The sine of 60 degrees is equal to the square root of 3 divided by 2. And the sine of 90 degrees is equal to 1. So it can be useful to remember those. The cos of 0 degrees is equal to 1. The cos of 30 degrees is equal to the square root of 3 divided by 2. So the cos of 30 degrees is equal to the sine of 60 degrees. They're the same as each other. The cos of 45 degrees is equal to the square root of 2 divided by 2, the same as the sine of 45 degrees. And the cos of 60 degrees is equal to a half. And I always remember that one as well. I always remember the sine of 30 degrees is equal to a half, and the cos of 60 degrees is equal to a half. And the cos of 90 degrees is equal to 0. And finally, tan. The tan of 0 is equal to 0. The tan of 30 degrees is equal to the square root of 3 divided by 3. The tan of 45 degrees is equal to 1. And the tan of 60 degrees is equal to the square root of 3. And the tan of 90 degrees is undefined. There's no answer for that. Okay, so we want to write down the values of these. So the sine of 30 degrees would be equal to a half. The tan of 45 degrees would be equal to 1, and the cos of 30 degrees, well, the cos of 30 degrees is equal to the square root of 3 divided by 2. And that's it. So next topic now is to have a look at 3D Pythagoras. So this is whenever we're dealing with Pythagoras in 3 dimensions. So here we've got a cuboid, and we've been asked to find the length of AG. So the length of AG is from A, going up diagonally, all the way up to G. So let's find the length of this line AG, this diagonal going from one corner up to the opposite corner. So if we want to find the length of this line, well, let's have a look and see what we've been given. So we've been given the length of the cuboid is 6, we've been given the width is 2, and the height is 3. So let's start off by looking at the base of this cuboid. So the base of the cuboid is a rectangle. We've got 6 and we've got 2. So if we turn this base into a right angle triangle, we can find the length AC. And that's going to be very important because we know this is a right angle triangle. So if we know what this is and we've got the 3, we can then find the length of AG. So let's find the length of AC to begin with. So AC squared, this is a right angle triangle here, it's a cuboid. So we've got AC squared is equal to 2 squared plus 6 squared. So 2 squared plus 6 squared would be equal to AC squared using Pythagoras. So that would mean that AC squared is equal to 2 squared is 4 and 6 squared is 36. So we've got AC squared would be equal to 40. So that means that AC would be equal to the square root of 40. Now in these questions I tend not to want to square root them. I like to work with surds because you're going to see in a minute we're going to square this again, so that makes it easier if we don't actually use decimal numbers and we use our exact answer. So we find the distance from A to C is equal to the square root of 40. So we've got this distance. Now if we look at this triangle ACG, this is a right angle triangle also, where this is our right angle there. So we know that AG is going to be the hypotenuse, it's the longest side, and our AC and our CG are our two shorter sides. So that means that AG squared is equal to AC squared plus CG squared. So substituting in our values, we've got AG squared is equal to AC squared, so that's AC, which is the square root of 40, squared, plus CG squared will be 3 squared. Now let's work this out. So we've got AG squared will be equal to, now if you've got the square root of 40 squared, that means the square root of 40 times the square root of 40. Now considering surds, that will be equal to 40 because root A times root A is A. So root 40 squared is 40 plus, and then 3 squared is 9. So we've got that's equal to 9. So we've got AG squared is equal to 49. Oh, this is great. Now we just want to find AG, so we want a square root. So we've got the square root of 49, which is equal to 7. So that means that from A to G would be equal to 7 centimeters, and that's it. Okay, let's have a look at our next topic. So our next topic is 3D trigonometry. So as well as doing Pythagoras in 3 dimensions, we also need to know for M8 how to do trigonometry in 3 dimensions. So here we've got a cuboid, and we've been asked to find the size of angle ACE, or ACE. So we've got ACE. So that's going to be the angle if we go from A to C, there, and then we're going to go from C up to E, so that's going to be this way. The angle we want to find is this angle in here. Let's call this angle X. So we want to find this angle in here. Now if we want to find this angle, we're going to need to know some of the lengths of the sides of this right angle triangle. So you can see AC is a right angle triangle, and we need to know the lengths of some of the sides to be able to find the size of that angle. 2 sides would be useful. So if you notice CG is equal to 3, the height of the cuboid is 3 centimeters. So that means that AE will also be equal to 3 centimeters. That means now we need to either find the length of EC or AC, and that means we can use trigonometry to find the size of this angle. let's find the length of AC. So here we've got on the base, we've got our ABC, and this is a right angle triangle as well, where we've got our two shorter sides of 6 centimeters and 2 centimeters. And this length, this diagonal will be the hypotenuse. So it'll be the longest side in this right angle triangle. So let's write that down. AC squared equals, and we've got AB squared plus BC squared. So it's going to be equals 6 squared plus 2 squared. Now 6 squared is 36. And 2 squared is 4, so we've got AC squared is equal to 36 plus 4, so that means that AC squared will be equal to 40. And if we square root, we get AC is equal to the square root of 40. So we've got the length of this line going diagonally from A across to C will be equal to the square root of 40. Now we've got this triangle ACE, and I tend to like to draw a sketch of it, so let's draw a sketch of that triangle, and let's label what we've got. So we know it's a right angle triangle. We know the height from A to E is 3, so we've got that's equal to 3 centimeters. So A, E, and then C's down there. We're trying to find this angle X down there. We've got that's equal to 3, and we've got A to C being the square root of 40. So that is our triangle where we've got A, E, C, A, E, C. We've got 3 centimeters, the square root of 40, and we've got our X. Now if we have a look at this triangle, we're now going to use basic trigonometry to find the sides of this angle X. So we've got our 3, that's our opposite. So we're using our 2 old angels skipped over heaven carrying a harp. So we've got our opposite, we've got our hypotenuse here, and we've got the side down here, this is our adjacent. Now we're not actually using the hypotenuse, so we can cross that out, and we can cross out any has the h in it for hypotenuse. So to find the size of this angle here, this x, we're going to use tan. We're using 2 old angels, so tan opposite adjacent. We want to find the tan of the angle, so tan x is equal to the opposite divided by the adjacent. So the opposite is 3, and the adjacent is the square root of 40. So that's great. We now know that the tan of this angle is 3 divided by the square root of 40. So if we do the inverse tan, we will find the size of the angle. So the inverse tan of 3 over the square root of 40. And we can type that in our calculator. So shift tan, the fraction button, 3, and then on the denominator, the square root of 40. And if we press equals, we get that's equal to 25.377 degrees to 3 decimal places. And that's it. So we have used trigonometry in 3 dimensions to find the size of that missing angle. Our next topic is a sine rule. So the sine rule is really useful whenever you want to find out missing angles or missing sides on non-right angle triangles. Because with right angle triangles, we can use basic trigonometry. So the 2 old angels skipped over heaven carrying a harp. But whenever you've got triangles that aren't right angles, the sine rule is really useful. And here's part of the Corbettmaths revision card. So if you've got a triangle such as this, where you've got capital A, capital B, and capital C being the angles, and then you've got the opposite sides being little a, little b, and little c, the sine rule is A over sine A would be equal to B over sine B, which is equal to C over sine C. So the sine rule is really useful whenever you know a side and the opposite angle, such as this triangle here. We've got a side 9 and we've got the opposite angle 85 degrees. So that's going to be really useful in this question. So let's use the sine rule to work out the size of x, this missing side. So the sine rule is A over sine A equals B over sine B. So what that means is we've got x over sine 45, so x over sine 45, because they're opposite each other, will be equal to 9 over sine 85. So 9 over sine 85. So we've got our x divided by sine 45, and we've got that's equal to 9 divided by sine 85. So if I do 9 divided by sine 85 in my calculator, that gives me x over sine 45 will be equal to 9.0343, and so on. And I keep that on my calculator display, and I'm just going to write it on the page like this. Now I want to find what x is, so I don't want this sine 45 on the denominator. So if I want to get x on its own, I want to get rid of the divide by sine 45. So I'm going to multiply both sides by sine 45. So multiplying the left hand side by sine 45 will just leave me with x. On the right hand side, I'm going to have my 9.0343 and so on, and it's still in my calculator display. And then I'm going to type in times sine 45. So if I just press times sine 45 in my calculator and press equals, I get x is equal to 6.388 and so on. Or I could round this to 2 decimal places, and I could round it to x equals 6.39 to 2 decimal places. And I should put in my units, which is centimeters. And that's it. So the sine rule is really useful, particularly if you've got a side and the opposite angle, and that is that A over sine A will be equal to B over sine B. And you can use it to find missing sides, like this example, or we can use it to find missing angles, like our next example. So in this case, we've got our side and our opposite angle, we've got our 35 centimeters and our 80 degrees, and we've got our 16 centimeters and our vita. And the sine rule is A over sine A equals B over sine B equals C over sine C. Now, one thing you can do is, whenever you're doing miss an angle questions, rather than using A over sine A, you can actually flip it over and write sine A over little a will be equal to sine B over little b, and that's equal to sine C over little c. So if you are finding angles, it can be useful to actually flip over the formula and to write it the other way around. So sine A over little a equals sine B over little b equals sine C over little c. Now if we have a look at our triangle, we do have an angle on the opposite side, and we're trying to find another angle, and we've got its opposite side. So we can write that down. We could write sine vita, what we're looking for, vita, sine vita over 16, will equal sine 80 over 35. Sine 80 over 35. Now we can do sine 80 divided by 35 in our calculator, so that would give us 0.02813 and so on, and the calculator display carries on, and I just leave that in my calculator, and that gives us that sine vita divided by 16 is equal to 0.02813 and so on. Now I don't want this divided by 16, I just want the vita on its own, so let's multiply both sides by 16. So let's multiply by 16 and multiply by 16. And when we do that, on the left hand side we'll just be left with sine vita, and on the right hand side we're just going to press on our calculator. We've still got this on our calculator display, so we're just going to press times 16 equals, and we get 0.45019 and so on. Now we found what the sine of the angle is. The sine of the angle is equal to 0.45019 and so on. But we don't want the sine of the angle, we want to know what the angle vita is. So we want to get rid of the sine, so we have to do the inverse. So that's going to be the inverse sine, and when we press shift sine. So we'll write down vita equals sine to the negative 1, the inverse sine, of 0.45019 and so on. Now we've still got this in our calculator display, so if we just press shift and then sine, we get our sine to the negative 1, or inverse sine, and then just press ANS on our calculator. So we'll just type in this sine negative 1, so shift sine, and then press the answer button, and then press equals, and it will give us the answer of vita equals 26.756 degrees. And that's to 3 decimal places, and that's it. So we have used the sine rule to find the size of this missing angle. So the sine rule is A over sine A equals B over sine B equals C over sine C, and that version of the formula I use a lot whenever I'm finding missing sides, because the side's on the numerator. And if I'm finding the missing angle, I flip it over and write sine A over A equals sine B over B equals sine C over C. And the sine rule is particularly useful whenever you've got an angle and a side opposite each other, and then you're trying to find a side or an angle. Okay, so we've looked at the sine rule. We're now going to look at the ambiguous case, and that's video 334A in Corbettmaths. Now the ambiguous case, it's mentioned on 2 of the exam boards, but not mentioned in one of the others. I believe it's mentioned in Edexcel and AQA, but I don't think it's mentioned in OCR. It may be worthwhile to watch anyway, because if you are learning the sine rule, there's a good chance you're going to be going on to do A-level maths anyway, and it can be quite useful to just know this whenever you're going into A-level maths anyway. So here we've got a triangle, we've got ABC, and we're trying to find the angle vita here. And we've been asked to find the 2 possible sizes of vita, calculate the 2 possible sizes of vita. So here we've got 30 degrees and 8 centimeters, and we've got 14 centimeters and vita. So remember with the sine rule, if we're finding an angle, we're going to write sine vita over the opposite side, which should be 14, is equal to sine 30 over 8. So sine 30 over 8. So if we multiply both sides by 14, we're going to get sine vita is equal to 14 sine 30 divided by 8. And whenever we work this out, because sine 30 is equal to half, we get 14 times a half, which is 7. So we're going to get 7/8, or 0.875. So that means that the sine of this angle is 0.875. And if we do the inverse sine, we're going to get that vita is equal to sine, the inverse sine of 0.875, and when we do that on our calculator, we get that vita is equal to, and we get vita is equal to 61.04497 and so on degrees, and I'm just going to round this to 3 decimal places. That means that vita is equal to 61.045 degrees. So that means that vita is equal to 61.045 degrees. But the question asks us for the 2 possible sizes of vita. Now, if you actually take your calculator and you do the sine of 80 degrees and you do the sine of 100 degrees, let's have a look and see what you get. 0.984807753. And if we do the sine of 100 degrees, we get that's also equal to 0.984807753. And whenever we do the sine of 100, we also get that's equal to 0.984807753. So the sine of 80 and the sine of 100 are both the same. So if on your calculator you do the inverse sine, the sine minus 1, the inverse sine of 0.984807753, let's have a look and see what we get. So shift sine and then answer is equal to 80 degrees. So the calculator has just told me 80 degrees. It didn't say anything about the 100 degrees. So in this question here, we've got 61.045. But there's going to be another possible answer, an obtuse angle that could also work here for beta. And as you can see, the question says not drawn accurately. So what we're going to do is we're going to look at the graph of y equals sine of x. And later on in this video, we're going to look at our trig graphs. But the graph of y equals sine of x looks something like this. This is the graph of y equals sine x. And as you can see, this graph, it goes up from 0 up to 1 at 90, because the sine of 90 is equal to 1. And then it starts coming back down again. Between 0 to 180 degrees, it's symmetrical between here and here. And there's a line of symmetry here. And because there's a line of symmetry, if we were to work out the sine of 80 degrees, and then we also work out the sine of 100 degrees, it would give us the same answer. If we were to work out the sine of 89 degrees and the sine of 91 degrees, it would give us the same answer. So that means that whenever we're doing the sine rule questions and we're finding the angles, there sometimes can be two possible answers. Now, for instance, in this question, this angle here couldn't be 179 degrees because with there already being a 30-degree angle, we know that this angle has to be less than 150 degrees. But let's figure out what this angle could be. So we know that one of our solutions is 61.045. So that's one of our solutions. So here is equal to 61.045. And whenever we work out the sine of that, we get that's equal to 7/8, or 0.875. And then there must be another angle over here that whenever we do the sine of that, we also get 0.875. Now, to work out what this angle is, what I do is I take this angle, the 61.045, away from 90 to work out how much below 90 it is. And then if I add it on to 90, it will then tell me what this angle would be. So let's do 90 take away this. So 90 take away 61.045. 28.955. So that means that 61.045 is 28.955 below 90. So to find this value, what we're going to do is we're going to add 28.955 onto 90, and then that would tell us this angle, because obviously this is symmetrical. So if we do 90 plus 28.955, that would be equal to 118.955 degrees. So that's one way we could find the second angle. Another approach is to take our angle for beta, our 61.045, and just take that away from 180 degrees. And that would also give us 118.955 degrees. So that means that this angle of beta could either be 61.045 degrees or 118.955 degrees. And that's it. So sometimes useful to know whenever you're using the sine rule that there can be two possible solutions. Okay, so we've looked at the sine rule. Let's now have a look at the cosine rule. And the cosine rule is video 335 and 336 in Corbettmaths. And here's part of the Corbettmaths revision card. And we've got our cosine rule here, which is a squared. So we've got this triangle, and we've got a squared equals b squared plus c squared minus 2bc cos a. So in other words, if you have got a side, another side and an angle between them, you can find the length of the opposite side. So here we have got a side and the angle between them, and we can find the length of this opposite side. So if we wanted to find this value, what we would do is we would do 20 squared plus 15 squared minus 2 times 20 times 15 times the cos of 120. And that would tell us the value of this value squared, and then you'd square root it. So let's do that now. Let's find the value of x. So we have got the cosine rule, which is a squared equals b squared plus c squared minus 2bc cos a. So we've got our two sides and we've got the angle in between them. So the little a will be the side opposite the angle. So this means that little a will be x. So we'll write x squared equals. Now b and c doesn't actually matter which way around these go. So we're just going to write 20 squared plus 15 squared. And then we've got minus. And then we've got 2bc cos a, and I tend to write this in a bracket, so I tend to put a bracket down and do 2 times b, which is 20, times c, which is 15, times the cos of a, and that's the cos of 120, so cos of 120, close brackets. Okay, next, let's work this out. So we've got x squared equals, and then on our calculators, we can type in 20 squared, which is 400, and then 15 squared, which is 225, and then we put minus, and then let's type this in our calculator and see what we get. So 2 times 20 times 15 times the cos of 120. And whenever I do that, I get that's equal to negative 300. So our answer to that was negative 300. And let's close brackets around that. So we've got x squared is equal to 400 plus 225 minus negative 300. Now let's work out what we get. So x squared equals, so 400 plus 225 minus 300 is equal to 925. So this side is not 925 centimeters. It wouldn't make sense for this question because that's x squared. So we need to square root it to find the value of x. So x will be equal to the square root of 925, which is equal to 30.414 centimeters. So the answer will be 30.414 centimeters to 3 decimal places. I've rounded out to 3 decimal places, and that's it. So the cosine rule is really useful whenever you've got two sides and the enclosed angle, and you're trying to find the length of the other side, the one opposite the angle, and that's the cosine rule formula. The cosine rule can also be really useful if you have a triangle and you know the length of the 3 sides. You can work out the size of one of the angles. But just remember that little a is opposite capital A. So whenever you're trying to find the angle, so cos A, little a will be the side opposite it. And the B and C, it doesn't actually matter which way around they go. So that could be B and that could be C. So let's substitute those values into the cosine rule formula and work out the size of this missing angle A. So the cosine rule is a squared. So remember the little a and the capital A are opposite each other. So a squared, so in this case the a will be 7. So 7 squared is equal to b squared plus c squared. So b and c will be 8 squared plus 5 squared minus 2 times b times c times cos A. So 2 times b, which is 8, times c, which is 5, times the cos of A. So in this case, A is veta, so the cos of veta. So let's work this out. So we've got 7 squared is 49 equals 8 squared is 64 plus 5 squared, which is 25. Then we've got minus 2 times 8 times 5 times cos veta. Well, 2 times 5 is equal to 10 times 8 is 80. And then so that's 80 cos veta, multiplying the numbers in front of the cos veta together and then just putting the cos veta after it. So let's simplify this. So we've got 64 plus 25, that's going to be 89. So we've got 49 equals 64 plus 25 is 89 minus 80 cos veta. Now we want to get the cos veta on its own, so let's get rid of this 89. So let's minus 89 from both sides, so minus 89 and minus 89. And 49 take away 89 will be equal to negative 40 is equal to, and with the 89 take away 89 is 0, so we'll be left with negative 80 cos veta. I've got a couple of options of things I can do here. I could divide both sides by negative 80, and that would give me negative 40 divided by negative 80 equals cos veta. Well, one thing I like to do is if I've got an equation where I've got things both being negative, I can multiply both sides by negative 1. 40 times negative 1 is 40, and negative 80 cos veta times by negative 1 is 80 cos veta. Now I'm just going to divide both sides by 80 to get what cos veta is. So divide by 80 and divide by 80. So 40 divided by 80 is 0.5. And on the right hand side, 80 cos veta divided by 80 just leaves us with cos veta. So that means that the cos of this angle is 0.5. We don't want to know the cos of the angle. We want to find the angle, so we need to do the opposite. So we're going to do the inverse cos of 0.5, and that will give us the size of our angle. And when we do that, we get that's equal to 60. So that means that veta equals 60 degrees. So veta equals 60 degrees. And that's it. So the cosine rule can be really useful to find missing angles as well as missing sides. Okay, let's have a look at our next topic. So our next topic is finding the area of a triangle using trigonometry, and that's video 337 on Corbettmaths. So the area of a triangle is found by a half AB sine C, where A and B are two sides and capital C is the angle in between them. So if you have a triangle such as this one, if you want to find the area of this triangle, we can do area equals a half times the two sides, so 14 times 8 times, and then the sine of the angle in between them, so the sine of 70. And when we do that on our calculator, we've got a half multiplied by 14 multiplied by 8 multiplied by the sine of 70. You get that's equal to 52.623 centimeters squared to 3 decimal places. So I've rounded that to 3 decimal places, and also because it was an area question, we've got our units of centimeters squared. And that's it. So if you want to find the area of a triangle, and if you know two sides and the angle in between them, you can just do a half AB sine C. Okay, now we've looked at how to find the area of any triangle. What we're going to do is we're going to use that to find the area of a segment. So here we've got a sector, which is OPR, and we've got a segment, which is PQR, this segment here, and we want to find the area of this segment, this green region here. So if I wanted to find the area of this green region, what I would do is I'd find the area of the whole sector to begin with. So remember, to find the area of a sector, we use the formula β, which is the angle, which is 25 over 360, times by pi, times by the radius. Now if we had the whole circle, the radius would be 6 squared. So if we do 25 over 360 times by pi times by 6 squared, that would give us the area of this whole sector. And let's do that and see what we get. And whenever I do that, I get 5 over 2 pi, or 2.5 pi. Alternatively, we could write it as a decimal number, and as a decimal number would be 7.853981634, and so on, centimeters squared. So that's the area of this sector. Now what I want to do is I want to find the area of the triangle, and if I take the area of the triangle away from the area of the sector, it will leave me with the area of the segment. So let's find the area of the triangle. So let's write sector up here, that's the area of the sector. Now let's find the area of the triangle. So remember, the area of a triangle is a half AB sine C, so it's going to be a half. Now if we look at this triangle, we've got two sides and the angle in between them, so it's going to be A, B and C. So half of 6 times 6 times by the sine of 25. That's equal to 7.607128711, and so on, centimeters squared. So we've now got the area of the triangle and we've got the area of the sector. If we take them away, we'll find the area of the segment. So let's write that down, segment. And that would be 7.853981634, and so on. Take away 7.607128711, and so on, and that will give us the area of the segment. And let's see what we get. So whenever you type this in or use 2.5 pi, take away the answer, we get an answer of 0.24685, and so on, centimeters squared. And that's it. We could round this to perhaps 3 decimal places, so that'd be 0.24, and then we've got 68, so that'd be 7 centimeters squared. That's it. So if we want to find the area of a segment, it can be useful to find the area of the sector, then find the area of the triangle, and take them away to leave us with the area of the segment. That's it. Okay, so our next topic is translations, and that's video 325 in Corbettmaths. And a vector looks something like this, where we're going to have a number on the top and a number beneath and some brackets around it. The number on the top will tell you how to move the shape horizontally, and it'll tell you how many squares to the right to move it. So for instance, if it's an 8, you'll move it 8 squares to the right. If it's a 5, it'll be 5 squares to the right. If it's a 0, you won't move it any squares to the right, it'll stay where it is horizontally. If it's a negative, so for instance, if it was -3, you would move it 3 squares to the left. If it was -9, it'd be 9 squares to the left. So the top number tells you how to move the shape horizontally, and if it's positive, it'll be to the right. If it's negative, it's to the left. The number beneath that will tell you how to move the shape vertically. So if it's positive, here it's a 1, so that's going to mean move the shape 1 square upwards. If it's a 4, you move it 4 squares upwards, and if it's a negative, you move it downwards. So if it's -3, you'd move it 3 squares downwards. So here we've got a typical question, and we've got a little shape. It's a little T shape, and the shape's called C, and we've been asked to translate shape C by, and we've got -1, 5. That will mean 1 square to the left, so 1 left, because it's negative, it's going to go to the left, so 1 left. And then we've got a 5, that's going to mean 5 up. So we're going to move the shape 1 square left and 5 squares up. And that's it. So next topic is rotations. So here we've got rotate shape A 90 degrees anti-clockwise about the point 2, -1. So let's mark on the point 2, -1. So this is going to be our center of rotation. And we're going to rotate shape A 90 degrees anti-clockwise, so going this way, anti-clockwise, about that point. So get your tracing paper and put it on top of the center of rotation and the shape like so. And make sure your tracing paper is straight. So it's straight and it's not diagonal, like something like that. So make sure, in this case, I put it landscape, so going that way. And what we're going to do is we're going to draw over the center of rotation, and we're going to draw over the shape A. So we've drawn over the center of rotation and we've drawn over shape A. So now what we're going to do is we're going to put our pencil on the center of rotation, and we're going to rotate the tracing paper 90 degrees anti-clockwise. So when we do that, we turn it, and it's important to keep the center of rotation on that point. We're turning it like so. until we've rotated the tracing paper 90 degrees anti-clockwise. And we can now see the position of where A would go after we rotated it 90 degrees anti-clockwise about to -1. So now what I would do is I would just draw over this rectangle a couple of times just to make sure that whenever I move my tracing paper that there's a sort of a light impression on the paper. So it would look something like this. And that's it. So we've rotated A 90 degrees anti-clockwise about the point to -1. Let's have a look at our next question. So this time we've been given a triangle and we've got a set of coordinate axes. We've got our x-axis and we've got our y-axis. And the question says reflect triangle A. So we've got this triangle A and we've been asked to reflect it in the y-axis. In other words, this is where the mirror is. Okay, so we've got this y-axis and this is where the mirror is. And we want to reflect this triangle across to the other side. So let's do each point at a time. So this top point of the triangle, it's one line away from the y-axis. So we need to go another one to the other side there. The point down here, it's one away from the y-axis, so we need to go one the other way. And the bottom right hand point of the triangle, it's 1, 2, 3, 4 away from the mirror line, so we need to go another 4, 1, 2, 3, 4, so it'll be there. And if we get a ruler and a pencil and join those up, we'll have reflected triangle A in the y-axis. And that's it. Okay, let's have a look at our next question. So we've got the same triangle and we've been told this time to reflect triangle A in the x-axis. So we've got this x-axis, so this is where the mirror line is this time, and we're going to reflect the triangle downwards, so it's going to move down here somewhere. So again, let's look at each corner of the triangle. So let's start off with this corner, and it's 1, 2 away from the x-axis, so we go down another 2, 1, 2 to here. This corner is 1, 2 away from the x-axis, so we go another 2, 1, 2 to there. And this point up here, it's 1, 2, 3, 4 away from the x-axis, so we need to go down 4, 1, 2, 3, 4 down to there. And if we get a ruler and a pencil and join those up, that will be our answer for reflecting triangle A in the x-axis. And that's it. So we've been asked to reflect this shape C, in the line x equals -1. So this line x equals -1 is going to be a line going straight through -1 on the x-axis. So if we go to the x-axis and go to -1 here, it's going to be a vertical line going straight through that -1. So that's where our mirror line is going to be. So an x equals line will be a vertical line going through whatever number that is on the x-axis. Now we have to reflect the shape C in that mirror line. So let's start off with this corner. So this corner is 1, 2 to the mirror line. So we need to go another 2, 1, 2. So it's going to move to here. The bottom right hand corner of C, well, it's 1, 2, 3, 4 to the mirror line. So we're going to go 1, 2, 3, 4 to here. And the top of triangle C is here. So it's 1, 2, 3, 4 to the mirror line. So we need to go another 4, 1, 2, 3, 4. So it's going to be there. Now we get a ruler and pencil and we just join up that shape. And we have reflected C in the line x equals -1. Next, we're going to reflect the shape C in the line y equals 1. So let's just rub out what we've done. So we've got our shape C again, and we're going to reflect it this time in the line y equals 1. So what we're going to do is we're going to go to the y-axis and the point 1. So the y-axis and the point 1, and we're going to draw a horizontal line going through that point. So going through 1 on the y-axis. So if you've got a y equals and a number, it'll be a horizontal line passing through that number on the y-axis. And we have to reflect this shape, this triangle, in that mirror line. So let's start with this bottom left hand corner of C. It's 1 above the mirror line, so let's reflect it to 1 below. This point is 1 above the mirror line, so we're going to go another 1 downwards, so there. And finally this point, to get to the mirror line, we go 1, 2, 3 down, so let's go another 3, 1, 2, 3 to there. And let's join up those points. And that's it. We need to be able to reflect shapes in the lines y equals x, so the diagonal line going upwards this way, and the line y equals -x, the line going down this way here, okay? And it would look something like this. So it's very important to know what the lines y equals x and y equals -x look like, so that whenever you're doing reflections, you can then draw them really quickly and easily. Now to reflect the shape in that line, it's quite easy. We just count the diagonals. So let's look at each corner. So let's start off by looking at this corner, the bottom left hand corner of B. And as you can see, if we go diagonally to our mirror line, it's one diagonal. So we need to go another diagonal the other way, so it'll move to here. This point, the bottom right hand corner, if we count the diagonals, it's one diagonal and then we've got half a diagonal. So if we go another 1.5, so a half and then 1 would be here. So we've reflected these 2 points. Now let's look at the points at the top of the rectangle. So let's look at the top left hand corner. That would be one diagonal, 2 diagonals, so we need to go another 2 diagonals. That'd be 1 diagonal, 2 diagonals would be there. And finally the top right hand corner of B would be up here. So if we count the diagonals, that'd be 1 diagonal, 2 diagonals and a half. So we go a half, 1 and 2. And as you can see, we've got our rectangle shape. Now we just need to get a ruler and pencil and draw a nice rectangle. And that's it. So we reflected shape B, or rectangle B, in the line y equals negative x. Okay, so let's have a go at this question. So it says enlarge by scale factor half using -5 as a centre of enlargement. So let's find -5. So that's our centre of enlargement there. And we've got our original shape, our object, and we're going to enlarge it by a scale factor of half. That means that all the points in the image will be half the distance away from the centre of enlargement. So if, for instance, we looked at this point at the top of the kite, this point at the top of the kite is 1, 2, 3, 4, 5, 6 squares to the right, and 1, 2, 3, 4, 5, 6, 7, 8 squares upwards. So because we're using scale factor of a half, we're going to half those distances. So instead of going 6 to the right, we're going to go 3 to the right, 1, 2, 3. And instead of going 8 up, we're going to go 4 up. So 1, 2, 3, 4. So the top of our kite will move to here. Okay, now let's look at the left-hand side of the kite here. So this point is 1, 2, 3, 4 squares to the right, and 1, 2, 3, 4, 5, 6 squares upwards. So we're going to half those distances. So instead of going 4 squares to the right, we're going to go 2 squares to the right, 1, 2. And instead of going 6 up, we're going to go 3 up, 1, 2, 3. So that means that the left-hand side of the kite will move to here. The right-hand side of the kite, so we can kind of guess it's going to move to this point here, but let's check it. So going back to our centre of enlargement, it is 1, 2, 3, 4, 5, 6, 7, 8 squares to the right, and 1, 2, 3, 4, 5, 6 squares upwards. We're going to half those, so that'll be 4 to the right and 3 up. So 1, 2, 3, 4, and 1, 2, 3. So that's the right hand side of the kite. And let's be careful with the bottom of the kite, because we need to make sure we get the right height here. So it is, whenever we look at our bottom of our kite, going back to the centre of enlargement, it's 1, 2, 3, 4, 5, 6 squares to the right and 1 up. So we're going to half our distances. So instead of going 6 to the right, we're going to go 3 to the right, 1, 2, 3. And instead of going 1 square up, we're going to go half a square up. So it's going to be there. And then we'll get our ruler and our pencil, and we'll join those up. And that's it. So we've enlarged this shape by a scale factor of a half, so it's got smaller, using the centre of enlargement -5, -5. Okay, our next topic is negative scale factor. So we're looking at enlargements, and we're looking at how to enlarge things with a negative scale factor. So whenever you enlarge by a negative scale factor, what happens is the points move in the opposite directions. So let's have a look at our question. So here we've got a square, and it's drawn on our grid, and we've been asked to enlarge by scale factor -4 using -3, -1 as the centre of enlargement. Let's mark on that centre of enlargement. So that centre of enlargement will be here, -3, -1. And we're now going to enlarge each of these points. So let's start off with this point here. Okay, so to get from our centre of enlargement to the point, we would move 1 square to the left. So if we're enlarging by -4, what that means is instead of going 1 to the left, we're going to go 4 to the right. So we're going to go 1, 2, 3, 4. So that point will move there. Okay, our next point, so this point here. So this point here was 1, 2 to the left from our centre of enlargement. So instead of going 2 to the left, we're going to go 8 to the right. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So it's going to move to here. So we've done these 2 points. Now let's choose this point here. So this point is 1 to the left and 1 down. So we're going to go 4 times as far away, but in the opposite direction. So we're going to go, instead of going 1 to the left and 1 down, we're going to go 4 to the right and 4 up. So 1, 2, 3, 4, and 4 up. 1, 2, 3, 4 will be here. Okay, and finally, our point down here, the bottom left-hand point of our square, it's 1, 2 to the left and 1 down. So instead of going 2 to the left and 1 down, we're going to go 4 times as far away, but in the opposite direction. So instead of being 2 to the left, it's going to be 8 to the right. And instead of being 1 down, it's going to be 4 up. So 1, 2, 3, 4, 5, 6, 7, 8, and 4 up. 1, 2, 3, 4. So we've now got our 4 points, we just need to join them up. And that's it. We've enlarged this square by scale factor -4 using -3, -1 as the centre of enlargement. And whenever you're enlarging by negative scale factors, it's enlarged, but it goes in the opposite direction. And that's it. And if you want more practice on this, it's video 108 on Corbettmaths. And also remember, you've got those practice questions and textbook exercises beside that number. And also remember, there's that bumper pack of questions. So if you do look at the booklet in the description below and open it up, there'll be a question there on negative scale factors. Okay, let's have a look at our next topic. So our next topic is invariant points, and that's video 392 on Corbettmaths. So an invariant point is whenever we carry out a transformation, if a point or any points stay in the exact same location after that transformation is applied, then they're what we call invariant points. So here we've got a triangle ABC, and we've been asked to reflect the triangle ABC in the x-axis. So here you can see here's the x-axis, and we're going to reflect this triangle in the x-axis. So let's reflect the triangle in the x-axis and see where the points move to. So the point A, well, it's 1, 2 to the x-axis, so we're going to go 1, 2 up, so A is going to move to here, so that'll be A dash. B is 1, 2 to the x-axis, so we go up another 2, 1, 2, so the point B will move to here, so it's going to be B dash. And the point C, well, it's on the x-axis. When we reflect it on the x-axis, it's going to stay where it is. So the point C will stay where it is. So let's draw a triangle. And the question says, are there any invariant points? As you can see, the point C stayed where it is, so the answer is yes, there are invariant points, and it is the point C, the point C. So the point C stayed where it was after we carried out the transformation, so it's an invariant point, and that's it. So if you want to find out more on invariant points, if you watch video 392 on Corbettmaths, that would be the video tutorial on invariant points. Also remember, you've got that bumper pack of questions, the ultimate GCSE higher revision question booklet. I think that was the name of it. But in that booklet, you've got a questionnaire on invariant points as well. Okay, our next topic. So similar shapes are where one shape is an enlargement of another. So if you have got one shape and another shape that's similar to it, then it's an enlargement of it. So whenever you've got shapes that are similar, such as this rectangle A and this rectangle B, we know that to find the lengths, we multiply by a certain scale factor. Now notice that the sides will become so many times bigger or smaller, but the angles will all stay the same because obviously this shape is staying the same shape. So here we've got the Corbettmaths revision card, part of it, and we've got here two similar rectangles. So we've got this rectangle A, which is 6 centimeters long and 4 centimeters wide, and we've got this rectangle B, which is similar to it, so it's an enlargement, and it's got a width of 12 centimeters and a length of, well, we need to find that. We've been asked to find the length of rectangle B. So let's look at the sides. So let's look at the widths of these rectangles. We've gone from 4 centimeters to 12 centimeters. So to find the scale factor of enlargement, if we divide 12 by 4, we will find the scale factor of enlargement. So if we do 12 divided by 4, 12 divided by 4 is equal to 3. So that means that this width is 3 times larger than this width, so multiply by 3. So if we multiply the width of rectangle A by 3, that means we're going to multiply the length of rectangle A by 3 as well, and that will give us the length of rectangle B. So if we do 6 multiplied by 3, that's going to be equal to 18 centimeters. So the length of rectangle B would be 18 centimeters. So similar shapes are where one shape is an enlargement of another. That's it. Okay, let's have a look at our next topic. So our next topic is congruent triangles, and that's video number 67 on Corbettmaths. So congruent means identical. It means the same shape and the same size. So it means that if you've got two shapes that are congruent, it'll mean that the angles are the same and the sides are the same length as well. Now, whenever we're dealing with triangles, in a triangle, we've got 3 angles and there's 3 sides. Now, if you've got 2 triangles, if you want to see if they're congruent to each other, you don't actually need to know all 6 angles in both triangles and the lengths of all 6 sides. What you can actually do is know if they're congruent by just knowing some of that information. And these are the conditions to know if triangles are congruent or not. So the first condition is what we call side, 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 or SSS. And what that means is that the sides are the same size. So here we've got 5 centimeters and 5 centimeters. Then we've got 7 centimeters and 7 centimeters and 9 centimeters and 9 centimeters. So if you've got 2 triangles that both have the same lengths of the sides, so side, side, and side, those 2 triangles will have to be congruent to each other. So they will be the same shape and size. Okay, let's look at the next condition. So the next condition is what we call angle, side, angle, or ASA. And what that means is if you've got 2 angles and you know the side in between them for 2 triangles, those 2 triangles will be congruent to each other. So for instance here we've got 70 degrees, 30 degrees, and in between those is 4 centimeters. So if you draw that triangle, and then if you've got another triangle where you've got 30 degrees and 70 degrees, so the same 2 angles and 4 centimeters in between them, those 2 triangles will have to be congruent to each other because there's only one possible triangle that will have 70 degrees, 30 degrees, and 4 centimeters in between them. So it's called angle, side, angle, or angle, side, angle. Okay, let's look at the next condition. The next condition is SAS, or side, angle, side. So that means if you've got 2 sides and you know the angle in between them, and they're the same for 2 triangles, those triangles will be congruent. So as you can see here, we've got 12 centimeters and 14 centimeters and 30 degrees in between them. And on this triangle here, we've got 12 centimeters and 14 centimeters and 30 degrees in between them. So these 2 triangles will have to be congruent to each other because there's only one possible triangle you can draw which has 12 centimeters and 14 centimeters and 30 degrees in between them. So those 2 triangles will be congruent. Okay, and another condition is what we call RHS, which stands for right angle, hypotenuse, side. So if you've got 2 right angle triangles and you know the hypotenuse and one of the shorter sides, those 2 triangles will have to be congruent to each other. Because if you use Pythagoras' theorem, you can find the length for the third side, and then it would be side, side, side. So these 2 triangles will have to be congruent to each other. So this is the Corbettmaths revision card, and it's very useful to remember the conditions for congruent triangles, whether it's side, 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 angle, side, angle, side, or RHS. And And that's it. Okay, let's have a look at our next topic. Okay, so let's have a look at our next topic. So our next topic is similar shapes. And that's videos 292 and 293 in Corbettmaths. So similar shapes are shapes that are enlargements of each other. So if two shapes are mathematically similar, one is an enlargement of the other. If the scale factor of enlargement for the sides is n, the scale factor for the area is n squared, and the scale factor for the volume is n cubed. In other words, if you re-enlarge a shape and the sides are perhaps 3 times bigger, the area will be 9 times bigger because 3 squared is 9. And the volume, if for instance it was a cube and we enlarge it by scale factor 3, the volume wouldn't actually be 3 times bigger. You would do 3 cubed, which is 27, so it would be 27 times bigger. If we enlarge the shape by scale factor 5, the area would become, well, 5 times 5 is 25 times bigger, and the volume would be 5 cubed, which is 125 times bigger. And that's really useful whenever we're dealing with similar shapes. So here we've got two similar shapes, two trapezia. If we have a look at this first trapezium, you can see one of the lengths of the parallel lines is 5 centimeters. And for the larger trapezium, the corresponding length has a side length of 15 centimeters, which if we look at it is 3 times bigger, because 5 times 3 is 15. That means, because the sides are 3 times larger, we will square that, and that's 9, so I mean the area is actually 9 times bigger. And if we were given the area of the smaller trapezium, which is 20 centimeters squared, and we wanted to find the area of the larger trapezium, we could do 20 times 9, which is 180. And that's it. If we were given the area of the larger trapezium, we would divide by 9, and then that would give us the area of the smaller trapezium. But if we know the scale factor of enlargement for the sides, we can square that to get the scale factor of enlargement for the areas, and we can cube it to find the scale factor for the volumes. And that's it. So this time we've got two cuboids, and we've got a smaller cuboid, which has a side length of 7 centimeters, so the length of it is 7 centimeters, and the length of the larger cuboid is 14 centimeters. And as you can see, the sides are 2 times larger, so that means the scale factor of enlargement for the sides is 2. That means if we want to find the scale factor for the volume, we will cube that. 2 cubed is 8. That means the volumes are 8 times bigger. So the volume of this cuboid will be 8 times larger than the volume of that cuboid. So if we do 100 times 8, that will give us the volume of the larger cuboid. 100 multiplied by 8 would be 800 centimeters cubed, and that's it. So if we have a look at these prisms, prism A and prism B, pentagonal prisms. Pentagonal prism A, this prism has got a surface area of 300 centimeters squared, whereas the surface area of B is 1,200 centimeters squared. Well, if we divide the surface area of B by the surface area of A, we can find the scale factor of enlargements for the areas. So we divide 1,200 by 300. We get that's equal to 4. That means the surface areas are 4 times larger. So that means that our scale factor, our n squared, is equal to 4. That must mean that our sides were, if that's 4 times bigger, that means our sides, if we square root this 4, that means our sides will be 2 times bigger. So for instance, if that was 10 centimeters, that would be 20 centimeters. And to get the scale factor of enlargement for the volume, well, we cube this, so 2 cubed is 8. So if we know what the scale factor of enlargement is for the areas, in this case we know it was 4, we could square root that, which is 2, and we can cube that then to find the scale factor of enlargement for the volumes. So we can then find out the volume of this larger prism by doing 600 multiplied by 8. And if we do 600 multiplied by 8, that's equal to 4,800 centimeters cubed. So that's great. That means if we know what the surface areas are, we can actually divide them to see how many times larger the surface area is for the larger shape than the smaller one. We can then square root that, and then that'll tell us the scale factor of enlargement for the sides. If instead we knew the volumes, we could divide the volumes, and then in this case that would have been 8. And then we could cube root that to find the scale factor of enlargement for the sides, and then we could square it to get the areas, and so on. And if you want to do more practice on this topic, you can watch video 293b in Corbettmaths, and it will go through more examples of how to deal with questions whenever you're dealing with surface areas and volume. And that's it. And we're going to start off by looking at circle theorems. And these are videos 64 and 65 in Corbettmaths. So here we've got our first circle theorem. So our first circle theorem, and this is part of the Corbettmaths revision card, is the angle in the semicircle is 90 degrees. So if you've got the diameter of the circle and you've got two lines that go from the diameter up to a point on the circle or down, the angle will always be 90 degrees. So here's an example. So if you're given this question and asked to find the value of x, well, here we've got our triangle. We know that's a right angle. So we need to find x. Well, we know that that's 90 degrees. And then we can just use the angles in a triangle to find x. So 90 plus 34, well, 90 plus 34 is equal to 124 degrees. And if you take that away from 180, we can see what's left for x. So 180 take away 124 would be 56. So that means that x is 56 degrees. Okay, let's have a look at our next example. Now, one thing to look out for whenever you're doing circle theorem questions is looking for isosceles triangles. So from the centre of the circle to the edge is the radius. So here we've got a radius and a radius, they're two radii. That means they're the same length as each other. So this would have to be an isosceles triangle. So if we know that this angle is equal to 98 degrees, we know this angle x and this angle over here would be the same, so that's x as well. So we can work out what x would be. We could do 180 minus 98, which would be equal to 82. And then if you've done 82 divided by 2, that's equal to 41 degrees. So x here would have to be 41 degrees. So look out for isosceles triangles in circle theorem questions where you've got, particularly whenever radii are involved. Okay, next. Now here again you can see we've got from the centre to the circumference is a radius, so that's a radius, that's a radius, and that's a radius. So here we've got two isosceles triangles. This is an isosceles triangle, and this is also an isosceles triangle. And also another thing to note is the big triangle is a right angle triangle because we've got that diameter as well. So that's a right angle at the top if you add these two angles together. So let's look at our x and y to begin with. So we know that's the radius and that's the radius. That means that y and 55 are the same as each other. Y equals 55. Now I have 55 degrees. Now if y is equal to 55, you got 55 plus 55, or 55 plus 55 is equal to 110 degrees. So 180 minus 110 is equal to 70 degrees. So that means that x is equal to 70 degrees. And finally, because this is the diameter, we know that x and z are in a straight line. So we know that if we do 180 minus 70, that's equal to 110 degrees. So z is equal to 110 degrees. And that's it. So it is useful to look out for those isosceles triangles. Okay, next. Okay, so our next circle theorem is that the angle at the circumference is half the angle at the centre. So here we've got our circle, we've got the centre of the circle, and you can see this angle is 120 degrees between the two radii, and the angle at the top here between the two chords would be equal to 60 degrees. So the angle at the circumference is half the angle at the centre. So let's have a look at some examples. Okay, we have our first example. Okay, so we know the angle of the circumference is half the angle at the centre. Well, that means if we double the angle at the circumference, we get the angle at the centre. So if we do 51 multiplied by 2, that's equal to 102 degrees. So that means that x here is equal to 102 degrees. Next, we've got the angle at the centre, and we're trying to find the angle at the circumference. So if we divide the 122 by 2, we'll get the angle at the circumference. So that would be 61. So that means that x equals 61 degrees for this circle. Okay, so the angle at the circumference is half the angle at the centre, or the angle at the centre is double the angle at the circumference. Okay, let's have a look at one more question. So here we've got a circle this time. Here we've got a circle, and we've got the angle of the circumference, but we don't actually have the angle at the centre. We've got the angle inside of the shape here. So what we're going to do is we're going to take the 234 away from 360 to find the angle at the bottom. It has to be like this, where you've got the angle at the circumference and the angle at the centre. So if we do 360, subtract 234, we get that's equal to 126 degrees. So that's 126 degrees at the centre. Now the angle of the circumference is half of that, so if we do 126 divided by 2, we get that's equal to 63 degrees. So the angle for x would be 63 degrees. Now before we move on to the next circle theorem, I just want to show you that we can move the angle of the circumference over to the side. So it could, instead of looking something like this, our diagram might look something like this. And the angle of the circumference here, 60 degrees, is still half of the angle at the centre. So just be aware that it might not always look like this, that the point at the circumference might be over to the side, and the angle of the circumference is still half the angle at the centre. And that's it. So the next circle theorem is the angles in the same segment from a common chord are equal. So if you look at this chord, this blue line, this dotted blue line, you've got a pair of green lines coming up from either end of that chord, and they're meeting at a point on the circumference of the circle. And likewise, we've got a pair of red lines that are coming off from either end of that chord, meeting at a point at the circumference. That means that this angle and this angle will be equal to each other. Now if you have a look at this example, we've got a common chord here, and we've got all these lines coming off from that chord, either end of the chord, to the circumference. So that means that A, B and 37 are all equal to each other. So if A is equal to 37 degrees, B is equal to 37 degrees as well. And that's it. They're all lines coming off from that same chord. Okay, let's have a look at our next example. So we've got this circle. We've got our 27 degrees, our 88 degrees, and our angle x. And we've been asked to find this angle x. As you can see, we've got this chord at the bottom here. And we've got our lines coming up here and here. And also the lines coming off across here and here. So that means that this 27 will be the same as this angle here. So that means that that angle there is 27 as well. Next thing to notice is we've got two straight lines that cross each other. That means the opposite angles are equal. So if this angle is 88 degrees, that means that that angle is 88 degrees also. They're vertically opposite angles. And finally, you've got this little small triangle here with this x, 88 and 27. That means that those three angles will add together to be 180 degrees. So if we do 88 plus 27, that's equal to 115 degrees. Next, if we do 180 subtract 115 degrees, we get that's equal to 65 degrees. So that means that x is 65 degrees. Now you could have done this question in a slightly different way, where we looked at the 88 and 27 and worked out this missing angle at the bottom, and then looked at the chord and said, well, x is the same as that angle there, and worked it out that way, but that would be 65 as well anyway. Okay, let's have a look at our next circle theorem. So our next circle theorem is, if you've got a cyclic quadrilateral, so that's a quadrilateral where all the corners lie on the circumference of a circle, the opposite angles add up to 180 degrees. So as you can see here, we've got 70 degrees and 110, and we've got 80 and 100. So the opposite angles add up to 180 degrees. Okay, let's have a look at our example. So here you can see we've got a cyclic quadrilateral. This point, this point, this point, and this point are all on the circumference of a circle. That means the opposite angles will add up to 180 degrees. This 114 is outside, but we can actually subtract that from 180 to find the angle inside. So 180 subtract 114 degrees is equal to 66 degrees. So that means this angle in here is 66 degrees. Now we can find our x and our y really quickly and easily. So because the 66 is opposite the x in the cyclic quadrilateral, we know if we take away the 66 away from 180 degrees, we can find out what x is. So 180 subtract 66 is equal to 114 degrees. So that means that x is 114 degrees. Next, our y, well, the opposite angles add up to 180. So if we do 180 subtract 121, that's equal to 59. So we know that y is equal to 59 degrees. So we've worked out what x is and y is by using the fact that the opposite angles in a cyclic quadrilateral always add up to 180 degrees. Okay, next circle theorem. Well, the next circle theorem is if you have the radius and a tangent, they meet at 90 degrees. So here you can see AB is the tangent. So that means that the tangent and the radius meet at 90 degrees. That's a 90-degree angle there. Now here we have got, if this is 154, you can take that away from 180. That would be equal to 26. So that would be 26 degrees in there in a straight line. Next, we've got a triangle. We've got 90 degrees and 26 degrees. If we add those together, we get 116 degrees. So 180 minus 116 degrees equals 64 degrees. So that's 64 degrees there. And then finally, we have a straight line here. So if we do 180 minus 64, we get that's equal to 116 degrees. So that means that x equals 116 degrees, and that's it. So the radius and the tangent will meet at 90 degrees. Our next circle theorem, it's got a name that I always remember, that's the alternate segment theorem, and that is if you have a tangent, the angle between the tangent and a chord equals the size of the angle opposite it inside the triangle. So this 70 is the same as the angle opposite it in the triangle, and this 60 is equal to this 60, the angle opposite it inside the triangle. And that's called alternate segment theorem. So let's have a look at our example. So here we've got our tangent, and the angle between the tangent and the chord is 55. So that 55 will be equal to the angle opposite it. So x is equal to 55 degrees. And here we've got our y, that's equal to the angle opposite it. So y would be 60 degrees. And that's it. Now what's interesting is if you go to the videos and worksheets section in Corbettmaths, there's a video showing you the proof of this. So if you want to see why they're equal to each other, have a look at Corbettmaths and you can see me explaining why. Okay, next. Okay, two more interesting circle theorems are, if you've got a point, the two tangents from that point to the circle will be the same length. So as you can see here is a point C, and you can draw two tangents to the circle that meet at D and E, and the lengths of CD and CE will be equal to each other. And then finally, if you've got a chord, the radius that cuts that chord in half will meet the chord at 90 degrees, like so. Okay, let's have a look at our next topic. So our next topic is geometric proof, and that's video 366 on Corbettmaths. Now with geometric proof, I highly recommend you watch that video and try the practice questions, because the more practice you do with geometric proof, the better. And here we've got a diagram, and we're told that APC is a straight line, and we're told that CP, so CP is the same length as BP. So these two lines are the same length. I'm actually just going to put dashes in here and here to show they're the same length as each other. And we're told that angle ABP is twice angle, so this angle ABP is twice angle CBP. So that angle is double the size of that angle. and it says angle BCP, so BCP is equal to x. So let's put x into here. Now this is actually an isosceles triangle, so if this is x up here as well, because it's an isosceles triangle. And actually we were told that this angle ABP is twice this angle here, so if that's x, this angle will be 2x. And we've been asked to prove that angle BAC is equal to 180 minus 4x. So let's actually write down some of the things we've written down so far already. So we've said that angle, because we were given this angle is equal to x, we wrote down that angle CBP was equal to x as well. So that's our first step. We wrote that this was equal to x because this is an isosceles triangle, because they're the same as each other. Then we know that angle ABP is equal to 2x because that's double angle CBP, and we're given that in the question, so let's write that down. Okay, now we're trying to show that this angle here is equal to 180 degrees minus 4x. Now, for geometric proof questions, there can be different approaches we can take. Now, this is actually my second time filming this. I filmed it, first of all, and in my first approach, what I'd done at this point was, I looked at this triangle here, this triangle CBP, and I said that this was a triangle, and I knew that the angles would add up to 180 degrees. So I added the x and the x together to get 2x, and then I took that away from 180 to get this angle to be 180 degrees minus 2x. Then I said this was a straight line, so if this was 180 degrees minus 2x, this would have to be 2x, so that adds together to make 180. And then if this was 2x and this was 2x, then I know that this triangle, the angles add up to 180 degrees, so if I add 2x and 2x together, that's 4x, and then that means that this angle here would have to be 180 degrees minus 4x. So I'd done that in my first approach, and then in editing it, I realized, hold on a minute, there's a much better way to do this question. Now, we're trying to show that this angle here is 180 degrees minus 4x. So let's have a look and see what we've got. So if we look at this big triangle, ABC, this big triangle, the angles in this triangle will have to add up together to give us 180 degrees. So it means that this angle at the top, and this angle would have to add together to give us 180 degrees. So if we have a look at this angle at the top here, we've got 2x and x. So if we add them together, we get the sides of this angle altogether, which would be 3x. So this angle up here would have to be 3x altogether. So that means that the angles in this triangle add up together to give us 180. So if we do 3x, the sides of this angle, plus this angle, which is x, we'll get 3x plus x, and that's equal to 4x. So these two angles added together, this angle at the top, this whole big angle, and this angle added together is 4x. And then if you take that away from 180 degrees, we'll find the size of this angle. So 180 degrees minus 4x would have to be the size of this angle. And that's what we're asked to show. So this angle is 180 degrees minus 4x. And that's it. So let's write that down. And that's it. So I've just said the angle BAC would have to be 180 degrees minus 4x because the angles in a triangle, the whole big triangle, have to add together to give us 180 degrees. There is also that question in the bumper pack of questions that you've got also to try, and the more practice you do with geometric proof, the better. Okay, let's have a look at our next topic. So our next topic is vectors. Now, a vector is something that's got a direction and it has got a size, or another name for size is a magnitude. So it's got a direction, so it's got a certain way, and it has got a magnitude or a size, so it's got a certain length. So these lines are all vectors. They're all going in a certain direction, shown by their arrows, and they've all got a certain magnitude or size. That's its length. And we've already looked at vectors whenever we're dealing with translations because we moved the shapes. We slid the shapes and we used a column vector, and it showed us how many squares to the left or the right and how many squares up or down. And what we're going to do is we're going to represent these vectors as column vectors, and we're going to use the same approach where the number on the top will be how many squares left or right, and the number on the bottom will be how many squares up or down. And if the top number is positive, it's to the right, and if it's negative, it's to the left, and the number beneath, if it's positive, it's up, and if it's negative, it's down. So let's start off with looking at this vector here. So this vector here, we can see the starting point, and the arrow shows us which way we're going. And we're starting here, and we're going 1 square to the right, so let's write that as a 1, and then we're going 2 squares up, 1, 2. So that would be represented, so this vector will be represented by the column vector 1, 2, 1 to the right and 2 up. Okay, now let's have a look at this column vector. So this column vector starts here and it goes in this direction. And if we count the squares to the right, it goes 1, 2, 3, 4, 5 to the right, and then 1, 2 down. So because it's 5 to the right, we're going to write 5. And then because it's 2 down, we're going to write negative 2. So this vector will be represented by the column vector 5, negative 2. Okay, our next vector is this one, and we start here, and as you can see from the arrow, we're going in this direction here, and we're going 3 squares to the left, 1, 2, 3, and 1 square up. So because it's 3 squares to the left, we're going to write negative 3, because if we go to the left, it's negative, and then it's 1 square up, so we then write 1. So this vector would be negative 3, 1. Okay, our next column vector is this one. We're starting here and we're going up 2 squares, 1, 2. So to the left or right, well, it doesn't go to the left or right, so we're going to write 0, and then it goes 2 up, 1, 2, so then it would be 2. So this is the vector 0, 2. And finally, our last vector, this one, we're starting here and we're going down to this point here. So we're going 1, 2 to the left, so that's going to be negative 2, and then 1, 2, 3 down, so that's negative 3. So this would be the vector negative 2, negative 3, which means 2 to the left and 3 down. Okay, so that's how you represent vectors as column vectors. Now let's have a look and see what happens whenever we add and subtract and multiply these column vectors. So here are some column vectors. We've got A. The vector A is 3, negative 1. So the vector A is 3 to the right and 1 down. And the vector B is 4, 6, which means 4 to the right and 6 up. Now these letters A and B, they're the vectors, and they're in bold, which means that they've been typed in a thicker ink, obviously. Now whenever we're writing, we can't write A in bold. We can't just sort of write it over and over and over. What we could do is to show that A is bold, to show that something is a vector, we write it and then put a line underneath it. So instead of writing a bold A, which is very difficult, we can just write A with a line underneath it. So our first question says, find the vector 2a. So we've got the vector a, which is 3 to the right and 1 down. So the vector 2a would be double that. So instead of being 3 to the right, it would be, let's write 2a is equal to, and instead of being 3 to the right, it's going to be 6 to the right. Instead of being 1 down, we're going to double it, so it's going to be 2 down. So the vector 2a would be double the vector a, so it would be 6, negative 2. If we're asked to find the vector 3a, we would multiply both these numbers by 3. If we're asked to find the vector 10a, we would multiply both these numbers by 10. If we're asked to find the vector negative 4a, we would multiply both these numbers by negative 4, and so on. Okay, let's have a look at our next one. So this time we've been asked to find the vector a plus b. So here's the vector a, which is 3 to the right and 1 down, and here's the vector b, which is 4 to the right and 6 down. So to find the vector ab, we would just add these vectors together. So the vector a plus b would be equal to, and if we add them together, 3 plus 4 is equal to 7, and then negative 1 plus 6, well, negative 1 plus 6 is equal to 5. So the vector a plus b would be 7, 5. And that makes sense because if we start off at a starting point and we go 3 to the right and 1 down, so 3 to the right and 1 down, and then we go 4 to the right and 6 up, altogether we have gone 7 to the right and 5 up. And that's what the vector a plus b is. Okay, and finally, we've been asked to find the vector b subtract 2a. So we've got the vector b, which is 4, 6, and the vector 2a is 6, negative 2. So we've got the vector b, and we've got the vector 2a. Now we just need to do b subtract 2a. So that's going to be equal to, b subtract 2a would be equal to, well, 4 subtract 6 would be negative 2. And then 6 subtract negative 2. Well, 6 subtract negative 2 would be 6 plus 2, which would be 8. So the vector b subtract 2a, if you get b and 2a and you subtract 2a from b, would give you negative 2, 8. And that's it. Okay, so that's column vectors, and that's video 353A in Corbettmaths. Okay, let's have a look at our next vectors question. So this time we've been given a diagram, and it's a triangle, and we've got the points O, A, B, and Q is the midpoint of AB. And we've been told that the vector OA is equal to 4A, and the vector, let's write that down, OA is equal to 4A, and the vector OB is equal to B. So OB is equal to little b. And we've been asked to find the vector BA. So we want to get the vector from B to A. Now we don't know B to A, but what we can do is we can go from B to O and then from O to A. So let's write that down. So BA would be equal to BO plus OA. So if we go from B to O and then from O to A, that will be the vector BA. So let's write down what that would be. So BO, well, BO is going to be, well, it's not B, it's going to be going the opposite direction. So it's going to be negative B or minus B. So it's equal to minus B. And then we're going to go from O to A, and we know that's equal to 4A, so plus 4A. And that's it. So the vector from B to A would be equal to minus B plus 4A, or we could write it the way around as 4A minus B. And that's it. Okay, next we've been asked to find the vector BQ. So we want to get from B to Q. Now Q is the midpoint of AB, so Q's in the middle. So that means that the vector BQ will be half of the vector BA. So if we half the vector BA, we will get BQ. So let's write that down. BQ is equal to half of BA. And that's going to be half of 4A minus B. And that will be equal to, well, half of 4A is 2A. And then half of minus b would be minus a half b. And that's it. So the vector BQ would be equal to, let's write it down, BQ is equal to 2a minus a half b. Okay, let's have a look at the next part. So the next part asks us to show that OQ is parallel to the vector 8a plus 2b. So we want to show that OQ and 8a plus 2b are parallel to each other. Now to do that, if two vectors are parallel to each other, they're multiples of each other. So for instance, if we had the vector b and we had the vector 2b, they're both going in the same direction. It's just that 2b is twice as long as the vector b. So let's find what OQ is. So if we want to find OQ, we're going to have to go from O to b and then from b to q. So let's write that down. OQ is equal to OB plus BQ. Now OB, well OB is equal to b, so that's going to be b, plus, and then BQ is equal to 2a minus a half b, so 2a minus a half b. Now let's simplify this. We've got b, or 1b, we're taking away half b, so that's going to leave us with, so that means the vector OQ is equal to half b plus 2a. Now we want to show it's parallel to 8a plus 2b, so let's actually write this the other way around. Let's put the a's at the front, so that would give us 2a plus a half b. So that means the vector OQ is equal to 2a plus a half b, and we want to show that's parallel to 8a plus 2b. Now if we multiply OQ by 4, if we multiply this by 4, we would get 8a plus, and 4 times a half is 2b. So if we multiply the vector OQ by 4, we get that's equal to the vector we want to show it's parallel to. So that means that OQ and this vector are multiples of each other. So let's write that down. And that's it. So just written down the 4OQ, so if we times this by 4, we get the vector 8a plus 2b. And the 8a plus 2b is a multiple of OQ, so therefore they're parallel to each other. And that's it. Okay, let's have a look at our last vectors question. So this time we've been given a diagram and we've got O, A, B and C, and we're asked, is A, B, C a straight line? So we're looking to see, is this a straight line? Now in vectors questions, if I want to see if something is a straight line or not, what I would want to do is, if for this ABC, I would want to find the vector AB, I would want to find the vector BC, then I would want to see if they're multiples of each other. That would mean they're parallel to each other. And if they both pass through B and they're parallel, then it must be a straight line, because if they pass through the same point and they're parallel to each other, then it's a straight line. So let's do that. Let's find the vector AB and let's find the vector BC. So AB, to get from A to B, well, we're going to go from A to O and then from O to B. So let's write that down. So AO, well, AO is equal to 4a minus 3b, so 4a minus 3b. And the vector OB is equal to 5a plus 2b, so plus 5a plus 2b. And when we add these together, 4a plus 5a is equal to 9a. And then minus 3b plus 2b is equal to minus b. So that means the vector AB would be equal to, if we write it down, 9a minus b. And that's it. So that's the vector AB. Now we want to find the vector BC. So to get from B to C, we're going to go from B to O and then from O to C. Now in this one, we're going to need to be careful, because if we look at the arrows, they're going in the opposite directions to the way we want to travel. So let's be careful with that. So we're going to do BC is equal to BO plus OC. Now BO, well, B to O would be equal to, now we're going the opposite direction, so it's going to be minus 5a minus 2b, so minus 5a minus 2b. And then going from O to C, well, we're going the opposite direction, so instead of doing b minus 32a, we're going to go the opposite way, so it's going to be minus b plus 32a. So that means if we simplify this, let's see what we get. So that means the vector from B to C, this vector, would be equal to 27a minus 3b. Now if we look at these vectors, A, B and BC, we can see that they're multiples of each other. That means they're parallel and they both pass through B. That means it is a straight line. So let's write that down. And that's it. So I've written down that BC is equal to 3AB, because if we look, BC is 3 times AB. That means they're multiples of each other. So BC and AB are parallel and they both pass through the point B. So ABC is a straight line. And that's it.
Okay, our next topic is on collecting like terms, and so that means we're going to simplify expressions such as this one, such as 7x plus y, take away x plus 5y, and that's video 9 on Corbettmaths. So if you do want to recap this, watch video 9 on Corbettmaths. Okay, so we've got 7x plus y, take away x plus 5y. So when we're collecting like terms, we collect the like terms. So let's start off with our x's. We've got 7x's, so here we've got 7x's, and we've got subtract an x. So if you get 7x's and you take away an x, or 1x, you'll be left with 6x's. So let's write that down, 6x. Now let's deal with our y's. We've got plus y, so that's positive y, or 1y, and we're going to add another 5y's. So if we added 1y and another 5y's altogether, that's adding 6y's. So it'd be 6x plus 6y, and that's it. So we've simplified an expression by collecting the like terms. Our next topic is substitution. So that's video 20 on Corbettmaths. And we've been given the question, given that w equals 9 and y equals 5, find the value of 8w minus 3y. So remember in algebra we don't write the multiplication sign, so 8w means 8 times w, or 8 times whatever value w is. In this case it's 9. And then subtract 3 times y. So that's 3 times whatever value y is, and that's 5. So let's work out what 8w is. So that's 8 times w, so that's 8 times 9, and that's equal to 72. So 8w is 72, and we're going to take away whatever 3 times y is. So 3 times 5 is equal to 15. So 3y is 15, and then we're going to do 72, take away 15, and that's equal to 57. So 8w subtract 3y, if w is equal to 9 and y is equal to 5, then that would be equal to 57, and that's it. Sometimes you're given substitution questions that involve odd and even numbers or positive and negative numbers, and I want to look at one of these now. So here we've got x is a positive number and y is a negative number. And we've been asked to state if the following expressions are positive or negative. So we've got 5x, so that means 5 times x. And x is a positive number, so it could be numbers such as 10. And 5 times 10 would be 50. But remember, x is a positive number, any positive number. So 5 is a positive, so positive times a positive would always be a positive. So 5x would be positive. So our next expression, xy, that means x times y. Now x is a positive and y is a negative. Well, a positive times a negative is a negative. For instance, if we had 10 and negative 2, 10 times a negative 2 is negative 20. So this would be a negative. And finally, we've got y squared. So y squared means multiply y by itself. So y is a negative number, so we're going to multiply the negative number by itself. And a negative times a negative is a positive. So that means that y squared would be a positive. And that's it. So sometimes you're asked to do substitution questions where you're asked to find if things are positive or negative or odd and even. And if you have a look at that bumper pack of questions, there's another one there for you to practice now. Okay, let's have a look at our next topic. So our next topic is laws of indices, and that's video 174 in Corbettmaths. And now what we're going to do is we're going to look at laws of indices whenever we're using algebra as opposed to using numbers. But the same rules apply. So for instance, if we had m to the power of 3 multiplied by m to the power of 4, we just add the powers, so it'd be m to the power of 7. If we had m to the power of 8 divided by m to the power of 2, we take away the powers if we're dividing, so that'd be m to the power of 6. And then finally, if we had a power to a power, so we've got a power and then a bracket and then a power outside, we'd multiply the powers together. So if we had m cubed squared, we then have m to the power of 6 by multiplying the powers together. Okay, and this is the Corbettmaths revision card on laws of indices, so this might be quite useful if you've got the revision cards as well. So let's have a look at our examples. We've got y to the power of 8 multiplied by y to the power of 3. So we've got y times y times y times y 8 times, and then we're multiplying that by another y times y times y, so that altogether there'll be 11 y's multiplied together, so that'll be y to the power of 11. In other words, adding the powers together, 8 plus 3 is 11, so it'll be y to the power of 11. Next, we've got y to the power of 15 divided by y to the power of 5. Well, if we're dividing and we've got the same base, so they've both got a base of y, we just take away the powers. So we've got 15, take away 5 is 10, so it'll be y to the power of 10. And finally, if we had y to the power of 6 squared, we've got a power of a power, so we multiply the powers together. 6 times 2 is 12. So it'll be y to the power of 12. Or another way to look at this one is we've got y to the power of 6 multiplied by itself, so we could then add the powers and that will give us 12 as well. That's it. Okay, now we're going to look at expanding brackets. And x bracket 3x plus 4. So remember, to expand our brackets, we multiply what's inside by the term outside. So we're going to do 3x multiplied by x, and we're going to do 4 multiplied by x. So 3x multiplied by x, well, that would be 3x squared, because we're multiplying the x by x would give us the x squared, and we've got a 3. So 3x multiplied by x is 3x squared. Then we've got our plus sign, and then we've got 4 multiplied by x, so that's just going to be 4x, and that's it. Okay, our next question. So here we've got our term outside, 2y, and we're going to expand our brackets, y minus 3. So we're going to multiply what's inside by the term outside. So we're going to do y multiplied by 2y. Well, that would be 2y squared, because we've got y times y is y squared. And then we've got the 2 as well, so that's 2y squared. Then we've got our minus sign. And then we're going to do 3 multiplied by 2y. Well, 3 times 2y would be 6y. So the answer would be 2y squared minus 6y. And if you want more practice on this, remember you can go to video 13 on Corbettmaths. You can watch that video, Beside that, there's the practice questions and also the textbook exercises. And then also remember there's that bumper booklet of questions, and there'll be questions there that involve expanding brackets. Okay, our next topic. Okay, so let's have a look at our next topic. So our next topic is expanding two brackets. So as you can see here, we've got two brackets, x plus 6 and x minus 2. And we've been asked to expand and simplify them. So to expand two brackets, I use this approach. I take my first term, my x, and I do x times x. So x times x is x squared. Then I do my x times minus 2, and x times minus 2 is equal to minus 2x. So 6 times x is 6x, so plus 6x. And then we've got 6 times minus 2, and 6 times minus 2 is equal to minus 12. So whenever we expand these brackets, we get x squared minus 2x plus 6x minus 12. Now, as you can see, we've been asked to expand and simplify, and if you look at these two middle terms, we've got minus 2x plus 6x. Now minus 2x plus 6x is 4x, so our final answer would be x squared plus 4x minus 12, and that's it. And another approach to expanding two brackets is to use a grid. So here we've got x plus 6, we write x and then plus 6. And then we've got x subtract 2, so we write x and negative 2. And what we're going to do is we're going to multiply each of these terms and put the answers inside of our grid. So we've got x times x, well that's x squared. We've got x times 6, or x times positive 6, that's going to be plus 6x. Then we've got negative 2 times x, so it's going to be negative 2x. And finally, we've got negative 2 times 6. Well, negative 2 times positive 6. Well, a negative times a positive is a negative, and 6 times 2 is equal to 12. So we've got x squared plus 6x, subtract 2x, subtract 12. So let's write that down. X squared plus 6x, subtract 2x, subtract 12. And then we need to simplify, so let's collect our like terms. We've got 6x take away 2x. Well, 6x take away 2x is 4x. So that would be x squared plus 4x subtract 12. So that's another approach we can use to expand in two brackets, is to use a grid. Okay, let's have a look at our next question. So our next question says expand and simplify 2x plus 1, x plus 4. So again, we're going to multiply both of these terms by the 2x, and then we're going to multiply both of these terms by the 1. So 2x times x. Well, 2x times x would be 2x squared. So 2x squared. Then we've got 2x times 4. Well, 2x times 4 would be 8x, so plus 8x. Now we're going to multiply both of these terms by the 1. So 1 times x is equal to x, or 1x, so that's x plus x. And then we've got 1 times 4. Well, 1 times 4 is equal to 4. So what we're going to do now is we're going to simplify these two middle terms. 8x plus x is equal to 9x. So our final answer would be 2x squared plus 9x plus 4. And that's it. And again, we could use the grid to expand these brackets. So we've got 2x plus 1 and x plus 4. Well, x times 2x, well, x times x is x squared, and then we've got times by 2, so that's 2x squared. Then we've got x times 1, well, that's going to be plus 1x, or plus x. We've then got 2x times 4, well, 2x times 4 would be 8x, so plus 8x. And then we've got 4 times 1, well, 4 times 1 is equal to 4, so plus 4. And then we can just write it all out, 2x squared plus x plus 8x plus 4. And then collecting our like terms, x plus 8x is 9x. So we've got 2x squared plus 9x plus 4. And that's it. Okay, let's have a look at our next topic. So our next topic is expand in three brackets, and that's video number 15 in Corbettmaths. So here's our question. It says expand and simplify x minus 2, x plus 3, x plus 5. So expand these brackets, what we're going to do is expand the first two, get that answer, and then multiply by x plus 5. So let's start off with the first two brackets. So we could use the grid. I'm just going to use this approach. X times x is x squared. X times 3, well, that's going to be plus 3x, so plus 3x. Minus 2 times x, well, minus 2 times x would be minus 2x. And then minus 2 times 3, well, negative 2 times 3 would be negative 6. So we've got x squared plus 3x minus 2x minus 6. And if we simplify the two terms in the middle, our 3x take away 2x, well, 3x take away 2x is x, or 1x. So we've got x squared plus x minus 6. So we've expanded our first two brackets. Now we need to multiply that by x plus 5. So we're going to multiply that by x plus 5, and then we'll see what we get. Now you could expand this using the grid approach, but I'm just going to use this approach. X squared times x, well, x squared times x is x cubed. X squared times 5, well, that'll be plus 5x squared. So we've done the x squared term. Now let's move on to the x term. Well, x times x would be plus x squared. X times 5 would be plus 5x.
And then finally, we've got our -6. -6 times x is -6x. And finally, -6 times 5 will be -30. So we've expanded our brackets. Now we just need to simplify. So we've got x cubed. If we have a look at our x squared terms, we've got 5x squared plus 1x squared. That'll be 6x squared, so plus 6x squared. If we look at our x terms, we've got 5x take away 6x, so that's going to be -1x or -1x or just minus x. And then finally, we've got -30, so we've got -30, and that's it. So if we were asked to expand and simplify, x minus 2, x plus 3, x plus 5, our answer would be x cubed plus 6x squared minus x minus 30, and that's it. Now, one thing to note, if we had a question like this where we've got x plus 1 and then x plus 3 squared, what we would do is, because we're multiplying the x plus 3 by itself, you'd write out the brackets as x plus 1 and then in brackets x plus 3 and then another x plus 3. And then you would just expand those in the same way we've done this by expanding the first two and then just multiplying by x plus 3 again. And that's it. Factorise w squared plus 8w. Now, as you can see, both terms have w's, so let's take w out. So w squared divided by w, that would just leave you with w. And then we've got our plus sign. And then 8w divided by w would just be 8. So our answer would be w bracket w plus 8. And you can test it by expanding the brackets. So w times w is w squared and w times 8 is 8w. Okay, next one. We've been asked to factorise 4y squared plus 6y. So we're looking for common factors of 4y squared and 6y. Now in terms of the numbers, I can see I can divide 4 and 6 by 2. So I'm going to take a 2 out as a common factor. And also in terms of the letters, we've got y squared and y, so we can divide both of those by y. So we're going to factorise this by taking out 2y. So we're going to divide both of these terms by 2y and see what we get. Well, 4y squared divided by 2y, well, that will leave me with 2y, because 2y times 2y is 4y squared. And then plus, and if we had 6y divided by 2y, that would just leave us with 3. So answer would be 2y bracket 2y plus 3. Okay, our next topic. Okay, so our next topic is factorising quadratics, and that's video 118 on Corbettmaths. We're going to be factorising quadratics, that's expressions with an x squared term, where it is just an x squared term. And whenever we factorise these quadratics, what we need to do is figure out what the two brackets were that we expanded to get that. So we want to figure out what two brackets we've multiplied together or expanded to get x squared plus 8x plus 15. What I'm actually going to do is I'm actually going to just pick two brackets to begin with, okay? And I'm going to call it x plus 4 and x plus 3. And I'm going to expand these brackets. So if we had the pair of brackets x plus 4 and x plus 3 and we expanded them, we would get x squared plus 7x plus 12. Now, one thing that I notice is that the 4 multiplied by the 3 gives us the number on the end, the 12. So the two numbers in the brackets at the end, the 3 and the 4, will multiply together to give you the number at the end of the quadratic. So here, where we've got our x squared plus 8x plus 15, the number here and the number here will times together to give us 15. Another thing to notice about these two numbers, the 4 and the 3, 4 plus 3 is equal to 7. They add together to give you the term in the middle. So whenever we're factorising this quadratic, x squared plus 8x plus 15, well, because it's x squared, we know there's an x at the front of both brackets because x times x is x squared. And in terms of the two numbers that follow the x's, they will times together to give you the 15 on the end, and they're going to add together to give you the 8 in the middle. So we want to find two numbers that will multiply together to give you 15 and add together to give you 8. Now, first of all, I'm thinking here it's going to be 3 and 5. Because if we had 3 and 5, 3 times 5 is equal to 15, and 3 plus 5 is equal to 8. So let's just check it. If we had x plus 3 and x plus 5, if we expanded these brackets, we would get x squared plus 5x plus 3x plus 15. And the 5x and the 3x would add together to give you the 8x. So that's it. So to factorise quadratic, where it's just an x squared term at the front, you're going to factorise and put your two brackets down. You're going to put x's in the front of them, and you're going to think of the two numbers that will times together to give you the number at the end, and they will add together to give you the number in front of the x, the coefficient of x. Okay, let's have a look at another example. So this time we've been asked to factorise x squared plus x minus 6. So we're going to have two brackets, and we're going to put x at the front of both of them. And we want to find two numbers in these brackets that will times together to give you minus 6, and they will add together to give you the number in front of the x. And as you can see here, it's just x, that means it's 1. So they're going to add together to give you 1. So we want to find two numbers that will times together to give you minus 6 and add together to give you 1. So let's think of numbers that times together to give you minus 6. So minus 6, we could have minus 6 times 1. We could have 6 times minus 1. We could have 3 times minus 2, or we could have minus 3 times 2. So these are all our options which will times together to give you minus 6. But we want the one that will add together to give you 1,
because it was plus x or plus 1x. So as you can see here, we've got minus 6 plus 1. Well, minus 6 plus 1 is minus 5. That's not going to be our right answer. We've got 6 plus minus 1. Well, that's going to be 5. That's not going to work. You've got minus 2 plus 3. Well, minus 2 plus 3 is 1. So that's going to be our correct option. We're going to have x plus 3 and x minus 2. So that means our answer must be x plus 3 and x minus 2. Okay, let's have a look at our next question. So our next question says factorize x squared minus 8x plus 7. So we've got our quadratic, and we're going to start off by putting our brackets down, because we know that we're going to have brackets with x's at the front of both of them. And we want to find two numbers that will times together to give us 7, and that will add together to give us negative 8. So let's start off by thinking of numbers that will times together to give us 7. So it could be 1 and 7, because 1 times 7 is equal to 7. But it could also be negative 1 and negative 7, because negative 1 times negative 7 is 7. Now we want the option where they will add together to give us negative 8. So first of all, I know it's not going to be the top option because they will add together to give us 8. Let's check our other option. Well, negative 1 plus negative 7. Well, negative 1 going down another 7 would be negative 8. So this will be our correct option. So in their brackets, we will have x minus 1 and x minus 7. And that's it. Factorize 5x squared plus 13x plus 6. So it's a quadratic, and we're going to factorize it. So there's going to be two pairs of brackets like so. And we're trying to factorize something that has a 5x squared at the beginning. That means at the front of both brackets, it won't just be an x and an x like it was. In this case, it's going to be a 5x and an x, because they will multiply together to give us our 5x squared. If we had something such as 4x squared, it's a bit harder because you're then having to figure out whether it's 4x and x or 2x and 2x. But with this one being 5x squared, that's quite nice. So we've got 5x and an x. Now then, if we were expanding our brackets, we would do 5x times x, which is our 5x squared. Then we would do 5x times this number, and then x times that number, and they would add together to give us our 13x's in the middle. And then finally, the number here times the number here will give us 6. So they'll times together to give us this number on the end. So we know that we're looking for two numbers which will times together to be equal to 6 to go at the end of both brackets. Now they could be 1 and 6. They could be 6 and 1. It could be 2 and 3, or 3 and 2. It could also in theory be negative 1 and negative 6 and so on, but they wouldn't work for this question, because if we had 5x times negative 1 and then x times negative 6, when you'd add them together, it wouldn't give you a positive term in the middle. So I know that because this is positive 13x, these are going to be positive numbers here. I'm looking at this bottom option here because I know if I use 2, I can do 5x times 2, which is 10x. And then if I put my plus 3 here, that will give me x times 3, which is 3x. And if you add them together, you get 13x. So let's just check it. 5x times x is 5x squared. 5x times 2 is plus 10x. 3 times x is plus 3x. And 3 times 2, which is plus 6. And then if you add the terms in the middle, you get 5x squared plus 13x plus 6. And that's it. And our answer would be 5x plus 3, x plus 2. So the main thing with factorising quadratics is practice. The more often that you factorise quadratics, the better you'll become at it. So you'll get to spot how to put those numbers in really quickly and easily. Okay, so if you want to factorise this using the split in the middle technique, I'd highly recommend you watch that video on Corbettmaths, but the technique is this. First of all, you take the number in front of the x squared, this 5, the coefficient of x squared, the number in front of the x squared, the 5, and you multiply that by the number on the end of the quadratic, the 6. So 5 times 6 is equal to 30, so you do 5 times 6 is equal to 30. Now we're going to want to find numbers which will times together to be 30, but they will add together to give you the term in the middle, which is 13. So in terms of numbers which will times together to be 30 and add together to be 13, they would be 3 and 10, because 3 times 10 is 30 and 3 plus 10 is 13. So what we're going to do is we're going to split this middle term up, this 13x, into a 3x and a 10x. And if we do that, we get 5x squared. Now we could write plus 10x plus 3x, or we could write plus 3x and plus 10x, and it doesn't actually matter which way around you do that, and I'll show you that in a minute. So let's do plus 10x and then plus 3x, and then we've still got our plus 6 on the end. So we've split this middle term up into a 10x and a 3x. So what we're now going to do is we're going to factorise the first two terms of this expression, and we're going to factorise the second two terms of this expression. So starting off with the first two terms of this expression, we've got 5x squared plus 10x. Now I can see that these two terms have 5x as a common factor. So we'll write 5x, and then we'll do a bracket, and then factorising this by taking out the 5x would leave us with an x to begin with, because 5x squared divided by 5x is just x, and then 10x divided by 5x is plus 2. Now let's factorise the second two terms of this expression. So we've got 3x plus 6. Well, we can divide both of these by 3, so we'll write plus 3, and then open up our brackets, and dividing both of them by 3 will also give us x plus 2. And that's great because we've got the same bracket, this x plus 2, twice. We've got 5x lots of x plus 2, and we've got 3 lots of x plus 2. Now, because we've got 5x lots of it, and we've got 3 lots of it, altogether that would be 5x plus 3 lots of x plus 2. And that factorizes our 5x squared plus 13x plus 6. Because as you can see, that's what we got whenever we factorized it using inspection. Okay, so that was one approach. I just want to show you that if you had written it as plus 3x plus 10x, you'll also get the same answer. So this time let's write our 5x squared plus 3x plus 10x. So splitting up the 13x into 3x and 10x plus 6. Now we're going to factorize the first two terms. So we've got our 5x squared and our 3x. Well, the common factor there would just be x, so we'll take x out as a common factor. So dividing both of them by x will give us 5x plus 3. And then our second two terms, we've got 10x plus 6. Well, if we had 10x plus 6, the common factor would be 2, so we'd write plus 2 and then bracket 5x plus 3. And what's great is, again, there we've got the same bracket twice. We've got x lots of 5x plus 3, and we've got 2 lots of 5x plus 3. So altogether that would be x plus 2 lots of 5x plus 3. So as you can see, there are two different approaches to factorize this quadratic. Okay, our next question is to factorize 7x squared plus 20x minus 3. So if I was using inspection, I would put my brackets down like so and put a 7x and an x. Now we know the numbers will times together to be negative 3, so it's going to be 1 and negative 3, or negative 1 and 3, or 3 and negative 1, or negative 3 and 1. So they would be my options, but I know that I want to get 20x whenever I expand. So whenever I do 7x times that number and x times that number, whenever I add them together, they will simplify together to be 20x. Now straight away I know that if I want 20x, it would be really great at positive 20x. If I put my plus 3 here, I would have 7x times 3, which is 21. Then if I had a minus 1 here, I would then have x times minus 1, well, that'll bring me down to 20x. So that would be it. So my answer would be 7x minus 1 and x plus 3. Alternatively, we could use the split in the middle technique, and I'll just do that in blue ink now. So 7 multiplied by minus 3, so that'll be minus 21. So we want two numbers which will times together to be minus 21, but will add together to be 20. And straight away I'm thinking 21 and minus 1. So 21 times minus 1 would be minus 21, but also minus 1 plus 21 would be 20. So they would be our two options. So we've got our 21x and our x. So let's split up the middle terms. So we could write 7x squared minus x plus 21x minus 3. So we've split up our middle term, our 20x, into a minus x and a 21x. Now let's factorize the first two terms. So if we had 7x squared minus x, we could divide both of those by x. So that would be x bracket 7x, and then taking x out here would be minus 1 whenever we factorize these first two terms. So we get x bracket 7x minus 1. And our second two terms, we can divide both of those by 3. So we would write plus 3 bracket, and dividing both of these by 3 would give us 7x minus 1. And that's great because we've got the same bracket twice. So putting our terms in front, our x plus 3 in a bracket, we would get x plus 3, 7x minus 1, and that's it. Now this actually isn't really a different topic, this is really a special case. So this is the difference between two squares, and this is video 120 on Corbettmaths. So what I'm going to do is I'm going to expand these brackets where I've got x minus 7 and x plus 7. Now I've just chosen these brackets where we've got x minus and an x plus and then the same number, and I just want to show you what happens whenever you have this case. X times x is x squared. X times positive 7 will be plus 7x. Then we've got minus 7 times x, that's minus 7x. And then we've got minus 7 times 7. Well, a negative times a positive is a negative, and 7 times 7 is 49, so it's going to be minus 49. And whenever we look at our two middle terms here, we've got 7x minus 7x. Now they will give you 0. Whenever you do 7x, take away 7x, that's 0. So we'll be left here with x squared. This and this cancels out, and we're just left with minus 49. So if you expand in brackets where you've got an x and then the same number, but then one with a plus sign and one with a minus sign, the two middle terms will cancel out. Now that's very useful because sometimes we can factorize expressions like this, and it's called difference between two squareds, because whenever we expand these brackets, the answer will always have a squared term, so x squared, and maybe a square number, and then you'd have a takeaway in the middle, so that's your difference. You're taking away the difference between two squares. Okay, let's have a look at some factorizing using this then. Okay, so our first question says factorize x squared minus 49. Okay, so we've just done that one actually. So we know whenever we expanded x minus 7, x plus 7, we got x squared minus 49. So if we were asked to factorize this, our answer would be x minus 7 and x plus 7. And the shortcut would be, well, we had x squared, so the square root of x squared is just x, so that goes at the front of both of them. And then we've got 49, so you square root 49, that's 7, so you know that it's going to be 7 at the end of both brackets. And then you put one with a plus sign and one with a minus sign, and that's it. So if I wanted to factorize x squared minus 9x, I would put two brackets down. I would square root both terms because they're both squares, so square root of x squared is just x and x. The square root of 9 is 3 and 3, and we put one with a plus sign and one with a minus sign, and it doesn't matter which way around they go, and that's it. So if we were to factorize x squared minus 9, the answer would be x plus 3, x minus 3. Okay, next we've been asked to factorize x squared minus 36, so again, bracket, 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 x, x, because the square root of x squared is x, and then 36, well, the square root of 36 would be 6, so 6 and 6, one with a minus sign and one with a plus sign. That's it. Okay, and our last one's to factorize 64 minus x squared, and this is just to show you that it's the difference between two squared, so it doesn't have to be x squared at the beginning. It could be the other way around. So let's factorize, and we'd get the square root of 64 is 8, so 8's going to be at the front of both brackets. We've got our two squares, so one's going to have a plus sign and one's going to have a minus sign, and the square root of x squared is x. So it's going to be 8 plus x and 8 minus x, and that's it. Our next question is to factorize fully 20x squared minus 125y squared. And this is video 120 now, so this is the difference between two squareds. And as you can see here, we've got 20x squared and 125y squared. So we've got the x squared and the y squared, but we don't have square numbers in front of them. We've got 20 and 125. So let's see if we can actually factorize by taking out any numbers to begin with. Now, because we've got 20x squared minus 125y squared, I can see that both of these, the 20 and the 125, have a factor of 5. So let's take 5 out as a common factor, and let's divide both of them by 5. So that would be 4x squared minus 25y squared. Now that's great. Now this is the difference between two squares. So as you can see, you've got 4x squared, and you got 25y squared, and the 4 and 25 are both square numbers. So that would be, so put our 5 down, and now remember with the difference between two squares, you put your brackets down, you square root both of them, so square root the 4x squared, so that'd be 2x, and that'll be at the front of both brackets, and square root in 25y squared, that'd be 5y and 5y, and you put one with a plus sign and one with a minus sign, and that's it. Okay, we're now going to look at equations, and we're going to deal with equations with letters on both sides. So here's an equation with letters on both sides, and we've got 5x plus 1 equals 3x plus 19. Now, whenever I'm solving equations with letters on both sides, I want to get rid of the lowest number of x's. Now, if you look at this, the lowest number of x's would be the 3x. So I'm going to get rid of this 3x. And remember, we do the inverse to both sides. So if I want to get rid of 3x, I'm going to take away 3x. So minus 3x and minus 3x. So if we had 5x plus 1 and we take away 3x, that leaves us with 2x. We've still got our plus 1. And on the right hand side of the equation, we had 3x plus 19. We're taking away the 3x's, so that just leaves us with 19. So we can solve this by taking away 1 and taking away 1. So that would leave us with 2x equals 18. And then we can divide by 2 and divide by 2 and see that x is equal to 9. And again, we can check our answer. 5 times 9 is 45, plus 1 is 46, and 3 times 9 is equal to 27, plus 19 is 46, so that's right. Okay, our next question. So our equation this time says 4x plus 5 equals 20 subtract x. Now whenever I'm solving equations with letters on both sides, I always want to get rid of the lowest number of x's. Now minus x is lower than 4x, so I'm going to get rid of the minus x. Now if I want to get rid of minus x, I'm going to do the opposite, which is add x to both sides of the equation. So I'm going to add an x and add an x. So on the left hand side I had 4x's and I add an x, or one more x, so it's going to be 5x plus 5, the numbers will stay the same, equals. And on the right hand side of the equation, I had 20 minus x. I added x, so the minus x and x will add together to give you 0, so they're just going to disappear, so you're just going to be left with 20. So we've got 5x plus 5 equals 20. And this is just like the equations you will have seen in the M1 video. So we're going to minus 5 and minus 5. So that will give us 5x equals 15. And then finally, we're going to divide by 5, and we're going to divide by 5. And that gives us x equals 3. And that's it. Okay, let's have a look at our next topic. So our next topic is forming equations. So here we've got some information, and we're going to form an equation out of it. So we've got Daniel is x years old. Daisy is 5 years older than Daniel, so she's 5 years older than him. So he's x. So to find her age, you would do x plus 5. So we'd write x plus 5. That's Daisy's age. And Chris is twice Daniel's age. So Daniel is x, and we're going to times it by 2 to get Chris's age, so that would be 2x. And the sum of their ages is 53. And our first question says, A, form an equation using the information given. So we've got the sum of their ages is 53. And remember, the word sum means to add up. So if we add up our x plus 5, and our 2x, we will get the sum of their ages, and we know that's equal to 53. So x plus 5 plus 2x, the sum of their ages equals 53. So let's collect our like terms. Let's do x plus 2x's. So x plus x is 2x, plus another 2x's is 4x's. And we've still got our plus 5, and that's equal to 53. So that is our equation. We've got an equation, 4x plus 5 is equal to 53. And part B says solve the equation to find Daniel's age. So we're going to solve this equation. So let's then get rid of this plus 5 by take away 5 and take away 5. So we'll leave us on the left-hand side with 4x, because we took away 5 to get rid of the plus 5. On the right-hand side of the equation, we had 53, take away 5 is equal to 48. Now we've got 4 times x is equal to 48. Well, we don't want this multiplied by 4, so let's divide by 4 and divide by 4. So 4x divided by 4 is just x. And on the right-hand side, we had 48 divided by 4, that's equal to 12. So Daniel was x years old, so we know that x is equal to 12, so Daniel is 12. So our next topic is forming equations, and that's videos 114 and 115 on Corbettmaths. So here we've got an isosceles triangle, and we've been told the angle at the top is 2x, and we've been told the angle at the bottom left is x plus 20. Now from where the sides of the mark the same, on the left hand side and the right hand side, I can see that this angle is equal to this angle. So this is going to be x plus 20 as well. Now the angles in a triangle add up to 180 degrees. So if we add up all these terms for the angles, the 2x, the x plus 20 and the x plus 20, we'll find that's equal to 180 degrees. So let's do that. So let's take our 2x and add our x plus 20 and add another x plus 20, and that will be equal to 180 degrees. So let's add up our x's. We've got 2x plus x, that's 4x's. And then we've got 20 plus 20, so that's going to be plus 40, and that equals 180. Now we've got 4x plus 40 equals 180, so let's take away 40 and take away 40. So take away 40 and take away 40 leaves us with 4x equals 140. And then we want to get x on its own, so we're going to divide by 4 and divide by 4, and that gives us x equals, and 140 divided by 4 would be 35. If the question asks us to find the size of the angles, then you would substitute the 35 into these expressions. So 2 times x would be 2 times 35. So this angle would be 70. And if we took our 35 and added 20, this angle would be 55 and this angle would be 55. So our angles would be 70, 55 and 55. But the question didn't ask us that, it just asked us to find x, and that's what we've done. Okay, so our next topic, we're going to look at solving quadratic equations, and that's video 266 in Corbettmaths. So to solve this equation, we're going to use the technique we just looked at, that factorisation. So if you have a quadratic equation where equals 0, you can try to factorise the left-hand side, and if it factorises, then you can solve it really quickly and easily. So let's factorise x squared plus 14x plus 45. So we'll put our brackets down, bracket, 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 and we're going to put x's at the front of both of them, and we're going to look for two numbers that will multiply together to give us 45, and we'll add together to give us 14. We could do 5 times 9, 5 times 9 is 45, and they add together to be 14. Fantastic. So we've got x plus 5, and then we've got x plus 9 equals 0. So we've factorised this quadratic, and we've got in brackets x plus 5, and then x plus 9 equals 0. Now, whenever you get two things that multiply together to give you 0, one of them has to be equal to 0. So that means that either this bracket's equal to 0 or this bracket's equal to 0. So let's look at this bracket. So you have a number plus 5, x plus 5 equals 0. So x plus 5 equals 0. Or x plus 9 is equal to 0. Either that bracket's equal to 0. So let's solve this equation. If you had x plus 5 equals 0, well, you could subtract 5 from both sides, and you'd get x equals negative 5. And in this case, you had x plus 9 is equal to 0. So if you subtracted 9 and subtracted 9, you'd get x equals negative 9. So if you had this equation, x squared plus 14x plus 45 equals 0, we've got two possible answers, and they are x equals negative 5 or x equals negative 9. And one other thing to note is sometimes I take a little bit of a shortcut whenever I'm doing these questions. So if I had x plus 5 and I'm trying to find when that bracket's equal to 0, I just know it's a negative 5 because negative 5 plus 5 is 0. So I would often take a bit of a shortcut. So whenever I'd be doing these questions, I would often just go straight to this point here. So I would say, well, x plus 5 is 0, so x equals negative 5. Or, and in this case, I know that it'd be negative 9 plus 9 is 0, so I just jump to x equals negative 9. And that's it. Okay, so let's have a look at our next question. So our next question is to solve x squared minus 4x minus 12 equals 0. And that's great because the equation, the quadratic, equals 0. If it's not equal to 0, you'd want to make it equal to 0. And then let's try and factorize this left-hand side. So let's put our brackets down and put equals 0. So we'll put our x's at the front of both brackets, and we're trying to find two numbers that will multiply together to give us negative 12, and they'll add together to give us negative 4. And 2 and minus 6, well, negative 6 plus 2 would be negative 4, so that's going to be our option. So our brackets will be x plus 2 and x minus 6. Now we're trying to find when each of these brackets could be 0. We know this bracket would be equal to 0 whenever x is equal to negative 2, because negative 2 plus 2 is 0. And for this bracket, we know it will be whenever x is equal to 6. So it would be x equals 6, and that's it. So x equals negative 2 or x equals 6. So we've been asked to solve 3x squared minus 10x minus 48 equals 0. So what I'm going to do here is I'm going to factorize this left-hand side. So let's put our brackets down, bracket, 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 bracket equals 0. And we've got 3x squared, so let's go for 3x and an x. Now we know that two numbers will multiply together to be minus 48, and so that means that one's going to be positive and one's going to be negative, and that whenever we expand our brackets we're going to get minus 10x in the middle, plus 8 and minus 6. Well, 3x times x is 3x squared, 3x times minus 6 would be minus 18x, x times 8 is plus 8x, fantastic, and then minus 48, so that would be 3x squared minus 10x minus 48. So now we've factorized, let's then solve it. So because we know that these two brackets will multiply together to give us 0, that means that the brackets will be equal to 0. So either this bracket is 0 or this bracket is 0. Now this bracket is quite easy to solve. We know that x will equal 6 there because 6 minus 6 is 0. This bracket, whenever I have a 3x plus 8 equals 0, I tend to write 3x plus 8 equals 0 and then just minus 8 from both sides. So 3x equals minus 8, and then divide by 3, x equals minus 8 thirds, like so. So there are our two solutions, that either x equals minus 8 thirds or x equals 6. And that's it. So we have solved a harder quadratic equation by factorizing. Okay, so our next topic is the quadratic formula, and that's video 267 on Corbettmaths. Now sometimes we're given a quadratic that can't be factorized, so we solve it by using the quadratic formula. So if you've got a quadratic in the form ax squared plus bx plus c equals 0, where a is the number in front of the x squared, so a is the coefficient of x squared, b is the coefficient of x, the number in front of the x, and c is the number on the end, then you can substitute them into the quadratic formula and it will tell you your solution straight away. And the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is part of the Corbettmaths revision card. And here's our example. We've been asked to solve 2x squared minus x minus 9 equals 0. Now sometimes in a quadratic formula question it will say solve 2x squared minus x minus 9 equals 0 and give your answers to 1 or 2 decimal places, and that's a clue that you're going to be using the quadratic formula. So let's label our a, b and c to begin with. So a equals, b equals and c equals. So a is the number in front of the x squared, so a is going to be equal to 2. B is the number in front of the x, so it says minus x, that means minus 1x, so that means that b is equal to minus 1. And finally c is the number on the end, which is our minus 9. So we have got a, b and c. Now we're going to substitute those into the quadratic formula. So x equals negative b, well b is minus 1, so we've got negative b, well if it's already negative that's going to make it positive, so that's going to be 1. Plus or minus the square root of b squared, well minus 1 squared, it's going to be minus 1 squared, minus 4 times a, and I just put it in brackets, so that's 2, times c, which is equal to minus 9, like so. And that's all divisible by 2a, and 2 times a is equal to 4. So we've got x equals 1 plus or minus the square root of minus 1 squared minus 4 times 2 times minus 9, all divided by 4. So now let's simplify what's under the square root sign. So we've got x equals 1 plus or minus the square root of, we've got minus 1 squared. Well, negative 1 times negative 1 is 1, so it's going to be 1. And then we've got subtract, and whenever I work out this 4ac part, I always put my answer in a bracket. So we've got 4 times 2 times minus 9. Now 4 times 2 is equal to 8, times minus 9 is minus 72. So we've already got our minus sign outside here. So we've got 4 times 2, which is 8, times minus 9, which is minus 72. So that goes there. And then all divided by 4. Next, we've got 1 minus minus 72. That's going to be 1 plus 72, which is 73. So we're going to get x equals 1 plus or minus the square root of 73, all divided by 4. And now, I'm actually just going to move this down here, so I'm just pulling it down here. Now here we're going to have two solutions. We're going to work out 1 plus the square root of 73 divided by 4, and we're going to do 1 minus the square root of 73 divided by 4. So let's write those out separately. So we're going to have 1 plus the square root of 73 divided by 4, and we're going to have or x equals 1 minus the square root of 73 divided by 4. And so let's just work those out in our calculator and see what we get. So we get x equals 2.386 or x equals negative 1.886. And that's it. So we've used the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a to solve a quadratic which couldn't be factorized. Okay, let's have a look at our next topic. So our next topic is completing the square. Now we've looked at how to solve quadratics by using factorization and by using the quadratic formula, and completing the square is a technique that we can use to solve quadratics and also to help us with things such as finding the turning points of quadratic graphs. And its videos on Corbettmaths are videos 10 and 267a. So first of all, we've been asked to write the quadratic x squared plus 6x plus 15 in the form of x plus a close bracket squared plus b. So writing this quadratic in this form is what we call completing the square. So to do that, what I do is I first of all start off by opening up my brackets and put my x inside the brackets. Because it's x squared, I'm just putting an x inside the bracket, because when I multiply this bracket by itself, we'll get the x squared. Then to get the a, what we do is we halve the coefficient of x. So the coefficient of x is the number in front of the x, which is 6. So we halve 6, so that'll be plus 3. So that's the value of a, 3. If it was plus 10x, we would then have plus 5. If it was x squared minus 8x, we would have x minus 4, halving the coefficient of x. And then we have our squared. Now, whenever we expand this bracket, when we multiply it by itself, we would get x squared plus 6x plus 9. What I'm now going to do is I'm going to take away 9. And I'm taking away a 9 to just leave us with the x squared plus 6x part of the quadratic. And to get this 9, this minus 9, what we do is we take away whatever this number is squared. So for instance, if it was plus 6, we would take away 36. If it was plus 7, we would take away 49. If it was minus 4, well, minus 4 squared is 16, so we would minus 16. It's always take away whatever this number is squared. And then we just put the plus 15 on the end, so this plus 15. So we've got x squared plus 3, close bracket squared, minus 9 plus 15. Now, we just want a plus b, so we don't want the minus 9 plus 15, so we're going to do minus 9 plus 15, which is 6. So the answer would be x plus 3, close bracket squared, and then we've got minus 9 plus 15, which would be plus 6, and that's it. So we've written this quadratic in the form of x plus a, close bracket squared, plus b, where we've got x plus 3, close bracket squared, plus 6, and that's it. Right, so now let's have a look and see how we can use completing the square to solve quadratics. And we've got x squared plus 6x plus 2 equals 0. So let's solve it using completing the square. So let's complete the square for this quadratic to begin with. So that would be x, and then half of 6 would be 3, so plus 3, close bracket squared. We then take away this number squared, so 3 squared is 9, so take away 9, and then we've still got our plus 2, and that equals 0. Now negative 9 plus 2, well negative 9 plus 2 would be negative 7, so we've got x plus 3, close bracket squared, subtract 7 equals 0. So we now want to solve this equation, so we want the x on its own, so let's add 7 to both sides of the equation. So that would give us x plus 3, close bracket squared, equals 7. So we now want to get rid of the squared. So we're going to square root both sides of this equation, but just be careful when we're square rooting, we can have the positive or negative solution. So we're going to have on the left hand side x plus 3, and on the right hand side of the equation we're going to have the square root of 7 or root 7, but it could be positive or negative because root 7 times root 7 is 7, or negative root 7 times negative root 7 is equal to 7 as well. So I'm going to write plus or minus the square root of 7. And then finally, we want the x on its own, so we want to get rid of this 3, so we're going to take away 3 from both sides of this equation. So we're going to take away 3 and take away 3. On the left-hand side, that would just leave us with x, and on the right-hand side, whenever I'm taking away 3 here, instead of writing plus or minus root 7 take away 3, I tend to put the negative 3 at the front, so I then have negative 3 plus or minus the square root of 7. And that's it. So that means that x is equal to minus 3 plus the square root of 7, or x is equal to negative 3 minus the square root of 7. And that's it. So this is a great way to solve quadratics that can't be factorized instead of using the quadratic formula. And that's it. Okay, next topic is changing the subject. So here we've got a formula. We've got t is equal to AW take away c. And at the minute, the capital T is the subject because it's on its own. The t is on its own there, so t is the subject. But we want to make w the subject. So what that means is we want to get the w on its own. So we don't want this take away c, and we don't want this to multiply by a. So what we're going to do is, like an equation, we're going to get rid of this take away c and multiply by a. So let's write out our formula. We've got t equals AW take away c. Now we want to get the w on its own, so let's get rid of this take away c to begin with. So if I wanted to get rid of take away c, I'm going to add c to both sides. So add c and add c. Well, t plus c was just t plus c. We just read it out. And then on the right hand side of our formula, well, we had aw minus c. We added c to get rid of the minus c because minus c plus c is 0. So we would just be left with aw. Now we want to make w the subject, which means we want to have the w there on its own. This is a times w. We're multiplying the w by a. We don't want to multiply the w by a, so let's divide both sides by a. So let's divide by a and divide by a. On our right hand side, we had aw. We divided by a to get rid of it, so we'd just be left with w. On the left hand side of this formula, we had t plus c, and we're dividing that by a. So what we're going to do is write t plus c. Now remember, in algebra, we don't write the divide by sign, and we do over a. And that means we've got t plus c divided by a. And that's it. So we've got w on its own, so w is the subject. So our answer would be w equals t plus c over a. And that's it. And changing the subject is video 7 on Corbettmaths. So if you want to watch more examples of changing the subject, starting off with some simple questions and building up to questions like this, video 7 will be really, really useful. And also remember, there's the practice questions and the textbook exercise there as well. If you do have the revision cards, changing the subject is one of the revision cards. And as you can see here, we've got a typical change in the subject question where it says make w the subject, and it goes through step by step explaining how you would make w the subject of that formula. So changing the subject is a really important topic. It's video 7 on Corbettmaths, and if you do have the revision cards, that revision card will be really useful for it. Okay, so let's have a look at this example. So we've got make y the subject of w equals y plus 2 over y. So what I'm going to do is, I don't want to have this y on the denominator, so I'm going to multiply both sides of this by y. So multiply by y and multiply by y. W times y will be wy, just putting them beside each other. And on our right hand side, we had y plus 2 divided by y. We multiply by y to get rid of the divide by y, so we're just going to be left with y plus 2. We've now got yw equals y plus 2. Now we want to make y the subject, which means we want to have, so at the end, y equals something. But here we've got two terms with y's in it. We've got wy and we've got the y. So what we want to do is we want to bring them over together on the same side. So what I'm actually going to do is take away y from both sides of this formula. And what that will do is bring the y's to the left hand side here. So we've got wy and we're going to take away y. So we're going to write wy minus y. So we've brought all the y's over to the left hand side. And we've got the plus 2 or just 2 on the right hand side. So we've got the terms with y's on one side and everything else on the other side. Now we want to make y the subject. Now we've got wy minus y. We can actually factorize this because they both have y's in them. So we can write y and then brackets, and we can factorize this by dividing both of these by y. So wy divided by y would just leave us with w. And then we've got minus, and y divided by y is 1. So if we were to factorize wy minus y, taking the y out, we'd leave us with y bracket w minus 1. And that equals 2. Now we're almost there. We've got y times w minus 1 equals 2. But we don't want the w minus 1 there, we just want the y. So if we want to get rid of this w minus 1, what we're going to do is we're going to divide both sides by w minus 1. So dividing the left hand side by w minus 1, well, that would just leave us with y, which is great. And on the right hand side, we had 2, and we're going to divide it by w minus 1, so we'll just write that down. We'll write 2. Now remember, we don't write the divide by sign in algebra, we write the big line, so over, and then we write w minus 1 on the denominator. So we've got 2 divided by w minus 1. So that's our answer. We've got y equals 2 over w minus 1. And let's just write that out, 2 over w minus 1. So we've made y the subject. And these are videos 7 and 8 in Corbettmaths, changing the subject and changing the subject advanced. And this particular type of question would be video 8, the advanced video. So I'd highly recommend watching that video on Corbettmaths, and there's practice questions there. I've actually updated those recently, and there's actually video solutions to those. So whenever you go through those questions, you want to see how I've done each question. I've actually made a video talking about every single question in that booklet. Okay, our next topic is algebraic fractions, and that's videos 22, 23 and 24 on Corbettmaths. So here we've got an algebraic fraction. It's a fraction with algebra, and we've been asked to simplify it. And that means to cancel it down. And whenever we're cancelling down fractions, so we tried to divide the numerator and the denominator by the same thing, so they get simpler. So as you can see here, if we look at the top here, we've got x minus 3 times x plus 2, and on the bottom we've got x plus 2 plus x plus 9. Now as you'll notice, we've got two brackets that are the same. We've got this x plus 2 and x plus 2. So if we divide the numerator of this fraction by x plus 2 and the denominator of the fraction by x plus 2, we can cancel it down. So let's divide it by x plus 2, and that just means, well, cancelling it out would give us x minus 3 on the top and x plus 9 on the bottom. Okay, so our next question is to simplify x squared minus 2x over x squared plus 2x minus 8. So this time we've got to factorize before we can cancel it down. So let's factorize it. So our numerator, we can just take x out as a common factor. So that's going to be x bracket. And then if we divide both of these by x, we get x minus 2, close brackets. And then the denominator, we can factorize it. So that's going to have two brackets. We're going to have x's at the front of both of them. And we want to find two numbers that will times together to give us minus 8 and add together to give us 2. Now I'm thinking minus 2 and 4, because minus 2 and 4, they will multiply together to give us our minus 8, and they will add together to give us our 2. So that means it's going to be x minus 2 and x plus 4. And that's great because, as you can see, we've got x minus 2 on the numerator and we've got x minus 2 on the denominator. So we can divide both the numerator and denominator by x minus 2. So that means they'll cancel out. And then you'll be left with x on the numerator, and on the denominator we'll be left with x plus 4. And we don't write the brackets, we just write x plus 4. And that's it. Okay, our next topic. Our next topic is algebraic fractions, but this time we're going to look at multiplying algebraic fractions. So remember, to multiply fractions, we multiply the numerators and multiply the denominators. So we've got simplify x over 7 multiplied by x over 3. So let's multiply the numerators. Well, x times x is x squared. And on the denominator, we've got 7 times 3, that's 21. So the answer would be x squared over 21. This time we've got 3x over 2 multiplied by 5x over 6. So this time, again, we're going to multiply numerators. 3x times 5x, well, that's going to be 15x squared. And then multiplying our denominators, 2 times 6 is equal to 12. Now, one thing I noticed on this fraction is we've got 15 on the numerator and 12 on the denominator. Now, they're both divisible by 3. So we can actually cancel down this fraction by dividing both the numerator and denominator by 3. So that will give us, if we divide both of them by 3, 5x squared over 4, and that's it. So the answer would be 5x squared over 4. Okay, let's have a look at our next question. So our next question says to simplify 1 over 2x multiplied by x squared over 3. So again, multiplying the numerators, 1 times x squared is x squared, and on the denominator, 2x times 3 would be 6x. So we've got x squared on the numerator and we've got 6x on the denominator, so we can actually cancel down this fraction. So you could divide the numerator and denominator by x. So if you did that, you'd be left with, on the numerator, x, and on the denominator, if you divide this by x, you'd be left with 6. Another way to look at it would be, you could just divide the x squared by x, and that would leave you with x, and then again that would just leave you with x over 6. This time we've been asked to simplify x minus 3 divided by x plus 4 multiplied by x plus 4 over x plus 1. So let's multiply these together. So I'm going to write x minus 3 multiplied by x plus 4 over x plus 4 multiplied by x plus 1. Now, one thing I've noticed is we've got the same bracket on the numerator and denominator, so we can cancel down this fraction, so we can cancel those out, and that would leave us with x minus 3 on the numerator and x plus 1 on the denominator, and that's it. Okay, let's have a look at some questions now where we're dividing algebraic fractions. So we've got x minus 2, and we've got divided by, remember, whenever we're dealing with fractions, we multiply by the reciprocal of the fraction we're dividing by. So we're going to change the divide to multiply, and we're going to find the reciprocal, which means flip over the second fraction. And then we just multiply, so if x times 3 is 3x, and then on the denominator we've got 2 times 2, which is 4. So our answer would be 3x over 4. So when we're dividing algebraic fractions, we change the divide to multiply and find the reciprocal of the fraction we're dividing by. Okay, our next question. We've been asked to simplify 3x plus 9 over 2 divided by x plus 3 over 4. So again, we're going to keep the first fraction the same, 3x plus 9 over 2 times by, and finding the reciprocal of the second one, we're going to have 4 over x plus 3. Now when we multiply these together, we get 4 bracket 3x plus 9, close brackets, over 2 bracket x plus 3. Just putting them together. Now one thing that I've noticed is we've got a 4 and a 2, so we can divide both the numerator and denominator by 2, and that would give us, on the numerator, if we divide the numerator by 2, we get 2 bracket 3x plus 9, and on the denominator we'd just be left with x plus 3. Now another thing is 3x plus 9 will also factorise. If we had 3x plus 9, we could take 3 out as a common factor. They're both divisible by 3. It would give us 3 bracket, and dividing both of them by 3 would be x plus 3. So if you've got 3x plus 9, that's the same as 3 bracket x plus 3. But we had 2 lots of that. So instead of having 3 lots of x plus 3, we're going to have 6 lots of x plus 3. So it's going to be 6 bracket x plus 3. Another way to look at it is if we take the 3 out, we could do 2 times 3 is 6, and that's why there's a 6 in front there. But that's divided by x plus 3. Now another thing to notice is we've got x plus 3 on the numerator and the denominator, so we can cancel those out. So the answer would just be 6. And I think that's fantastic. We had this complicated algebra, and the answer would just be 6. Now, I want to sort of show you another approach to this question. So one thing to notice is also, rather than multiplying and then cancelling down, you can actually cancel down at this point here by cancelling down the numerator of this fraction and the denominator of this one, and the numerator of this fraction and the denominator of this one. Because when we multiply them, they're going to be together on the numerators and the denominators anyway. So if you had 2 and 4, you could divide both of those by 2, and that would give you 1 and 2. And here, if you had 3x plus 9 and x plus 3, you could factorise this to get 3 bracket x plus 3. And then if you cancel down these ones, well, you could divide both of them by x plus 3. So you'd be left with, here, 3 over 1 multiplied by 2 over 1. Because obviously, if you divide this by x plus 3, you'd be left with 1 there. And the answer would again just be 6 over 1, which is 6. So as long as there's a multiplication, you can cancel down in that technique where you cancel down the numerator with the denominator of the other one and the numerator by the other denominator, and so on. Okay, so we've looked at simplifying algebraic fractions, we've looked at multiplying them and dividing them. Let's look at adding and subtracting them. So our question says simplify x plus 4 over 3 plus x plus 1 over 2. So to add algebraic fractions, they need to have the same denominator. If we had 3 and 2, a common denominator would be 6, so 6 and 6. And to have a 6 on this denominator, we would need to double both the numerator and the denominator. To get from 3 to 6, you'd multiply by 2, so we need to multiply this by 2. Multiplying both of these terms by 2 would give us 2x plus 8. And to get from 2 to 6, you'd multiply by 3, so you'd need to multiply these by 3. And multiplying these both by 3 would give us, well, 3 times x is 3x, and 3 times 1 is plus 3. Now we can just add them together, so you know we're going to have 6 on the denominator, and 2x plus 3 would be 5x, and 8 plus 3 is equal to 11. So our answer would be 5x plus 11 over 6. Okay, so our next question. Is x plus 1 over 4. Subtract x plus 4 over 6. So if we want to find a common denominator, well, 4 and 6, well, I think 12 would be a good choice. So 12 and 12, and it's take away. Now to get from 4 to 12, we multiply by 3, so we need to multiply both of these by 3. So 3 times x is 3x, and 3 times 1, well, plus 3. And to get from 6 to 12, we double it, so we need to double the numerator. So doubling x and 4 would be 2x plus 8. And again, we want to subtract, so we're going to have equals, and we're going to have our denominator of 12. In terms of the numerator, we've got 3x take away 2x, and 3x take away 2x is 1x, or x. And then we've got 3 subtract 8, and 3 subtract 8 will be minus 5. So the answer would be x minus 5 over 12. And we've been asked to express as a single fraction 2 over 3x plus 1 plus 1 over x minus 1. Now whenever we're adding together fractions, we want the same denominator, and to do that, what we're going to do is we're going to multiply both the numerator and denominator of the first fraction by the denominator of the second fraction. So we're going to multiply both of these by x minus 1, and for our second fraction we'll multiply both the numerator and denominator by the denominator of the first fraction. So we'll multiply both of these by 3x plus 1. So whenever we do that, we get, well, we'll write 2, and then we're going to multiply our numerator by the denominator of this fraction, so 2 bracket x minus 1, like so. And then our denominator would be, well, we would have 3x plus 1 in a bracket, and then we're going to put another bracket beside it with x minus 1, like so. So we've multiplied both the numerator and denominator, both by x minus 1. Now we're going to multiply both of these, the numerator and denominator, by 3x plus 1. So when we do that, we get, well, multiplying the numerator by 3x plus 1. Because it was a 1, we could just write 3x plus 1, because we know that we're just multiplying it by 1. And then with our denominator of x minus 1, we're multiplying that by our 3x plus 1. So we've got x minus 1 bracket 3x plus 1. And that's it. And as you notice, we've got the same denominators for these fractions. So we've got 3x plus 1 times x minus 1. And here we've got 3x plus 1 times x minus 1. So now that we've got the same denominators, we can combine our fractions as a single fraction. So we'd have our numerator. So we've got 2 bracket x minus 1. And then we've got our second numerator, so plus, and then 3x plus 1. And then we've got our denominator, which is just 3x plus 1 bracket x minus 1, like so. Now let's simplify our numerator. So let's expand that bracket. So 2 times x is 2x. 2 times minus 1, that's minus 2. And then we've still got our plus 3x plus 1. And our denominator is still 3x plus 1 and x minus 1. And then finally, simplifying our numerator, well, we've got 2x plus 3x, that's going to be 5x. And then we've got minus 2 plus 1. Well, minus 2 plus 1 is minus 1. And our denominator was 3x plus 1, x minus 1, like so. And that's it. So we've expressed 2 over 3x plus 1 plus 1 over x minus 1 as a single fraction as 5x minus 1 over 3x plus 1 times x minus 1, like so. Okay, so we've looked at algebraic fractions, and now we're going to look at some equations that involve algebraic fractions. So we've got solve x plus 5 over 3 plus x plus 1 over 2 equals 8. So whenever you've got an equation like this, I would deal with the left-hand side to begin with. So I would look at these algebraic fractions and I would simplify them. So we're going to give them a common denominator of 6 and 6. To get from 3 to 6, you multiply by 2. So let's multiply both of these by 2. So that would be 2x plus 10 on the numerator. And for this fraction, to get from 2 to 6, you multiply by 3. So multiplying both of these by 3 would give us 3x plus 3 equals 8. So as you can see, we've written both fractions with a common denominator. Okay, so now let's focus on this left-hand side and write this as a single fraction. So let's just put a big line and 6 on the denominator. And we're going to do 2x plus 3x. 2x plus 3x is 5x. And 10 plus 3, well, 10 plus 3 is 13, so plus 13. And that still equals 8. So we have just combined this left-hand side as a single fraction. Now we want to solve it. So because we've got this big divide by 6, I want to get rid of that. So I'm going to multiply both sides by 6. I'm going to multiply the left-hand side of this equation by 6 and the right-hand side of the equation by 6. So I'm multiplying the left-hand side of the equation by 6 to get rid of the big divide by 6. So that would just leave me with 5x plus 13. And on the right-hand side of the equation, I had 8 times 6, and 8 times 6 is 48. So that equals 48. Now I just want to solve this, so subtract 13 and subtract 13, and that will give me 5x equals 35, and divide by 5 and divide by 5, and you get x equals 7, and that's it. So here's our example. It says solve 2 over x minus 3 plus 1 over x minus 4 equals 2. So as you can see, at this left-hand side, we've got two algebraic fractions, and we're going to add them together and combine them as a single fraction. So we'll add them together to write them as a single fraction. So let's do that. So let's multiply both the numerator and denominator of this fraction by x minus 4, and then we'll multiply both the numerator and denominator of this fraction by x minus 3. So doing that would give us 2 bracket x minus 4 over x minus 3 times x minus 4. So multiplying both of these by x minus 4, and then plus, and we're going to multiply both of these by x minus 3. Now because it's a 1, I'm just going to write x minus 3 on the numerator. If there was a number there, I would put it in a bracket and put the number in front. Then over, and then I had x minus 4, and then I'm timesing that by x minus 3. And although the brackets are in a different order, remember a times b and b times a is the same thing, that equals 2. Okay, now we're going to combine them as a single fraction. Because they've got the same denominator, I can write my x minus 3, x minus 4. My fraction line went up a bit there. So I can write my x minus 3 and x minus 4. And on the numerator, I have 2 bracket x minus 4 plus, and then we've got our x minus 3. And that equals 2. So I've just written the two fractions as a single fraction, but with the same denominator. Now, what we're going to do is we're going to simplify this numerator. So let's expand the brackets. So 2 times x is 2x, and 2 times minus 4, that's minus 8, plus x minus 3 over x minus 3, x minus 4, like so. And that equals 2. So just expanding these brackets. Now let's simplify the numerator. 2x plus x is 3x. And then we've got minus 8 minus 3, that's minus 11 over x minus 3, x minus 4, and that equals 2. So now we've got 3x minus 11 over x minus 3 times x minus 4 equals 2. Now I don't want these brackets on the denominator here. I want to actually get these off the denominator. So what I'm going to do is multiply both sides of the equation by x minus 3 and x minus 4. So multiplying both sides by x minus 3 and x minus 4. So whenever we do that, well, we're timesing this side by x minus 3 and x minus 4 to get rid of it on the denominator. So we'd just be left with 3x minus 11. And then on the right hand side, well, we're multiplying 2 by x minus 3 and x minus 4. So we would have 2 bracket x minus 3 and x minus 4. So now we're going to multiply this right hand side. So we've got 3x minus 11. And then let's expand these brackets. So let's put our 2 down and put just a big bracket and then expand our brackets. So x times x is x squared. X times minus 4 is minus 4x. Minus 3 times x is minus 3x. And minus 3 times minus 4 is plus 12. Now let's simplify it. So let's simplify these middle terms. So we've got 3x minus 11 equals 2 bracket x squared minus 7x plus 12. Then expand our brackets. So we've got 3x minus 11 equals 2x squared minus 14x plus 24. And then finally, whenever you're solving quadratics, we want it to equal 0. So let's get rid of this 3x and minus 11. So let's minus 3x from both sides. So that would give us minus 11 equals 2x squared minus 17x plus 24. And then we want to get rid of this minus 11. So let's add 11 to both sides. So it'll be 0 equals 2x squared minus 17x plus 35. So we've now got a quadratic which we can hopefully factorize and solve. So when we do that, we get 0 equals, so we factorize our quadratic and we put 2x and x. Now we want two numbers that will multiply together to give us 35. And whenever we expand and add the terms together, will give us minus 17x. So I'm thinking it's going to be a negative and a negative. So let's put a 5 here, so that's 2x times minus 5, which would be minus 10x. And then put a 7 here, so it's minus 7 times x, which is minus 17x. Fantastic. And that's it factorized. Now let's solve it. So we know that whenever two brackets multiply together to give us 0, that they have to be 0. So that means that for our first bracket, we've got 2x minus 7 equals 0. So adding 7 to both sides, 2x equals 7, and dividing by 2, x equals 7 over 2. So x can be equal to 7 over 2 or 3.5 if you prefer decimals. And then our right hand bracket, well, we know then that x equals 5. So our two answers are x equals 7 over 2 or x equals 5, and that's it. So there are two solutions. So we've been given a question and it says circle the identity. So here first of all we've got an equation. We've got 4x plus 1 equals 21, and we can solve this. So we can take 1 away from both sides and we'll get an answer, and if you solve this you would find x equals 5. Now because that's just got an answer, that's an equation, so it's not an identity. Now next we've got 3x minus 7 is less than or equal to 50. That's what we call an inequality, because we've got this inequality sign. We've got the less than or equal to sign. So if it's got a greater than sign, a greater than or equal to, a less than or equal to sign, they're called inequalities. That's an inequality, it's not an identity. Next we've got 6x minus 8, and that's what we call an expression. We've got these terms 6x and minus 8, so that's just what we call an expression. And finally we've got an identity, and an identity is something that's always equal to each other. So we've got 5 bracket x plus 1 close brackets, and then we've got this symbol here with 3 lines. That's the equivalent to symbol, and then we've got 5x plus 5. And if you expand this set of brackets, so you get 5x plus 5. So 5 bracket x plus 1 is always equal to 5x plus 5. So that is an identity. It's always equal to it. So an identity is something that's always true, and that's it. Okay, so we've had a look and seen what an identity is. Now let's have a look at a question where we're given an identity and we need to find some unknowns, and in this case we need to find the values of a and b. So here we've got on the left hand side of our identity, in brackets 3x minus 1 multiplied by x minus 5, close brackets, plus ax plus b is equivalent to, or always equal to, 3x squared plus 11x minus 1. So let's have a look at the left hand side of this identity. So let's multiply these brackets. So let's expand these brackets and see what we get. 3x times x is 3x squared. Then we've got 3x times minus 5, that's going to be minus 15x. And then we've got minus 1 times x, that's going to be minus x. And then finally, we've got negative 1 times negative 5. Well, negative times a negative is a positive, and 1 times 5 is 5. And then we've still got our plus ax plus b. So that's the left-hand side of our identity, and that's equivalent to 3x squared plus 11x minus 1. Now let's simplify this because we've got our minus 15x minus x. So minus 15x, take away another x, will be minus 16x. So we've got 3x squared minus 16x plus 5 plus ax plus b is equivalent to 3x squared plus 11x minus 1. Okay, so we've expanded our brackets and we've got 3x squared minus 16x plus 5 plus ax plus b, and we know that's going to be always equal to 3x squared plus 11x minus 1. Now if we have a look at our x squared terms, we've got 3x squared on the left hand side and 3x squared on the right hand side, so that's fantastic because they're the same as each other. Now if we have a look at our x terms, we've got minus 16x plus ax would have to be equal to 11x. Now if we've got minus 16x and we're going to add so many x's and we want to get 11 x's, that means that a would have to be equal to 27, because minus 16 plus 27 is equal to 11. So minus 16 x's plus 27 x's would give us our 11 x's. So a would be equal to 27. Okay, now let's find b. So if we have a look at our constants, our numbers, we've got 5 plus b on the left hand side, and on the right hand side that's equal to negative 1. So we want to take 5 and we want to add a number to it to get negative 1. So that means that b is going to be a negative, so b will have to be a negative. And if we add negative 6 to 5, that's going to give us negative 1. So b would have to be equal to negative 6. And that's it. So a is equal to 27 and b is equal to negative 6. Okay, let's have a look at our next topic. Our next topic is drawn linear graphs. So that is drawn a straight line graph. And we've been asked to draw the graph of y equals 2x plus 1. So we're going to plot the coordinates where the y value of the coordinate is twice the x coordinate plus 1. So to do that, sometimes in the question they give you a table, but occasionally they haven't given a table. So I'm going to show you how to do this without a table. But if they give you a table, it should look something like this. So it starts off with x and y, and then you've got some values of x at the top. So it could be something like minus 2, minus 1, 0, 1, 2. And if they haven't drawn a table for you, you would just do something like this. And to find what y is, well, y is equal to 2 times x plus 1. So we're going to substitute in these values of x into this, and we're going to find what y is. So we've got 2x plus 1. So we're going to times all the x coordinates, all these numbers, by 2 and add 1. So let's start off here with our 2. 2 times 2 is 4, add 1 would be 5. This point is 1, so 2 times 1 is 2, plus 1 is 3. And doing that for the rest of the points we'll get, and that's it. So we've got our coordinates. Now we just need to plot them. This is a set of coordinates here, 2, 5, 1, 3, 0, 1, negative 1, negative 1, and negative 2, negative 3. So we'll plot these 5 points and then draw a nice straight line through them. And then get a ruler and a pencil and draw a nice straight line through those points, and it looks something like this. And that's it. So that's how you draw a straight line graph. Our next topic is to find the midpoint of a line. Now the midpoint of a line, it can be done in 2 different ways. If it's drawn on a grid for you, sometimes you can do it just by inspection, just by having a look and seeing if you can spot where the midpoint is. So here we've got the line AB, and if I wanted to find the midpoint of this line, I can see straight away it's here. So that means that the coordinates of the midpoint would be 1 minus 2, because it's 1 across, 2 down, so it's 1 minus 2. So that would be the midpoint of the line. So if you've got it on a grid, you can just sometimes spot it, but sometimes you're given the coordinates. So the coordinates of B would be the point 3, 0. The coordinates of the point A here would be minus 1, minus 4, minus 1, minus 4. And if you were given the coordinates and you were asked to find the midpoint, what you do is just add the coordinates together and then divide by 2, and that would tell you the coordinates of the midpoint. So if we have minus 1 and 3, well, minus 1 plus 3 is 2, and divide by 2 is 1, so fantastic. And then in terms of the y coordinate, if we add the y coordinates together, the minus 4 and 0, well, minus 4 plus 0 is minus 4, divided by 2 is minus 2. So if you add the coordinates together and divide by 2, you'll find the coordinates of the midpoint. Okay, let's have a look at our next topic. So our next topic is coordinates, and we're going to look at coordinate questions whenever we're dealing with ratio, and that's video 87A in Corbettmaths. So here we've been given a question. We're told that A is the point with coordinates negative 20, negative 7, and B is the point with coordinates 16, 11, and there's a point on this line somewhere called P, and the ratio of A to P to P to B is equal to 4 to 5. So it means that the distance AP to PB, whenever we simplify it, we get 4 to 5. And we've been asked to work out the coordinates of the point P. So the point P is going to be around here somewhere, because we know the distance from A to P is smaller than the distance from P to B, because we know that the ratio of AP to PB is 4 to 5. So I've just put it roughly here on the diagram. It's just to the left of the midpoint. And we've been asked to work out the coordinates of this point. So to start off with, what I'm going to do is I'm going to look at the points A and the point B, and what I'm going to do is I'm going to turn it into a right angle triangle. So I'm going to go across, and then I'm going to go up, and it's a right angle triangle. Now if we have a look at this triangle, if we consider the distance we've gone across, we've gone from -20 to 16. So we've gone from -20 to 16. So that means that we're going 36 across. So 36 across. And then if we look at how much we've gone up by, so the point A has got a height of -7, and the point B's got a height of 11. So we've gone from -7 up to 11. So we've gone up 18. So that means to get from the point A to the point B, we would move across 36 and we would go up 18. Now if we have a look at the ratio, we're told that the point P is a point on this line such that AP to PB is 4 to 5. So that means that if we add 4 and 5 together, so 4 plus 5, we get that's equal to 9. So if we divide both of these distances by 9 and times them by 4, that would tell us how we would get from A to P. And that means that we can work out the coordinates of the point P. So let's start off with horizontally. So if we take our 36 and we divide it by 9, so 36 divided by 9 is equal to 4. And then we're going to multiply by 4 because we want to get from A to P. So we're going to do 4 times 4 is equal to 16. So that means to get from A to P, we would move 16 across. So we move 16 across. So that means that if we were at -20, and we add 16, that means the point P will have an x-coordinate of -4. Now let's consider vertically. Well, we're going up 18 altogether, so we're going to take our 18 and we're going to divide it by 9. So 18 divided by 9 is equal to 2. Now we want to go from A up to P, so we're going to multiply that by 4. So we're going to do 2 times 4 is equal to 8. So that means to go from A to P, we're going to go across 16 and we're going to go up 8. And that means that if we take our -7 and add on 8, that's going to be 1. So the point P has coordinates -4, 1, and that's it. Okay, our next topic is to find the length of a line. Now if you have a look at this line, you can see if we just go across and then go up, we can turn it into a right angle triangle. And the great thing is then we can use Pythagoras' theorem to find the length of this line. So this is a right angle triangle. So let's mark on our lengths. So we've got this point here, which is the point 1, 1. In terms of horizontally, you can see we're going across 1, 2, 3. So it's going to be 3. And in terms of the heights, you can see here we're at 1 and we're going up to 5. So that means the height of this triangle would be 1, 2, 3, 4. So we've got the lengths 3 and 4. Now they're not centimeters, they're just 3 and 4 units. And we want to find the length of the line. So remember, Pythagoras' theorem is a squared plus b squared equals c squared, where a and b are the shorter sides and c is the longest side. So a and b, well, so a is going to be 3, so 3 squared plus, and b, let's let b equal 4, so 4 squared equals, and then we've got c squared, well that's going to be ab, so we could call it x if we wanted to and just write x squared. Then let's work out 3 squared plus 4 squared. Well, 3 squared is 9, so we've got 9 plus, and 4 squared is 16, so 16 equals x squared. So we've just squared 3 and squared 4. Then we're going to add our 9 and 16 together. So 9 plus 16 is 25, and that equals x squared. So we've got 25 equals x squared, or x squared equals 25. Now we want to find the length of this line. So what we're going to do is we're going to square root, the opposite of square root, to find the length of this line. So we're going to do the square root of 25, and the square root of 25 is 5. So that means that the length of this line is 5 units. And that's it. Our next topic is to work out the gradient, or the steepness of a line. So to work out how steep a line is, we use the formula gradient equals rise over run. So if we've got a straight line drawn on a grid, if we do the rise of the line divided by the run of the line, that will tell us the gradient or the steepness of the line. And this is video 189 on Corbettmaths. So let's have a look and see what rise and run are. So if you've been given a line drawn on a grid such as this one, and you've been asked to work out the gradient of it, choose 2 points on the line to begin with. Now in terms of the points here, we could choose this point here, -1, -2, or 0, 0, or 1, 2, or 2, 4, or 3, 6, or 4, 8. They would be good points to choose. I'm just going to choose this one here, 1, 2, and I'm going to choose this point here, 3, 6. And I'm going to turn it into a little right angle triangle. So I'm going to go across and then I'm going to go up. So the rise is the rise here, so it's how far up you've gone. So whenever you draw your little right angle triangle, it's the rise, it's how much the line's gone up by. So if you can see, we've gone up, and make sure you know what you're going up in. So we've gone up in ones here, so we got by 1, 2, 3, 4. So the rise here would be 4, and the run, and again check what we're going to cross in, we're going to cross in ones, so the run would be, well, we're going to cross 1, 2, so the run would be 2. So we've got our rise of 4, and we've got a run of 2, so let's work out the gradient. The gradient is the rise, 4, divided by the run, 2, and that's equal to 2. So the gradient of this line is 2, and what that means is for every 1 unit you go across, the line's gone up 2. And as you see, if we started at 0, 0, if we go across 1, it goes up 2. If you go across another 1 to 2, you go up another 2. If you go across another 1 to 3, you go up another 2, and so on. So the gradient of this line is 2, and the gradient is found by doing the rise divided by the run. And you just draw a little right angle triangle, you just work out what the run would be and the rise would be, and then you do the rise divided by the run. So if you had a line going downwards like this, and you wanted to find the gradient of this line, again, you would draw a right angle triangle. You would choose 2 points. So I'm going to choose this point, and I'm going to choose this point. And as you can see, we're going across 1. So going from 5 to 6, our run is 1. And in terms of our rise, well, we're going downwards this time. So our rise is -4 because we're going down. And you would do -4, the rise, divided by 1, and that would be -4. And that means for every 1 you go across, the line goes down 4. If you go across 1, it goes down 4, and so on. Okay, let's have a look at another gradient question. This time I've changed the scale so the numbers are a bit bigger, and we've been asked to work out the gradient of this line. So here we've got a line, and we're going to choose 2 points on it. I'm going to choose this point, which is the point 0, 50. I'm going to choose another point, and another point I think looks quite good would be 25, 250 here. And let's draw our little right angle triangle. So we're going to go across, and then we're going to go up. Now in terms of the run, we're going from 0 here, all the way across to 25. So the run here would be 25. We're going across 25. And the rise, well, we're going from here up to here. So we're going from 50 up to 250. So our rise would be 200. And then to find the gradient, we're going to do the rise divided by the run. So we're going to do the rise, 200, divided by 25, and that's equal to 8. So the gradient of this line is 8. And that what that means is for every 1 you go across, 1 unit you go across, you're going to be going up 8. So the gradient of this line would be 8. So our next topic is looking at the equation of a line. So the equation of a line is in the form y equals mx plus c. So for instance, something like this, y equals 4x plus 3. Now what we're going to do is we're going to look at this equation. So whenever you got it in the form y equals mx plus c, the number in front of the x is the gradient. So if I had the line y equals 4x plus 3, the gradient of that line is 4. And you'll remember that means that for every 1 square you go across, or 1 unit you go across, the graph goes up 4 units. So you go across 1, it goes up 4, and so on. And then our plus c is the y-intercept. This shows you where the graph crosses the y-axis. So for this graph here, this graph would have y equals 4x plus 3, has a gradient of 4, and it crosses the y-axis at 0, 3. It has a y-intercept of 3. Now here's part of the Corbettmaths revision card on the equation of a line, and you've got y equals mx plus c, where m is the gradient, so this number is the gradient and c is the y-intercept. And if we had this line here, if we wanted to find this equation, well, first of all, we would find the y-intercept. It crosses the y-axis or meets the y-axis at 1, so that means that it's going to be plus 1 on the end. In terms of its gradient, well, we can make a little triangle, and we can do rise divided by run. And if the rise was 4 and the run was 2, well, 4 divided by 2 is 2. So that means the gradient of this line is 2. For every 1 you go across, it goes up 2. 1 you go across, it goes up 2. So the gradient of this line is 2. So the equation of this line would be y equals 2x plus 1. So let's find the equation of this line that's been drawn on the grid. So we know it's going to be in the format y equals mx plus c. We know that m's the gradient, so let's find the gradient to begin with. So let's make a little triangle. So let's choose 2 good points. I think that a good point would be this one here at -1, 1, and another good point would be this one here. You could have also chosen 0, 4. So I'm going to make a little triangle, so going across and up. And for my triangle, it's got a run of 2. It goes across 2 units. So it goes from -1 to 1. It's got a run of 2. And the height, it goes from 1 up to 7. So that's got a rise of 6. So for the gradient, we've got rise divided by run. So m equals rise over run. So it's going to be equal to the rise 6 divided by the run 2, and 6 divided by 2 is 3. So the gradient of this line is 3. So we know it's going to be y equals 3x. Now in terms of the y-intercept, it crosses at 4, positive 4, so it's going to be plus 4. If it crossed down here at -1, you would write -1, and so on. If it crossed through the origin 0, you wouldn't write anything, you would just write y equals 3x. But this graph, it crossed, it had a y-intercept of 4, so we wrote y equals 3x plus 4, and that's it. Okay, our next question says, a straight line with gradient -2 passes through the point 1, 5. Find the equation of the line. So we know, first of all, it's a straight line. So we know it's in the form y equals mx plus c. So we know that the answer is going to be y equals something x plus or minus something. And it says it's a straight line with gradient -2. So we know it's going to be y equals -2x and then something after it. And it passes through the point 1, 5. And it says find the equation of this line. So we need to find this y-intercept, and that's where the straight line meets the y-axis. There's two ways which I would typically do this question. One is by looking at the gradient. The gradient's -2. So that means that this graph is actually going down. So we've got a x and y axis. It's got a gradient of -2. So it's coming downwards like so. And we know it goes through the point 1, 5. So it goes through the point 1, 5. So because we know the gradient is -2, that means for every 1 you go across, it comes down 2. You go across 1, goes down 2. So for this point here, if we want to find where it crosses the y-axis here, so the y-axis, we know that it's gone across 1 and it's come down 2, and it's now got a height of 5. That means it must have had a height of 7 to begin with, because it must have had a height of 7 to go across 1 and come down 2 to now have the height of 5. So that means that our y-intercept would be 7. So the equation of our line is y equals -2x plus 7. So one approach is to know what the gradient means and to look at the point you've been given and to work out where it would have crossed the y-axis. Now there is another approach, and this is actually the approach that I would typically use, and that is whenever we knew it was y equals -2x plus something, I would just write plus c, which stands for the y-intercept. And I know that the point that they've given me is 1, 5. So I know that it has an x-coordinate of 1 and a y-coordinate of 5. And we can substitute these in to our equation. So we can, instead of writing y equals, we could write 5 equals. So 5 equals. And then next, we know we've got -2x. So that's -2 times whatever x is. And x is equal to 1. So -2 times 1 is equal to -2. And then we've got our plus c. And then we want to find what c is, our y-intercept. Well, we want the c on its own, so we want to get rid of this -2, so we'd add 2 to both sides of this equation, and you get 7 equals c. So c is equal to 7, so you get y equals -2x plus 7. Okay, let's have a look at our next question. So this time we've been given a straight line passes through the points 3, 8 and 5, 20. And we've been asked to find the equation of the line that passes through those points. So again, we know it's going to be in the form y equals mx plus c. So we want to find the gradient of the line that passes through these points, and we want to find where it crosses the y-axis. So first of all, let's find the gradient. Okay, so let's do a little sketch. So we've got our x and y-axis, and we've got our first point, which is 3, 8. So 3 across, 8 up, somewhere like that. And then we've got 5, 20. So a little bit across and much further up like that. So we've got 5, 20, and we've got 3, 8. And we want to find the gradient of that line, so the gradient of that straight line. And so what I do is, as before, I would draw a little right angle triangle like so and get our rise and our run. So our run, well, we're going from 3 across to 5, so our run is 2, and our rise, we're going from 8 up to 20, so our rise would be 12. So we've got a rise of 12 and a run of 2, so the m equals rise over run, so rise over run. So that's going to be equal to rise 12 over 2 is equal to 6. So the gradient of this line is 6. So for every 1 we go across, we go up 6. And let's just check it. If we went across 1, we would get to 4. And then if we go up 6, we would get to 14. And then if we went across another 1, we get to 5. And up another 6, we get to 20. So yeah, that's right. Okay, so we know it's y equals 6x plus something, so plus c. Let's just choose one of our points because we know the line passes through both of these points, 3, 8 and 5, 20. So let's choose one of these points. I'm going to choose 5, 20. I could have chosen 3, 8. And I know x is equal to 5 and y is equal to 20. The x coordinate is 5 and the y coordinate is 20. So let's substitute those into our equation. So y, that's 20, equals 6 times x, so that's 6 times 5. 6 times 5 is 30, plus c. So to get c on its own, I'm going to want to take away 30 from both sides. So that will leave me with 20 take away 30 is -10. And then we've got 30 plus c, take away 30 just leaves us with c. So c is equal to -10, so our y-intercept is equal to -10. So our answer would be y equals 6x minus 10. And again, let's just check it. We knew the gradient of the line was equal to 6. So I meant that, so for every 1 we go across, we go up 6. So if we're at this point, if we go across 1, we'd go down 6. That would then bring us to 2, 2. If we go across 1 and down 6, that would bring us to 1 minus 4. And across 1 and down 6 would bring us to 0, -10. So yeah, the y-intercept would be -10. And that's it. Okay, so let's have a look at our next topic, and it's parallel lines, which is video 196 on corporate maths. And parallel lines, they're lines that go in the same direction and they never meet each other. And because they go in the same direction, they have the same gradient or the same steepness. So if we had y equals 2x plus 1 and y equals 2x minus 3, those lines would be parallel to each other because they've got the same gradients. And this is the corporate maths revision card on that. So if you do have the corporate maths revision cards, make sure you know this one and stick it up on your wall or bring it with you on the bus in the morning or whatever. Make sure you remember the parallel lines have the same gradient. And that's it. So that's a very useful bit of information that parallel lines have the same gradient, and you can use that in questions as well. Okay, let's have a look at an example. So here we've been told the line A is parallel to the line y equals 3x plus 9 and passes through the point 7, negative 1. Find the equation of line A. So because the line A is parallel to y equals 3x plus 9, we know that it's got the same gradient. So the line A will have an equation in the form y equals mx plus c. And we know the gradient of the line will be 3 because it's parallel to this line, so they must have the same gradient, 3. So we know it's going to be y equals 3x plus c. Now we just need to find c, but we know the line A passes through the point with coordinates 7, negative 1, so it's got an x coordinate of 7 and a y coordinate of negative 1. So if we substitute these values into our y equals 3x plus c, we can find our value for c, and then we will know the equation of the line A. So we know that x is equal to 7 and y is equal to negative 1. So y, that's going to be negative 1, is equal to 3 times x. Now x is equal to 7, so 3 times 7 is 21 plus c. Now we want to find c, so we want to get rid of this 21, so subtract 21 from both sides of the equation to get rid of this 21 on the right hand side. So we know that c is equal to negative 22. So that means the equation of the line A will be y equals 3x minus 22, and that's it. So let's have a look at our next topic. Now we're going to look at perpendicular lines, and these are lines that meet each other at 90 degrees. They cross each other at a right angle. Now here we've got the corporate maths revision card, and as you can see we've got an example here of a pair of perpendicular lines. We've got the line y equals 2x, which is going up in this direction, and then going down in this direction we've got y equals minus a half x plus 1. And as you can see, these two lines meet at 90 degrees, they cross at 90 degrees. Now one thing to notice about their gradients is, well, here we've got 2 and here we've got minus a half. Now the reciprocal of 2 is a half. The negative reciprocal of 2 would be minus a half. So if you know the gradient of one line, if you find the negative reciprocal of it, you'll find the gradient of the other line. So here, if you knew the gradient was equal to 2, if you find the negative reciprocal of it, so take the reciprocal, which is a half, and then make it negative a half, you will find the gradient of the line that's perpendicular to it. Another interesting point is if you multiply the gradients of two perpendicular lines, you will get negative 1. So if you have 2 times negative a half, well, 2 times negative a half is negative 1. So the product of the gradients for perpendicular lines is negative 1. I tend to just use the negative reciprocal. So if you know that the gradient of this line is a negative a half, well, the reciprocal of a half is 2. And then because it was negative, it's now positive. So the gradient of the perpendicular line would be 2. Okay, let's have a look at a question based on that. So here we've got a question that says a line is drawn that is perpendicular to y equals negative 4x plus 7 and it passes through the point 8, 3. Work out the equation of the line. Now we know that it's perpendicular to y equals negative 4x plus 7. So it's perpendicular to this line, and this line has a gradient of negative 4. So if we find the negative reciprocal of negative 4, you will find the gradient of the line that's perpendicular to it. So we first of all know this gradient was negative, so the gradient for our line is going to be positive, so we know it's going to be positive. And the reciprocal of 4, well, the reciprocal of 4 is equal to a quarter. So we know that the gradient of our perpendicular line would be a quarter because the negative reciprocal of the gradient that we were given. So we know that the equation of our line will be y equals a quarter x plus c. Now we know that it passes through the point 8, 3, so if this is the x coordinate and that's the y coordinate, we can substitute those into our equation and we can find our c. So we know that our y is equal to 3, so we've got 3 equals a quarter x, so that's a quarter of x, and x is 8, so that's a quarter of 8 plus c. So next we've got 3 equals a quarter of 8 is 2, so we've got 2 plus c. Well, c is going to have to equal 1 here, so we've got what c is. So that's it. So we know that the equation of the line that's perpendicular to y equals minus 4x plus 7 that passes through the point 8, 3 would have to be y equals a quarter x plus 1, and that's it. Got an example, and the question says the graph below shows the cost of hiring a hot tub, and this is video 171A in Corbettmaths Maths. So here we've got a graph that shows us the cost of hiring a hot tub, and you've got the number of days going along horizontally, and we've got the cost going up vertically, so going from 0 up to 350. So the question says the graph intersects the vertical axis at 100. So as you can see here, it starts at 100. What does this represent? So as you can see here, this would be on 0 days. So this is like a set fee. It's like a set charge that you're charged for hiring the hot tub. So no matter what, there's £100 to begin with, and then you're going to be charged so much per day. So what this represents, so this represents a fixed fee, a fixed cost of £100. So that means that no matter how long you hire this hot tub for, there's a £100 fee to begin with. If this was the cost of a plumber, that might be a call-out fee. Or if this is a taxi, that whenever you go into a taxi, sometimes you see the meter starts at a particular number, like a set fee that you have to pay to begin with. So this is a fixed cost, this value of £100. The next question says, find the gradient of the graph. So we've got this graph and we want to find its gradient. So let's choose 2 points. I'm going to choose the point here, 0, 100. I'm going to choose this point up here, which is 10, 350. And let's make our little right angle triangle. So going across and going up. And let's work out the rise divided by the runs. So our gradient, m, that's the letter for gradient, m, is rise divided by run. So for our right angle triangle, the rise, well, it's gone from 100 up to 350. So that's a rise of 250. So that will be 250 divided by. And the run, if you look at how much we've gone across by, we've gone from 0 to 10. So the run would be 10. So we're going to do 250 divided by 10, and that's equal to 25. So that means the gradient of this line is equal to 25. And the question says, explain what the gradient represents. So remember the gradient, it means for every one you go across, how much the line goes up by. Now in terms of this context of hiring a hot tub, what that would mean is for every one more day you hire the hot tub, how much the price increases by. So that's what it means. It means the hot tub, it means the cost per day of hiring the hot tub is £25. So that'd be the cost per day, £25. So our next topic is simultaneous equations. And here we've got a pair of simultaneous equations. We've got 3x minus y equals 23 and 2x plus 3y is equal to 8. So whenever we get simultaneous equations, what we want to do is cancel out one of the letters. We want to add or subtract the equations so that one of the letters disappears. So as you can see here, we've got minus y and we've got 3y. Now if we had minus 3y and 3y, we could add them together to get 0. So what I'm going to do is I'm going to multiply this top equation by 3 to begin with. So let's number them, 1 and 2. So we've got equation 1 and equation 2. We're going to do 3 times equation 1. So whenever we do 3 times equation 1, well, multiplying this by 3 gives us 3 times 3x is 9x. Then 3 times minus y, well, that's going to be minus 3y. And 3 times 23, well, 3 times 23 is 69. Then we've got equation 2, which is 2x plus 3y equals 8. We've got one equation with minus 3y and we've got one equation with 3y. So that's fantastic. What we can do now is we can add these two equations together and our minus 3y and our 3y will add together to give us 0. So we'll just be left with x's, and that's fantastic. Okay, so let's add the two equations together. So let's write the word add. I tend to avoid putting a plus or minus symbol just in case if it was a subtract and I put a minus here in front of the 2, I might get confused and think it's a minus 2x. So I write add or sub. Now what I'm going to do is I'm going to add these two equations together. So 9x plus 2x, well that would be 11x. Minus 3y plus 3y, well that's 0, so they cancel out. And finally we've got 69 plus 8, that's equal to 77. So we've got 11x equals 77. Now we can divide by 11 and divide by 11 and we get that x equals 7. So x equals 7. So that's fantastic. So we know x is equal to 7, so let's now find y. So let's substitute this x equals 7 into one of our equations. And I'm going to substitute it into equation 2 just because we have positive 3y. And let's write that down. So sub x equals 7 into 2, just to show what we're doing. So whenever we substitute x equals 7 into this equation, we get 2 times 7, so that's 14, plus 3y equals 8. Now we're going to solve this equation, so minus 14 and minus 14. Well, we had 14 plus 3y, and we took away the 14, so we're just left with 3y. And on the right-hand side, we've got 8 take away 14, that's going to be equal to negative 6. Now we're going to divide both sides by 3, and whenever we divide both sides by 3, well, 3y divided by 3 is just y, and negative 6 divided by 3 is equal to negative 2. So that means we've got our answers. We've got x equals 7, and y equals negative 2. And let's just check our answer. Now we substitute x into equation 2 to find our value of y. Let's now substitute both of them into equation 1. So let's check in 1. So check in 1. Well, if we put these numbers, if we substitute these numbers into equation 1, we've got 3 times x, so that's 21. 3 times 7 is 21. Minus y. Y is minus 2, so we're going to do minus minus 2. And that's meant to be equal to 23. So let's check it. 21 minus 2, that's 21 plus 2, and that's 23, so that's right. So we know we've got this question right, and that's it. Okay, let's have a look at our next question. So our next question says, solve the simultaneous equations 2x plus 3y equals 1 and 7x plus 2y equals negative 22. And I've chosen these numbers on purpose because what we're going to have to do now is multiply both equations by certain numbers to get the same number in front of either the x's or y's. So let's call our equations equation 1 and equation 2. Now we could cancel out our x's, so we could multiply the top equation by 7 to get 14x, and we could double equation 2 to get 14x, and we could cancel those, or we could cancel our y's, so we could multiply, let's say if we've got 3 and 2, let's get 6, so we can multiply our top equation by 2 and our bottom equation by 3, and that would give us 6y and 6y. And because they're both 6y's, we would then take the equations away from each other to get 0. Let's actually do that. Let's cancel our y's. So let's multiply equation 1 by 2 because we want to get 6y. So we're going to do 2 times 1. And when we do 2 times equation 1, we get, well, multiplying this whole equation by 2 would be 4x plus 6y equals 2. Now we've got equation 2, but we want to get 6y, so let's now multiply this whole equation by 3. So let's do 3 times equation 2. And when we do that, we get, multiplying these all by 3, we get 3 times 7x is 21x, 3 times 2y, that's going to be plus 6y, and 3 times minus 22, that's going to be minus 66. So this is great because we've now got two equations, both with 6y's in them. Now what we can do is we can now take away these equations from each other. Now the only thing is that whenever we take these away, we're going to have 4x take away 21x, which would be negative 17x and so on. So what I'm actually going to do is I'm going to write this top equation again just beneath this other one. So I'm going to write 4x plus 6y equals 2. Just so that whenever I take these equations away from each other, I'm going to get 17x rather than minus 17x. So now let's put a line beneath them and let's say subtract. So we're going to subtract these equations from each other. So 21x take away 4x, that's 17x. 6y take away 6y, well that's 0, they cancel out. And then we've got minus 66 take away 2. So when we've got minus 66 take away 2, we're going to go down another 2, so it's going to be minus 68. So we've now got 17x equals minus 68. So let's divide both sides of this equation by 17. So divide by 17 and divide by 17, and we're going to get that x equals negative 4. So we now know that x is equal to negative 4. We can substitute that into either equation 1 or equation 2 to get our y. Let's substitute it into equation 1. So equation 1, so sub x equals negative 4 into 1. And when we do that, we get, well, 2 times x, well, that's going to be 2 times negative 4, and 2 times negative 4 is negative 8, plus 3y equals 1. Now, if we want to solve this, we want to get rid of our negative 8, so let's add 8 to both sides, so add 8 and add 8. So that would give us 3y equals, and 1 plus 8 is 9, and divide by 3, and divide by 3, and we get y is equal to 3. So our answers are x equals negative 4, and y equals 3. And again, we can check our answer in equation 2, check in 2, and when we do that, we get, well, 7 times x, well, 7 times minus 4 will be minus 28. Then we've got plus 2y, well, y is equal to 3, so 2 times 3 is 6, so we're going to add 6, and that should be equal to negative 22. And let's just check it. Negative 28 plus 6 would be negative 22. So that is equal to negative 22. So we're right. We know that our answers would have to be x is equal to negative 4 and y is equal to 3. Okay, let's have a look at our next question. A wordy context, maybe where you're buying so many of something and so many of something else and you're given the price and so on, and you've got to create your own simultaneous equations and solve them. So let's have a look at a typical question. So we've got 5 adult tickets and 3 child tickets cost £58, and 2 adult tickets and 8 child tickets cost £47. Find the cost of each type of ticket. So we've got our two equations. We've got 5 adult tickets. Well, let's let an adult ticket be x pounds, and let's let a child ticket be y pounds. So let's make our equations. We've got 5x plus 3y is equal to £58, so equals to 58. And then we've got 2x plus 8y, and that's equal to £47. So we've got our two equations. Now what we want to do is either get the same numbers in front of our x's and y's, or the same but one being positive and one being negative, because if they're both the same, we can take them away from each other, or if they're both the same but one's positive and one's negative, we can add the two equations to get 0. We could cancel out our x's or we can cancel out our y's. Just for fun, I'm going to cancel out our x's this time. So I'm going to actually cancel out our x's. So I'm going to multiply our top equation, this equation 1, by 2 to get 10x. I'm going to multiply the second equation, equation 2, by 5 to get 10x as well. And then what I'm going to do is take the two equations away from each other. So let's do 2 times equation 1. And when we do 2 times equation 1, we get, well, multiplying these all by 2 would get 10x plus multiplying 3y by 2 would be 6y, equals, and multiplying 58 by 2 would be 116. And then multiplying equation 2 by 5, because we want to get 10x, so 5 times equation 2 would be, multiplying these all by 5, would give us 5 times 2x is 10x, 5 times 8y, well, that's going to be 40y, and then multiplying 47 by 5 would be 235. Now we want to cancel out our 10x's, so if we've got 10x and 10x, we want to take them away to get 0. Now because we're taking away, rather than 6y take away 40y, I'm actually going to write this top equation just beneath the other one again. So let's scroll down and let's write 10x plus 6y equals 116. And let's write sub, because we're going to subtract them from each other. So 10x take away 10x is 0. 40y take away 6y, well that's 34y. And then we've got 235 take away 116, and when we do that we get an answer of £119 or 119. So we now know that 34y equals 119. We can divide both sides by 34 to get y equals, and 119 divided by 34 is equal to 3.5 or £3.50. So we now know what y is, and that's the cost of a child ticket, which is 3.5 or £3.50. Let's find the cost of an adult ticket. So let's sub y equals 3.5, and we can choose either equation 1 or equation 2. I'm going to choose equation 2, so into 2. And when we substitute 3.5 in for the value of y into equation 2, we've got 2x plus, and then we've got 8 times 3.5, that's equal to 28, and that's equal to 47. So we've got 2x plus 28 is equal to 47, so let's take away 28 from both sides, so that gives us 2x equals, and 47 take away 28 was equal to 19, and then if we divide that by 2 we get x equals, and dividing 19 by 2 is 9.5. So as the question says, find the cost of each type of ticket. So we've got an adult ticket, which is x, and that's going to be equal to 9.5 or £9.50, so let's write it as a price, £9.50, and a child ticket, which was equal to y, is equal to £3.50, and that's it. Okay, let's have a look at our next topic, and our next topic is solving simultaneous equations by using graphical approaches. In other words, drawing the graphs and finding out where the graphs meet and using that to find the answer to simultaneous equations. So here we've got a pair of simultaneous equations, so that's two equations at the same time. We've got y equals 3 minus x and y equals 2x minus 3. So to solve this, what we're going to do is we're going to draw suitable lines. In other words, we're going to draw the graph for y equals 3 minus x, and we're going to draw the graph for y equals 2x minus 3, and where those two straight lines meet will be our answer. So let's first of all draw the graph for y equals 3 minus x. So to draw this graph, I'm going to draw an xy table. So it's x and y. And what I'm going to do is I'm going to choose some values for x, so 0, 1, 2, 3, and I'm going to work out the values for y. So y equals 3 take away x. So if I take away x from 3, I can find the value for y. So if x is equal to 0, well, 3 take away 0 is 3, so that means that y is 3. 3 minus x, well, if x is 1, it would be 3 minus 1, that's 2. If x is equal to 2, well, 3 minus 2 is 1, so that would be 1. And if x was equal to 3, I'd have 3 minus 3, which is 0. So the points in this graph will be 0, 3, so 0, 3. There'll be 1, 2, so 1 across 2 up. There'll be 2, 1, so 2 across 1 up. And there'll be 3 zeros, so 3 across and 0 up, like so. And if I get my ruler and pencil, I can draw a nice straight line through those points, and it would look something like this. And that's it. That's the graph for y equals 3 minus x. Now, in a typical question, I'd imagine what they would do is draw one of these two lines for you, and you just have to draw the other one and then find out where they meet. Okay, let's have a look at our next one. So our next graph is y equals 2x minus 3. So we'll do an xy table, x and y, and we'll choose some points. And again, I just tend to use 0, 1, 2, 3. And I choose a few of them, or in this case I choose 4 of them, just so whenever I plot them I can see that all 4 of them are in a nice straight line. If they're not in a straight line, then I know I've done something wrong. So what I'm going to do is to find y, we do 2 times x and we take away 3. So we're going to times all these numbers by 2 and then take away 3. So let's start off with 0. 2 times 0 is 0. Take away 3 would be minus 3. Then we've got 1. Well, 2 times 1 is 2. Take away 3 would be minus 1. Now we've got 2. 2 times 2 is 4. Take away 3 is 1. And finally we've got 3. 2 times 3 is 6. Take away 3 is 3. So we've got our coordinates 0, 3, 1 minus 1, 2, 1, and 3, 3. So let's plot them. 0 minus 3, 1 minus 1, 2, 1, and 3, 3. and get our ruler and pencil. We'll draw a nice straight line through those points. And as you can see here, the two straight lines meet at the point 2, 1. This is the point of intersection here, 2, 1, there. So that means they meet at the point 2, 1. Now when we're solving simultaneous equations, what we're trying to do is find the value for x and we're trying to find the value for y. So if we look at this point 2, 1, we're going 2 across. That means the x value is 2 because the coordinate's 2, 1. The first number is the answer for x and the second number is the answer for y. So x is equal to 2 and y is equal to 1. And let's just check that. 2 across 1 up, the x value is 2 and the y value is 1. And that's it. Okay, let's have a look at our next topic. So our next topic is solving nonlinear simultaneous equations. And that's video 298 in Corbettmaths. We may have to solve simultaneous equations such as this, where here we've got a nonlinear, this is a quadratic. Now we may be asked to solve simultaneous equations and find the values for x and y, or we may be asked to find where a quadratic or a circle meets or intersects a straight line. And so let's solve these simultaneous equations. So here we're quite lucky. We've got y equals x squared plus x minus 14, and we've also got y equals x minus 5. Now if we've got two simultaneous equations where it's y equals and y equals, we can put them equal to each other. The reason is we know y is equal to this, and we also know that y is equal to this. So that means that we could write x squared plus x minus 14 equals x minus 5. So if they're both in the form y equals and y equals, you can just put them equal to each other like this, and then you can solve that and find their points of intersection or solve the simultaneous equations. So let's solve this. So whenever we're solving a quadratic, we want everything brought over to one side and 0 on the other side. So let's bring everything to the left hand side here. So we've got x squared plus x minus 14 equals x minus 5. So let's get rid of this x. So let's take away x from both sides of this equation. So that will leave us with x squared. X take away x is 0, so we've got then minus 14. And on the right hand side we had x minus 5. We've taken away the x, so we're just going to be left with minus 5. Next, well, we want this quadratic to equal 0, so let's add 5 to both sides of this equation. So let's add 5 and add 5. And that will give us x squared. And then we've got minus 14 plus 5. Well, minus 14 plus 5 is going to be minus 9. And that's equal to, well, minus 5 plus 5 is 0. So we've got x squared minus 9 equals 0. Now, whenever you solve an equation like this, you could have something like this, something which is x squared minus 9. So that's going to be difference between two squareds. Or you may have a quadratic that you may need to factorize, or sometimes you might even need to use the quadratic formula. And a hint in the question there would be to find your answer to 1 or 2 decimal places. But in this case, here we've got difference between two squareds. We've got x squared and minus 9. So let's put bracket, 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 and then equal 0. We'll put x at the front of both brackets. And the square root of 9 is 3. So let's put 3 in both brackets, one with a plus sign and one with a minus sign. And then solving this, well, we want to make each bracket 0. So in this bracket, it'll be x equals negative 3 or x equals 3. So they would be our two solutions for x. But remember, we need to find our solutions for y as well for simultaneous equations. So let's substitute these back into one of our equations. And I do think this equation is much easier to substitute into, the second one. So let's sub into y equals x minus 5. So let's start off with x equals negative 3. So let's write an x equals negative 3. We would have y equals, and instead of x, we're going to have minus 3 minus 5. And minus 3 minus 5 would be minus 8. So y would equal minus 8. So that's one pair of solutions. X can be equal to negative 3 and y would be equal to negative 8. Or let's sub in x equals 3. And that would give us, we would have y equals, and then we've got x minus 5. So that's going to be 3 minus 5. And 3 minus 5 is equal to negative 2, so y would be equal to negative 2. So that's another pair of solutions. And that's it, so we've found our pair of solutions. So we've got that x equals negative 3 and y equals negative 8, or x equals 3 and y equals negative 2. And that's it, so our solutions are simultaneous equations. If you're asking this question to find where the quadratic y equals x squared plus x minus 14 and the straight line y equals x minus 5 intersect, then those would be our coordinates. We would have the coordinate negative 3, negative 8, and 3, negative 2. But this question was just a simultaneous equations question, so we've got our pairs of solutions. We've got x equals negative 3 and y equals negative 8, or x equals 3 and y equals negative 2. Okay, let's have a look at our next topic. So the next topic we're going to look at is the equation of a circle. That's video 12. And here we've got the Corbettmaths revision card, and the equation of a circle at GCSE level is x squared plus y squared equals r squared, where the centre of the circle is always the origin at GCSE level. That's the point 0, 0. So the circle will always have a centre of 0, 0. And the radius of the circle is r. So this r is equal to the radius. So if you have a look at this circle, the centre of the circle is the origin. So that means it'll be in the form x squared plus y squared, its equation. tangent, and it will be equal to, well, its radius is equal to 4, so 4 squared is 16, so the equation of this circle would be x squared plus y squared equals 16. And if we were to look at the revision card, that's what this says. It says it's got a centre of 0, 0, and since 4 squared is equal to 16, the radius is 4. So that's it. So that's the equation of a circle. This is the Corbettmaths revision card. If you are interested in those, then the link below, and they're really, really useful, and this is one of the revision cards. Okay, let's have a look at our next topic. It's the equation of a tangent to a circle. And that's video 372 in Corbettmaths. So here we've got a circle, and there's a tangent to that circle, and there's a tangent at the point 26. And the question says, the diagram shows the circle x squared plus y squared equals 40. So it's a circle with a centre of the origin, and it's equal to 40. Let's just check. 2 squared is 4, 6 squared is 36, 4 plus 36 is 40. Yep, that's a point on the circle. And we're trying to find the equation of the tangent at that point 26. So we've got the point 26, and this is a tangent, and we're going to find the equation of that tangent. So let's find the equation of that tangent. So first of all, we know it's a straight line. So we know the tangent will be in the form y equals mx plus c. So we need to find m, the gradient of this tangent, and we also need to find c, where this tangent will meet the y-axis, so this point here. And if we know the gradient of this line, and if we know where the line crosses the y-axis, we will be able to find its equation. So first of all, let's find the gradient of this tangent. Now here we've got the radius of the circle. So this is the radius of the circle. Now thinking back to our circle theorems, a radius and a tangent always meet at 90 degrees, so that is a right angle. And because that's a right angle, that means that the tangent and the radius are perpendicular to each other. So that means if we know the gradient of the radius, we can then find the negative reciprocal, and that will be the gradient of the tangent. So let's first of all find the gradient of the radius. So here we've got a radius, and it's going, let's change colour of pen to blue so it just stands out a bit more. So here we've got the point 0, 0, and here we've got the point 26. So let's find the gradient of this radius here. So it's rise over run, so let's turn it into a right angle triangle. So we've got rise over run, and it's run, well, we're going from 0 across to 2, so it's run as 2. And it's rise, well, we're going from 0 up to 6, so it's rise as 6. So that means the gradient of this radius will be m equals rise, which is 6, divided by run, which is 2, which would be equal to 3. So the gradient of this radius is equal to 3. Now the tangent is perpendicular to it. That means that its gradient is the negative reciprocal. So that means that our gradient of our tangent will be the negative reciprocal of 3. So that means it would be, well, the reciprocal of 3 is a third, and the negative reciprocal will be minus a third. So that means that for our tangent, it will be y equals negative a third x plus c. And if we can now just find its y-intercept, this point c, where it crosses the y-axis, we can then find out its equation. All we need to know is one point that that line passes through, and then we can find this plus c. Well, that's great, because we know that it passes through the point 26. So we know a point on the line, so if we substitute in our values for x and y, so x equals 2 and y equals 6, if we substitute those into our equation, y equals minus a third x plus c, we can then find our plus c. So let's substitute those in. So y is equal to 6, so we're going to get 6 equals, then we've got negative a third x, well x is 2, so that means negative a third times 2, and then we've got our plus c. Now, negative a third times 2, well, a third times 2 is 2 thirds. Negative a third times 2 would be negative 2 thirds. So we've got 6 equals negative 2 thirds plus c. Now, we want to get c on its own, so we don't want this negative 2 thirds here. So let's add 2 thirds to both sides. So 6 add 2 thirds would be 6 and 2 thirds. And then on the right hand side, we added 2 thirds to get rid of the 2 thirds, and then we'll just be left with c. So that's it, we've got our y-intercept. This point here is 6 2/3, or 6.66666 reoccurring. So that's it, so we have found our y-intercept, and we know the gradient of the tangent is equal to negative a third. So that means that the equation of this tangent will be y equals negative a third x plus 6 2/3. Alternatively, this could be written as a top-heavy fraction. We could have written y equals negative a third x plus, and 6 times 3 is equal to 18, plus 2 is 20 over 3, and either of these would be acceptable. So this is the equation of the tangent. The equation of tangent, I really like this topic because you put several topics together. We use the equation of a circle, we can work out the gradients of lines, we consider the circle theorem, so the radius and the tangent meet at 90 degrees, we look at the gradient of perpendicular lines being the negative reciprocal and things like that, and you just put them all together, and it's just it's a great topic. Okay, let's have a look at our next topic. So our next topic is rates of change, and that's video 390A in Corbettmaths. So here we've got a question that says, below is the depth of water in a container over 6 seconds. So at 0 seconds, the depth is just over 12 centimeters. At 1 second, it looks like it's about 12 centimeters. At 2 seconds, it's just above 11 centimeters, and so on. And actually at 6 seconds, it's actually empty. It's the depth of the water at 6 seconds is 0. And the question says, estimate the rate of change of the depth of the water at 2.5 seconds. So we've got the point at 2.5 seconds. So this is the depth of the water at 2.5 seconds, which looks like it's about 11 centimeters. And we've been asked to find the rate of change of the depth of water at that time. So the gradient of this graph at that particular time will be its rate of change. But obviously this is a curve, so we can't just do rise over run because obviously it's curving. So what we're going to do is we're going to draw a tangent at that particular point. So let's draw a tangent. So we've just drawn the tangent to the curve at 2.5 seconds. And if I find the gradient of that tangent, that's going to be the same as the gradient of the curve at that particular time. So that would tell us the rate of change of the depth of water at 2.5 seconds. So let's find the gradient of this tangent. So let's find two suitable points on that tangent to find the gradient. So let's start up with this point here. So we've got 0. And then if we look at where it meets the y-axis, it meets the y-axis at 1 square down. Altogether, there's 1, 2, 3, 4, 5 little boxes that make up 2. 2 divided by 5 is 0.4. So this is going to be 0.4 below 14, so that will be 13.6. So that's one particular point on the tangent. So let's go for another point on the tangent. I'm going to go for this one here, which is at 4 seconds. At 4 seconds, the tangent passes through the first square below 10, so that's going to be 9.6. So we've got two suitable points, 2 points that are on the tangent. So remember the gradient is equal to, gradient m is equal to rise over run. So let's look at our points. Let's look at, first of all, the run. Well, we're going from this point across, all the way across to 4 seconds. So the run would be 4 seconds. We're going 4 across. And in terms of the rise, well, we're going down here. The graph's actually going downwards. So it's going to have a negative rise because it's going downwards. And it's going down from 13.6 to 9.6. So it's going down by 4. So that means our rise is negative 4 because it's going down by 4. So the gradient is equal to the rise, well, that's negative 4, divided by the run, which is 4. And negative 4 divided by 4 would be minus 1. So that means that the gradient of this tangent is negative 1. That means the gradient of the curve at that particular moment is negative 1 also. And the question wants us to find the rate of change of the depth of water. So it's going to be negative 1 centimeters per second. So the rate of change of the depth of water at 2.5 seconds is negative 1 centimeters per second. So in other words, the container is decreasing by height at 1 centimeter every second at that particular moment. Okay, so we've looked at the instantaneous rate of change. So that's finding the rate of change at a particular moment or a particular time. Now what we're going to do is we're going to find the average rate of change. So if we look at this question, we've got below the depth of water in a container over 6 seconds. So as you can see, the depth of water is decreasing over 6 seconds. And we've been asked to estimate the average rate of change of the depth of water between 1 second and 6 seconds. So first of all, let's have a look at 1 second and 6 seconds. So if you have a look at 1 second, you can see at 1 second, the depth of water is 12 centimeters. So the depth of water is 12 centimeters. That's the point 1, 12. And then if we have a look at 6 seconds, at 6 seconds, the container is now empty. So that's going to be 6, 0. And we've been asked to find the average rate of change. So what we're going to do is we're going to join those points up. We're going to join up the 1, 12 and the 6, 0. So we're just going to join those up. And to find the average rate of change, what we're going to do is we're going to find the gradient of this chord that joins up those 2 points. And that will tell us the average rate of change. So whenever we're finding an instantaneous rate of change, we draw a tangent and we find the gradient of that tangent. To find the average rate of change, we join up the points that were asked in the question to find the average rate of change between. And then what we do is we find the gradient of that chord. So we need to find the gradient of this chord, and that will tell us the average rate of change. So let's do that. So we're going to do rise over run. So let's make our little right angle triangle. So we've got our right angle triangle here. So we've got our run. So run has gone from 1 second to 6 seconds. So run will be 5. And then our rise, well, we're going down, and we're going down from 12 down to 0. So our rise will be negative 12. So we've got our run, which is 5, and we've got our rise, which is negative 12. So to find the gradient, we're going to do m is equal to rise over run. So it's going to be negative 12 over 5. So we're going to do negative 12 divided by 5, which is negative 2.4. So the gradient of this chord is negative 2.4. Now let's make sure we put our units on, which would be centimeters per second. So the average rate of change of depth of water between 1 second and 6 seconds is negative 2.4 centimeters per second. So in other words, on average, every second, the depth of water is decreasing by 2.4 centimeters. And that's it. So this has been average rate of change. Okay, let's have a look at our next topic. So our next topic is the area under a graph, which is video 389 in Corbettmaths. So here we've got a speed time graph. We've got speed on the vertical axis starting at 0 meters per second and going up to 14 meters per second. And we've got time on the horizontal axis starting at 0 seconds and going across to 30 seconds. And this is the speed time graph for a bicycle, and it shows us how a bicycle travels for 30 seconds. So it starts at rest, It accelerates for the first 10 seconds up to a speed of 12 meters per second, and then for the next 20 seconds it travels at a constant speed of 12 meters per second. And we've been asked to find how far does the bicycle travel over the 30 seconds. Now if you find the area under a speed time graph, that tells you the distance travelled, because if you do speed times time you get the distance. So if we find the area under this graph, it will tell us how far the bicycle has travelled over the 30 seconds. Now if you have a look at this graph, I think there's two regions. We have first of all got this triangle on the left hand side, let's call that A, and then we've got this rectangle here on the right hand side, so from 10 seconds to 30 seconds, and let's call that B. So if we find the area of the triangle and the area of the rectangle and add them together, that will tell us the distance travelled. So let's find the area of A. So A is a triangle, and as you can see it's got a base of 10 and it's got a height of 12. So let's do half the base, so half of 10 times its height, which is 12, and a half of 10 is 5 times 12 is equal to 60, and our units will be meters because we're travelling meters per second. So that means that in section A, the bicycle, for the first 10 seconds, the bicycle has travelled 60 meters. Now the next 20 seconds is section B. So it's a rectangle, and to find the area of a rectangle we just do the length multiplied by the width for the length multiplied by the height. So the length of the rectangle, well, that's 20 times the height, which is 12. So we're going to do 20 times 12. And 20 times 12 is equal to 240 meters. So that means from 10 seconds to 30 seconds, that 20 seconds, the bicycle travels another 240 meters. So it travels 60 meters and then another 240 meters. So if we do 60 plus 240, that's equal to 300 meters. So that means that the bicycle has travelled 300 meters in total over the 30 seconds. And that's it. So if you find the area underneath a speed times graph, you find the distance travelled. Okay, this time we've been given a speed time graph for a bicycle. We'll have a look at the graph in a second. And we've been asked to find an estimate for the total distance travelled by the bicycle in the first 12 seconds. And we're to use 3 strips of equal width. So let's have a look at our speed time graph. So this is our speed time graph. You've got our speed in our vertical axis, and we've got our time in our horizontal axis. And we've been asked to find out an estimate for the distance travelled by the bicycle in the first 12 seconds. So what I'm going to do is I'm just going to put a dashed line here at 12 seconds, and we want to find the distance travelled over the first 12 seconds. Now, unlike our last question, which was a straight line, so that's quite nice to find the area underneath that, this is a curve. So it means that we can only find an estimate for the area underneath this curve. And we've been asked to use 3 strips of equal width. So as you can see, there's 12 seconds. If we divide that by 3, that's equal to 4. So we're going to use strips of 4 seconds. So we're going to look at this strip here. We're going to use this strip here, and we're going to use this strip here. So 1, 2, 3 strips. And let's label them A. So this is A. This strip, let's call that B, and let's call this strip C. And let's find the areas of A, B, and C. Now, because this is a curve, we're not going to be able to find the exact area of these strips at GCSE level. So what we're going to do is we're going to find the approximate area of A, the approximate area of B, and the approximate area of C. So what I'm going to do is I'm going to start off with the point 0, 0, and I'm going to join it up here to this point here, which is the point 4, 0.8. Then I'm going to join that point up to the next point here, which is the point 8.2. And then finally, I'm going to join the point 8.2 up with this point here, which is the point 12.4. And as you can see here, we have now got a triangle, a trapezium, and a trapezium. And if we find the area of the triangle, the trapezium, and the trapezium, and add them together, that will give us the approximate area underneath this curve. Now, it's not going to be the exact area. It's actually going to be slightly over, because actually, if you have a look at this trapezium, the line we've drawn is slightly above that curve, which is underneath it. So we're actually going to find an overestimate for the underneath this curve, but it's going to be close enough. Okay, so let's start off with A. So if we have a look at A is a triangle. It starts at the point 0, 0 and goes up to this point here. Actually, let's label the coordinates that we have joined up. The triangle, the area of the triangle is half the base times the height. The base is 4, so we're going to do half of 4 times the height. So the height is 0.8, so times by 0.8. That will give us our estimate for the area of A. So half of 4 is equal to 2, times by 0.8 is equal to 1.6. And our units will be meters. So that means that over the first 4 seconds, our estimate for the distance travelled by the bicycle is 1.6 meters. Now, if we have a look at B, B is a trapezium. We've got 2 parallel lines. We've got this parallel line and this parallel line. And then we've got the distance between them. Suppose the height of the trapezium if we turn our head sideways. So the area of a trapezium, let's write down B, is equal to half brackets A plus B times h, which is the distance between them. So that means if we know the lengths of the 2 parallel sides and the distance between them, we can find the area of this trapezium. So let's work that out. So the 2 parallel sides, well, this length will be 0.8 because it's 0.8 high. This length will be 2, so it's going to be 8 plus 2, and then times by the distance between them, which would be the height of the trapezium if we turn our head sidewards, which is 4, so times by 4. So if we work out a half of 0.8 plus 2, and then times that by 4, that would tell us the area of that trapezium. And when we do that, we get that's equal to 5.6 meters. So that means that the bicycle travelled approximately 5.6 meters over the next 4 seconds. And then if we have a look at the next 4 seconds from 8 to 12, that's C. So if we work out the area for trapezium C, then that will tell us approximately how far the bicycle travelled in these 4 seconds. So again, it's a trapezium. We've got 2 parallel lines. We've got this parallel line with a length of 2. This parallel line with a length of 4, because the height of this is 2 and the height of this is 4. So it's got a length of 2, a length of 4. And the distance between them, the height of the trapezium, if we turn our head sidewards, is 4. So it means we're going to do a half of 2 plus 4, the two lengths to two parallel sides, here and here, and then times by the distance between them, which is 4. 2 plus 4 is equal to 6, and half that's equal to 3, times by 4 is equal to 12. So over the next 4 seconds, the bicycle travels approximately 12 meters. So we now know approximately how far the bicycles travelled over the first 4 seconds, the next 4 seconds, and the next 4 seconds. So if we add them together, that will tell us approximately how far the bicycles travelled in total over those 12 seconds. So if we do 1.6 plus 5.6 plus 12, that will give us our answer. And that's equal to 19.2 meters. And that's it. Okay, our next topic is functions. And functions is one of the few topics where the exam boards differ subtly from each other. Edexcel and AQA require you to know the function notation. That's what I'm going to go through in this video. OCR, however, don't require you to know the function notation. So whenever I do each section, I'll just say how OCR would expect you to approach those topics. Okay, so let's get started. Okay, let's have a look at our next topic. So our next topic is composite functions. That's video 370 in Corbettmaths. Now if we have a particular variable, let's call it x, and we apply a function to it, let's apply the function g, we would get g of x. And then if we apply another function, let's call that function f, we would get fg of x. Now rather than applying function g and then function f, particularly if you've got to do this lots of times, it can be useful to find what we call a composite function. And a composite function would mean that instead of applying function g and then function f, we can apply this composite function, this fg, and that'll bring us straight from x to our end result, our fg of x. Okay, so here we've got an example. We've got two functions. G of x is equal to x squared plus 5, and we've got f of x is equal to 2x plus 1. And we've been asked to find fg of x. In other words, there's going to be a variable x, the function g is going to be applied, and we'll get g of x, and then we're going to apply the function f to that. So let's see how we get this composite function. So if we start off with a variable x and we apply the function g to it, because g is the one closest to it, so we're going to apply g to it first of all, that would give us x squared plus 5. Then we're going to apply the function f. In other words, we're going to substitute this x squared plus 5 in for the x in our function of f of x, and then that would give us our composite function. So that means that our composite function fg of x would be equal to 2 bracket, and instead of x we're going to write x squared plus 5, so x squared plus 5. We're then going to close brackets and then write plus 1. Now we're going to expand and simplify this, so 2 times x squared would be 2x squared, and 2 times 5 is 10, so plus 10, and we've still got our plus 1. And then if we add the 10 and the 1 together, we get that's equal to 2x squared plus 11. So our composite function, fg of x, is equal to 2x squared plus 11. Okay, let's look at our next example. So our next example says find g f of x. In other words, we're going to apply the function f first of all, and then apply the function g. So if we apply the function f first of all, we get 2x plus 1. And then if we apply the function g, so let's substitute that in for the value for x in function g, and that will give us our g f of x, so g f of x. And that'll be equal to, now instead of x squared, we're going to write in brackets 2x plus 1, close bracket squared, then plus 5. And then if we expand and simplify this, we'll find g f of x. And let's see what we get. So I've written the bracket out twice because we're squaring it. We're going to multiply by itself. And when we expand these brackets, we get 4x squared plus 2x plus 2x plus 1. And we've still got our plus 5. And then simplifying our like terms, we get 4x squared plus 4x plus 6. So that means that g f of x is equal to 4x squared plus 4x plus 6. Now if you're asked to find something such as g f of 4, what you would then do is substitute the value for 4 into this, and you would do 4 times 4 squared plus 4 times 4 plus 6. Or if you're asked to find g f of minus 7, you would do 4 times minus 7 squared plus 4 times minus 7 plus 6, and so on. And that's it. If you're asked to find a composite function such as f of x, then what you would do is get f of x and substitute into f of x. So you'd write 2 bracket 2x plus 1, close brackets, plus 1, and so on. Now, if you're studying for OCR higher, if you're doing composite functions, you aren't expected to know that notation of fg of x and gf of x. What you'll often see in OCR higher is you may be given two function machines, function A and function B, and then you're asked to find a composite function, and what you'll do is you'll do one of the function machines, you get the result, you then put it into the other function machine, and that'll give you your composite function. Okay, let's have a look at our next topic. So our next topic is inverse functions, and that's video 369 in Corbettmaths. So sometimes you might be given a function such as f of x, and here we've got f of x is equal to 3x plus 2, and we need to find an inverse function. So in other words, if we know what the result is of f of x, how we would go back to find the value for x. And if I want to find an inverse function, what I do is I look at my function, my f of x equal to 3x plus 2, and I write, instead of f of x equals, I write y equals 3x plus 2. And as you can see here, y is a subject. And what I'm actually going to do is I'm going to make x a subject here. And once I make x a subject, that will tell me what my inverse function will be. So let's make x a subject here. So let's take away 2 from both sides, so minus 2 and minus 2. That will give me y minus 2 is equal to 3x. And then if I divide by 3 and divide by 3, so divide by 3 and divide by 3, I get y subtract 2 all over 3 is equal to x. So I've made x a subject. So this tells me my inverse function. So my inverse function of x, my f minus 1 of x, will be equal to, and instead of writing y minus 2 over 3, I'm going to write x minus 2 over 3. And that's it. Let's just have a look at the Corbettmaths revision card. Let's just make it a wee bit bigger. So we've got given f of x equal to 3x plus 2, find f minus 1 of x, the inverse function. So step 1, let y equals the function. Step 2, make x a subject. And step 3, write f minus 1 of x in terms of x. So replace the y with x, and that's it. Now, if you're studying for OCR higher, you aren't expected to know that function notation, that f minus 1 of x. So what you will often be given is a function machine, or a diagram that shows a function machine, and to find the inverse function, you'll work backwards to find that inverse function. And that's it. So that's inverse functions. Okay, let's have a look at our next topic. Okay, let's have a look at our next topic, and our next topic is quadratic graphs, and that's video 264 on Corbettmaths. So what we're going to do is we're going to draw this quadratic graph. And whenever we draw quadratic graphs, what you'll find is instead of being straight lines, they'll either be this U-shape or a parabola, like so, this U-shaped parabola, or they could be an N-shaped parabola, like so. And so whenever you draw a quadratic graph, it will either have this U-shape or this N-shape. And it depends on whether this x squared is positive or negative. So because this is a positive x squared, I can tell it's going to be a U-shape. If it was minus x squared, it would actually be an N-shape. Okay, so the question asks us to complete the table for y equals x squared plus x minus 4. So we've got this xy table, and we've got lots of points. The reason we've got lots of points is it's not a straight line anymore, it's a curve, so we're going to need more points so we can draw a nice curve through them. And we've got our x values of minus 2, minus 1, 0, 1, 2, and 3. And what we're going to do is we're going to work out our y values. And to find our y values, we're going to square x, add x, and take away 4. So let's start off with 3. So we're going to do 3 squared plus 3, and then take away 4. So 3 squared is 9, plus 3 is then going to be 12, take away 4 is 8. So that means that would be 8. And doing that for the rest of the points, we'll get... So we've now found our coordinates. Now what we're going to do is we're going to plot them. So we've now got our points, and as you can see, they make a curve. So what we're going to do is we're going to draw a nice curve through them. So we're going to do this on the computer, and it can actually be quite tricky on the computer, so please bear with me whenever I'm doing it. So it might not be absolutely fantastic, but I'll do the best I can. Hey, that's pretty good. So that's it. So we've drawn a quadratic graph, and we've drawn a nice curve for our points. And if you want more practice, video 264 in Corbettmaths will give you more practice on that. And remember, you've got that bumper pack of questions. So ultimate video practice question booklet. And if you go to that in the description below and click on it, there'll be questions there on the quadratic graphs, and it'll give you a chance to draw one yourself. Okay, so let's have a look at our next topic. So our next topic is solving quadratics graphically. So it could be something like this, where using your graph, estimate the values of x whenever y is equal to negative 3. So if we go back to our graph, we need to now draw the graph of y equals negative 3, because we're told to find the values of x whenever y is equal to negative 3. So if we draw that graph of y equals negative 3, that's going to be all the coordinates with a height of negative 3, such as 0, negative 3, 1, negative 3, 2, negative 3, 3, negative 3, and so on. The graph y equals negative 3 is a horizontal line that passes through negative 3 is on the y-axis. So y equals a number graph will be a horizontal line, and it'll be horizontal going through whatever the number is. So if it was y equals negative 3, it'll be a horizontal line going through negative 3 on the y-axis, because all the coordinates on that line have a height of negative 3. If it was y equals 8, it would be a horizontal line going through 8, and so on. Okay, but in our question, we were asked to find an estimate of the values of x whenever y is equal to -3. So if you have a look at our parabola and our straight line, our y equals -3, you can see they actually meet each other twice. They meet here and they meet here. And what we're actually going to do is we're going to go up to the x-axis, so just going up to here, there, and going up from this intersection point, the second intersection here, we're going to go up again to the x-axis there. And we're going to read off what those values would be, and they would be our two solutions. And it says estimate because, remember, we've drawn a curve and we've drawn it freehand, so it's not going to be perfect, this question. It's an estimate to our answers. So let's have a look and see what we've got. So let's start off with this one. We've got 0, we've got 1, and in the middle is 0.5. I think that's about 0.6. So I'm going to say x equals 0.6 would be one of our solutions. And this one over here, well, we've got 0, we've got -1, we've got -2. That's -1.5. I think that's about -1.6. So -1.6. So our two estimates would be x equals 0.6 or x equals -1.6. So there would be our two estimates. So x equals 0.6 or x equals -1.6. Just to also point out that the question could be written in a slightly different way. Rather than saying find estimates of the value of x whenever y is equal to -3, it could have had the equation of the graph that we drew in the first question, this x squared plus x minus 4. And it could have just written equals -3. And then what you do is you'd look at that value, you just draw the graph for y equals -3 like we did. So we just draw a horizontal line going through -3 and go up to the x-axis and find those values.
And another thing you could be asked whenever you're dealing with quadratic graphs is to find the roots of the quadratic. So here we've got a quadratic graph and it's y equals x squared minus x minus 2. And we've been asked to use this graph to find the roots of x squared minus x minus 2 equals 0. So when the quadratic equals 0. And that means where the quadratic has a height of 0. And that means where it crosses the x-axis. So if you have a look at where this quadratic crosses the x-axis, it crosses the x-axis at -1 and 2. So that means the roots of this equation will be x equals -1 or x equals 2, and that's it. So to find the roots of the quadratic, if you've been given the graph and then they've written the graph equals 0, just find where that graph crosses the x-axis. And another thing that they sometimes ask you is to write down the coordinates of the turning point, and that would be the coordinates of this point here. So you just write down the coordinates of that point, and that's it.
Okay, let's have a look at our next topic, and that's sketching quadratics. So if we had a quadratic such as y equals x squared minus 7x plus 10, it can be useful to be able to sketch this. And whenever you're sketching a quadratic, first of all, I would consider the shape of the quadratic, whether it is a U-shaped parabola or an N-shaped parabola. And what determines if it's a U-shaped parabola or an N-shaped parabola is this x squared term. If this x squared term is positive, so for instance x squared or 2x squared or so on, it'll be a U-shaped parabola. If it's negative, so if there's a minus x squared or minus 2x squared, it will be an N-shaped parabola. So that's very important whenever we're sketching a quadratic. And what's also important is where the quadratic meets the y-axis and if and where it meets the x-axis. So let's start off by looking at this quadratic, y equals x squared minus 7x plus 10. And let's first of all consider its shape. Well, it's going to be a U-shaped parabola because it's an x squared, it's positive x squared. Okay, next, let's find where the graph meets the y-axis, or sometimes it's called the y-intercept. So to find the y-intercept, or where the graph meets the y-axis, what we do is we consider where x equals 0, because we know that the y-axis is whenever x equals 0. So if we substitute in x equals 0 into our equation, we'll find this y-intercept quite easily. So let x equal 0, and if we do that, we get y equals 0 squared minus 7 times 0 plus 10. So we've got y equals 0 squared minus 7 times 0 plus 10. And when we work it out, we get y equals 0 squared is 0, 7 times 0 is 0, so 0 take away 0 is 0, plus 10 is 10. So whenever x equals 0, y equals 10. So that would be the coordinate 0, 10. So that means our quadratic y equals x squared minus 7x plus 10 will pass through the point 0, 10. So our point 0, 10 will be, well, going 0 across and 10 up will be here. So that's the point 0, 10. Okay, so we now know where our quadratic meets the y-axis. Let's see if we can find where it meets the x-axis. So to find where it meets the x-axis, well, we know all the points on the x-axis have a height of 0. So if they've got a height of 0, that means that y equals 0. So let's let y equal 0. And whenever we let y equal 0, that will give us 0 equals x squared minus 7x plus 10. So we've got a quadratic equation, and if we can solve this, we can find where it meets the x-axis. So let's try and solve this using factorization. So 0 equals, and bracket, 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 bracket. Let's put x in the front of both brackets. And then we're looking for two numbers that multiply together to give us 10 and add together to give us negative 7. Well, it's going to be negative 2 and negative 5, because negative 2 times negative 5 is 10. and negative 2 plus negative 5 would be negative 7. So let's find our solutions. Well, if we know the two things times together to give us 0, that means that either bracket would be 0. So that means that here, x would be equal to 2, because 2 take away 2 is 0. So that means one answer will be x equals 2, or, and then looking at the other bracket, that means that x could be equal to 5. So we've got our two solutions, 2 and 5. That means our quadratic will pass through the coordinates 2, 0, and 5, 0. And there will be our 2 points where the quadratic graph crosses the x-axis. So let's put those on our graph. And before we do that, I'm just going to actually move something. I'm actually going to move this to the other side. And I'm now going to put on where that meets the x-axis. 2, 0 and 5, 0. So that'll be 2, 0 roughly there and 5, 0 roughly there. And if we do a nice quadratic through that, a nice U-shaped parabola through those points, it would look something like this. And that's it. And let's label our coordinates 2, 0 and 5, 0. And that's it. So we've done a sketch of the quadratic y equals x squared minus 7x plus 10. And we've shown the shape of the quadratic, that's a U-shaped parabola. We've found out where it met the y-axis, so the y-intercept, which was 0, 10. And we found that this quadratic did meet the x-axis twice, and at the points 2, 0 and 5, 0. Sometimes whenever you solve the quadratic, you might find there's only one solution. And what that will mean is the quadratic touches the x-axis and goes back up. And sometimes whenever you try and solve the quadratic, you might find actually there's no solutions. And that will mean actually that the quadratic graph, the parabola, will be above the x-axis. Okay, let's have a look at our next topic. So our next topic is quadratic graphs, and we're going to be looking at videos 267 and 267D on Corbettmaths, and those videos focus on drawing quadratic graphs. So we're going to draw a quadratic graph here, this y equals x squared plus x minus 1 on this set of axes. And what we're going to do is we're going to write down the coordinates of where this quadratic meets a straight line graph. So first of all, let's draw this graph. So let's do an xy table, so x and y. And for the axes we've been given, we've got the x values of minus 2, minus 1, 0, 1, 2, and 3. So let's put those in the table, minus 2, minus 1, 0, 1, 2, and 3. So what we're going to do with all these numbers is we're going to square them, then we're going to add the number again, and then we're going to take away 1. So looking at 3, we're going to do 3 squared, which is 9. Then we're going to add 3, which is 12, take away 1, which is 11. 2 squared is 4, plus 2 is 6, take away 1 is 5. Whenever x is equal to 1, 1 squared is 1, plus 1 is 2, take away 1 is 1. 0, 0 squared is 0, plus 0 is 0, take away 1 is minus 1. Next, negative 1, well, negative 1 squared is 1, plus minus 1, well, 1 plus minus 1 is 0, take away 1 is negative 1. And actually, without actually working this one out, I can see we're going to have a value of 1 in here, because with this quadratic, we know it's going to be symmetrical, and because we've got a height of negative 1 and negative 1, the next two will be symmetrical, so if this one's 1, this one should be 1, and negative 3 will be 5, and so on. But let's just check it. Negative 2 squared is 4, plus negative 2 is 2, take away 1 is 1. And that's it. Now let's plot our points. And now we've plotted our points, we're going to do a nice parabola through them. And please bear with me, whenever I do this on the computer, it's quite tricky to actually do it nice and accurately. Okay, so that's our parabola. It's the best I could do on the computer. And we've been asked to write down the coordinates of where this quadratic, this y equals x squared plus x minus 1, intersects with this straight line graph, y equals 3x plus 2. Now I could do an xy table for this, so I could do x, y, 0, 1, 2, 3, and multiply the numbers by 3 and add 2. I'm actually going to draw this graph using a slightly different technique. I know it meets the y-axis, it's got a y-intercept of 2, so I'm going to start at 2. And then I'm going to consider its gradient, which is 3. So I'm going to go 1 unit across. So 1 unit across, and I'm going to go up 3. So that'll be 5. I'm going to go another unit across and go up 3. That'll be 8. And again, because the gradient's 3, I'm going to go another unit across. So go moving from 2 to 3 and go up 3. So that'll bring me to 11 and so on. So I've got these 4 points. I'm going to get my ruler and pencil, draw a nice straight line through them. And that's it. So we've drawn the graph y equals 3x plus 2, and we've got our quadratic, and we've been asked to write down the coordinates of where they intersect or where they meet. So if we have a look, we can see they meet twice. They meet here at the coordinate negative 1, negative 1, so negative 1, negative 1. And they also meet again up here at 3, 11. And that's it. So they are the coordinates of the 2 points of where they meet. Okay, let's have a look at our next topic. So our next topic is finding graphical solutions to quadratics, and that's video 267D. And these are slightly more complex than the ones we looked at previously. So here we've got the graph of y equals x squared plus 2x minus 3. And it says, by drawing an appropriate straight line, use your graph to find estimates to the solutions of x squared plus 2x minus 3 equals x plus 2. Now, whenever we looked at simultaneous equations earlier, like this one here, where we've got y equals and y equals, I mentioned that whenever you solve this, whenever you solved it, it would give you the coordinates of where they intersect each other. So if you had y equals something and y equals something, if you then solve those simultaneous equations, you find out where they intersect each other. So if we go back to our graph, as you may notice here, we've got our quadratic, our x squared plus 2x minus 3 on this left-hand side of the equation. And on the right-hand side of the equation, we've got x plus 2. So if we want to solve this equation, what we can do is we can draw the graph of y equals x plus 2 on this grid. And then if we find where they intersect each other, we can then go to the x-axis and find those values of x. And they'll be estimates because we're using the graph for it. So let's draw the graph y equals x plus 2. So we're going to use an xy table, and let's choose some values for x, so -1, 0, 1, and 2. And to find our y values, we're going to add 2. So -1 add 2 is 1, 0 add 2 is 2, 1 add 2 is 3, 2 add 2 is 4, and so on. So let's plot these coordinates. Now let's get a ruler and pencil and draw a line through those, a nice straight line through those points. And we've just drawn that straight line of y equals x plus 2. And if you notice here, we've got y equals x squared plus 2x minus 3, that left-hand side of the equation. And the right-hand side of the equation, we've got that x plus 2, that y equals. So we've got our y equals x plus 2 and our y equals x squared plus 2x minus 3. And we've drawn them on the graph, and we can see they intersect each other twice. So let's find where they intersect. So if we go down to our x-axis, so we've gone down to our x-axis. So between 1 and 2, we've got 10 little squares, and that's the 8th one. So it's going to be 1.8. And then if we look at the other one, they intersect here. So we go up to the x-axis. That'll be here, which is at -2, -2.5. That'll be -2.8. So our approximations, our solutions will be x equals -2.8 or x equals 1.8. And there are our estimates to our solutions. And that's it. So whenever you've got the quadratic equals something else, if you just draw that something else, as long as the quadratic you're given in the question, drawn on the grid, is the same as the one in the equation, if you just draw that other line and find where they meet each other and then go to the x-axis, you'll then find your approximations. Okay, let's have a look at a more complex one now. So we've got the graph y equals x squared minus x minus 2. So drawn for us is y equals x squared minus x minus 2. And the question says, by drawing an appropriate straight line, use your graph to find estimates to the solution of x squared minus 2x minus 1 equals 0. But what we're trying to solve doesn't actually have x squared minus x minus 2. It's actually slightly different. It's got x squared minus 2x minus 1 equals 0. But it does equal 0. If we were trying to find where a straight line intersects a quadratic, we would normally put them equal to each other. But you notice that this equals 0, so that means that whatever the linear was, we've taken it away from both sides to then leave us with x squared minus 2x minus 1 equals 0. So if we take what we've been given, this y equals x squared minus x minus 2, and we write down what we've been given, with the 0 at the front, so 0 equals x squared minus 2x minus 1. If we take these away from each other, that will tell us the straight line graph we should draw. So let's take those away from each other and see what we get. So y take away 0 is y. So x squared minus x squared, they would cancel out. Then we've got minus x subtract minus 2x. Well, minus x minus minus 2x will mean minus x plus 2x, and minus x plus 2x would just be x. And then we've got minus 2 minus minus 1. So whenever we do minus 2 minus minus 1, we're going to add 1 on. So minus 2 add 1 would be minus 1. So that tells us we should draw the graph of y equals x minus 1. And we can check this. If we took the quadratic in the question, this x squared minus x minus 2, and we put it equal to x minus 1, and then if we take that away from both sides to make it equal to 0, hopefully we'll be left with this. So if we take away x from both sides, we'd have x squared minus 2x, because if you take away x from both sides, that would be minus x, take away another x, would be minus 2x. And if we added 1 to both sides as well, we'd have minus 2 plus 1, which would be minus 1 equals 0. And as you can see here, then that gives us that quadratic we're trying to solve in the question. So that's it. So if you're given a quadratic graph, y equals something, and you then ask to solve something which is slightly different and it equals 0, if you're at the 0 at the front and then take it away from the y equals, it will tell you what straight line to draw. So if we draw the line of y equals x minus 1, and we find where that straight line intersects y equals x squared minus x minus 2, it will give us our solutions for the quadratic we're given. So let's do that. So let's do our xy table, x and y. And we'll go for 0, 1, and 2. And to find our y values, we're going to do x minus 1. So we're going to take 1 away from each of these. That'll be minus 1, 0, and 1. And let's plot those points. And that's it. So we've drawn the graph y equals x minus 1. And we want to find where that graph intersects the quadratic. So let's find the points of intersections. That's here. And it's also here. So if we're looking at this point, we've got, well, between 2 and 3, so this 1, 2, 3, 4, 5 squares. That means we're going up in 0.2s. So it's 2.2, 2.4, so this would be 2.4. And this point here would be, well, let's go down in 0.2, so minus 0.2, minus 0.4. So our two solutions would be x equals minus 0.4 or x equals 2.4. And that's it. If you do want to watch another video on that topic, video 267D on Corbettmaths, we'll go through this in a bit more detail. Okay, let's have a look at our next topic. So our next topic is reciprocal graphs, and this video 346 on Corbettmaths. So a reciprocal graph is something in the form of y equals a number and then over x. So something like y equals 2 over x. And you will have heard of the term reciprocal before whenever you're dividing by fractions, because whenever you're dividing by fractions, instead of dividing by a fraction, you multiply by the reciprocal. That's what you get when you flip it over. And that's what we mean whenever we've got a graph in this format, y equals 2 over x. So we're going to draw a graph, and we've got an xy table, and we've got quite a lot of points because there's curves involved. It's not nice straight lines. So we're going to substitute in these values of x into our equation to get our values for y. So let's start off with the positive values. So let's use x equals 5. So 2 divided by 5 is 0.4. Then we've got 2. Well, 2 divided by 2 is 1. Then we've got 1. 2 divided by 1 is 2. Then we've got 0.5. So we've got 2 divided by 0.5. Well, there's 4 halves in 2, so the answer would be 4. Now let's move on to our negative numbers. So we've got 2 divided by negative 5. Well, a positive divided by a negative is a negative, so it's going to be a negative answer. And 2 divided by 5 is 0.4, so it's going to be negative 0.4. We've then got 2 divided by negative 2. Well, that's going to be, well, positive divided by a negative would be a negative, so negative 1. Now we've got 2 divided by negative 1, that would be negative 2. And finally, 2 divided by negative 0.5 would be negative 4. Okay, so we've now got our points. Now let's plot them. So we've got 5 across and 0.4 up. So 5 across would be here. 0.4 up, well, we've got 10 little squares for 2. 2 divided by 10 is 0.2. So it'll be 2 of them upwards, or 2 of them up. So it'll be like that, somewhere like that. Then we've got 2, 1. So 2 across, 1 up would be there. Then we've got 1 across, 2 up. So 1 across, 2 up. And then we've got 0.5 across, 4 up. So 0.5 across would be halfway in between, and 4 up would be there. So we've now got our points. Now what we're going to do is draw a nice curve through them. Now this is quite tricky on the computer, so just bear with me. Okay, this won't be perfect, but it's just going to be a nice curve that looks something like so. That's not too bad. And as you can see, the curve, it never actually reaches the y-axis, because if you done 2 divided by 0, well, that's undefined. You can't divide 2 by 0. So this curve will never actually reach the y-axis. And as you divide by smaller and smaller and smaller decimals, so 2 divided by 0.1 would actually be 20. So that's really hard. 2 divided by 0.01 would be equal to 200. So what happens is the graph would just shoot off to infinity, and it would never actually reach the y-axis. And similarly, whenever we're going across horizontally to the right here, because we're doing 2 divided by something, even if we divide it by a million, there'll still be a tiny number there. It'll be 0.0000 and so on. So the graph will approach the x-axis but never actually reach it. They're what we call asymptotes. It's quite a fancy word, but that's just what they're called. Okay, and these points on our left-hand side of the table, we've got negative 0.5 and negative 4, so that would be there. Then we've got negative 1, negative 2, so negative 1, negative 2 would be there. Negative 2, negative 1 would be there. Negative 5, negative 0.4 would be there. So we've got our points, and we're going to draw a nice curve through them. So that would be the graph of y equals 2 over x. If you had something like y equals 4 over x, it would have the same shape, but it would just be slightly further out. So it'd be slightly higher up and slightly further down, and so on. Okay, let's have a look at our next topic. So the next topic is cubic graphs. So here we've got the graph y equals x cubed. So cubic is whenever we've got this cubed. And here we've got y equals x cubed. So here we've got our xy table. So let's cube all these values to get our y values. 2 times 2 times 2 is 8. 1 times 1 times 1 is 1. 0 times 0 times 0 is 0. Negative 1 times negative 1 times negative 1. Well, negative 1 times negative 1 is 1. And times that by negative 1 is negative 1. Because a negative times a negative times a negative is a negative. Then we've got negative 2. So negative 2 times negative 2 is 4. Times negative 2 is negative 8. And finally, negative 3 times negative 3 times negative 3 would be negative 27. And now let's put these points on our grid. Let's draw our curve. So it'll come upwards. So go through the points. And then what will happen is it'll flatten out and come through 0, and then curve back upwards and look something like that. And excuse my sketch, it is freehand on the computer, it's quite tricky. And now let's have a look at our y equals negative x cubed. So what this means is we're going to cube our value of x, and then we're going to make it negative. So we're going to do 2 cubed. So 2 times 2 times 2 is 8, but we're going to make it negative, so it's going to be negative 8. Then we've got 1 times 1 times 1, which is 1, but we're going to make it negative, so negative 1. Then we've got 0 times 0 times 0, 0. Well, that's just 0. Then we've got negative 1 times negative 1 times negative 1. That's negative 1. but we're going to make it negative. What that means then, because it's already negative, means we're going to make it positive, so it's going to be 1. And then we've got negative 2, so negative 2 times negative 2 times negative 2 is negative 8. But then we're going to make it negative, but it's negative already, so it means make it positive. We're going to change the sign, so that's 8. And then finally, we've got negative 3 times negative 3 times negative 3, which is negative 27. We're going to make it negative. It's already negative, so it's going to be 27. And another way to consider this negative sign, do you remember if you have got something like x cubed, that means 1x cubed, or 1 lot of x cubed. If you've got negative x cubed, that's the same as negative 1x cubed. So really what we're doing is we're finding our value for x cubed, and then we're multiplying it by negative 1. So here we had 2 cubed, which is 8, multiplied by negative 1 is negative 8. Whenever we had our negative 1 cubed, that's equal to negative 1. When we times it by negative 1, that's 1, and so on. And what it does is it just changes the signs whenever there's a negative sign in front of it. Now let's pull out our points. Okay, we're now plotted out our points. Now let's try and draw a curve, and that's meant to be a curve. And what you'll find is it's the same as the x cubed graph, but it's just flipped around the other way. Okay, let's have a look at a more complex cubic. And here's an example of the Corbettmaths revision card where there's y equals x cubed minus 3x minus 1. And what we've got is we've got the table of values. So we've got our x coordinates are 3, 2, 1, 0, minus 1, minus 2, minus 3, and so on. And we've worked out that number cubed minus 3 times that number, take away 1, and we've got our values for y. And whenever you plot them, it has this shape. So there's the simple cubic graphs, which will look something like this, where it's quite steep, flatten out, pass through the origin, and then curve upwards. And that's typically whenever you get something such as y equals x cubed or y equals x cubed plus 1 or something like that. But if you do have a more complex cubic where you've got x terms or x squareds and so on, it could look like this, where it actually comes up, reaches this point, this maximum, comes down again, reaches a minimum, and comes up again, and so on. Okay, let's have a look at our next topic. So our next topic is exponential graphs. That's video 345 in Corbettmaths. So here's an example of an exponential graph where we've got y equals 2 to the power of x. And you may notice that the x is in the power. So that's why it's exponential. You've got a number, positive number, and you've got an x as the power. So let's have a look at our table of values. So if we had an xy table where we've got the values of negative 2, negative 1, 0, 1, 2, 3, let's substitute those values of x in and find out what we would get. So if we had a power of 3, we would have 2 cubed, and 2 cubed is 8. So that means that y would be equal to 8. If we had a power of 2, we would have 2 squared, and 2 squared is 4. If we had a power of 1, we'd have 2 to the power of 1, and that's equal to 2. Okay, our next one, whenever x is equal to 0, well, that's an important point because that's going to be the y-intercept. It's going to be where it crosses the y-axis. And 2 to the power of 0 is equal to 1. That's quite important because if it was y equals 5 to the power of x, it'd be 5 to the power of 0, which would be 1. If it was y is equal to 10 to the power of x, that would also cross at 1. Even if it was y is equal to 0.5 to the power of x, 0.5 to the power of 0 is also equal to 1. So that's a very important point. It'll cross the y-axis at 0, 1. Okay, next, whenever x is equal to negative 1, well, it's going to be 2 to the power of negative 1. That means we would have 1 over 2 to the power of 1. And 2 to the power of 1 is just 2, so the answer would be a half. So our next point would be negative 1, a half. And finally, if we had the value for x negative 2, we would have 2 to the power of negative 2. And that would be 1 over 2 squared. And 2 squared is 4, so that would be a quarter. That's it. Now, what's important to notice is if we had another point, if we had x equal to 4, well, that'll be 2 to the power of 4, which is 16. If we had 5, that'll be 2 to the power of 5, which is 32. And you may notice these values getting very big very quickly. And that's why you might have heard of the term exponential growth, because as the values for x just increase by 1 each time, you're going to get very large values, where it crosses through the points 0, 1, the y-intercept. It goes through the points 1, 2, 2, 4, 3, 6, 4, 16, 5, 32, and so on. So the right-hand side of this graph gets very steep very quickly. And on the left-hand side, well, we're going to have minus 1, a half, minus 2, a quarter. And what happens is this graph approaches the x-axis but never reaches it. So it goes down like so. Okay, so this is the graph of y equals 2 to the power of x. If you had a graph y equals 10 to the power of x, it would look similar. It would still pass through 0, 1. It would get steeper quicker on the right-hand side, and it would go just a bit shallower, quicker on the left-hand side, but it would still just approach the x-axis, not meet it. If you had something in the form of y equals and then something else such as 0.5 to the x, what would happen for that graph is it would actually go the other way around. Okay, let's have a look at our next topic. So our next topic is the trigonometric graph, so the trig graphs. And there are videos 338, 339, and 340 in Corbettmaths. Okay, so let's have a look at our first graph. So our first graph is y equals sine of x. So this is the y equals sine of x graph, or the sine graph, and it passes through the points 0, 0, 91, 180, 0, 270, negative 1, 360 degrees 0, and it carries on 450, 1, 540, 0, and so on. And it just carries on in that pattern, and it would carry on in the same pattern to the left as well, so it would go down and up and so on. Okay, so let's have a look at our next graph. So this is the y equals cos x graph. So this is the cosine graph, and it passes through the point 0, 1, 90, 0, 180 degrees, negative 1, 270 degrees, 0, 360 degrees, 1, 450 degrees, 0, and so on. It just carries on that pattern, and to the left it carries on in the same way, so it just comes down and so on. Okay, let's have a look at our next graph. So our next graph is y equals tan x, or the tangent graph. So this is the tan graph. It passes through the point 0, 0, and then curves up to infinity and just keeps going up here. Then we've got an asymptote, so the graph doesn't have a point at 90 degrees. Then it starts down here at negative infinity and comes up and passes through the point 180 degrees and 0, and then curves up again up to infinity. And then again we've got another asymptote at 270 degrees, because if you try to work out the tan of 270 degrees, try it in your calculator, you'll get an error message. And then it comes up from negative infinity again and passes through the point 360 degrees and so on, and then it just curve up to infinity and so on. And then have another asymptote of 450 degrees and so on. And again, if we were to draw the left hand side of this graph, it would just curve down, and then another asymptote at negative 90 degrees and so on. So this is the tan x graph. Now it's important to know what these graphs look like and be able to spot which one's which. So the tan graph's quite unique, so you can usually spot the tan graph quite easily, especially with its asymptotes. And then in terms of the sine graph and the cos graph, I just remember that the sine graph passes through the origin, whereas the cos graph starts at the point 0, 1, and that helps me recognize which one's which. And that's it. Okay, let's have a look at our next topic. So our next topic is transforming graphs, and that's videos 323 and 324 in Corbettmaths. So at GCSE level, there's 4 transformations that we need to know. So if we were given the graph of y equals f of x, we need to know how to sketch or how to draw y equals minus f of x, y equals f of minus x, y equals f of x plus a, and y equals f of x plus a. So let's have a look at each of these now, and I'm going to use the Corbettmaths revision cards to help us. So let's start off with our first transformation. So our first transformation is y equals minus f of x. So if we want to sketch y equals minus f of x, we reflect the graph of y equals f of x in the x-axis. So if we have this curve, this black curve, and we reflect it, it becomes this green curve when we reflect it in the x-axis. Now the points on the x-axis will stay where they are, and the points above will go below, and the points below will go above. So let's have a look at a question here. So we've got the curve y equals f of x here, and we're going to sketch the curve y equals minus f of x. So to sketch it, we're going to reflect this graph in the x-axis. So the point minus 6, 1 will go to minus 6, minus 1. So it will move to here, minus 6, minus 1. And this curve, this part, all the points that were above the x-axis will go below the x-axis, like so. And then the points that were below will go above, so like so. And then this side will look the same on the other side. So we'll reflect the graph, this y equals f of x, in the x-axis, and it would look something like this. So what happens is it flips the graph or reflects the graph vertically, like so. So let's have a look at our next transformation. So our next transformation is y equals f of minus x. And y equals f of minus x reflects the graph of y equals f of x in the y-axis. So as you can see here, if we started off with this y equals f of x, this black curve, if we reflect it in the y-axis, the points that were on the right-hand side of the y-axis will now move to the left-hand side of the y-axis, and the points that were on the left-hand side will move to the right-hand side, and any points that were on the y-axis will stay where they are. So if we have this curve here, y equals f of x, and we want to sketch y equals f of minus x, we'll reflect it in the y-axis. So any points that are on the y-axis will stay where they are. The coordinates of the maximum point were negative 6, 1. Whenever you reflect that in the y-axis, what will happen is instead of being 6 to the left, it'll be 6 to the right. So it'll move to 6, 1. So it'll move to here, 6, 1. And the points that are on the right-hand side will move to the left-hand side, and the points that are on the right-hand side will move to the left-hand side. So it'll look something like this. And that's it. So this would be the graph of y equals f of minus x. Okay, our next transformation. Our next transformation is if we're given y equals f of x, if we want to sketch y equals f of x plus a, we shift the graph a squares upwards. Or if we subtract a, we move the graph a squares downwards. So if we have this graph, this y equals f of x here, and we want to sketch the graph of y equals f of x plus 2, we're going to shift this graph, all the points in this graph, 2 squares upwards. So let's start off with the maximum point. It was negative 6, 1. So it's going to move upwards to negative 6, 3. Like so, and then all the points will move 2 squares upwards, so it would look something like this. And that's it. So if we started off with the graph y equals f of x, this black curve here, and we added 2, we had y equals f of x plus 2, we shift all the points 2 squares upwards, like so. If it was subtract 4, we would move it all the points 4 squares downwards, and so on. Okay, and let's look at our last transformation. Our last transformation is, if we have y equals f of x, how to sketch y equals f of x plus a, or x minus a. And this one's, it's a bit counterintuitive. If you're adding a, instead of moving the graph a squares to the right, we actually move it a squares to the left. So if we had y equals f of x, like so. And then we wanted to sketch y equals f of x plus 3. We move the coordinates all 3 squares to the left. So instead of it being 4, 0, it moves to 1, 0. Instead of being minus 4, 0, it's now minus 7, 0. Instead of having a minimum point at 0, negative 4, it's now negative 3, negative 4. So if you add, it moves to the left. And if you subtract inside the brackets, it moves all the points a squares to the right. Okay, so let's have a look at this one. If we have y equals f of x, and we then want to sketch f of x plus 2, what we're going to do is we're going to move all the points 2 squares to the left. So instead of having a maximum point at negative 6, 1, it's now going to move 2 squares to the left, so it's now going to be negative 8, 1. Instead of crossing the x-axis here, it's going to move 2 squares to the left to here. Instead of crossing the x-axis here, it's going to move 2 squares to the left to here. And then we just sketch our curve, and it looks something like this. And that's it. So our 4 transformations that we need to know at GCSE level are y equals negative f of x, that's a reflection of the graph in the x-axis. Y equals f of negative x, that's a reflection of the graph in the y-axis. Y equals f of x plus a. If the plus a is outside of the brackets, you just move the graph a squares upwards, or if it's take away a, you move it a squares downwards. And then finally, y equals f of x plus a. This one's counterintuitive. Instead of moving the graph a squares to the right, we actually move it a squares to the left. And if it's subtract, we move it to the right. Okay, and that's it. If you want more practice of these, you can go to videos 323 and 324 in Corbettmaths. There's some questions in that booklet on transforming graphs, so they'll be ideal to practice now as well. And also remember, if you have the Corbettmaths revision cards, you've got those Corbettmaths revision cards that include transforming graphs, and they'll be quite useful to pin up on your wall and study and learn and memorize as well. Okay, let's have a look at our next topic. Now what's fantastic is now we know how to transform graphs, and also that we know the topic completing the square, we can use that information to help us find the turning points and lines of symmetry of quadratic graphs. So if for instance we were asked to use completing the square to find the coordinates of the turning points of the graph y equals x squared minus 8x plus 1, we can use completing the square and transforming graphs to do that. So let's consider this quadratic x squared minus 8x plus 1, and let's do completing the square on this. So we would put our bracket, then we'd write x, and then instead of minus 8x, well, we're going to half the minus 8, so it's going to be minus 4, close bracket, squared. Now minus 4 squared, minus 4 times minus 4 is 16, so we're then going to take away 16, because we always take away whatever number's in here, squared, and then we've still got our plus 1. So we've got y equals this. Now we've got minus 16 plus 1, that's going to be, if we go up 1 from minus 16, that'll be minus 15. So we've got y equals, and then in brackets, x minus 4, close bracket, squared, minus 15. Now if we consider the graph y equals x squared, that's the x squared graph, it's a parabola, and as you should know, it should look something like this. It passes through the origin and then back up like so. So that's the graph y equals x squared. Now if we have a look at the graph that we've been given in the question, our y equals x squared minus 8x plus 1, we've been able to write it in the form x minus 4 close bracket squared minus 15. Now considering our transformations of the graph, we've got a minus 4 inside the brackets. So what that does is it translates the graph, it slides the graph 4 squares to the right. Remember, if we take away, it's counterintuitive. Instead of moving the graph to the left, it moves it to the right. So it translates it 4 squares to the right. And then, so that means that the graph would look something like this, where it would go through and touch there, and go up like that. And then we have a minus 15 outside of the brackets. That's then going to move our graph 15 squares down. So let's actually translate it, move it down 15 squares. So it's going to move down to somewhere like that. So whenever we have the graph in the form of y equals x minus 4 close bracket squared minus 15, we've got a minus 4 inside the brackets, so it moves the graph 4 squares to the right, and then we've got our minus 15, so it moves it 15 squares down. So the coordinates of this turning point, it was the origin, we moved it 4 squares to the right, so it's going to be 4, and then we moved it 15 squares down, so it's going to be minus 15. So the coordinates of that turning point would be 4 minus 15. And that's fantastic, being able to use completing the square and our transformations of graphs to find what that graph would look like, that quadratic. Also, if we were asked to find the line of symmetry of that quadratic, what we could do is we could just consider, well, if that's the turning point at 4 minus 15, the line of symmetry would pass through that as a vertical line like so, and that is the line x equals 4. It's a straight line passing through 4 in the x-axis. So if you were asked for the line of symmetry, it would be x equals 4. Okay, and that's it. Okay, let's have a look at our next topic. So our next topic is solving inequalities, and that's video 178 in Corbettmaths. So our first question says solve 5x is bigger than 30. Now whenever I'm solving inequalities, I use a similar approach to I would use for solving equations. So here we've got 5x is bigger than 30. Now we don't want 5x, we want just x. So we want to get rid of this multiplied by 5. So to get rid of this 5, we're going to do the opposite, which is divide by 5. So we're going to divide both sides by 5. So if we divide both sides by 5, well, 5x divided by 5 would be 1x, or x, and that would be bigger than, and if we done 30 divided by 5, that would be 6. So the answer would be x is bigger than 6. Okay, this time we've been asked to solve 3x plus 4 is smaller than or equal to 31. So if this was an equation, the first thing I would want to do is get rid of this plus 4. So let's take away 4 and take away 4 from both sides of the inequality. So we've got 3x plus 4. We're taking away 4, so that leaves us with 3x. And then we've got our less than or equal to sign. And then we're taking away 4. 31 take away 4 is 27. So we've got 3x is smaller than or equal to 27. Now we don't want 3 times x, we just want x, so let's divide both sides by 3. So dividing by 3 and dividing by 3 would give us, well, on our left hand side, we're dividing by 3 to get rid of this times by 3, so we're just left with x. And then we've got smaller than or equal to, and then if we do 27 divided by 3, well, 27 divided by 3 is 9. So if we've been given the question 3x plus 4 is smaller than or equal to 31, well, we know that x will have to be smaller than or equal to 9. That's it. Okay, let's have a look at our next question. So this time we've got an inequality with letters on both sides. So remember, whenever we're solving equations with letters on both sides, we want to get rid of the lowest number of x's. So here we've got 8x plus 1 is smaller than 10x subtract 6. So with this inequality, I'm going to get rid of the lowest number of x's, which is our 8x. So let's take away 8x from both sides of this inequality. So when we do that, we had 8x plus 1, we took away the 8x, so we're just going to be left with plus 1, or 1. And that's smaller than, well, we have 10x take away 6, and we're taking away 8x, so that's going to leave us with 2x. So we've got 2x take away 6. Okay, now like an equation, I would want to get rid of this take away 6, so let's add 6 to both sides of this inequality. So 1 plus 6 is 7, so we've got 7 is less than 2x, and we added 6 to get rid of the minus 6, so we're just left with 2x. And finally, we want the x on its own, so we want to get rid of this multiply by 2, so let's divide by 2 and divide by 2. And whenever we divide 7 by 2, we get 3.5, so that's 3.5 is less than x, and that's it. So we've got 3.5 is less than x. Now we might want to write this the other way around, so we've got the x at the front. So if we write this the other way around, just be aware whenever we write it the other way around, we've got x. Now we've got 3.5 is less than x, or if we read it the other way around, we've got x is bigger than 3.5. So we need to flip that inequality sign round whenever we're writing it the other way around, because x is bigger than 3.5, and that's it. So whenever you're solving inequalities, it's similar to solving equations, but you just need to be aware of whenever you are wanting to flip it around. So in other words, whenever you want the x at the front rather than the number at the front, whenever you flip it around, that you need to be aware of that inequality sign. Okay, let's have a look at our next topic. So our next topic is inequalities, but this time we're dealing with number lines. So it's representing inequalities on a number line, and it's also looking at how to solve inequalities and then represent the answer on a number line. And this would be video 177 on Corbettmaths. So let's look at how we'd represent some inequalities on a number line. So here's a number line, and our first inequality is x is greater than -1. So x is bigger than -1. So first of all, what we do is we go to -1, and because x is greater than -1, it can't actually be -1. So what we do is we put a hollow circle at -1, and because x can be bigger than -1, what we do is we put an arrow to the right, like so, and we just do an arrow, and that tells us that x can be any value that is bigger than -1. And because the circle's hollow, it shows us that it can't actually be -1, so it's any number greater than -1. Okay, this time our inequality says x is greater than or equal to 2. Now this time we've got x is greater than or equal to 2. So that means it can actually be 2 and any number that's bigger than 2. So instead of doing a hollow circle, what we do is we actually do a circle and colour it in. So a shaded in circle, and then an arrow to the right, like so. And what that means is that x can be 2 or any number bigger than 2. So our next inequality is x is smaller than -2. So this time what we're going to do is, because it's smaller than, so it's not equal to, we do a hollow circle, and the arrow points to the left because it's smaller than -2. Okay, and our next inequality. So our next inequality is x is smaller than or equal to 3. So because it's smaller than or equal to, instead of doing a hollow circle, we do a shaded in circle at 3, and we do an arrow to the left, like so. And that's it. So that's how we represent inequalities where we've just got x is bigger than a number, or bigger than or equal to a number, or less than a number, or less than or equal to a number. And if we had an inequality such as this, where x is bigger than 1, but less than or equal to 3, and I wanted to represent an inequality like that on the number line, because we know that x is bigger than 1, but we know it's bigger than 1, so it can't be equal to 1, so we do a hollow circle at 1. And because x is smaller than or equal to 3, because it can be 3, we do a shaded in circle at 3. And because x can take the values in between those numbers, we join them up like so. So if we wanted to represent an inequality such as x is bigger than 1 but less than or equal to 3, we would do a hollow circle at 1, a shaded in circle at 3, and that represents that inequality on a number line. Okay, let's look at our next question. Okay, so let's have a look at another type of inequalities question. So we've been asked to list all the integers that satisfy the inequality 2n is greater than 7 but less than or equal to 14. So we're looking for integers, so numbers such as -2, -1, 0, 1, 2, 3, and so on, that satisfy this inequality. Now if we have a look at this inequality, we've got 7 is less than 2n, that is less than or equal to 14. Now we've got 2n here. What I'm going to do is I'm actually going to divide this inequality by 2. I'm going to divide everything by 2, and that will give me n instead of 2n. So if I divide everything by 2, 7 divided by 2 is equal to 3.5. Is going to be less than, and then 2n divided by 2 would be n, and then we've got our less than or equal to symbol, and then we've got 14 divided by 2, that's 7. So we know that n is greater than 3.5 but less than or equal to 7. So we need to list all the integers that are greater than 3.5 but less than or equal to 7. So let's list our integers. So our first integer that is greater than 3.5 would be 4, and then we've got 5, and then we've got 6, and then it says less than or equal to 7, so 7 is going to be an integer that works. So our integers that satisfy this inequality would be 4, 5, 6, and 7, and that's it. Okay, let's have a look at our next topic, and our next topic is graphical inequalities, and I really like this topic in this video 182 in Corbettmaths. So here we've got a set of axes. We've got our x-axis and our y-axis, and we've been asked to show the region that satisfies x is smaller than or equal to 7, y is bigger than or equal to 3, and y is less than or equal to half x plus 2. So what we're actually going to do is we're going to draw these lines to begin with. We're going to draw the line of x equals 7, we're going to draw the line of y equals 3, and we're going to draw the line of y equals half x plus 2. And so we'll draw those lines to begin with, okay? And then once we draw those, we'll then be able to see which region satisfies these inequalities. So let's start off with x equals 7. Let's look at the line of x equals 7. So x equals 7 is a vertical line passing through 7 on the x-axis. So here we've got our x-axis and here we've got 7. And the line x equals 7 is a vertical line that passes through 7 on the x-axis. You might have seen it before whenever you've done reflections, when you're reflecting shapes on axes. So that's the line x equals 7. Because all of the points on that line have an x-coordinate of 7. There's 7 across, 1 up, 7 across, 2 up, and so on. Okay, our next line, y equals 3. So we want to draw the line y equals 3, and that's going to be a horizontal line passing through 3 on the y-axis. So here we've got the y-axis, here we've got the number 3, and that line y equals 3 will be a horizontal line that passes through that point. So let's get our ruler and pencil, and let's draw that line. So we've drawn the line y equals 3, and finally we need to draw the line of y equals a half x plus 2. So what we've done is I've just taken the inequalities we've been given, changed all the inequality signs to equals, and we're just going to draw those lines to begin with. So what we're going to do is we're going to draw this line of y equals a half x plus 2. So I'm going to do an xy table, x and y, and choose some values for x, so 0, 1, 2, 3. And we're going to find the y value. It's half of the x value plus 2. So half of 0 is 0 plus 2 is 2. Half of 1 is 0.5 plus 2 is 2.5. Half of 2 is 1 plus 2 is 3. And half of 3 is 1.5 plus 2 is 3.5. So here we've got our coordinates 0, 2, 1, 2.5, 2, 3, and 3, 3.5. So 0, 2, 1, 1.5, 2, 3, 3, 3.5, and so on. So let's get our ruler and pencil and draw a nice straight line through those. And it would look something like that. Okay. Now one thing to note in this question, we have x is less than or equal to 7, y is bigger than or equal to 3, and y is less than or equal to half x plus 2. All of them have the equals to bit, and that's why we've drawn 3 solid lines. If any of the inequalities were just greater than or less than, then you would do a dashed line instead. Okay. So in this question, we've been asked to show the region that satisfies these inequalities. Now we've drawn the line of x equals 7, but we've been told in the question that x is less than or equal to 7. So that means our region will have to be less than 7. So it means that our region will be on the left of this line. So it can't be anything on the right hand side of this line, because anything over here would have an x value bigger than 7. So what I'm actually going to do is just shade this right hand side to show that it can't be anything on this side of the line, because x has to be less than or equal to 7. Okay, let's have a look at our next one. So we've got y is bigger than or equal to 3. So we drew the line of y equals 3. And if we wanted a y is bigger than or equal to 3, it would be anything above that line. Anything below it would have a y value of something less than 3. So that means that anything below this horizontal line couldn't work. So we have to reject anything below that line. So let's just shade in just beneath it like this, just to show that we're rejecting anything below that line. Anything below this line would have a y coordinate of less than 3. And we wanted to find the region where the height is bigger than or equal to 3. Okay, let's have a look at our last inequality. Our last inequality is y is less than or equal to half x plus 2. So here we've got this diagonal line. We've drawn the line of y equals half x plus 2. And one of these sides, either the top or the bottom, we want to keep, and one side we want to reject. Now, in terms of figuring out which side I want to keep or which side I want to reject, what I do is I look at the inequality, y is less than or equal to half x plus 2. And what I do is I pick any point that's not on this line. I'm actually going to pick the origin, this point here, the coordinate 0, 0. Okay, so I'm going to choose this coordinate 0, 0. And I'm going to substitute in x equals 0, and y equals 0 into this inequality, and I'm going to see if it works or not. So let's substitute x equals 0 and y equals 0 into this inequality. So we had y, so instead of y we're going to write 0, and that's less than or equal to half of x. Well, a half of 0 is 0 plus 2. So we've got 0 is less than or equal to 0 plus 2. Now 0 plus 2 is 2, so we've got 0 is less than or equal to 2. Now let's have a look at this inequality. We've got 0 is less than or equal to 2. Well, 0 is less than 2. So that means that this inequality works, okay? 0 is less than or equal to 2. If we had something like 9 over here and we had 9 is less than or equal to 2, it wouldn't work because 9 is not less than or equal to 2. But here we had 0 is less than or equal to 2, so that works. So that means that this point, the origin, 0, 0, satisfies this inequality. It works. That means that below this diagonal line is the region we want to keep, and above the diagonal line is the region we don't want to keep. So what we're going to do is we're just going to shade in above the diagonal line like so to show that this section of the line, this section of the graph, anything above this line is rejected and anything below is accepted. And as you can see, we're left with this triangle, and inside this triangle in this region it satisfies all three of these inequalities. So then in the question it might ask you to label it with an R to show that's the region that works, that satisfies all three inequalities, or sometimes the question could say shade in the region that satisfies each of them, and then you would shade in that region really carefully to show that it satisfies them. But typically the ones that I normally see say label it with an R to show that that's the region that satisfies all three inequalities. And that's it. Okay, let's have a look at our next topic. So our next topic is quadratic inequalities, and that's video 378 in Corbettmaths. So here we've been given an inequality and we've been asked to solve x squared plus 2x minus 24 is less than or equal to 0. Now as you can see, it's a quadratic because we've got our x squared term, and it's an inequality because it's less than or equal to 0. Now we want to find the values for x, and whenever we substitute them into this quadratic, they give us an answer that is either negative or equal to 0 because it says less than or equal to 0. Now I find it really useful to sketch the quadratic graph for this, because if we sketch the quadratic graph, we can look at the graph and see when the heights are less than 0, in other words when they're negative below the x-axis, or equal to 0 on the x-axis, and that'll help us solve this quadratic inequality. So let's sketch this quadratic. Let's sketch the quadratic y equals x squared plus 2x minus 24. So to sketch this quadratic, what I'm going to do is I'm going to find where it crosses the x-axis to begin with. In other words, when the height is equal to 0. So that means that 0 will equal x squared plus 2x minus 24. And if I solve that quadratic, it will tell me the points where it crosses the x-axis. So we've got 0 equals, and if we factorize this, that will give us, in our brackets, x and x. And we've got two numbers that were times together to give us negative 24 and add together to give us 2. So I'm thinking plus 6 and minus 4. So that's our quadratic factorized. That means that x will be equal to negative 6 or x will be equal to 4. So they're the points where our quadratic will cross the x-axis. It's going to cross here at negative 6 and here at 4. So our quadratic would look something like this, where it crosses at negative 6 and 4. And because it's x squared, it's going to be a U-shaped parabola, so it looks something like this. So now we've sketched our quadratic. We want to find where the quadratic has a height that is less than or equal to 0. In other words, the values for x, so whenever we substitute them into the quadratic, will give us an answer that is negative or equal to 0. And if we have a look here, we can see that any value of x, so whenever we substitute into the quadratic that is in between negative 6 and 4, so for instance, if we had 3, if we'd done 3 squared plus 2 times 3 minus 24, the answer will be negative. If we tried 2, the answer would be negative. 0, the answer would be negative 24. If we tried negative 5, the answer would be negative. So all the values of x in between negative 6 and 4 would give us a negative answer. And also, whenever x is equal to negative 6 and whenever x is equal to 4, we get 0. So all of those points in between negative 6 and 4, including negative 6 and 4, would satisfy this inequality. So that means that x will be any value that is bigger than or equal to negative 6, but any value that is less than or equal to 4. And that's our answer. Okay, let's try another one. Okay, let's have a look at our next quadratic inequality. So our next quadratic inequality we're going to solve is x squared minus 7x plus 10 is bigger than 0. So my first step again is to sketch the quadratic, and we've got y equals x squared minus 7x plus 10. And we want to sketch that quadratic, so I'm going to factorize it and let it equal 0 and find where it crosses the x-axis. So I'm going to write 0 equals x squared minus 7x plus 10. And let's factorize it, so 0 equals, and if we factorize that quadratic we get x minus 5 is negative 2. So that means that x will be equal to 5 or x will be equal to 2. So this is an x squared quadratic, so it's going to be a U-shaped parabola and it's going to cross the x-axis at 2 and 5. So let's sketch it. So it's going to look something like this. So we've now sketched the quadratic. We now want to find the values for x, so whenever we substitute them into the quadratic, we will get an answer that is bigger than 0. In other words, when is the quadratic graph above the x-axis? So as you can see here, any value for x that is bigger than 5 will give us an answer that is positive. So that means that x will be bigger than 5. So that's one possible set of answers. Any value of x that is bigger than 5 would work. For instance, if we tried 10, 10 squared is 100. Take away 7 times 10, well, that's 70, that would leave us with 30. Add 10 is equal to 40, and 40 is bigger than 0. And any value of x that is above 5 would work, even 5.1, 5.01, and so on. But 5 wouldn't work because if we tried 5, that gives us an answer of 0. Now, the values of x between 2 and 5, they give us negative answers. Now, we want an answer that is positive, so we want to find where the graph is above the x-axis. So now let's have a look at this part of the quadratic whenever the values of x are less than 2. So if we try a value less than 2, such as negative 1, well, negative 1 squared is 1. Take away 7 times negative 1, well, 7 times negative 1 is negative 7, so we've got 1 take away negative 7, well, 1 minus 7 is 8, plus 10 is equal to 18. So any value of x that is less than 2 would work also. So answers would be x is less than 2, or x is greater than 5. So any value of x that is less than 2, or any value of x that is bigger than 5 would work, because that's where the graph is above the x-axis. And that's it. So if we want to solve quadratic inequalities, well, let's have a look at the Corbettmaths revision card. So whenever we're solving a quadratic inequality, I recommend that you sketch the quadratic to begin with. If you want to find where the quadratic is less than 0, you look and see where the quadratic graph is below the x-axis, and you write the values of x where the graph is below the x-axis. So for instance, if we look at this quadratic, x squared plus x subtract 12 is less than 0, you can see that it's below the x-axis for any value of x in between negative 4 and 3. So we write down that x is bigger than negative 4 or less than 3. And if you have a look at this inequality, if you want to find where quadratic is bigger than 0, you sketch the quadratic again and you look at the parts of the graph above the x-axis. So for this graph of x squared plus 2x minus 15 is bigger than 0, as you can see here, any value for x that is bigger than 3 or less than negative 5 would work. So we would write x is less than negative 5 or x is bigger than 3, and that's it. And if it has less than or equal to 0 or bigger than or equal to 0, you make sure that you put those signs on your inequalities as well. So if it was less than or equal to 0, then it would be x is bigger than or equal to negative 4 and less than or equal to 3, and that's it. Okay, let's have a look at our next topic. Okay, let's have a look at our next topic. So our next topic is iteration, and that's video 373 in Corbettmaths. So in this video, I'm going to go through 2 different types of iteration question. I'm going to go through this one to begin with, and then I'm going to look at an iteration question in context. And part A says, show the equation x squared plus 3x minus 1 equals 0 can be rearranged to give x equals a third minus x squared over 3. Now if we have a look at what we've been given, we can see here we've got over 3 and over 3. I think we're making this x a subject. Let's try and make this x a subject and see what we'd get. So if we start by adding 1 to both sides of this equation, we would get x squared plus 3x is equal to 1. Now we want to make this x a subject, so let's take away x squared from both sides of the equation. So then that would give us 3x is equal to 1 subtract x squared. And then finally, we want to make x a subject, so let's divide everything through by 3. So we get x equals 1 divided by 3, that's a third, subtract x squared over 3, and that's it. So we have rearranged this equation to give x equals a third minus x squared over 3. Okay, let's have a look at part B. So part B says, starting with x0 equals 0, use the iteration formula, xn plus 1 is equal to a third minus xn squared over 3. And we're going to have to use the iteration formula 3 times to find x1, x2 and x3. So whenever we're using an iteration formula, we need to know what we're starting with. So we're starting with x is equal to 0, and we're going to substitute that in here, and we're going to do a third minus 0 squared over 3, and we're going to get that answer. And that will become our x1. Once we know x1, we'll then substitute that in again, and we're going to do a third minus whatever the value for x1 squared is over 3, and then that will give us our value for x2. We'll then get the value for x2, substitute it in again, and that will give us our x3, and we can just keep going. But in this question, we've been asked to use the iteration formula 3 times. So we're told that x0 is equal to 0, so let's write that down. x0 is equal to 0. Now we want to find x1, so x1 will be equal to, so the next term, x1, will be equal to a third, so a third, minus, and then it would be x0 squared. Now x0 is 0, so 0 squared over 3. And if we do 0 squared, we get 0, and then divided by 3, that's equal to 0, and a third minus 0 will be equal to a third. So that means that x1 will be equal to a third. To find our value for x2, well, we're going to substitute our value for x1 into here. So we're going to do a third minus whatever x1 is, which is a third squared over 3. And then when we work that out, that will give us our value for x2. And then we can just keep going. So let's do a third minus. Now we could do 0.33333 reoccurring squared, or we could write a third there over 3. And then if we do a third minus 0.3 reoccurring squared over 3, we would get that's equal to 8/27, or 0.296296296 and so on, okay, or 0.296 reoccurring. And then to get our value for x3, we're going to substitute that into here to get our x3 is equal to a third minus x2 squared over 3. So we'll substitute our value for x2, which is equal to 8/27, or this, into here, and then that will tell us our value for x3. So it's going to be a third minus, and we could write 8/27 squared, or we could write 0.296 reoccurring squared over 3. And whenever we substitute that into our calculator, we get that's equal to 665 over 2187, or as a decimal number, that's equal to 0.30406950016, and so on. And that's it. So whenever you've been given an iteration formula, what you do is you start off with the value you've been given, and you substitute that in, and you find your value for x1, you get that value, you substitute it in to get your value for x2, and so on. Now there's quite a nice way to do this on the calculator. Because we were told to start with 0, what I'm going to do is I'm going to press 0 equals on my calculator, so I've got 0 up as the answer. And then I would type into my calculator a third minus, and then what I would write is I'd write answer, A-N-S, I just press answer, and then squared over 3. And I would type that into my calculator. So I would type in a third minus, and then the fraction button, answer squared divided by 3. And if I press equals, that substitutes in the value for 0 in here, so it does a third minus 0 squared over 3, and it gives me a third. If I then just press equals again, it's substituted in that value of a third into here, and I get 8/27, or 0.29626, and so on. If I just press equals again, it gives me 665 over 2187, or my 0.304, and so on. So whenever you're using an iteration formula, it can be very useful to just use that answer button, and if you just keep pressing equals, it would just tell you each one of your each one of the next values. So x1, x2, x3, I can press equals again and I get x4, press it again, I get x5, and so on. Okay, let's have a look at part C. Part C says explain the relationship between the values of x1, x2 and x3 and the equation x squared plus 3x minus 1 equals 0. Now this is the equation we started off with when we rearranged, and if we look back at our values, we've got 0.33333 and so on, 0.296296296, and then we get 0.304069 and so on, and each one of these values are getting closer and closer and closer to one of our solutions, one of our roots in that quadratic. So let's write that down. And I've just written down there are increasingly accurate approximations to a solution or root of x squared plus 3x minus 1 equals 0. And if you use the quadratic formula and solve this, you should see that they are getting closer and closer to one of those solutions. Okay, let's have a look at our next question. So this time we've got an iteration question and it's in a context. We've got tn plus 1 is equal to 0.9 tn plus 200. And this formula tells us that if we take the number of season tickets sold and we times it by 0.9 and add 200, we will get the number of season tickets sold in the next season. So we've been asked to work out how many season tickets are sold in their fourth season. Now in the first season, we know that's equal to 1,000. So we know there's 1,000 tickets sold in the first season. In the second season, well, we could do 0.9 times 1,000, which is 900, plus 200, which would be equal to 1,100. Then to find how many season tickets were sold in the third season, we just need to times this by 0.9 and add 200. So let's do that. So let's do 0.9 times 1,100. That's equal to 990. And if we add 200, that's equal to 1,190. And finally, in the fourth season, if we times this by our 1,190 by 0.9, so multiply by 0.9, that's equal to 0.9 times by 1,190 is equal to 1,071, and if we add 200, that would be equal to 1,271. So that would be how many season tickets were sold in the fourth season. And that's it, because we're told if we multiply the number of season tickets sold by 0.9 and add 200, we'll find how many season tickets are sold in the next season. Now there was a shortcut, as I said, to use your calculator, and what you can do is, because you're starting off with 1,000, you can press 1,000 and then press equals. And then, because we know that we multiply the number of season tickets by 0.9 and add 200, we can then type in this. We can write 0.9 times answer plus 200. And then that means that it's going to be doing 0.9 times 1,000 plus 200. And that will give us 1,100. Then if you press equals again, it will do 0.9 times 1,100 plus 200, and that will be equal to 1,190. And then if you just press equals again, it would tell us our answer of 1,271. So I like using that answer key whenever I'm doing iteration questions. Okay, let's have a look at our next topic. So here we've got a pattern of dots, and these are our triangular numbers where we start off with one dot, then we add a row of two dots beneath it, so 1 plus 2 is 3. Then we add a row of 3 dots beneath that, so 3 plus 3 is 6. Then we add a row of 4 dots, well, 6 plus 4 is 10. Then we add a row of 5 dots, which would be 15, and so on. So to get our triangular numbers, we start with 1, and then we add 2, add 3, add 4, add 5, add 6, and so on. And they are our triangular numbers, and they are 1, 3, 6, 10, 15, 21, 28, 36, and so on. Okay, and another type of sequence that we should know is our Fibonacci sequence. So a Fibonacci sequence is if we choose two numbers such as 1 and 1, we find the next term of a Fibonacci sequence by adding the two previous terms. So 1 plus 1 is equal to 2. Now we do 1 plus 2 is equal to 3. Now we do 2 plus 3 is equal to 5. Then we do 3 plus 5 is equal to 8. 5 plus 8 is equal to 13, and so on. And that's it. So a Fibonacci sequence is to find the next number, we add the two previous numbers. So here's an example. It says find the next three terms of this Fibonacci style sequence. So we've got 2, 7, 9, and 16. So to get the next number, we need to add the 9 and 16. So 9 plus 16 is 25. To get the next number, we're going to add 16 and 25. That's equal to 41. And finally, to get our next number, we're going to do 25 plus 41. And 25 plus 41 will be equal to 66. And that's it. So Fibonacci sequence is where we find the next term by adding the two previous terms. Okay, let's have a look at our next topic. So our next topic is the nth term. So whenever we've got a sequence, there's often a rule or an nth term for it, which means that we can find out any term in the sequence by substituting in which value we're looking for. So here we've got our sequence, 3, 8, 13, 18, and so on. As you can see, we're going up in fives because we're adding 5, adding 5, adding 5, and so on. And we've been asked to find the nth term of this sequence, in other words, the rule for the sequence. So if we want to find the nth term, our first step is to consider the sequence and see what it's going up in or going down by. And as this sequence has gone up in fives, we're adding 5, adding 5, adding 5. What we're going to do is we're going to write the 5 times tables beneath the sequence. So the 5 times tables are 5, 10 are the multiples of 5, 5, 10, 15, 20, and so on. And because we're multiplying the numbers by 5, we're doing 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, and so on. We're going to write 5n because that means 5 multiplied by n. Because 5 times 1, 5 times 2, 5 times 3, and so on. So if the sequence has gone up in fives, we write the 5 times table, so the multiples of 5 beneath it, and we write 5n in front. Now our sequence is not 5, 10, 15, 20. Our sequence is actually 3, 8, 13, and 18. And to get from 5 to 3, we take away 2. To get from 10 to 8, we take away 2. To get from 15 to 13, we take away 2. To get from 20 to 18, we take away 2. So if we took away 2 from all of these numbers, we would get our sequence. So that means if we had 5n minus 2, that would be 3, 8, 13, and 18. So that means our nth term is 5n minus 2. 5n minus 2. And let's just check it. Well, the first term in our sequence, well, if we do 5 times 1 is 5, take away 2 is 3. Great. The second term in our sequence is 8. Well, if we do 5 times 2, that's 10. Take away 2 is 8. Fantastic. Our third term, 5 times 3, 15. Take away 2 is 13, and so on. Let's work out another one. So if we had the sequence 7, 9, 11, 13, and so on. As this sequence is getting bigger by 2 each time, we write the multiples of 2 beneath the sequence. So that's 2, 4, 6, 8, and so on. And that's 2n. Our sequence, though, isn't 2, 4, 6, 8. Our sequence is 7, 9, 11, and 13. So to get from the multiples of 2 to our sequence, we'd have to add 5, add 5, add 5, and add 5. So that means our nth term would be 2n plus 5. So that means the nth term of this sequence would be 2n plus 5. And let's just check it. 2 times 1 is 2, plus 5 is 7. 2 times 2 is 4, plus 5 is 9. Great. 2 times 3 is 6, plus 5 is 11, and so on. So to find the nth term of a sequence, you consider what the sequences are going up or down by. You write their multiples beneath it, and then you figure out what you would need to do to those multiples to get to the sequence. Now, because I said down by, let's just have a look at an example where a sequence is going down instead of up. So let's have a look at one of those now. So if we had the sequence 15, 12, 9, 6, and so on, and if we look at our sequence, we can see we're going down by 3 each time. We're taking away 3, taking away 3, taking away 3, and so on. So that means that what we're going to do is we're going to write down the negative 3 times tables. So that's going to be minus 3, minus 6, minus 9, minus 12, and so on. So that would be minus 3n, because it's minus 3 times 1, minus 3 times 2, and so on. But our sequence is not minus 3n. It's not minus 3, minus 6, minus 9, minus 12. Our sequence was 15, 12, 9, 6. To get from minus 3 to 15, we would have to add 18. To get from minus 6 to 12, we would have to add 18. To get from minus 9 to 9, we'd have to add 18, and so on. So that means our nth term for our sequence would be minus 3n plus 18. Now the nth term is really useful, because what we can actually do is we can use the nth term to work out terms in the sequence. If we had the sequence 3, 8, 13, 18, and someone asked me to find the 100th term in the sequence, rather than carrying on the sequence for 100 terms, I can use this nth term. So I can do, if I want the 100th term, I can do 5 times 100, which is 500, take away 2, which would be 498. So the 100th term in this sequence, without having to list them all down, would be 498. And that's great. So it saves us a lot of time and effort. Another reason why the nth term is quite useful is we can use it to work out if a term's in the sequence or not. So for instance, if somebody came along to me and said, is 200 in this sequence? Well, first of all, I can tell it's not, because our sequence goes 3, 8, 13, 18, and so on. And as you can see, the numbers end in a 3 or an 8, a 3 or an 8. So because 200 ends in a 0, it's not going to be in the sequence. But we can actually use the nth term to show that. We can actually write 5n minus 2, the nth term, and write equals 200. So that's an equation. And if we solve this equation and we get a whole number, so we get n equals a whole number, it would mean that 200 is in the sequence, and whatever whole number that is tells us which term in the sequence it is. But if whenever we solve this equation we get a decimal number, it would mean that the number 200 wouldn't be in the sequence. So let's solve our equation and see what happens. So if we had 5n minus 2 equals 200, we would add 2 and add 2. Well, we add 2 to get rid of the minus 2, so we're left with 5n, and on the right hand side we've got 200, add 2 is 202. Now we've got 5n, we don't want 5n, so let's divide by 5 and divide by 5. So that would give us 5n divided by 5 is n, and 202 divided by 5 would be 40.4. And as that's not a whole number, that means that 200 is not in the sequence. And because it's 40.4, it means it's not the 40th term and it's not the 41st term in the sequence. So that means that 200 is not a term in the sequence. Okay, so our next topic is the quadratic nth term, and that's video 388 in Corbettmaths. Well, actually, I say video, there's actually 388A, 388B, and 388C. And I've actually had to make 3 different videos there because there's 3 popular approaches with teachers with how they find the quadratic nth term. Now, in this video, I'm going to go through one approach. So here we've got a quadratic sequence, and it goes 5, 6, 11, 20, and 33. And if I want to find the nth term for this quadratic nth term, I'm going to find what we call the first differences. So the first differences are the difference between these terms, and then I'm going to find the second differences, which are the differences between the first differences. So let's write down the first differences to begin with. So we go from 5 to 6, that's a difference of 1. We then go from 6 to 11, that's a difference of 5. We go from 11 to 20, that's a difference of 9. Now we're going to find our second differences, and with quadratic nth term, the second differences should always be the same number. So from 1 to 5, the second difference will be 4. From 5 to 9, the second difference will be 4. And from 9 to 13, the second difference will be 4. So we have got the first differences and the second differences. Now we need to consider what the quadratic nth term would look like. So the linear nth term is something such as 3n plus 7. That's the nth term for a linear sequence. For a quadratic sequence, it's something in the form an squared plus bn plus c. So if we consider our quadratic graphs, that's something in the form of y equals x squared plus so many x's plus a number, and so on. Here we've got the quadratic nth term, and it would be in the form of an squared plus bn plus c. Okay, so now let's have a look and see how we would find A, B, and C. Now, if you do watch my video on Corbettmaths, the 388A video, it'll show you clearly why this is the case. But if we have a look at these numbers, this number here, this first second difference, or actually any of the second differences, that's equal to 2A. So if we halve this number, we will find A. Next, if we want to find our B, we will look at this number, the first difference, and that number would be equal to 3A plus B. And once we know A, we can then find out what B would be. And finally, this term in the sequence, the first term in the sequence, would be equal to A plus B plus C. And that's it. Now, if you do watch that video 388A, I go through and show you why that's the case. But let's use this information to find what A, B, and C are. So 2a is equal to 4, so let's write that down. 2a is equal to 4, and if we divide by 2, we get a is equal to 2. That's fantastic. We've got 2n squared. Now we want to find our value for b. Well, if we look at our first difference, the 1, that's equal to 3a plus b. So 3 times a, 3 times 2 is equal to 6. Actually, let's write that down. 3a plus b is equal to 1. And a is equal to 2, so 3 times 2 is 6. So we're going to have 6 plus b is equal to 1. And then if we take away 6 from both sides, we get b is equal to negative 5. So that means b is equal to negative 5 or minus 5. So that means that here we're going to have 2n squared minus 5n. And then finally, we just need to find our c. The first term in the sequence is equal to a plus b plus c. So let's write that down. A plus b plus c is equal to 5. And we know that a is equal to 2, so that's going to be 2. And then b is equal to minus 5, so plus minus 5. And then plus c is equal to 5. And then we've got 2 plus minus 5. Well, 2 take away 5 is minus 3. So we've got minus 3 plus c is equal to 5. And then if we add 3 to both sides, we're going to get c is equal to 8. And that's it. So that means that our c is equal to 8, so plus 8. So our quadratic nth term for this sequence would be 2n squared minus 5n plus 8. Now, once you know the quadratic nth term of a sequence, you can also do other things with it. So for instance, if we want to know what the 100th term in this sequence would be, we would just substitute in n is equal to 100. So we would do 100 squared times 2, subtract 5 times 100 plus 8, and so on. And that's it. Okay, let's have a look at our next topic. So our next topic is geometric progressions. That's video 375 in Corbettmaths. So we've looked at arithmetic progressions. That's where we're adding or taking away the same number each time. Now let's look at geometric progressions where we're multiplying by the same number each time, a common ratio. So here we've got two geometric progressions, and we've been asked to find the next two terms for each one of the following geometric progressions. So let's start off by looking at this one. We go from 2 to 40. So let's see what we're multiplying by. We're multiplying by 20, because if we do 2 times 20, we get that's equal to 40. Or we could just do 40 divided by 2, and that's equal to 20. If we're for geometric progression, if we divide the next term by the previous term, that gives us what we're multiplying by each time. So if we do 800 divided by 40, we will also get that's equal to 20. So here each time we're multiplying by 20. So if we want to find the next two terms, we're going to times by 20 again. So multiplying by 20 would give us 16,000. And then if we multiply by 20 again, that would give us our next term, which would be 320,000. And that's it. Our next geometric progression, this time we've gone from 3 to 15 to 75. As you can see, we're multiplying by 5 each time. Multiplying by 5, multiplying by 5. So if we multiply by 5 again, so 75 times 5, 75 times 5 is equal to 375. And then we're going to take our 375 and times that by 5, and that would tell us our next term, which would be 1,875, and that's it. Okay, let's have a look at another geometric progressions question. So this time we're told that S is a geometric sequence. So we've got a geometric sequence, so that means that we're multiplying by the same number each time in the sequence. And all terms of the sequence are positive integers, so they're all positive numbers. And the first three terms in the sequence are 8, x, and 72. And we've been asked to find the value of x. So in this question, we don't actually know what we're multiplying by each time because we're trying to find this term, and without knowing this term, we don't know what we're timesing by. But what I do know is with a geometric sequence or geometric progression, if I divide the next term by the previous term, that will tell me what I'm multiplying by. And remember, I'm always multiplying by the same thing. So that means that if I do x divided by 8, that would be the same as 72 divided by x. So let's write that down. X divided by 8, the second term divided by the first term, will be equal to the third term divided by the second term. So that's 72 divided by x. Now this is just an equation and we can solve it. Now I want to find what x is, so I don't want x on the denominator, so I'm going to multiply both sides of this equation by x. So timesing both sides by x would give us, well, if we multiply the left hand side by x, we would have x over 8 times x, that would be x squared over 8. And on the right hand side of the equation we had 72 divided by x. We're timesing by x to get rid of the x, that's just going to leave us with 72. Now we don't want to have this divide by 8, so let's multiply both sides of the equation by 8. That will give us x squared equals, and 72 times 8 would be equal to 576. So that means that x squared is equal to 576. Now whenever we're solving an equation like this, we've got to be careful because there's a positive solution and a negative solution. So that means that x is going to be equal to plus or minus, and then we'll just square root 576. And the square root of 576 is 24. So that means that x is equal to plus or minus 24. So that means that x could be 24 or x could be negative 24. Now in the question it said that all terms of x are positive integers. So that means that it can't be the negative number, so it's going to have to be that's equal to 24. So x is equal to 24. And that's it. Okay, let's have a look at our next topic. So our next topic is algebraic proof, and that's video 365 in Corbettmaths. So here's an algebraic proof question. We're going to look at two different types of algebraic proof questions in this video. We're going to start off by looking at this type of one, where we're trying to show that this is a multiple of 8, and then we're going to look at a question which involves odd and even numbers. So here we've been asked to prove n plus 6 close bracket squared minus n plus 2 close bracket squared is a multiple of 8. So let's expand this and see what we get. So we've got n plus 6 squared, so that's going to be n plus 6 brackets n plus 6, and we're going to take away n plus 2 multiplied by itself, n plus 2. So let's expand this and simplify. So n times n is n squared, n times 6 would be plus 6n, 6 times n is plus 6n, and 6 times 6 is plus 36. And then we're going to take away, now I'm going to expand this, but I'm actually just going to put the answer in a bracket just to remember that I'm taking away the whole thing. So n times n is n squared, n times 2 is plus 2n, 2 times n is plus 2n, and 2 times 2 is plus 4. Now let's simplify. We've got n squared plus 6n plus 6n, so it's going to be n squared plus 12n plus 36. And then we're going to take away, and then we've got n squared, and we've got 2n plus 2n, that's going to be plus 4n, and then we've got plus 4. So we've got n squared plus 12n plus 36, take away n squared plus 4n plus 4. So we need to take away the n squared, 4n, and 4 away from what we have here. So n squared, take away n squared, will be just 0. So we've got 12n, take away 4n. 12n take away 4n will be equal to 8n. And finally, we've got 36 take away 4, and 36 take away 4 is equal to 32. So whenever we expand this and simplify it, we get the answer of 8n plus 32. So if we just factorize this and take our 8 out, we get 8 bracket n plus 4. And that means that this would be a multiple of 8 because we've got 8 times something. So that means that, and that's it. So because we have been able to expand it and then factorize and take 8 out, that means it's 8 times something, so therefore it will be a multiple of 8. And that's it. Okay, let's have a look at our next question. So our next question involves odd and even numbers. Now, whenever I'm dealing with algebraic proof, if I wanted to use an even number, I wouldn't just use n because n is a number. It could be 1, 2, 3, 4. That could be either odd or even. So if I wanted to have an even number, I would multiply this number by 2. Because if I do 2 times a number, the answer is always even. So that would be an even number. So 2n is even. And if I wanted an odd number, now I could minus 1 and say it's 2n minus 1. I like to add 1. I'm quite a positive person. I like to add 1. So I'm going to do 2n plus 1. Because if I know that 2n is even, 2n plus 1 would have to be odd. So that's what I would use if I was asked to use even numbers or odd numbers. I would use 2n for an even number and 2n plus 1 for an odd number. Now in this question we've been asked to show that the sum of two consecutive odd numbers is even. So it's consecutive odd numbers. So let's use our first odd number. Let's let our first odd number be 2n plus 1. So that's our first odd number. Now it's consecutive odd numbers, so I want to find the next odd number. Now if I added 1 to this, that would be even, because obviously 2n plus 2 would be even. So the next odd number would be 2n plus 3. They will be two consecutive odd numbers where you got 2n plus 1, meaning an odd number, and then if we add 2 more, we then get to the next odd number, so that would be 2n plus 3. So they are two consecutive odd numbers, and we've been asked to prove that the sum of these two odd numbers is an even number. So let's add them together because of the sum. If the question said product, we would times them together, but in this question we're asked to show that the sum of two odd numbers is even. If the question said product, you'd multiply things together. If the question said difference, you would take them away, and so on. So let's add these together and see what we get. 2n plus 2n is equal to 4n, and 1 plus 3 is equal to 4. So if we add two consecutive odd numbers, 2n plus 1 and 2n plus 3, we get 4n plus 4. Now, as you can see, if you factorize this, we want to show it's even, so let's take a factor out. Let's take 2 out, and that's going to be 2 times. And if we divide both of these by 2, we get 2n plus 2. So that's 2 times something, and 2 times something is always even. So therefore, and that's what I've written down, the sum of two consecutive odd numbers, 2n plus 1 and 2n plus 3, is always even, because whenever we added them together, we got 4n plus 4. We're able to take 2 out as a factor, so it's 2 times something, so therefore it's even. And that's it. Okay, let's have a look at our next topic. Our next topic is frequency tree. So here's a frequency tree, and we've got morning appointment, evening appointment. So we've got there's 40 appointments altogether. We know there's 23 in the morning and there's some in the evening. And then we've got on time, late, on time, late. So we've got 40 appointments altogether, 23 are in the morning. So if we do 40 take away 23, we'll find out how many evening appointments there were. So 40 take away 23 is 17. So there must have been 17 evening appointments because they need to add together to be 40. Now if we focus on the 23 morning appointments, 21 were on time. So that means there must have been 2 that were late, because 21 plus this number must be 23, so that must be 2. And in the evening appointments, where there was 17 altogether, 5 were late, so if we do 17 take away 5, that's 12. So 12 must have been on time. And that's it, so we've completed the frequency tree. And video 376 on Corbettmaths will give you more information on that. Okay, let's have a look at our next topic. So our next topic is two-way tables. And if you want to revise two-way tables, it's video 319 on Corbettmaths. So here we've got a two-way table. We've got some subjects at the top, English and art, and then total. And then we've got our information about whether they passed the course or failed the course. And again, we've got total at the bottom. So we've been asked to complete this two-way table. Well, we haven't, but I'm saying it now. We're going to complete this two-way table. So we've got, first of all, let's look at art. We've got 12 students that have failed art out of 19 in total. So 19 students studied art and 12 of them failed. So it must have been quite a hard test. And we can find out how many students passed, because we know there's 19 altogether and 12 failed. So if we take that 12 away from 19, that leaves us with 7. So 7 students must have passed the art course. Next, well, I'm looking at this top row here for how many students passed English and art, and we can find this total. We know 25 students passed English and 7 students passed art, so if we add those two together, we can get the total. 25 plus 7 is 32. So 32 students passed their courses. Next, I'm looking at these total. So we know 32 students passed the course and 13 failed their course. So if we add together the 32 and the 13, we can see how many students there are in total. So 32 add 13 is 45. So let's put that in. Next, let's look at the students that failed their courses. Well, altogether 13 students failed their course and 12 of them were from art. So that means that only 1 student failed English. So that means that we've got that number of 1. And then finally, how many students studied English in total? Well, we've got 25 that passed and 1 that failed, so altogether that'd be 26. And let's just check our answers. 26 plus 19 is 45. Okay, let's have a look at our next topic. So our next topic is composite bar charts, and that's video 148A on Corbettmaths. So here's a composite bar chart, and it's a bar chart, but as you can see, each of the bars is split up into different sections. So we've got this bar for January, and if we have a look at our key, in pink we've got hot drinks, and in grey we've got cool drinks. We've then got for February the hot drinks and the cool drinks, and for March we've got the hot drinks and the cool drinks. And we're told this composite bar chart shows us information about the number of drinks sold over 3 months. So if we look at the bars and we look at the totals, in January we can see the 600 drinks sold, in February we can see the 650 drinks sold, and in March the 750 drinks sold. But also, because it's a composite bar chart, we can actually see the breakdown of cold drinks and hot drinks sold as well by looking at each of these regions. So for instance, for January there's 450 hot drinks sold and there's 150 cold drinks sold, and we can see the same for February and March. And the question says, in which 2 months were the same number of hot drinks sold? So let's have a look at our key. In the question, we wanted to find the 2 months that got the same number of hot drinks sold. So that's going to be the pink sections of each bar. So if we look at the bar for January and the bar for February, they both go up to 450. So that means that in January there's 450 hot drinks sold, and in February there's 450 hot drinks sold. Whereas in March there's not as many hot drinks sold, maybe it's a bit warmer, and in March there's only actually 300 hot drinks sold. So in which 2 months were the same number of hot drinks sold? That will be January and February. Next topic is pie charts. So here we've got a table, we've got rugby team, and we've got frequency. So 90 rugby fans were asked which team they supported: England, France, Ireland, Scotland and Wales. And we've got 20 supported England, 5 supported France, 15 supported Ireland, 25 supported Scotland, and 25 supported Wales. Okay, and we're going to draw a pie chart for this information. So if you draw a pie chart, typically there'll be a circle drawn for you, with a line there going from the center up to the top for you. And we're going to draw a pie chart for this. So to draw a pie chart, the first thing you need to do is add up the frequencies. Well, we know there's 90 rugby fans, so if we add them all up, we'll find there's 90. Then we need to divide the whole circle, 360, by that number of people. So 360 divided by 90 is equal to 4. So that means that each person is given 4 degrees in the circle. So each person is 4 degrees. Now 20 people supported England. Now each of those people get 4 degrees, so if we multiply that by 4, we'll see what sides of angle they should have in the pie chart. 20 times 4 is equal to 80. So the angle we're going to draw for England fans would be 80 degrees. Next, we're going to multiply 5 by 4, and we're going to multiply all these numbers by 4 because each person gets 4 degrees. So we're going to multiply by 4, multiply by 4, multiply by 4, and multiply by 4. So 5 times 4 is 20 degrees. So we'll draw 20 degrees for the French fans. 15 times 4 is 60 degrees for the Irish fans. That should be much bigger. Then we've got 25 times 4. 25 times 4 is 100, so 100 degrees for the Scottish fans. And 25 times 4, 25 times 4 is 100. And then we've got all our angles. Now I like to add these up to make sure I get 360. 80 plus 20 is 100, plus 60 is 160, plus another 100 is 260, plus another 100 is 360 degrees. And that's it. So whenever you draw on a pie chart, you need to add up the frequencies, then divide 360 by the total frequency to find the number of degrees per person or per item or whatever you're looking at, and then multiply all the frequencies by that number to find the angle you should draw. Okay, so we're going to draw 80 degrees for the English fan. So let's start off by going to our pie chart, and we're going to get our protractor, and we're going to line it up like so. So that the cross goes in the center of the circle, like so, and then the 0 goes at the top. And we're drawing an 80 degree angle, so we're going to go around to where 80 degrees is. So that's here, and we'll do a little dot. Now you'll move your protractor and you will draw a nice straight line. So let's move our protractor, and you draw a nice straight line from the center through that point to the edge of the pie chart, like so. So that's for the English fans. So let's label it for English fans, so England, so like so, and that's that sector done. And it's an 80 degree angle, so we can put that in as well if we want to. Next, we're going to draw an angle of 20 degrees for the French fans. So we're going to get our protractor, we're going to have to turn it so that we put our 0 along the line we've just drawn. You always put the 0 on the line you've just drawn, or if there's no lines there yet, the one at the top. So we started off with the 0 at the top line because that was the only line. Now we've drawn this line, we're going to put 0 there, and we're going to draw an angle of 20 degrees. So we go to 0, we go around to where 20 degrees is. So that's here, so put a dot, and then move our protractor and draw a nice straight line through there with a ruler and a pencil. So it looks something like that. So that's 20 degrees. You don't necessarily need to put the angles in, but we do need to put it in. We do need to label that it's France. Okay, next was Ireland, and if we go back and look, that was 60 degrees. So we're going to get our protractor, we're going to turn it, so the 0 is along the line we've just drawn, so we're going to rotate it slightly. Again, the cross has to go in the center of the circle, and 0 is on the line, like so. And then we're going to go from 0 around to 60 degrees for the Irish fans, so to there, 60. Move our protractor. So move our protractor and draw a nice straight line from the center of the circle through that point and to the edge. And again, what we're going to do is we're going to label it for Ireland. And we can put the angle in if we want to, so that's 60 degrees, so you don't need to do that bit, but again, label it for Ireland. Next was the Scottish fans, so that was 100 degrees. So again, take our protractor and rotate it so that the 0 is on that new line. Like so. So start off with 0 and we're going to go around to 100 degrees. So we're going to start on the outside, go around 10, 20, all the way around to 80, 90 and 100. So remember, we are dealing with the outside numbers here, so don't look at this in inside 100. We're dealing with the outside numbers, so we're going 0 all the way around to 100 there. Again, move our protractor and draw a nice straight line from the center of the pie chart through that point to the edge. And that will be for the Scottish fans, so Scotland, to 100 degrees. And finally, the last sector will be for Wales. That should be already drawn for us for 100 degrees because that's all that's left. But let's check it. So let's take our protractor and rotate it. And when you do that, you can clearly see that is 100 degrees. And that's it. Okay, so we've had a look at drawn pie charts. Now let's look at reading them or interpreting pie charts. And that's video 164 in Corbettmaths. So we've been told 180 Year 8 students were asked how they travel to school, and the pie chart shows their responses. So we've got bus, some travel to school by bus, some walk, some travel by car, and some cycle. And we're asked what fraction of the students travel by bus. So sometimes when we're given a pie chart, we're asked to find a fraction or a percentage. So we could be asked what fraction of the students walk to school, or what percentage of students travel by bus to school. And to do that, what we're going to do is we're going to look at the whole circle, the whole pie chart, and figure out what percentage or what fraction is that region. So if we look at this sector for bus, we can see it's got a right angle. That means it's a 90-degree angle, and a 90-degree angle will be a quarter of a full circle. So that means that this is a quarter off the pie chart. So what fraction of students travel by bus? A quarter of them. If we were asked what percentage of students travelled by bus, that would be 25%. If we were asked what fraction of students travelled by car, we would write 80 out of 360, or 80 over 360, and then just cancel it down. So our next question says, how many students walk to school? So we've got 120 degrees for walk, so that's going to be a third. So we need to work out a third off 180. We're just going to do 180 divided by 3. It's equal to 60. So that means that 60 students walk to school. Okay, let's have a look at our next topic. And our next topic is scatter graphs, and they are videos 165 up to 168 on Corbettmaths. So here's a scatter graph, and it shows the cost of 10 plumbing jobs. So we've got these 10 plumbing jobs. You've got the duration from 0 up to 5 hours, and the cost from 0 up to £300, and you've got all the points there. And our first question says, what type of correlation is shown? So because the points are going upwards, in other words, as the hours are going up, the cost is going up, that is a positive correlation, so positive. So if the points were coming downwards in this direction, it would be a negative correlation. And if the points were just scattered around everywhere, that would be no correlation. Okay, our next question. Our next question says, draw a line of best fit. And I've just drawn a line of best fit like so. I've got my ruler and a pencil. I've drawn a line going straight through as many of the points as possible, or as close to the points as possible. This point here is an outlier, so I've just ignored that one. And I've drawn my line of best fit, so it's as close as possible to these points. So I've tried to sort of minimize the distance between my line and all the points that I've been given. Our next question says, estimate the cost of a job lasting 2.5 hours. So if we go down to our horizontal axis here for hours, 2.5 hours would be here. And if we get our ruler and pencil, and so use a ruler and pencil whenever you're doing this, and go up to the line of best fit, and then go across, you can clearly see that the cost would be £150. So our estimate for the cost of a job lasting 2.5 hours would be £150. Next, the question says, estimate the duration of a job costing £180. So if we go to £180 on the vertical axis here, and we get our ruler and pencil, and we draw across to our line of best fit, and then we draw down, we can see that's 3.5 hours. So our answer would be 3.5 hours. And that's it. Okay, so we've drawn a line of best fit, and we've used that to make some estimations. Okay, let's have a look at the next part. The next part says circle the outlier. So here we've got a scatter graph, and you can see this point just stands out. It just stands out from all the rest, so it's what we call an outlier. Okay, and another type of question we could encounter whenever we're looking at scatter graphs is a question like this. So here we've got our scatter graph. We've got hours along the bottom. We've got 0, 1, 2, 3, 4, 5. So this is the cost of a plumber, and we've got the cost of the job going from 0 all the way up to £300. So it's going 0, 30, 60, 90, 120, and so on. And as you see, the most expensive job we've got here is this job here, which is for 5 hours, and it's just below £240. And the question says here, explain why it might not be sensible to use this scatter graph to estimate the cost of a job lasting 18 hours. Now if you have a look here, the hours we've got for the jobs we've been given only go up to 5 hours. Now if this job would be 18 hours, that's a very long job. It might not actually be a 1-day job, or maybe a 2 or 3 day job, and the plumber may have to add in more travelling costs if he's going back and forth to do that job. So whenever we're dealing with scatter graphs, we've got to be very careful whenever we're using the line of best fit. So if we were to use this line of best fit for this scatter graph to estimate the cost of a job that lasts in between 0.5 hours and 5 hours, that would be okay, because that's what we call interpolation, where we're going inside the data that we've been given. But if we go beyond the data that we've been given, then we've got to be quite careful. So I've just written down it's beyond the range of the given data. It's extrapolation. So if we go beyond the data we've been given, it may not carry on in the same trend. So it might not be sensible to use lines of best fit to make estimates there. That's it. Okay, so our next topic is frequency polygons. Frequency polygon is the topic where there's a bit of difference between the exam boards, where Edexcel
Edexcel says you should know frequency polygons, whereas AQA and OCR don't mention frequency polygons. So if you're studying for Edexcel, you're going to have to watch this section. It should take a minute or two. If you're studying for AQA and OCR, you may want to skip on, but then again, it's only a minute or two, so I'd probably watch it anyway just to see what frequency polygons are, and they're not that complicated. So let's have a look at frequency polygons. That's videos 155 and 156 on Corbettmaths. So here we've got a table, and we've got time, 0 to 20 minutes, 20 to 40 minutes, 40 to 60 minutes, 60 to 80 minutes, and 80 to 100 minutes. And we've been given some frequencies for them. So there's 5 times that are between 0 and 20 minutes, 11 times between 20 and 40, and so on. So to draw a frequency polygon, what we're going to do is we're going to plot the frequencies in the midpoints of each of the categories. So if we've got 0 to 20 minutes, we're going to go to 10 minutes, and then we're going to go up to 5. So we're going to go 10 minutes and up to 5. Next, between 20 and 40 minutes, well, 30 minutes is in the middle, that's the midpoint, so we're going to go 30 across and 11 up, so 30 across and 11 up. Now, whenever you're dealing with how far up to go, make sure you know the scale. So if we have a look, there's 10 boxes for 5, that means each little box is 0.5 here. So we're going to go 30 across, we're going to go up to 10, and then we're going to go up 2 more boxes to get to 11, so we're going to go to there. Now, our next one, we've got between 40 and 60, so it's going to be 50 across and 20 up, so 50 across and 20 up. Next, we've got between 60 and 80, so that's going to be 70 across and 15 up, so 70 across and 15 up. And finally, we've got between 80 and 100, that's going to be 90 across and 9 up, so 90 across and then 9 up would be, well, we've got 10 here, each little box is 0.5, so we want to go down 2, and then that would be there. So we've plotted our points, now what we're going to do is get our ruler and our pencil, and we're going to join them up, so like so. And that's it, that's our frequency polygon. One thing to note is not to join up the first point and the last point, you're only joining up the consecutive points, so you join up the first one to the second to the third to the fourth, and the fourth to the fifth. So it's a frequency polygon like so, don't join up these points. And that's it. Another thing you could be asked to do with frequency polygons is to compare them. So this could be the times for class A. We could also have on the same grid another frequency polygon for class B, and you could have a look at them and compare them and see, which class was faster whenever you look at their frequency polygons.
Okay, sometimes we're asked to find the mode from a table. So here we've got some information, and we've got the age of some people, and they're 5, or people, or animals, or whatever it is, with the age of something, and the ages are 5, 6, 7, and 8, and we've got the frequency. So there's 2 5-year-olds, 2 6-year-olds, 5 7-year-olds, and 1 8-year-old. Now, whenever you find in the mode from a table, it changes the word from often the mode age to the modal age. And we're trying to find the modal age, that just means the most common age. And remember, we had 5 7-year-olds, so that means that was the most common age. So the mode here would be the one with the highest frequency, which is 7. So the mode, or the modal age, is 7. Our next topic is finding the mean from a table. So we want to find the mean from this table, and remember, to find the mean we add up all the values and divide by the number of values. So we want to find the grand total. Now if there's 2 5-year-olds, I add on this column called the FX column, and that stands for the frequency multiplied by whatever column this is. So if there's 2 5-year-olds, well, 5 plus 5 is 10, but another way to do that is just 2 times 5, and 2 times 5 is 10. If there's 2 6-year-olds, we could do 6 plus 6, but 2 times 6 is 12, so 12. If there's 5 7-year-olds, well, 5 times 7 is 35. And 1 8-year-old, well, that's going to be 1 times 8 is 8. So we find this column called the FX column, and it's found by multiplying the frequency by whatever the values are in the table. And then if we add that up, we will get the grand total, and that's equal to 65. So if you added up all the ages, that would be 65. Now we need to divide that by how many people there were. Well, if we look at the frequencies and add those up, so 2 plus 2 is 4, plus 5 is 9, plus 1 is 10. So altogether there was 10 people. So if we do the total, which is 65, divided by 10, that would tell us the mean age. So 65 divided by 10 would be 6.5. So the mean age is 6.5. Okay, our next topic. The next topic is to find the median from a table. So the median is the middle value. So if you look at this table, we're trying to find the middle value. So one way to do it is to arrange them all in order. So there we've got all the ages, and then we want to find the median, or the middle one, so we can then just work out the middle one. So the median would be 20. So that's one way to do it, is to list down all the ages in one list and then just find the middle one. So another way to do it though is we can consider the frequencies. Now altogether we've got 2 people, 3 people, another 13 people, and 1 person. So if you add those up, you'll find there's 19 people altogether. And if we were to line up 19 people, well, the median person would be the 10th person. So if you had 19 people, you could add 1, which is 20, and divide by 2, which would be the 10th person. And the 10th person, if you line these people up in order of age, the 10th person wouldn't be in here. There's only 2 18-year-olds. The 10th person wouldn't be here because there's only 5 so far, and the 10th person would definitely be in this group of people, so the 10th person would be 20 years old. Okay, our next topic is to look at the combined mean. So to work out the combined mean, let's just make sure we know what the mean is. So the mean is found by adding up all the values and dividing by the number of values. So that's going to be very useful. And what's also useful is if we know the mean is found by adding up all the numbers and dividing by the number of numbers, if we have the mean and multiply by the number of values, that will give us the grand total. So that's very useful as well. Okay, so our question says, there's 20 students in class A and 10 students in class B, and they sit the same test. The mean test score for class A is 60, and the mean test score for class B is 40. And the question says, work out or calculate the mean test score for all 30 students. So we're going to do this question by considering if we know what the mean is for class A and we know how many students there are, we can find out the total number of marks received by class A, by the students in class A. So we know the mean score for class A is 60 and we know there's 20 students. So if we do 60 times 20, that gives us 1,200. That means there are 1,200 marks obtained by the students in class A altogether. That's the total number of marks scored. And if we divided that by 20, we get the mean score of 60. So that's the total for class A. Now let's get the total for class B. So their class average was 40 and there's 10 students. So if we multiply 40 by 10, that's 400. So that means in total, the 10 students in class B scored 400 points or 400 marks altogether. So if we add together the 1,200 and the 400, that tells us how many marks were received by all 30 students altogether in this test. So 1,200 plus 400 is 1,600. Now we're trying to work out the mean score for these 30 students. So if we divide the grand total, the 1,600 by 30, we will get the mean test score for these 30 students. So 1,600 divided by 30 is equal to, that'll be 53.33333 so on, or 53.3 reoccurring, or let's just round our answer to two decimal places, so 53.33, and that would be the mean test score to 2 decimal places. And that's it. So whenever we're working out the combined mean, it's very useful to be able to work out the grand total, and that can be found by taking the mean and multiplying it by how many people were involved with that mean, and that will tell you the total, and that will be very useful. And if you want to watch the video on this on Corbettmaths, it's 53A. And just remember, you do have that bumper pack of questions, that practice booklet, which has loads of questions, and there'll be questions on that on the combined mean also. Okay, our next topic. Okay, let's have a look at our next topic. Our next topic is called the estimated mean, and that's video 55 in Corbettmaths. It's one of my favorite topics, and we've been asked to work out an estimate for the mean age. So we've got a group of people, and we know that there's 9 people from 0 up to 10. We've got 13 people from 10 up to 20. We've got 16 people from 20 up to 30, and we've got 2 people from 30 up to 40. And we've been asked to work out the mean age. And remember, to work out the mean age, we add up all the ages and we divide by the number of people. Let's actually start up by finding the number of people, and to do that, so we'll add up 9, 13, 16 and 2, and that's equal to 40. So we know there's 40 people. Now we want to add up their ages and divide by 40, the number of people. But unfortunately, we're not able to do that in this question because we don't actually know all their ages. We've made this group frequency table to make the data a bit more easier to interpret, but unfortunately, we're not going to be able to work out the exact mean. That's why the question says an estimate for the mean age. Okay, so we've got 9 people that have an age from 0 up to 10. We don't actually know their ages. They could be 4, they could be 8, they could all be 9-year-olds. We don't actually know, but what we're going to do is we're going to choose a fair age, or a representative age for these people. Because they're from 0 to 10, we're going to use the midpoint, which is 5 years old. We're going to add a column on called midpoint, and that will be the age that we're going to use for these people. So for the 0 to 10-year-olds, we're going to pretend that they're 5 years old each. We're going to pretend there's 9 5-year-olds. We don't actually know their ages. That's the fairest thing to do. Now we've got 13 people with an age between 10 and 20, so let's use the midpoint of 15. And for 20 to 30, the midpoint would be 25. And for 30 to 40, the midpoint would be 35. What we're going to do is we're going to just do 9 times 5. So we're going to do 9 times 5, 13 times 15, 16 times 25, and 2 times 35. So that tells our estimate for the total ages of the 9 people between 0 and 10, the 13 people between 10 and 20, and so on. So we'll call this column fx. And whenever you're doing the estimated mean question, you'll add on a column for midpoint, and you'll add on this fx column, and you'll times the midpoint by the frequencies, and that will tell you your fx column. So 5 times 9, or 9 times 5, is 45. 13 times 15 is 195. 16 times 25 is 400. and 2 times 35 is 70. So we've completed our fx column. Now what we're going to do is we're going to add those up to find our estimate for the grand total. So 45 plus 195 plus 400 plus 70 gives us a total of 710. So our estimate for the total of the ages would be 710. Now what we're going to do is we're going to divide that by the total frequency. So the grand total divided by the total frequency gives us our mean, our estimated mean. So 710 divided by 40 is equal to 17.75. So our estimated mean age is 17.75 years old. And that's it. Sometimes we've grouped frequency tables. What we need to do is find the modal class interval. So remember the word modal, it's similar to mode, and that just means the most common class interval. So the most common class interval, well, we just look at the frequencies. So we can see that this category with 16 as the frequency is the most common. So that means that this is our modal class interval. So D is larger than or equal to 20, but less than 30. And that's it. Okay, let's have a look at our next topic. So our next topic is finding the class interval that contains the median. So here we've got a grouped frequency table with duration going from 0 up to 10, from 10 up to 20, 20 up to 30, and from 30 up to 40. And we've got the frequencies and all together, and if we add up these frequencies, there's 40 altogether. And we've been asked to find which class interval contains the median. So if we knew these 40 durations, and if we wrote them all out, we're asked which of these categories, from 0 to 10, from 10 to 20, from 20 up to 30, or from 30 up to 40, would the median lie in? Would it be in this category, this category, this category, and this, or this category? Now straight away I can see this is not going to be in the first category, because there's 40 altogether. And so because there's 40 altogether, if we divide 40 by 2, that gives us a rough idea as to where the median would be. So 40 divided by 2 is the 20th. So the median would be roughly the 20th value. And because this is group data and we don't actually know the actual numbers, we may as well just use that 20th value. Now strictly speaking, if we knew all the values and we could write them all out, and there's 40 numbers, we would do 40 plus 1, which is 41, and we would divide that by 2. 41 divided by 2 is equal to the 20.5th value. So if you had 40 people and you'd lined them all up and we wanted to find the median would really be the 20.5th value. But for grouped frequency tables where you don't actually know the values anyway, where it's just 9 people in between these values, 13 in here and so on, we can just divide this frequency by 2. So that's the 20th and find where the 20th one is. So normally in a question like this, the 20th and the 20.5th value will be in the same category anyway, just to make sure that, you know, whenever they're making the questions that, you know, you don't have a sort of a difference, so that if students went for this value or if students went for the 20th one, they would design the question so they'd be in the same category anyway. And let's just see if that's the case. So here we've got 9 people in the first category. Now we're looking for the 20th one. It's not going to be in there because there's only 9 people there. Now we've got another 13. Well, 9 plus 13 is 22. So up to the end of this category, there's 22 people. That means if you were to line up those people, someone in this category would be the median, or it would be either the 20th or the 20.5th value. And as you can see, that means that both of them would be in this category. So the question says, which class interval contains the median? Well, it's going to be this class interval, 10, which is less than or equal to D, which is less than 20. And that's it. Okay, let's look at our next topic. So our next topic is the median and finding the median from group data. Now, I use this topic or this approach a lot whenever I'm finding the median from a histogram. If I've been given a histogram and I'm asked to find the median or calculate an estimate of the median, I use this approach quite a lot. Also, if I was asked to find an estimate of the lower quartile and upper quartile and so on. And this is video 52 on Corbettmaths. So here we've got a group frequency table. We've got hours going from 0 to 5, 5 to 10, 10 to 15, and 15 to 20. And we've got the frequencies, 27, 44, 21, and 8. And if we add them together, all together there's 100. And what we're going to do is we're going to find an estimate of the median. So if I wanted to find an estimate of the median from this data, what I would do is I would use an approach called linear interpolation. So what I would do is I would find which group the median is in to begin with. So let's do that. Now, because this is group data, we're finding an estimate of the median anyway. I'm going to take the frequency and I'm just going to divide it by 2 to find the position of the median. Obviously, I could add 1 and divide it by 2, but because it's an estimate anyway, I just find it easier to just take the frequency and divide it by 2. So I'm going to take our 100 and I'm going to divide it by 2, so that's equal to the 50th number. So the median is the 50th number, the 50th person. So maybe this is the amount of hours spent revising for a test, and we're looking for the 50th person. That's the median.
So the 50th person wouldn't be in here. There's 27 people here. They've revised between 0 and 5 hours. Now the 50th person then would be in here because we've got another 44. If we line them up and we had 27 and then another 44, the 50th person would be in this group here. So the median is in this group. So now we know the median's in this group, we're going to use interpolation to find out an estimate of the median. So the formula for linear interpolation is the lower bound plus the number into the category divided by the number in the category times the class width. So in other words, now we know that the value is in this category, the lower bound, but the lower bound for this category is 5, so let's write that down, 5, and then we're going to add the number into the category. Well, we're looking for the 50th person. We know that the first 27 people are in this category, so we want to go another 23 people. So it's going to be 23 people into this category. So we're looking for the 23rd person in this category, that would be the 50th person overall, divided by the number in the category, so that's the 44 people. So this gives us the fraction into the class, and then times by the class width. And the class width is how wide the class is, which is 5, because from 5 to 10, that's going to width of 5. So if we do 5 plus 23 44ths times by 5, that would tell us our estimate of our median. And whenever I do that, I get an answer of 7.61363 and so on hours. And that's it. So that would be our estimate of the median. And that makes sense because if we think about it, the person we were looking for was the 23rd person into this group. Well, the 22nd person's halfway, and halfway in this group would be 7.5. 23 is just over, so that'll be 7.61363 and so on hours. And that's it. This approach can also be used to find an estimate for the lower quartile and upper quartile, even an estimate for the interquartile range. And if we wanted to find an estimate for the lower quartile, we would find the 25th person. So we would look at this group and we would use the same formula. If we wanted to find an estimate for the upper quartile, we would look for the 75th person and so on. And as I say, I use this technique a lot whenever I'm dealing with histograms, whenever I'm asked to find an estimate for the median or the lower quartile or upper quartile from a histogram. Now you could consider the squares and so on. I just find this approach can be quite useful in some situations. Okay, let's look at our next topic. Okay, let's have a look at our next topic. So our next topic is stem leaf diagrams. So stem leaf diagrams is one of the topics which differ really between the exam boards, where Edexcel cover stem leaf diagrams and frequency polygons, whereas OCR and AQA don't. If you're studying for OCR or AQA, it's only 2 minutes. I would probably watch it because it's good practice for the mode and the range and the median anyway, but feel free to skip ahead if you do OCR or AQA, but it's up to you. Okay. Our next topic is stem and leaf. So stem and leaf is a great way to represent information in order, so represent numbers in order. And we've got here, this would be videos 169 and 170 in Corbettmaths. And the question says, the following stem and leaf diagram shows the times taken for 15 people to complete a jigsaw. So we've got the key, and that's very important for a stem and leaf. So 3 line 1 means 31 minutes. So we're dealing with minutes here. And the question said, what is the modal time taken? So the modal is the most common. So we've got 31, 39, 40, and so on. So if you look here, we've got 57 and 57. So the modal time taken would be 57 minutes. The next question said, find the range of the times taken. So the range is the largest, take away the smallest. So the largest amount of time taken was 75 minutes. And we're going to take away the shortest time, which was 31 minutes. And 75 take away 31 will be equal to 44 minutes. So the range, the difference between the largest and the smallest, is 44 minutes. And the last question says, find the median time taken. So the median is the middle value. So I like to do this by crossing off the values in pencil, of course. So crossing off the smallest, and then the largest, the next smallest, which would be 39, then the next largest, 66, the next smallest, 40, 64, the next smallest, 43, the next largest, 63, the next smallest, 46, the next largest, 60, the next smallest, 51, the next smallest, 59, and then cross off, and we're left with 57. So the median time taken is 57 minutes. And make sure that with this 7, you remember it's 57. So it's 57 minutes. That's it. Okay, let's look at our next topic. So our next topic is called quartiles, and that's video 57A in Corbettmaths. Now, we've looked at the median before, and the median is the middle value. So if you've got a set of data, the median is the middle value. If you've got a set of data and you're looking for the quarter value, that's called the lower quartile. So if you arrange the values in order from the lowest to the highest, a quarter of the way into the data is called the lower quartile, and 3/4 of the way into the data is called the upper quartile. Now, those are very useful for working out a thing called the interquartile range, and I'll talk about that in a minute. So the median is the middle value, the lower quartile is a quarter of the way into the data, and the upper quartile is 3/4 of the way into the data. Now, to find the lower quartile, I tend to put them in order. I find the median, and then I find the median of the lower half of the data. And for the upper quartile, I again arrange them in order. I find the median. I work out the median for the upper 50% of the data. And also, I mentioned a concept called the interquartile range, and the interquartile range is worked out
by working out the difference between the upper quartile and the lower quartile. So if you do the upper quartile, subtract the lower quartile, we get the interquartile range. Now in maths, again, you've seen a topic called the range before, which is the highest value subtract the lowest value. But sometimes there's outliers, and that will affect the range massively. If there's one value which is really, really big, for instance, and the rest are much lower, whenever you work out the range, you get a really large range. Well, if we work out the interquartile range, so the difference between the 3/4 of the way through the data and 1/4 of the way through the data, and you subtract those, that will tell us how spread out the middle 50% of the data is. And that's really useful because it means that the effect of outliers is reduced or eliminated. So let's have a look at some data. So we've got 5, 5, 6, 8, 9, 10, and 12. And let's find the lower quartile, the upper quartile, and the interquartile range. So if I wanted to work out the lower quartile to begin with, well, first of all, we know that 8's the median. So 8's the median here. And then if we look at the bottom 50% of the data, we've got 5, 5, and 6. So the lower quartile would be 5. And in terms of the upper quartile, well, that would be 10. So the lower quartile would be 5, the upper quartile would be 10, and the median would be 8. And that's the lower quartile, and that's the upper quartile. And if we wanted to work out the interquartile range, we would just do the upper quartile, 10, subtract the lower quartile, 5, and that gives us an interquartile range of 5. Okay? Now these ideas of quartiles, lower quartiles, and interquartile range are very useful in a topic called cumulative frequency curves or graphs, and I'll talk about those in a second. So let's have a look at our next topic. Okay, so our next topic is cumulative frequency. So that's videos from 153 and 154 in Corbettmaths. So I'd highly recommend you watch those videos because this is a very important statistics topic. Now in terms of the words cumulative frequency, so the cumulative frequency is the run-on total. So here we've got our frequency table, and it's a group frequency table, and we've got the lengths of some items, and we've got 0 to 5 centimeters, 5 to 10, 10 to 15, 15 to 20, and 20 to 25. And we're given the frequency, so we know it's 3 in between 0 and 5, 10 between 5 and 10, 21 between 10 and 15, and so on. And sometimes we're asked to complete a cumulative frequency table. So it looks something like this. We've got the length, but this time instead of going 0 to 5 and 5 to 10, it goes 0 to 5, 0 to 10, 0 to 15, 0 to 20, and 0 to 25. And we may be asked to fill in the cumulative frequencies. So that's the run-on total. So we know there's 3 in between 0 and 5. So that means that the cumulative frequency would be 3. Now in terms of 0 to 10, well, we know there's 3 between 0 and 5, and 10 between 5 and 10. So if we add those together, 3 plus 10, that means there's 13 altogether between 0 and 10. Now, from 0 to 15, well, we know there's another 21, so if we add 21 on, we'll find the cumulative frequency. So 13 plus 21 is 34. We know there's another 4, so that's now going to be adding on 4, 38, and adding on 2 would be 40. So we've completed the cumulative frequency table. Now let's draw the cumulative frequency curve. Now, this is sometimes called cumulative frequency curve or cumulative frequency graph. I tend to call it the cumulative frequency curve because it's quite nice to draw a nice curve through it. So to plot the points for the cumulative frequency curve, we're going to plot each of these cumulative frequencies at the end of each of these groups. So we're going to go 5 across and 3 up, 10 across and 13 up, 15 across and 34 up, 20 across and 38 up, and 25 across and 40 up. We know these are the cumulative frequencies up to the end of each of these categories. So 5 across and 3 up, 10 across and 13 up, 15 across and 34 up, 20 across and 38 up, and finally 25 across and 40 up. So our points would look something like this. Now we're going to draw a curve. Now in terms of your curve, you're going to start at the bottom of the first category. So it starts at 0. So we're going to go start at 0 here. And we're going to go up and do a curve going through the points like so. And this is quite tricky on the computer, but it looks something like that. So that's our cumulative frequency curve. Now sometimes after we draw a cumulative frequency curve, we're asked to work out things such as the median, the lower quartile, the upper quartile, the interquartile range, and so on. So let's have a look at those now. So now we're going to find those medians, lower quartiles, upper quartiles, and interquartile range for a cumulative frequency curve that I've already drawn for us. And it's for pocket money. And altogether there's 600 children, and the pocket money goes all the way up to £12. Okay, let's start off by finding the median. So the median is the middle value. Now this is grouped frequency, so we can just divide the frequency by 2 to find the position of the median. So for 600, we're going to divide it by 2, so that's the third hundredth value. So we go to 300 on the cumulative frequency axis, and we'll go from 300 across the curve, and it looks something like this, and then down. And make sure you do that with a ruler and a pencil, and we'll find that we're exactly halfway between this 6 and this value here. That's £6, that's £8, so that's £7 in the middle, and we're exactly in the middle of those, so it's going to be £6.50. So our median amount of pocket money is £6.50. Now our lower quartile, well, altogether there were 600 children, and the lower quartile will be a quarter of the way into the data, so we're going to divide 600 by 4 to find the position of the lower quartile. So 600 divided by 4 is equal to the 150th value. So we're going to go from 150 across and down, and when we do that we get to £5, so the lower quartile is £5. The upper quartile, well, that's 3/4 of the way through the data. So we're going to work out 3/4 of 600, but we know a quarter is equal to 150. So if we do 3 times 150, that's equal to 450. So we're looking for the 450th. So if we go across from 450 and down, we get to £8. So the upper quartile is £8. And finally, we've been asked to work out the interquartile range, so that's how spread out the middle 50% of the data is. So the upper quartile is 8, the lower quartile is 5, so we're going to do 8 take away 5, and that's equal to £3. So the interquartile range is £3, and that's it. Okay, so let's have a look at some more questions that you may be asked on cumulative frequency. So you're often asked to find the median, the lower quartile, the upper quartile, and the interquartile range, but sometimes you're asked other questions, so let's have a look at another question now. So here's a cumulative frequency curve. It's the same one with pocket money and cumulative frequency. We've been asked to estimate how many people earned less than £6. So if we go from £6 up and across, we get to 240. So that means that up to £6 there was 240 children. So how many children earned less than £6? Well, the answer would be 240. And this is an estimate because this would have been group data and we don't know the exact figures, so this is why it's an estimate. Okay, our next question. Our next question says estimate how many people earned more than £3. So if we go from £3, which is in between 2 and 4, so here and up and across. So we've gone to £3, we've gone up and across, and that tells us that 40 children earn up to £3 pocket money. So in terms of an estimate for how many children earn more than £3, that should be the rest of them. So there was 600 altogether, so if we do 600, take away 40, that's equal to 560. So our estimate for how many children earn more than £3 pocket money would be 560. Okay, next question. Our next question says, estimate the amount of pocket money that 100 people receive less than. So we're going to go from 100 people across and down. And when we do that, we get to the second square across after the 4. So we know 5's there, so there's going to be 1, 2, 3, 4, 5. So there's 5 squares for £1. So £1 divided by 5 is 20p. So each square is 20p, and we've gone to the second one there. So it's going to be £4.40. So we've got £4.40. So that means that the 100 children who receive the least amount of pocket money will receive less than £4.40. And that's our estimate. Also, make sure you use a pencil and a ruler for this. I'm doing it freehand on the computer, so make sure you're using a ruler and a pencil whenever you're doing these questions. Okay, now next topic. So we've looked at cumulative frequency. Now cumulative frequency links into another topic called box plots, or sometimes you'll see them called box and whisker diagrams, but I tend to call them box plots, and that's video 149 and 150 on Corbettmaths. So this is a box plot, and a box plot has 5 vertical lines. We've got a line for the lowest value, a line for the lower quartile, a line for the median, a line for the upper quartile, and a line for the highest value. So we've got 5 vertical lines, and the 3 in the middle, the lower quartile, the median, and the upper quartile, are joined up into a box like so, where a line will go horizontally at the top and the bottom. And then there will be 2 lines going out to the lowest value and to the highest value like so. So this is called a box plot. And one of the benefits of box plots is you can see how the data is spread out, because between each pair of vertical lines, 25% of the data lies. So in between the lowest and the lower quartile, there'll be 25% of the data. Between the median and the lower quartile, another 25. Between the median and the upper quartile, another 25. And between the upper quartile and the highest value, another 25% of the data. So box plots are really useful ways to represent data. This is the Corbettmaths revision card, so if you do have that revision card, make sure you have that and you sort of learn it and bring it to school with you, and make sure that you know how to draw and to read a box plot. Okay, let's compare 2 box plots now. So here we've got 2 box plots, and they show the reaction times of 2 groups. So we've got group A and group B, and we've got their reaction times. The quicker someone's reaction times, the less time it takes. So values down to the left hand side here are really good. That means someone's got quick reaction times because it's taken less time to react. And values over to the right hand side means they're a bit slower. Now if I was to compare these box plots for group A and group B, the first thing I notice is the medians are the same. So that means that their average, the median, reaction time is the same. It's equal to each other. But another thing that I notice is that this group A is much wider. It means it's much more spread out. So it means there's some people with really fast reaction times, and then you've got some people with really slow reaction times. So they're much more spread out, and you can see that by particularly the box itself, because that represents the middle 50% of the data, and it goes from 0.2, the lower quartile, up to 0.35. So the interquartile range here would be 0.15. Whereas if we have a look at this box, the interquartile range is much smaller, because our lower quartile is 0.24 and our upper quartile is 0.33, and if we take those away, that's much smaller. So if I was comparing two box plots, I would first of all look at the medians and see how they compare. So here we can see the medians actually equal to each other, so it tells you the average is the same, but you can see that the data is much more spread out for group A than group B. Our next topic is histograms. So a histogram is a way of representing group data, and here we've got our group data, and it's a way of representing it and in a fair way whenever you've got categories that have got different sizes. So as you can see here, we've got time 0 to 2, 2 to 4, 4 to 6, 6 to 10, 10 to 14 and 14 to 20. So as you can see here, we've got groups that are quite small. So the first group's only got a width, a class width of 2 seconds. It's only 2 seconds wide from 0 to 2. But the last group goes from 14 to 20, so it's actually got a width of 6. So it wouldn't be fair to draw a bar chart because some of the categories are much bigger or much wider than the other categories. So you draw a thing called a histogram. And the histogram looks at the frequency density. And the frequency density is found by doing the frequency divided by the class width. Now just before I go on, histograms is a very important topic, so if you go to videos 157 to 159 in Corbettmaths, you'll see me talk about histograms in great detail. So what we're going to do is we're going to start off by drawing a histogram for this grouped frequency table. So if we want to draw a histogram, we're going to work out a thing called frequency density. So let's put a column on for frequency density. So I'm going to write FD, standing for frequency density here. So we've added on a column for FD, or frequency density. Now what we're going to do is we're going to work out the frequency density for each one of these groups or classes. So from 0 to 2 seconds, well, that's got a class width of 2. It's 2 wide. It's got a frequency of 10. So if we do 10 divided by 2, so the frequency divided by the class width, 10 divided by 2, so 10 divided by 2, that gives us a frequency density of 5. So this category has a frequency density of 5. Our next category, well, it's got a frequency of 13, and it's got a class width of 2. It's 2 wide, going from 4 to 2. 4 take away 2 is 2. So we're going to do 13 divided by 2. So 13 divided by 2 is equal to 6.5. Our next group, well, again, its frequency is 18, and its class width, well, it goes from 4 to 6, so its class width again is 2. So we're going to do 18 divided by 2, and 18 divided by 2 is 9. Our next group, it's going from 6 to 10, so it's got a class width of 4 because it's 4 wide, and it's got a frequency of 16, so we're going to do 16 divided by 4 because we do the frequency divided by the class width, that's 4. Next, the next category has got a frequency of 8, and we're going to divide that by the class width, where that's equal to 4 because it's 4 wide. So 8 divided by 4 is 2. And finally, our last group has got a class width of 6 because it goes from 14 to 20. That's 6 wide. And its frequency is 6, so we're going to do 6 divided by 6, which is 1. So we've got our frequency densities. Now what we're going to do is we're going to draw a histogram. So we're going to draw bars for each of our groups. So our first group is from 0 to 2. So we're going to do a bar going from 0 to 2 and having a frequency density of 5. So it's going to go up to 5. So with a ruler and a pencil, you'd go draw a line from 5 across. With a ruler and a pencil, you draw down and you draw your bar like so. So that is your bar going from 0 to 2 and with a frequency density of 5. Our next bar, well, from 2 to 4, it's going to go up to 6.5. So from 2 to 4, well, we actually need to make our bar a little bit higher. So we're going to go now up to 6.5. So it's going to be halfway between 6 and 7. So that's there. We're going to go across to 4 and then down. Our next bar, well, from 4 to 6 goes up to 9. So from 4 to 6, we'll go up to 9. So again, we need to make that bar a bit higher. We're going to go up to 9 now, across and down. So we've done from 0 to 2 up to 5. We've done from 2 to 4 up to 6.5. And we've done from 4 to 6 up to 9. Now we're going to do from 6 to 10 and with a frequency density of 4. So from 6, which is here, to 10, we're going to have a bar that goes up to 4. So we'll draw across to 10 and then we're going to go down like so. So that bar from 6 to 10 has got a height of 4. Next, we're going to go from 10 to 14, and that's got a height of 2. So from 10 to 14, we're going to go across from 2 and down And finally, the last group goes from 14 to 20. So we're going to go from 14 to 20, and it's got a height of 1. So we're going to go make sure its height's 1, and we're going to go down like so. And that's it. We've drawn our histogram. So we've drawn our histogram for our group frequency table. Now, sometimes we're given a histogram and we might need to find out the frequency. Now, if we go back, frequency density was equal to frequency divided by Collatz width. If we wanted to make frequency the subject, we would multiply both sides by Collatz width. So that would give us the frequency density times Collatz width is equal to frequency. So the frequency is equal to the frequency density times the Collatz width. So in other words, if you multiply the height of each bar, the frequency density, by its Collatz width, how wide it is, you will find the frequency. So let's complete this grouped frequency table. So we've got our categories, 0 to 40. So as you can see, our first bar went from 0 to 40. Now, if we look vertically, we're going from 0 up to 1. There's 10 little squares. That means that each square is 0.1. So this bar has a height of 0.1, or frequency density of 0.1. And it's got a Collatz width from 0 to 40 of 40. Well, if we do the frequency density, 0.1 times by 40, that's equal to 4. So that means the frequency for this bar is equal to 4. So as you can see here, the frequency would be 4. Next, our next bar. Our next bar goes from 40 to 60, and its frequency density, well, it goes up to 2.4. So the frequency density is 2.4. So we're going to do 2.4 multiplied by the Collatz width, which is, well, from 40 to 60 is 20. So multiplied by 20 is equal to 48. So that means that this category from 40 to 60 has a frequency of 48. There was 48 people. And then our next category from 70 to 80, well, the Collatz width is 10. Its frequency density, well, it goes up to 3.9. So we're going to do 3.9 times 10. So 3.9 times 10 is 39. So it would have a frequency of 39. So to draw a histogram, we use the formula frequency density is frequency divided by Collatz width. So if you've been given a histogram and you want to find the frequencies, well, we would do frequency density times Collatz width. Okay, let's have a look at a typical histograms question now. So the histogram below shows information about the number of hours flown by some pilots. And we're told that 45 pilots flew for more than 400 hours. So we know that between 400 and 450 hours, there's 45 pilots in here. Okay, so our first question says to estimate how many pilots flew for under 100 hours. So if you have a look at our histogram, the first category goes from 0 to 200. So that's why the question says estimate, because whenever we had this group frequency table, it would have said 0 to 200 and it would have the frequency. So because it's group frequency, we don't actually know how many were between 0 and 100 or 100 and 200. So this is going to be an estimate. So if we have a look at this bar, let's work out the frequency for this bar. It's got a frequency density of 3.5 and the Collatz width is 200. It goes from 0 to 200. So if we do 3.5 multiplied by 200, that would tell us the frequency, and that's equal to 700. So that means there's 700 pilots in here. Now, under 100 hours, well, that would be half of the pilots. Well, our estimate, our guess will be it's half of the pilots. So we're going to do 700 divided by 2, and that's equal to 350. So that's our educated guess to how many pilots have flew under 100 hours. We do know the 700 that flew between 0 and 200 hours, and our estimate is that half of those, 350, have flew for under 100. Okay, our next question. Our next question says, what fraction of pilots flew between 200 and 400 hours? So we want to work out the fraction of pilots. So we're going to need to know how many pilots there are altogether. So let's get rid of that dotted line to begin with. And we know there's 700 in this bar. We've been told there's 45 in this bar because 50 multiplied by 0.9 is 45. So we know there's 45 in there. Let's work out how many pilots are in this bar and this bar. So for this bar here, it has a frequency density of 4.7. So a frequency density of 4.7 multiplied by a Collatz width of 100 would be equal to 470. So there's 470 pilots in here. And this bar has a height frequency density of 2.5. And again, the Collatz width is 100. 2.5 times 100 is 250. So we know the 700 pilots between 0 and 200, 470 pilots between 200 and 300, 250 pilots between 300 and 400, and 45 pilots between 400 and 450. We've been asked to find out what fraction of pilots flew between 200 and 400. So that's going to be altogether. So 470 plus 250, that's 720. Out of all the pilots altogether, so it's going to be 700 plus 470 plus 250 plus 45. That's equal to 1,465. And if I type that into my calculator, it'll simplify it nicely for me to 144 over 293. Okay, our next question. Okay, let's have a look at our next question. So our next question says, the histogram shows the heights of 2,400 trees. So we've got their heights in centimetres from 0 all the way up to 250. And we've been asked to find an estimate for the mean height. We've been asked to find an estimate for the median height. So if I was working this out, the first thing I'd want to know is the frequencies. So we've got the frequency densities of 8, 16, 20, and 5, and I would want to work out the frequencies for each one of those bars. So we've got here this bar 75, this bar would be 125, and yeah. Okay, so for the frequency for this bar from 0 to 75, well, I would do the frequency density 8 times the class width, which is 75. So it has a frequency of 600. Next, from 75 up to 125, it's got a class width of 50 times by 16 is 800. Next, from 125 to 150, that's a class width of 25 times by 20 is equal to 500. And finally, from 150 up to 250, that's 100 as a class width, times by 5 is equal to 500. And let's just add our frequencies up. 600 plus 800 plus 500 plus 500 is equal to 2,400, which we're told in the question, which is fantastic. So the question asks us to work out an estimate of the mean height and an estimate of the median height. Let's start off with the mean height. Now I'm actually just going to draw a frequency table, like so. And our frequencies were 600, 800, 500, and 500. And we've got our heights as 0 to 75, 75 to 125, 125 to 150, and 150 up to 250. Now we want to find an estimate of the mean. So remember, that's where we add on our fx column, and we do the midpoint times the frequency, midpoint times the frequency, and so on. So the midpoint for our first category from 0 to 75, well, that's going to be 37.5. So we're going to do 37.5 times 600, and that's equal to 22,500. Next, we'll do the midpoint. Well, the midpoint of 75 and 125 is 100. Times that by the frequency is 80,000. Next, we'll do the midpoint of 125 and 150, and that's 137.5. Remember, we can find the midpoint by just adding the numbers and dividing by 2. Times by 500 is equal to 68,750. And finally, we're going to do the midpoint of those numbers, which is 200, times by 500, which is equal to 100,000. Next, to find the estimated mean, we add up our fx column, so we find the grand total. And when we do that, we get 271,250. And then we divide that by the total frequency, but we're told in the question that's 2,400. So we could add up the frequencies, or we could just use the fact that we're told it in the question. So when we divide 271,250 by 2,400, the grand total divided by how many there are, that would tell us our estimate for the mean height. Remember, they're estimates because we're using the midpoints and we don't actually know the actual values. That's equal to 113.02 centimetres. And that's it. So that's our estimate of the mean. So that's the 2 decimal places, and that's it. Okay, next we were asked then to find an estimate of the median. Okay, so our next question says, find an estimate of the median height. So if we go back to our histogram and we look at each bar, its area represents its frequency, because the frequency density, the height of the rectangle, multiplied by the class width, the width of the rectangle, that gives us our frequency, or the area of the rectangle. So that means that the frequency is represented by the area of the rectangle. So that means that we can find the vertical line that we draw down, so that half the area of the histogram's on the left and half the area of the histogram's on the right. That means that we can read off and find out what the median would be. So let's find the area of this histogram. Now I could count the little tiny squares if I wanted to, but I'm actually going to count the bigger blocks, because I can actually see in this question that there's lots of these whole blocks, and each of the bars sort of is split up into these larger blocks, apart from obviously this one where I've then got half blocks. So if I count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. So there's 48 big blocks. So if I can find out where the halfway, the 24th block is, and divide it, so there's 24 blocks on the left and 24 blocks on the right, we can find out where the median would be. So let's find out where the 24th block would be. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 12 blocks in that one. So we need another 12. We've got 1, 2, 3, 4, 5, 6, 7, 8. Well, 12 plus 8 is 20. Now we need another 4 But we've got, if we look across here, we've got 1, 2, 3, 4, 5, 6, 7, 8. So we actually only need 4 blocks. That's half of those. So if we took our ruler and a pencil and we went halfway down here, that would mean that we would have 24 blocks worth on the left and 24 blocks worth on the right. And that value would be, well, it's in between 100 and 125 and exactly in the middle. So the median would be 112.5 centimeters, and that's it. So that's one way of finding the median. Now you may have been able to guess that that's not actually the approach that I use whenever I work out the median, just because I don't like counting the little blocks and trying to figure out where that line is. I use an approach called linear interpolation. So it's video 52 in Corbettmaths, and the formula for it is the lower bound plus number into category divided by number in category times class width. It sounds quite complicated, but it's not really. So it's lower bound plus number into category divided by number in category times class width. And let me explain what I mean by that. So we're looking for the median value. So if there's 2,400, we divide that by 2, because remember for group data, it's just an estimate anyway. So we can do 2,400 divided by 2 is equal to the 1,200 value. And if I was looking for the 1,200 value, I would look at my frequency table and I would say, well, the 1,200 value is not in the first category because there's only 600 in there. If I look at the next category, there's 800 in there. So altogether, if I work out the cumulative frequency, there's 1,400 trees altogether. So the 1,200th tree is in this category here. So we're going to look at this category and we're going to say, what's its lower bound? That's 75 plus the number into the category. We're looking for the 1,200th tree. So we've gone 600, we need to go another 600, so we need to go another 600 into this category. So we'll write 600, it's 600 into the category, divided by the number in the category, well that's 800, and then times by the class width. The class width is 50. So if we do 75 plus 600 over 800 times 50, we should get that median that we got before. And the answer is 112.5 centimeters, which is the same as before. The reason I like that formula is you can then work out the lower quartile, upper quartile, interquartile range really quickly and easily from histograms. And the formula is not actually that complicated. Okay, let's have a look at our last histogram question. This is the hardest histogram question we've got here. And it says 24 cars traveled faster than 40 miles an hour. So we know that 24 cars traveled faster than 40 miles an hour. And it says estimate the number of cars traveling between 25 and 35 miles per hour. So here we've got our histogram and we've got the frequency density going up vertically with no numbers. That's not going to be very helpful. And we've got our speed going across horizontally. And we've been told that 24 cars, so we know there's 24 cars in this bar here. And it says, or work out an estimate for the total number of cars traveling between 25 and 35 miles per hour. So we want to work out an estimate for how many cars would be in here. Now, first of all, what makes this question a lot harder than the previous ones is we don't know the frequency densities. So there's two different approaches you could use for this question. The first one, because we know that 24 cars travel more than 40 miles per hour, we know that the frequency for this bar is 24. So if you do 24, the frequency, divided by the class width, we can get the frequency density. 24 divided by 10 is 2.4. So we know the frequency density there would be 2.4. So we know the frequency density is 2.4. Now we can figure out our scale. So we've got 2.4s here. Well, there's 1, 2, 3 lines going up to that. So if we divide that by 3, that's 0.8. So 0.8, 1.6, 2.4, 3.2, 4, 4.8, and 5.6. So now that we've got our scale for our frequency density, we can now work out our estimate for how many cars are traveling between 25 and 35 miles per hour. So let's work out the frequency for this 20 to 30. So we would do the class width, which is 10 times 4. So that means there's 40 altogether in this bar. So that means that if we divided it by 2, there should be 20 in here. And likewise for this bar, this one going from 30 to 40 miles per hour. So we would do 10 times 5.6, which is 56. And if we divided that by 2, there'd be 28. And 20 plus 28 is equal to 20 plus 28 is equal to 48 cars. So that's our estimate for how many cars should be traveling between 25 and 35 miles per hour. So that's one approach. Now that question was quite nice because the information we were told is there's 24 cars traveling more than 40 miles per hour. So we were told the frequency for one of the bars. Sometimes in the question you might be given sort of, so many cars are traveling more than 35 miles per hour is a bit more complicated. Or another approach is to consider the frequency and to look at the area of that bar that represents that frequency. So as you can see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little squares going across. And there's 5, 10, 15 of those. So there's 150 little squares. So 150 squares equals 24 cars. You could then divide 150 by 24 and say, well, 150 divided by 24 is equal to 6.25. So 6.25 squares equals 1 car. Then you could look at the 25 to 35 region and see how many little squares there are in those. So as you can see, we've got 5, 10, 15, 20, 25 times 5. So there's 125 little squares there. And from 30 to 35, there's 5, 10, 15, 20, 25, 30, 35 times 5 is equal to 175. So altogether, there would be 125 plus 175, which is 300 squares. And if we divide that by 6.25, we can see how many cars it would be. So 300 divided by 6.25 is also equal to 48 cars. And that's it. Okay, let's have a look at a probability question. So here's our question. It says there are only pink, yellow, green and blue counters in a bag. So there's 4 different colors of counters in a bag. And the table shows the probability of picking each color. So the probability of picking a pink counter is 0.5. The probability of picking a green counter is 0.1. The probability of picking a blue counter is 0.2, and the question says find the missing probability, so that's the probability of picking a yellow counter. Because there's only pink, yellow, green and blue counters in the bag, there's no other colours, that means it's certain that we're going to pick one of these colours. So that means that these probabilities will add together to give us 1. So if we add up the probabilities that we know, so if we add those probabilities together, we get 0.5 plus 0.1 is 0.6. Plus 0.2 is 0.8. So that means the probability of picking a pink, green or blue counter is 0.8. So to find the probability found in the yellow, we're going to take this away from 1 to see what's left. So that means the probability of picking a yellow counter would be 0.2. And that's it. So the next topic is actually the probability of something not happening, and that's video 250 in Corbettmaths. The probability of something not happening is 1 take away the probability of it happening. And that will tell you the probability of something not happening. So here we've got the probability of Hannah winning a competition is 0.28. And we've been asked to find out the probability that Hannah does not win the competition. So to do that, we just need to take away 0.28 from 1. So we just do 1 take away 0.28, and that would be equal to 0.72. Okay, let's have a look at our next topic. So our next topic is expectation, which is video 248A in Corbettmaths. Now, if you know the probability of something happening, and you know how many times an experiment or something has taken place, if you multiply those two things together, you'll find out how many times you should expect something to happen. So let's have a look at an example. We've got a factory makes 6,000 plates each day. So the factory makes 6,000 plates each day. And the probability that a plate is faulty is 0.0035. So it's quite unlikely, it's very unlikely that one's faulty. It's got a probability of 0.0035. And we're being asked to find out how many faulty plates would be expected in one day. So if we multiply how many plates that are made by the probability of one of them being faulty, we'll find out how many faulty plates we'd expect. So if we do 6,000 multiplied by 0.0035, that would tell us how many faulty plates we would expect. And that is 21. So we would expect 21 faulty plates. If you're asked to find out how many plates weren't faulty, then you could just take the 21 away from 6,000 and that would tell you how many plates would be not faulty. Okay, let's have a look at our next topic. So our next topic is called relative frequency, or sometimes called experimental probability. And that's video 248 in Corbettmaths. So this time we've been given a table, and we've got two people, Susan and Helen, and they've done an experiment. And Susan's done the experiment 20 times. She span a spinner 20 times. And on that spinner, there's different letters, and we're told the number of bees that she got whenever she span it 20 times was 8. So if we're asked to find the relative frequency of spinning a bee, so because she spanned the spinner 20 times, it would be out of 20. And because she got 8 bees, the number of successes is 8, we write 8 out of 20, or 8/20, like so. We could write this as a decimal, or we could even simplify our fraction. Simplifying our fraction, we're dividing both of these by 4 would give us 2/5. So we could write an answer of 8/20 or 2/5. If the question doesn't tell you to simplify it, we don't have to, so we could just write 8/20. Alternatively, because Helen's result is a decimal number, we could also give it as a decimal number. We could write, well, 2/5 is a decimal will be 0.4. Okay, let's look at our next person, Helen. And Helen spun the spinner more times. She span it 120 times. And this time we don't know how many B's she's got, but we know the relative frequency of her getting a B. We know the relative frequency is 0.35. Now, to find the number of B's that Helen got, all we need to do is multiply the relative frequency by her number of spins. Thinking back to, we had a topic called expectation, where to find how many times you expect something to happen, you just multiply the number of trials by the probability. So if you multiply the relative frequency of the experimental probability by the number of trials, it'll tell you how many successes you had. So if we multiply 120 by 0.35, that will tell you how many times Helen's spinner landed on a B whenever she span it. So that would be 42. Okay, let's have a look at our next topic. So our next topic is called tree diagrams, and it's a probability topic, and a tree diagram is a really useful way of showing what can happen whenever two or more events take place. And it's video 252 in Corbettmaths. This is a very important topic, so I highly recommend you watch that video and try the practice questions as well. So let's have a look at our questions. Our question says, John and Dan are taking it in turns to throw a ball at a target. So we've got two different events. John's going to throw the ball at the target, and then Dan's going to throw the ball at the target. And what's great is this diagram will show us all the possible outcomes of what can happen. And we've been given some probabilities. So we've been given the probability that John hits the target is 0.6, and the probability that Dan hits the target is 0.7. Now, before we get started, let's actually label the probabilities on the diagrams. Now, the probability that John hits the target is 0.6. So let's work out the probability that John misses the target. Now, it's certain that he does one of these two things. He's either going to hit it or he misses it. That means these two probabilities need to add together to be equal to 1. So if we want to work out this missing number, we're going to do 1 take away 0.6, and that would be 0.4. So these two probabilities will need to add together to give us 1. Okay, now we've got Dan throwing the ball at the target. Well, he can hit the target, which is 0.7. So the probability that Dan misses the target is 0.3. And below, for Dan, again, we've got 0.7 as the probability that he hits the target, or 0.3 is the probability that he misses the target. Okay, so we've now got our tree diagram with our probabilities labelled on it. Now let's consider the outcomes of John throwing the ball and then Dan throwing the ball. Well, if we go along the branches, we can find out all the possible outcomes, and that's the great thing about a tree diagram. So let's start here, and John throws the ball and he can hit it, and then Dan can hit it. So we've got a hit and a hit, hit and a hit. So that's a hit and then a hit. Then we could have John hits the target and Dan misses the target, so that would be a hit and a miss. So that's a hit and a miss. Now if we go down this way, John can actually miss the target, and then Dan can hit the target, so that'll be a miss and a hit. And finally, John can miss the target and Dan can miss the target, so that'll be a miss and a miss. So we've got all the possible outcomes here. We've got a hit hit, hit miss, miss hit, and a miss miss. And what's fantastic is we can use the probabilities we've been given in the question to work out the probabilities of a hit hit, hit miss, miss hit, and miss miss really easily. And all we do is multiply the numbers along the branches. So if we wanted to work out the probability of John hitting the target and Dan hitting the target, because it's and, what we do is we multiply the probabilities together. So we're going to do 0.6 multiplied by 0.7. So we go along the branches and we do 0.6 multiplied by 0.7. So let's write that down. 0.6 multiplied by 0.7 is equal to 0.42. So the probability of John hitting the target and Dan hitting the target, a hit would be 0.42. Next, let's work out the probability of John hitting and Dan missing, so a hit miss. So that'll be 0.6 multiplied by 0.3. So 0.6 multiplied by 0.3 would be 0.18. Next, we could have John missing and Dan hitting, so that would be 0.4 multiplied by 0.7. So 0.4 multiplied by 0.7, and that'll be equal to 0.28. And finally, we've got a miss, so that's John missing and Dan missing, so that would be 0.4 multiplied by 0.3. So 0.4 multiplied by 0.3 would be equal to 0.12. And what's great is if we add these probabilities together, 0.42, 0.18, that's 0.6, plus 0.28, that's 0.88, and then plus 0.12, that gives us 1. Because obviously one of these four things will have to happen, either hit hit, hit miss, miss hit, or miss miss. Okay, so let's go to our question. So our question says, what is the probability that at least one man hits the target? So at least one man hits the target means either one of them could hit it or both of them could hit it. So hit hit, that would work. Hit miss, yep, one of them's hitting the target, that would work. Miss hit, yep, one of them's hitting it, that would work. But miss miss wouldn't work. So that means we're interested in this probability, and this probability. And we want to find the probability that either it's a hit hit or a hit miss or a miss hit. So if we add these three probabilities together, we will find the probability that at least one man hits the target. So we could do 0.42 plus 0.18 plus 0.28. And when we do that, we get 0.88. So the probability that at least one man hits the target would be 0.88. And that's it. Okay, let's have a look at our next topic. So our next topic is independent events. And independent events is a bit like tree diagrams, but we're just not going to be using our tree diagram. So and this would be 249. So we've got Naomi has a bias spinner. So here we've got a spinner and it's biased, so it means that it's not equally likely to land in any of the sections. So we've got the probability that the spinner lands on red being 0.1. The probability that it lands on white is 0.4. The probability that it lands on black is 0.3. And the probability that it lands on brown is 0.2. And she spins the spinner twice. And the question says, what's the probability that the spinner lands on black twice? Now you could draw a tree diagram here and you could do 1, 2, 3, 4 branches for the first outcome, the first spin, and then we could do another 4 branches for each one of them, like so, and it'd be quite complicated. What would be great is if we could do this question without drawing out the tree diagram. So we want to find the probability of a black and a black. Now the probability that the spinner lands on black anytime is 0.3. So what we're going to do is, if we imagine our branches, we're going to do black and black. So that would be 0.3 multiplied by 0.3, because that's the probability for black multiplied by the probability of a black. So 0.3 multiplied by 0.3 would be 0.09, and that's it. If we wanted to find out the probability it landed on brown twice, we would do 0.2 times 0.2. If we wanted to find out the probability it lands on white twice, we would do 0.4 times 0.4, red twice, 0.1 times 0.1, and so on. Okay, and that's it. So let's have a look at our next topic. So our next topic is tree diagrams, but this time we're going to be dealing with tree diagrams whenever objects perhaps are taken out and they're not put back in. So whenever the probabilities will change depending on what happens. Okay, so let's have a look at typical questions. So Kieran has 7 blue pens. So blue pen, blue pen, blue pen, blue pen, blue pen, blue pen, blue pen. So we've got 7 blue pens, and he has got 3 red pens. So he's got 3 red pens, 1, 2, 3. So Kieran's going to pick a pen out at random. So he's going to pick one of these pens out at random, and it says without replacement, so then he doesn't put it back in, and then he picks a second pen at random. And the question says, what's the probability that the pens are different colours? So here we've got a tree diagram, and we've got the first pen and then the second pen. Let's deal with the first pen to begin with, because we know that he's got 7 blue and 3 red to begin with. So the probability of him getting a blue would be 7 out of 10, so 7 tenths. And the probability of him getting a red will be 3 out of 10, so 3 out of 10. So we've labelled our 2 probabilities to begin with. Now the second branches are going to be a little bit more complicated because we're going to have to think about it a little bit. So he could have taken out a blue pen to begin with, because he could have taken out a blue pen. And now we're going to consider what the probabilities would be if he's taken out the blue pen. So let's get rid of a blue pen. So I've got rid of a blue pen, and let's now think of what the probabilities would be then for the second pen if he took out the blue pen to begin with. So altogether he's now got 6 blue and 3 red. So the probability of a blue pen, well, there's 9 pens altogether, so there's going to be 9, and there's 1, 2, 3, 4, 5, 6 blue pens. So the probability of the second pen being blue would be 6/9. So if Kieran took a blue pen to begin with, the probability of the second pen being blue would be 6/9. If we took a blue pen to begin with and we want to know the probability of it being red, well, there's 9 pens, and 1, 2, 3 of them are red. So the probability of the second pen being red, if the first pen was blue, would be 3/9. Okay, so these are the probabilities if he took a blue pen to begin with. Now let's find the probabilities if he took a red pen to begin with. So let's put that blue pen back. So there's that blue pen back again. And if he took a red pen out to begin with, so let's get rid of one of the red pens. So he's taken that one out. And now let's find these probabilities. So he's taken out a red pen. What's the probability for blue pen now? Well, again, there's still 9 pens because he's taken one of them out. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 pens. And there's 1, 2, 3, 4, 5, 6, 7. He's still got 7 blue pens in there because he took a red one out. So the probability for blue would be 7/9. Well, the probability for red, well, if he took a red one out to begin with, there'd be 9 pens, and there'd only be 2 reds now. So the probability for red would be 2/9. So we have now labelled the probabilities on the tree diagram, and as you can see, the probabilities change depending on what he does first. Now let's consider outcomes. So we could have a blue and blue, he could have a blue and a red, he could have a red and a blue, or he could have a red and a red. And to find these probabilities, remember we multiply the numbers along the branches. So for a blue and a blue, we would do 7/10 multiplied by 6/9. And that would give us 7 times 6 is 42, and 10 times 9 is equal to 90. So the probability for blue and a blue would be 42/90. The probability of a blue and a red, well, that would be a blue, 7/10 to begin with. And then we're going to multiply that by 3/9, so multiply by 3/9. And that would be equal to 7 times 3 is equal to 21 over 90. Now the probability of a red and a blue, well, that would be 3/10 multiplied by 7/9, so multiply by 7/9. 3 times 7 is 21, 10 times 9 is 90, so that would also be 21 over 90. And finally, the probability for red and a red, well, that would be 3/10 times 2/9. And that would be equal to 3 times 2 is 6, and 10 times 9 is 90. So the probability for red and a red would be 6/90. Now the question says, find the probability that the pens are different colours. So if we had blue and blue, that wouldn't work, they're both the same colours. If we had a blue and a red, that would work, so that probability is a good probability, that would work. A red and a blue, well, they're different colours as well, so that's another probability that we want to look at. And a red and a red wouldn't work, they're both the same colour, so we want to consider these two probabilities. So see if we're going to be a blue and a red, or a red and a blue. And remember in the OR rule, if it's one probability or another one, we add them together. So we're going to do 21 over 90 plus 21 over 90, and that would be equal to 42 out of 90. So the probability that the pens are different colours would be 42 out of 90, or 42/90. Now normally with probability questions you only need to simplify it if they ask you to, so if we simplify this at the very end, the answer would be 7/15. And that's it. Okay, let's have a look at our next topic. Okay, let's have a look at our next topic. So our next topic is conditional probability, and that's video 247 on Corbettmaths. And here's our question. It says, inside a bag there's 2 apples, so an apple, and there's 3 bananas. So there's 3 bananas. So in a bag there's 5 pieces of fruit, there's 2 apples and 3 bananas. And Olivia's going to pick out 2 items from the bag at random without replacement. So she's going to take out 2 items, she's going to take the first one out, she's not going to put it back in, and then she's going to take a second one out. And the question says, what's the probability of her picking 2 apples? So that's the probability of an apple and another apple. So probability of apple and apple. Okay, so altogether, Olivia has 5 pieces of fruit in the bag. Now we want to find the probability of her picking an apple to begin with. So altogether, there's 5 pieces of fruit, 2 of them are apples. So the probability of that first piece of fruit being an apple is 2/5. So that's the probability of the first piece of fruit being an apple, 2/5. So now she's picked an apple, she's taken it out of the bag, and that now leaves her with 4 pieces of fruit in the bag. She's got an apple and 3 bananas. And we want to find the probability of an apple and an apple. So remember on that tree diagram, we want to find the probability of the first one being an apple, and then we're going to multiply it by the probability of the second one being an apple. But she's taken one of those apples out. So now altogether there's 4 pieces of fruit in the bag, and she's only got 1 apple. So the probability of the second one being an apple would be 1/4. Now we've got our 2 probabilities, we can just times them together. 2 times 1 is equal to 2, and 5 times 4 is equal to 20. So the probability of Olivia picking an apple and an apple would be 2/20, or we can cancel that down to 1/10. And that's it. If we were asked the probability of her picking 2 bananas, so the probability of banana and banana, we would do, well, to begin with, let's put that apple back in the bag. So let's put that A back. So if we were asked the probability of Olivia picking 2 bananas, well, first of all, there's 5 pieces of fruit in the bag, and 3 of them are bananas, so it'd be 3/5. Then she would have taken out a banana, and then that would leave her with 4 pieces of fruit and 2 of them being bananas. So that would be the probability of the second one being a banana would be 2/4, so 2/4, so multiply by 2/4. And then we would just multiply them together. 3 times 2 is equal to 6, and 5 times 4 is equal to 20. And then we can cancel that down to be 3 out of 10. That's it. So whenever you're dealing with conditional probability, it's just very important to think about what the probability would be after the first thing has happened. So for, in other words, after she's taken out the first apple, what was the probability of her getting that second apple? Likewise with the bananas, once she takes out that first banana, what would the probabilities then be of the second one being a banana, and so on. So we're going to look at Venn diagrams now, and that would be 380A in Corbettmaths. And the question says 90 people were asked if they liked 3 drinks. So we've got drink A, drink B, and drink C. And 11 people liked all 3 drinks. So let's put that on the Venn diagram. They like all 3 drinks, so it's going to be 11 people in the middle. 8 people liked drinks A and B, but not C. So they like A and B, so they're going to be in the middle of A and B, so here, but not C, so it's going to be here. 8 people like drinks A and B, so they're in those circles, but they're not in the C circle, so that's there. Next, 17 people like drinks A and C, so A and C would be here, but not B, so that means that 17 people will go in there. And 9 people like drinks B and C, so they like drinks B and C, but not A, so that means that's going to go there. We're also told that 4 people only like drink B, so only 4 people like drink B. And we're told that 50 people like drink A, so that means that the whole circle here for A will be 50. So if we add up the numbers we know in this circle for A, we've got 17 plus 11, that's 28, plus another 8 is equal to 36. So that means that 14 people must go there. And 3 people did not like any drink, so they're going to go outside. And we've been asked to complete the Venn diagram, so we've done most of it, and there's just one missing number here. Now we're told that 90 people were surveyed, so if we take all these numbers away from 90, we'll see what number must go here. And when we take away all these numbers away from 90, we're left with 24. So that means there must be 24 people in here. So we've completed our Venn diagram.
Okay, so we've looked at a Venn diagram question whenever we're dealing with a wordy situation. Now let's have a look at some notation that you may encounter whenever you're looking at Venn diagrams. So here we've got a Venn diagram, so we've got A and B, and as you can see, here's A, here's B. This is the section where they overlap, and this is the section that is neither in A nor B. And then this is the universal set, which is the whole rectangle. And you've got A, and A, if you've been asked to shade A, that would be inside of A. If we're asked to shade B, that'll be inside of B there. Then next we've got this A with a little dash above it. That means the complement of A, and the complement of A means not A. It means anything that's not A. So if you have a look here, whenever we shade it in, it's going to be anything that's not in A. So A dash means not A, or the complement of A, and that means anything that's not A. And then here, if we've got B dash, that means the complement of B, or not B. So it's anything outside of B. So that's A, B, A dash, which means the complement of A, which is anything that's not A. We've got B dash, which is the complement of B, which is not B. Now we've got A, and then this symbol B. And this is A union B. And that means A or B. It means anything that's in A or B, anything at all. And that means that it would be this region here, anything that's in A or B, because it's A union B, A or B. Now we've got A and then this symbol B, and that means A intersect B, and that means A and B, so it's the region that's in A and it's in B, so that's the overlap region in the middle. So this is the Corbettmaths revision card. It's very useful, and it's very important to know this notation that A is inside of A, B is inside of B, A dash means the complement of A, so it means not A, and B dash means the complement of B, so it means anything that's not in B. A union B means anything in A or B, anything at all that's in A or B, and A intersect B means A and B, it means anything that's in that middle region, that overlap, and that's it. Okay, let's have a look at a question now where we're dealing with that notation. Okay, so here's a Venn diagrams question, and we've got the symbol as well, and this symbol means the universal set, and we've got the universal set, so that's all the numbers that we're going to put in the Venn diagram are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we're told that the numbers inside of A are 2, 5, 7, and 8, and the numbers inside of B are 2, 4, and 9. And we've been asked to complete the Venn diagram. So whenever I'm completing a Venn diagram like this, the first thing I would do is look and see what numbers are going to be in the middle. So in other words, what numbers are in A and in B. And if we have a look here, 2 is in both of them, A and B. So we're going to put a 2 in the middle. And then we've got no other numbers. So that means let's put the rest of the numbers in A side. So that's going to be 5, 7, and 8. And if we look at B, B has got 2, 4, and 9. So that's 2, 4, and 9. So if we look in A, we've got 2, 5, 7, and 8. And in B, we've got 2, 4, and 9. Now we're going to put the rest of the numbers outside of A and B because the rest of the numbers are in the Venn diagram, but they're not in A or B. So that's going to be 1. We've done 2. We've then got 3, 4, 5. Then we've got 6, 7, 8, 9, and 10. So we've completed our Venn diagram. And let's just check. We should have 10 numbers in this diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've completed the Venn diagram. We've done part A. And then we're told a number is chosen at random. So one of these numbers is going to be chosen at random. And we've been asked to find the probability of A intersect B. So in other words, that's A and B, so it's any number that's in A and B. So if we look, that's going to be the region here, so we want to find the probability of choosing a number that's in this region. Well, there's 10 numbers altogether, so we're going to put 10 on the denominator, and there's only one number in A intersect B in this region in the middle, so the probability of choosing this number would be 1 out of 10, or 1/10. Okay, next question, part C. Part C says find the probability that the number chosen at random is in A union B. In other words, it's in A or B. So that means it's anywhere inside of A or B or both, any of these numbers at all. So if we have a look, we've got 1, 2, 3, 4, 5, 6 numbers in A or B. So it's going to be 6. And then there's 10 numbers altogether. So the probability of choosing a number in A or B, in A union B, would be 6 out of 10, or 6/10. So the probability would be 6/10, or if you wanted to simplify, that would be 3/5. And that's it.
Now, samples can be very, very useful. Rather than surveying or interviewing everybody, for instance in a school if you wanted to find information about what colour blazer you would like, rather than asking every single student, it can be very useful, and that's called a census, asking everybody in a population. Rather than a census, you can do a sample where you ask a smaller number of people. But it's very important whenever you do samples, they're fair. So, for instance, if I was doing a survey of students about blazers, it's making sure that you ask people from different year groups, you ask a range of different classes. So it's very important that you get a good sample, a fair sample, to make sure that your sample is representative of the whole population. But here we've got a question, and it says 480 students attend a school, and a teacher asks 50 students which colour blazer they would like. So we've got black, 20 students would like a black blazer, 15 students want a navy blazer, 9 students want a green blazer, and 6 students want a maroon blazer. And the question says, estimate how many of the 480 students would like a navy blazer. Now altogether we knew there was 50 students altogether, and we want to work out an estimate for how many students would like a navy blazer. Now if I look at the sample, we know that 15 out of the 50 wanted navy. Now if we work out 15 over 50 as a fraction, that's equal to 3/10. So that means that 3/10 of the students asked would want a navy blazer. Now if this was a good sample, a representative sample, that means that it should be the same fraction of the whole school would want a navy blazer. So if we work out 3/10 of all the students in the school, we'll find out how many should want a navy blazer. So if we work out 3/10 of 480, that would tell us a good estimate. So we'll do 480 divided by 10, that's equal to 48, and then we'll do 48 multiplied by 3, and that's equal to 144. So that's it. If we were asked how many of the 480 students would like a black blazer, we would have done 20 over 50, which is 2/5, and then work out 2/5 of the 480, and so on. Okay, let's have a look at our next topic. So our next topic is Capture Recapture, which is video 391 on corporate maths. So Capture Recapture is one of the subtle differences between the exam boards. Edexcel mention Capture Recapture, whereas OCR and AQA don't actually mention Capture Recapture, but they do mention sampling, so it may still be useful to spend a minute or two just watching this part anyway, but it's up to you. Okay, so Capture Recapture is a technique that we can use to estimate the total population. And this is the formula that we use whenever we're working out Capture Recapture, and that's M, the total marked, over N, the total population, is equal to R, the total recaptured, divided by T, the total capture on the second visit. That sounds quite complicated, but let's have a look at an example. Now, whenever I was in school, our biology teacher actually taught us Capture Recapture by bringing us to the greenhouse, and she got us to work out an estimate for how many woodlice lived in the greenhouse. And what she did was, she brought us to the greenhouse on one day, perhaps Monday, and we captured as many woodlice as we could. And we marked them with Tipp-Ex. We put a little bit of Tipp-Ex in each one of their backs. We just put a little bit of white Tipp-Ex in each one of the woodlice's back. And what we done was, we then released all those woodlice, we put them back to where we found them, and we counted how many woodlice we captured to begin with, and we captured as many as we could. And let's just say, for instance, we caught 300 woodlice, so we put 300 here for the total marked 300. So then what happened was, we went back at the end of the week, went back on Friday, we gave the woodlice a chance to mingle, and we captured as many as we could. We captured as many as we could on that second visit. And let's just say we captured, and we looked to see how many of those woodlice out of those 80 had white marks on their back, how many we recaptured. Let's just say, for instance, there were 60 that had Tipp-Ex out of the 80. Then that gives us a formula that we could work out an estimate for the total population, because we have got 300, the total that we captured on the first visit and marked, over the total population, how many are there in total, is equal to how many we recaptured, that's a 60 with the white dots, divided by the total we captured in that second visit, which was 80. And we could use that information to work out an estimate for how many woodlice lived in the greenhouse. And if we just solve this, we can work out an estimate for the total number of woodlice that lived in the greenhouse. So that means that if we times both sides of the equation by n, we would get 300 is equal to 60n divided by 80. And then if we multiply both sides of the equation by 80, we get 24,000 is equal to 60n. And then if we divide both sides of the equation by 60, we get that's equal to 400. So we get n is equal to 400. So our estimate for the total number of woodlice that lived in the greenhouse would be 400. Okay, let's just have a look at one more example. So we've got some students want to estimate the number of woodlice that live in a greenhouse. Now, it doesn't always have to be woodlice in greenhouse. It could be fish in a pond. And they catch and mark 80 woodlice. So in their first visit, they capture 80 woodlice. That means that 80 out of the total population will be equal to. And then the next day they go back and they capture 50 woodlice, and 32 of them are marked. So 32 out of the 50 are marked. So that means that 80 over the total population is equal to 32 divided by 50. We've been asked to estimate how many woodlice live in the greenhouse, so let's just solve this for n. So let's multiply both sides by n, so that gives us 80 is equal to 32n divided by 50. Let's multiply both sides by 50, so that'll be 4,000 is equal to 32n. And dividing both sides by 32 will give us 125 is equal to n, so n is equal to 125. So our estimate for the total number of woodlice that would live in that greenhouse would be 125, and that's it. And that's it. So this has been the ultimate GCSE Higher Revision video. In this video, I've spent 2 or 3 minutes going through every single one of the topics on the GCSE Higher Revision checklist. Some of the topics, such as Surds and Standard Form, I've spent a bit longer than 2 or 3 minutes because they're quite important topics. But I've spent roughly 2 or 3 minutes on the topics on the GCSE Higher Revision checklist. The video has been quite long, roughly 10 hours long, so I hope you watched it in chunks and written notes on it. And remember, you've got that booklet, that ultimate GCSE Higher Revision booklet, where there's a question on every single one of the topics as we've gone through for you to practice. And this video is absolutely perfect for anyone that's studying for Edexcel Higher, AQA Higher and OCR Higher. Now remember, there are some subtle differences around topics such as stem leaf diagrams, frequency polygons, ambiguous case and rationalizing denominators, and if you watch those bits of the video, as I mentioned, the difference between them, but they're very subtle. And that's it. So remember, there's that ultimate GCSE Higher Revision question booklet, and the link for that's in the description below. Also, as we've gone through this video, I've used lots of the Corbettmaths revision cards, so if you do want to get the Corbettmaths revision cards, in the description below there's a link to the higher revision cards, and you can find them on the website as well, and they're fantastic for you if you're revising for your higher GCSE maths. Also on the website, we've got the 5-a-day books, so rather than cramming your revision to the very end, using a little and often approach is fantastic. So if you're revising for GCSE Higher, I'd highly recommend the yellow Foundation Plus books, the green Higher books, and the blue Higher Plus books. And that's it. So this has been the Corbettmaths Ultimate GCSE Higher Revision video. It's quite a long video. I really hope you found it useful. The whole purpose of the video is to make sure you're familiar with all the topics on the GCSE Higher Revision checklist. So I really hope that you're confident with those topics and you do really well in your GCSE Higher Maths exams. So if you have found it useful, please like the video, please subscribe to the YouTube channel, and all the very best of luck with your higher maths. Good luck. Cheers. Bye.